Welcome to this course. It's amazing to have you on board as a student. Now in this course, you will learn all about the MERN Stack. You will learn how to build amazing full-stack web applications with MongoDB, Express, React.js, and Node.js. And you will learn all of that not just in theory, but actually apply it in practice to a real course project, which we will build from scratch. A project that shows you how these pieces work together and which will also include important topics like file upload and user authentication. So that by the end of the course, you will be able to build your own full-stack web applications with these technologies. Now that's the course, but who am I? My name is Max and I will be one of your instructors in this course. I will be responsible for the parts about React, Node Express, and how we combine all these things, including authentication. But in this course, I'm joined by Manuel, a MongoDB expert who will be your instructor and guide in the database-related sections.
Hi, I'm Manuel, I'm a data scientist and MongoDB expert. Now you know what this course is all about, but what are the course requirements? What do you have to bring to the table to succeed in this course? In this course, you will learn how to connect Node, Express, MongoDB and React. And the connection is the core focus of this course. Therefore, this course does not dive deeply into each of these technologies. The course comes with refreshers on React, MongoDB and Node, but the refreshers are, well, refreshers. If you really want to dive deeper here, make sure to check out dedicated courses on these topics. But for this course, basic React.js knowledge is highly recommended, and also basic knowledge of Node.js helps a lot to succeed here. These are the core requirements of this course, and with that, it's now time to dive into the course.
So what's MERN? What does MERN stand for? The M stands for MongoDB, and that is a database solution. The E stands for Express. I'll come back to what this is in a second. The R stands for React.js, and this is a browser-side JavaScript library that helps us build amazing user interfaces. And the N stands for Node.js. This is a server-side JavaScript runtime, an environment where JavaScript code can be executed outside of the browser. And now Express.js is a framework for Node.js, so it in the end makes building Node.js applications easier. Now combined, these technologies form the so-called MERN Stack. They work together particularly well, and you can build amazing full-stack web applications with these four technologies working together. So let's take a closer look at each of these technologies to understand which role it plays exactly in that tech stack. So what's React? React is a client-side, so on the browser, library which allows you to build highly reactive user interfaces. So it's all about building user interfaces. With React, you write JavaScript code that will be executed in the browser. And since it runs there, it is responsible for controlling what the user sees on the screen and how things there change when a button is clicked, when something is entered into an input box. It's really all about that. It's about rendering a user interface with dynamic data and about updating it when data changes or when certain events occur. It's about handling user input and providing feedback to the user. And it's also, and that is where the other three technologies will come into play, it's also about communicating with backend services. And with backend, I mean services or technologies that don't run in the browser of your user. So React, so to say, is the front end. The other three technologies, Node, Express, and MongoDB, together make up the backend. Now we use libraries like React, and there are alternatives like Angular, with which you would have the MERN Stack instead of the MERN Stack, which do the same. But we use such technologies to provide users with a mobile app-like user experience, where everything happens instantly, where we have a great reactivity, where things on the user interface really feel great and instant, and we simply provide a really awesome and amazing user experience. Now what about the other technologies? What is Node exactly? It's a JavaScript runtime typically used or often used to create server-side JavaScript applications. Now, technically, that's not the only thing you can use it for, but it is one of the most prominent use cases and scenarios. You can use Node.js to execute JavaScript outside of the browser. And since it runs outside of the browser, you can, for example, use it to create a web server with it. So to run it on some machine which is exposed to the internet, which then accepts requests and sends back responses. So we can then use JavaScript as a server-side programming language, as an alternative to PHP, ASP.NET, Java, and so on basically. With Node.js, we can listen to requests and send back responses. We can execute server-side logic, and we can also interact with databases and with files. Things we typically don't do in the browser or we can't do in the browser. Since we're not tied to the browser anymore, there are certain things we can't do anymore. For example, interact with the DOM, because there is no DOM, it's running outside of the browser. But there are new things we can do. For example, well, write files or do things like this. And therefore, as I said, it's an alternative to other server-side programming languages. And just like those languages, it's also important to note that it's rarely used standalone. Instead, typically, we use it combined with Express. And Express is a Node.js framework, so we still write Node.js JavaScript code, but we get utility functions and a certain way of structuring and building our applications, so a certain rule set we adhere to basically, which makes building Node.js applications much, much easier. So it's based on Node.js, but gives us new functionalities. It's strictly middleware based, and you will learn what that means throughout the course, which means we have a clear way of handling requests, a clear funnel through which all requests are passed, where we then can extract data or prepare the response. And in general, with other features like routing, view rendering, and more, we got a lot of tools and clear rules that almost force us to write amazing and really well-working Node.js applications. So it really simplifies the usage of Node.js, and if you know PHP, it's a bit like what Laravel is for PHP, an amazing framework that simplifies the usage of the language. And that leaves us with MongoDB. What is MongoDB about? MongoDB is a NoSQL database engine which allows us to store documents in so-called collections instead of records in tables as we would have it in SQL. So it's a database engine. It's all about storing data. It's about storing our application data specifically. We use MongoDB in this course and in general to store, for example, our users, our products, or whatever our application is about. Unlike SQL, it doesn't enforce a schema for our data. We can still build one and use one if we want to, but we're not forced to. And we also don't need to work with relations. We can still set up kind of relations, but it's all a lot looser than it is in SQL. You're not forced to do these things. And this is the case on purpose, of course, because it also gives you many advantages. For example, NoSQL databases like MongoDB often give you amazing performance because they're way more flexible. It's also very easy to connect it to Node and Express, because as you will see throughout this course, writing queries against MongoDB is really straightforward and super easy when working with JavaScript anyways. So it's really fun and easy to use MongoDB in JavaScript applications. Now, for security reasons, as you will also learn throughout this course, we don't connect to MongoDB directly from inside our React application. Instead, we do that with the help of Node and Express, and that is how we then have all these technologies work together. So it's a powerful database which can easily be integrated into a Node Express environment. Technically, however, you could also swap MongoDB for other database engines. It wouldn't be the MERN Stack anymore because, well, our M would be gone. But of course, you could also build an app with React, Node, Express, and some other database. But as I said, MongoDB really works well and is super easy to use. So we learned about the individual technologies. What's the big picture then? How do these things work together? Now we can differentiate between the frontend and the backend if we want to, or client and server. What happens on the client is our frontend. What happens on the server side is our backend. And on the client, we use JavaScript, or specifically React.js, to build an amazing user interface. On the server side, we use Node, Express, and MongoDB. Now we use JavaScript here for the presentation and the user interface, We will build a single page application with it, and I will come back to that later in the course. And on the server side, we have all our server-side business logic. We can store data persistently, either in files or in a database. We also implement our authentication logic there, for example. And technically on the server, we even can split NodeExpress from MongoDB, because as you will learn throughout the course, MongoDB will actually also run on its own server, its own machine, but it all happens outside of the browser, so I all consider this to be the backend. Now that of course leaves us with the question how client and server communicate, and that will happen with help of requests and responses, HTTP requests and responses, which are exchanged between these two ends. We will send background HTTP requests from inside our React JavaScript app to our server side, to our NodeExpress application, and this application will then reply with responses. And we will also exchange data, typically in the JSON format. This is how this will generally work together. This is how this will be connected. But we will have an entire theory module where we will take a closer look at this. And then, of course, we have a huge course project which we built from scratch, where we will build all these different areas, where we will build the front end and the back end and connect to a database and so on. And there you will, of course, also see all these things come together.
So this is the big picture, but what's inside this course now? We are almost done getting started, and in the next module we'll dive into the MERN in theory. So we'll have a look at all the 4 core components of the MERN stack: MongoDB, Express, React and Node.js. We'll see how these work and how they are connected to, well, finally build the MERN stack. With that theoretical part out of the way, it's time to dive into our course project then. We will start with the React frontend. For this, we'll use features like components, hooks, routing, and we'll also add front-end user input validation. And with that, towards the end of this module, we will have a nice looking and, from a front-end perspective, working application. What's missing here, of course, is the backend then. Here we'll focus onto Node and Express, we'll create our own REST API, implement our own routes, use controllers and models, and as we did it for the front-end, now it's time for the backend user input validation. Besides that, we'll also learn how we can connect our backend to a real database, MongoDB in our case here. With that, the backend will be finished. What's missing here, of course, now is the connection of these two ends, and that's what's going to happen in the next module. With that, we will have our first draft of the working MERN application here. Few things are missing though at this stage. One thing is file upload, covered in the next module. Here we will learn how we can store files, images in our case, on our own server. Following the file upload, we'll work on authentication. The authentication module will mainly cover the user sign-up and the user login logic, so that only if you are logged in, for example, you can access certain parts of our application. And with that, our application will be built. We will have a full MERN Stack application at this stage. There is only one last thing missing, and this is the last module, which concludes the course, the deployment module, because up to this point, we were working in a local development environment. Here we will learn how we can deploy our app to a real server in the internet. So as you can see, lots of topics to cover in this course, lots of things to learn and to explore. And before we dive into the course now, let's have a look at how you can get the most out of this course. Our goal is that you get the best possible learning experience whilst following along this course. So how can you get the most out of it? Well, first, watch the videos. Sounds easy, it's an on-demand video course in the end, but it's important to watch the videos and to also watch the videos at your speed. You can adjust the playback speed in the Udemy video player, so make sure to use this feature to watch the course videos conveniently. Watching the videos is nice, but also code along. This is a very crucial part of the learning process. The whole course is interactive, so take the chance, code along, and important, pause and rewind. Don't just code along and don't understand what type of code you're writing and why you're writing it. In case something is unclear, pause and rewind, watch the lecture again until you really understand what you're doing here and why you're doing it. Besides coding along, practice is of course something that we highly recommend. Following along the course is great and you learn all the core things you need to create your own MERN Stack applications in this course. But you should advance on your own. Create your own projects, or enhance the course project according to your needs. These are all things that will help you in the long term. Practice, play around, and with that, become a MERN Stack master. Now, on the way to become a master, debugging and searching is also something that will happen to you. Things can go wrong when writing code. This is also a crucial part of the learning process in the end. But it's important to have the right approach for debugging the code and for searching for solutions. For that, you can find the used code attached to the last lecture of each module in the course. So in case you're stuck, make sure to download this code and compare it to your code. You might have a tiny little mistake, and with that approach, you can quickly find it and continue with the course. Also, Google in case you have any kind of error message. Chances are that if you have this problem, another person had this problem too, and with that, a solution can be found quickly via Google. Besides Google, you can also use the integrated Udemy search function. That's also very helpful. With that, you can search through the course content, and you can also search through the Q&A section, because that's the last important step to make sure you get the most out of this course. Ask and answer questions. In case you're stuck and you can't continue, ask in the Q&A section of the course, and we'll do our best to help you as quick as possible. But in addition to asking, it's also important to answer questions, because answering is so much more rewarding. Asking is easy, right? But answering and helping others, this is really great, because nothing can go wrong here. If you give a wrong answer, somebody will correct you and you will learn. Or if you gave the right answer, you practiced your knowledge and the person who asked the question gets an answer. And that's basically a win-win situation for everyone. Now with that, you are well prepared for the course, and this means we can now dive into the course and continue with the MERN Stack in theory now.
Now, in order to build an application with the MERN Stack, we need to thoroughly understand how it works. So in this module, we'll dive a bit into MERN and how the different pieces work together in theory. Towards the end of this module, we'll also have a look at a simple MERN application, but of course throughout the course we'll then build a bigger one. But learning this theory and understanding the big picture is crucial. Specifically in this module, we will have a look at all the different pieces, React, Node, Express, and MongoDB, and understand how these pieces are connected or how these pieces are working together. Because of course that is in the end the essence of the MERN Stack, that you understand how to combine all these technologies. You will also learn in this module that there is more than one way of combining these technologies, and therefore we'll have a look at those different approaches, and I'll explain the pros and cons of the different approaches and which approach we'll use in this course. And with that, let's dive right in and let's have a look at the big picture of the MERN Stack and how that all works. MERN, of course, stands for MongoDB, Express, React, and Node. And we want to have these four technologies work together. We want to build a full stack web application where these four technologies are used because they tend to work together really well. But how do they work together? How are they connected? The R, React, is responsible for the client side, for the browser side, for what the user sees, so the presentation and the user interface. This means that we will use React.js to build our front-end facing web application, the thing that runs in the browser. React.js, as you should know, is of course based on JavaScript. It's a JavaScript library, and it's JavaScript that is executed in the browser. So React is used to build beautiful and highly reactive user interfaces in the browser. It's there to render something onto the screen and re-render it whenever something changes, update the user interface, and provide a great user experience to our end users. Put in other words, React is responsible for what the user sees in the end. React alone is great, and we can build stunning user interfaces with it. But of course, if we only work with React, we have some limitations. Most importantly, we're not really able to execute any logic on a server. So in a place where users can't see our code, they can see it in the browser. Anyone can use the browser dev tools to look into our code. And in addition to running code the user can't see or running more performance intensive tasks, which we also don't want to do in the browser, In addition to that, we typically also want to store some data in a persistent storage, and the browser side is not such a persistent storage. Users can clear the data there. The browser might clear data on its own if it's running out of space, so data there is not persistent. It's also not shareable across all users of our web applications, because if we store data in the browser, of course it's only readable by that browser, so in the end by that user, and not of other users of our web application. For an online shop where users are able to create products which should be visible to any user, that would be bad. So that's why we need a so-called backend, a server side. This is a web application that runs on a dedicated machine, a server, somewhere in the internet, reachable by anyone, so opened up to incoming internet connections, and that server is created and run with the help of Node.js and a Node framework, Express.js. These two pieces are used to write JavaScript code that runs on a server, detached from our client, from our browser. There we can run any business logic which we might want to hide from our users, or which is more performance intensive. Since we run it on a dedicated machine, a dedicated server, we don't rely on the machine of our users, which is great. We also can use Node and Express for file storage, and we will in this course. And therefore, this is an important part of a real web application. Now, this server side and the client side, so the browser, communicate with requests and responses, HTTP requests and responses. Specifically, so-called AJAX, or as I like to call them, behind-the-scenes requests and responses. Requests and responses triggered from client-side JavaScript so that they are sent to the server and the response is handled in the client without reloading the page on the client. That is achieved by exchanging data, which is not a HTML page, which would be rendered by the browser and which would therefore lead to a page refresh, but instead which is in a so-called JSON format. There also are other formats you could use, and we'll have a look at one other format in this course, but JSON is by far the most common format for exchanging data. JSON stands for JavaScript Object Notation, and it's a machine-readable and also quite human-readable data format, which in the end is used to exchange text data, numeric data, and structured data in any form. This data is attached to both requests sent from the client to the server and responses received by the client incoming from the server to then re-render something on the client side, so using React to re-render parts of the UI, or to do something on the server side if the data is received there. For example, store it in a database. Now, speaking of that, the database, MongoDB, is missing in this picture. Now, that's our third building block, if you want to call it like this. We also have an extra database server which runs our MongoDB engine. And that's really important to understand. In the end of this picture, there are three big blocks working together. Two servers, one running our Node Express app and one running the database engine, and the client side. That's also involved, of course. Now, that database server can run on the same machine as our Node Express server or on a totally different machine. That doesn't really matter. The database server in MongoDB is then used for the persistent data storage. Not file storage. You should always store files on a file system, not in a database, but any other data, like the name of a product, the price of a product, the users of our web application. Things like that would be stored in a database like MongoDB. Now, the important question, when we have a look at this incomplete picture here, is who's talking to the database server? And that is our Node Express application. That application sends database queries using the MongoDB SDK, or a MongoDB library to be precise, to that database server. We don't send requests from the client side directly to the database. Why? Because to send these queries, we need to include our database credentials, so the username and password to log into our database, so to say. As I mentioned earlier, all the code that runs on the client side, so in the browser, is readable by all your users. There is no way of disabling this. This is how the web works. So if that code would include the credentials for your database, your users could hack your database. They could gain access to it. So we do this on the server side where the code is not readable by our users. And from the client side, we just send requests and responses to the server. And on the server, we decide which requests we want to handle and which responses we want to send back. So we have full control on the server side, and the client is only able to communicate with the server within the request-response patterns we allow. And that is, of course, what we will build in detail throughout this course. This is the big picture for the MERN architecture. This is how all the pieces work together and which pieces are involved in the first place. And this architecture allows us to build amazing web applications, highly scalable and very fast web applications with a beautiful and highly reactive user interface powered by React attached to them. Now with that, let's take a closer look at some of these building blocks. Let's take a closer look at the front end, the client side, the browser side. I will use these terms interchangeably, by the way. And that, of course, is powered by React. Specifically there, we build a React SPA, a single page application. Now, this simply means that React is in charge of re-rendering everything in the browser. Only one HTML page, that single page that makes up this term single page application, is served from some server to the browser in the end, and thereafter React takes over. And whenever something needs to be drawn onto the screen, or whenever something needs to change on the screen or needs to be re-rendered, React will do that. For that, we'll also handle front-end or client-side routing with an extra library, React Router DOM, and this will help us render totally different React components. React is all about components. You will, by the way, also get a React refresher in one of the next modules. So the React router will help us render React components based on a path the user enters into the URL bar of the browser. So we will have the feeling of having multiple pages, but in the end it's all React and therefore JavaScript re-rendering significant parts of our page, so of what the user sees when we change the URL or when we get new data from the backend and so on. Now, in our React application, we also typically handle some front-end state. State in the end is data, you could say, that influences what is shown on the screen. And when our state changes, chances are that we want to re-render parts of the screen. React is all about managing such state, and it has built-in mechanisms to automatically re-render the parts of the screen that need to change when something changes. Now, for state management, we can use React State in class-based components. We can use hooks, a relatively kind of new feature in React, and or also for application-wide state, the Redux library. Now, as I mentioned, you will get a refresher on React later in the course, but I will not dive into every aspect of React. That would be enough for its own course, and indeed I do have such a standalone React course, which I strongly recommend that you have a look at before you dive into this course. Now, one other important part of your React application are, of course, all these components you build, because React is all about components, and how you style those. So the styling is also part of the front-end work or of the front-end application, that your application looks good. Now, as I mentioned, for the routing, we'll use React Router DOM, and there we can basically set up a route configuration and then define which React components are rendered for which path. We can implement state management with React hooks, with our custom hooks, which we'll also build throughout this course, and or with Redux. And for components and styling, we will build in this course some utility and UI components, though I will also say that throughout this course, I will also provide some finished UI components to you and some finished styles so that we don't spend the majority of the time of this course on writing basic button or input components and managing the style of these components, because that's really not the core of React and of this course, and therefore some finished components will be provided to you for this part. In general, of course, we'll build the entire React application from scratch though. And this is what React is about. It's all related to the front end, how we update it, and when things should change there. Now let's have a look at the backend. If we dig a bit deeper into the backend, of course we have to keep in mind what I explained earlier, that we have decoupled ends, which means we have the front end powered by React, with the backend powered by Node.js, and then we also have the database server with MongoDB. Now, because of that decoupled ends thing, our backend is built as an API, which stands for Application Programming Interface. Now, the term API is not just related to web development or to Node.js apps. API is a general programming term, and it describes things which expose certain entry points, you could say, which other things can use. For example, if you're building a third-party library that should do some user input validation, you might offer certain functions the application that uses your library can call in a certain way to use your library. So basically, any library you create needs clearly defined entry points and a way of using them so that other users who did not build your library can interact with it. And for our backend, it's basically the same. We build a Node.js application which defines some entry points, some ways of communicating with it, and only these ways are supported thereafter. If some client which tries to talk to our backend, for example the React app later, wants to interact with some entry point we didn't define, it will get an error. This pattern is important because it allows us to keep control over our API and control which actions we want to do, which actions we don't want to perform, and what should happen on each action, as well as which data we need to perform each action. And when it comes to building such an API, of course we'll do that all step by step throughout this course. It's important to understand though that there are two major kinds of APIs which you can build when you build such a backend. You can build a REST API, where REST stands for Representational State Transfer, and you can build a GraphQL API. Now, both kinds of APIs can be built with any server-side language, not just with Node.js, but of course in this course we will use Node.js. And both kinds of APIs can do anything on the server: store data in a database, validate user input, get data from a database, and so on. Now, they work differently when it comes to how requests are received or how requests which are sent to the API should be formatted. A REST API, which is by far the most common and used form of backend web API, uses a combination of different URLs or paths, which are the things after the domain, and HTTP verbs, which is this get, post, patch, delete thing you might have heard of, to build so-called endpoints which trigger different actions. And I'll show some examples and come back to that in a second. So for a REST API, it's the combination of the URL and the verb used for the request that defines what happens on the server. And when we build such a REST API, we define the combinations of URLs and verbs we want to support. And for unsupported combinations, an error will be sent back if a client tries to use it. For a GraphQL API, that's different. There we have one URL and one HTTP verb, typically a post request. So we have one endpoint, which then in turn, however, accepts query commands. So since this HTTP verb is a post request, when you build a GraphQL API, the body of the request contains a query expression that adheres to the GraphQL standard in the end, which describes the operation you want to perform. Still, on the server side, when you build such an API, you define which query commands you want to support. So you still don't support everything. But you don't work with different path-verb combinations, but instead with that query language to trigger different actions and so on. Now, in both scenarios, we execute code on the server, and in both scenarios, we don't directly talk to the database. GraphQL and query commands, that might all sound a bit like we're already talking to a database, but always keep in mind, from your React app, you'll always send requests to your Node.js app, no matter if that's built as a REST API or a GraphQL API. It just influences how the requests look like, which you send. But in both cases, you talk to your Node.js app. And that Node.js app will then do something based on the action which is triggered because of your path verb combination or because of your query command. And then it's your Node.js server which will talk to a database. So let's take a closer look at this REST and GraphQL thing. How do these APIs look like in detail? Well, as I mentioned, we still have that client-server combination, and the server uses Node.js, and then we talk to a MongoDB database from that Node.js server. The client, of course, uses React. Now, how does such a request look like, which we send to the Node.js server if that server is built as a REST API? Well, as I mentioned, it's a combination of a specific URL, or specifically the path, which is the thing after the domain, because the domain, of course, will always be the same. Yourpage.com, for example, is the domain. But the thing thereafter, /products, /nothing, /new, /user, whatever it is, that is the path. And that combined with a specific HTTP verb triggers a specific action, at least if we support that path verb combination on the server. For example, we could be sending a post request with the post HTTP verb to the /post URL, or a get request to /posts, or a get request to /posts/ and then some dynamic path segment, which Node.js also supports, so that we, for example, could have different IDs of posts which are parts of our incoming requests. These are our so-called API endpoints, and as I mentioned multiple times, it's up to us, the developer of the Node.js REST API, to decide which endpoints we want to support. And then upon getting a request on such an endpoint, we run some server-side logic to do whatever we want to do, for example, to reach out to the database, and then store data there, get data from there, and so on. Now, when it comes to these HTTP methods, post and get might be methods or verbs you already know, but there's more than just get and post. Of course, we have get, which we typically use to get data or get a resource from the server. And we have post to post data to a server, so to send data there and then create new data, a new object, new resources on the server. But we got more than that. We also got put, which we typically use to create or override a resource. Patch, which we use to update an existing resource on a server. Delete, to delete a resource. And also actually options, which we won't send on ourselves, but which the browser automatically attaches for certain requests, which the browser then uses to find out if the request we actually want to send is supported. I will come back to that later. Now, what's really important to understand here, because it's a common misconception, is that just because you send a post request, you don't actually store something in a database automatically. As I mentioned, it's up to you, the developer of the API, to decide what you want to do, which code you want to execute, for which verb path combination. And you typically want to map the verbs in a way that's logical. So you want to create data when a post request is received. You want to delete data when a delete request is received. But theoretically, you could also return data, so you could get data upon a delete request, or return data upon a put request, or return data upon a post request. That would just not be logical, and therefore you want to avoid it. But it's really important to understand that the verb path combination alone does not dictate what happens on the server. That is up to the logic you wrote there for the different verb path combinations. So that's REST. Now, what about GraphQL? When we have a look at that same picture for GraphQL, we have the same general logic, and that's important to understand. We send a request to the Node.js app then, but how does this look like now? As I mentioned, with GraphQL, there aren't multiple endpoints. There is one single endpoint, and that typically is a post request on some path of your choice, often the path is /GraphQL, but that's not a must use. Now, the trick here is that this request, since it's a post request, has a request body. And that request body contains a query expression written in a standardized GraphQL query language, which is then parsed by your Node.js server. And if you then wrote code to support that specific expression which was sent, you can then, well, use the data which is part of that expression and so on to store data or to get data and so on. The query, which could be in the post request body, typically looks something like this. We describe the operation we want to perform. Alternatives to query, which we typically use to get data, would be mutation to add or change data, or subscription to set up a live subscription. We then have an identifier of our choice, which we also could call endpoint therefore. And then the data we, for example, want to request or we want to send. Now, I do have a free series on how to build basically a simple MERN application with a GraphQL backend, and attached you find a link where you learn how to build such a GraphQL backend from scratch. So that might also be interesting for you if you want to learn more about GraphQL. In this course, when we compare REST to GraphQL, we will go with REST, and here's why. The REST API approach uses this path HTTP method combination to identify resources or actions on a server, and that's very intuitive and very easy to learn. Such an API is stateless and decoupled from any frontend, which means a REST API you build cannot just be used with your React single-page application. Any client could talk to it. So if you later build a mobile application with iOS or Android, you could talk to that same API because the API is totally separated from the front end, which is the cool thing about this API approach. You can reuse the API and just attach different front ends. One of the reasons why such APIs are so popular these days. Now, we will use the REST API in this course because it's the most common type of API. You see a lot of APIs built in that way out there in the wild, because it's easy to use, easy to learn, easy to document, and very intuitive in the end. Now, a GraphQL API does not use the path HTTP method as you learned, but instead such a query expression using a certain query language to identify a resource in action. And just like the REST API, it's also stateless and decoupled. So just as with the REST API, you can attach any client to that API, which is great. But the reason why we won't use it is that despite GraphQL being very popular and very useful and powerful, you need to learn that extra query language, which is some extra effort, which not everyone wants to do. In addition, out there in the wild, you see way more REST APIs than GraphQL APIs, so I find it more important to learn that. Nonetheless, as I mentioned, attached you find a link to a free series I created in the past, where we also built a GraphQL API, and actually also a Node.js and React application that works with it, for free in a complete series. So this might be interesting to you if you want to learn more about that. In this course, we'll build a REST API from scratch because it is so important and so powerful, and we will build it from the ground up so that you definitely learn everything that's to it. And with that, we're almost done with the theory. Now there's just one more thing left, and that is related to how we host our different parts. You know from the big picture that we have three big blocks: the React app, the Node.js app, and the MongoDB database and the server that database runs on. Now the question is, where are the different pieces served from? Now we got two main options here. We can have one server, one computer, which hosts both our Node API and the React single-page application under the same domain. So mypage.com/nothing might return our single-page application, and then under mypage.com/API, we might have the endpoints for that single-page application to talk to. The alternative is that we have two separated servers. One very simple server, which simply serves our single React.js application HTML page and all the JavaScript files that application needs, and one server which hosts our API. So, If we take a closer look, for the left case that we have one single server, we have a Node.js API which handles incoming requests on that server. For example, under /API, any requests targeting these paths might reach our API. And requests which are not targeting our API routes would return the React single page application in the end. So these requests would get us the single HTML file and the associated JavaScript files that are required to run the React app. Between the React app and the Node API, even though they're running on the same server, we have that separation you learned about. So they don't really know much about each other than that they run on the same server. Data is still exchanged with these AJAX background requests in JSON format. If we have the two separated servers, then we really have two different machines. One which has our Node API on it, our NodeJS API, and one which is served from that very simple so-called static host. Static because it will be a server which doesn't need to execute any server-side code, because it is a server that doesn't run any Node or any other programming language application on it. Instead, it's just a server which returns our HTML file and the JavaScript files and the CSS files and so on. So therefore, we got our two ends served on different servers, and data is exchanged in JSON format when we send these background HTTP requests. So that's always the same. In one case, they're just served from the same machine, in the other case, from two machines. In both cases, we got these logically separated apps. Now, regarding the MongoDB database, that always has its own database server, but just like the Node server and the React app, this server could be installed on the same physical machine as our Node and maybe all the React app runs on, or on a separate machine. And often you want to use different machines here to make sure that just because you're getting a lot of requests, you're not slowing down on your database requests or database queries, and the other way around. So therefore, separating the NodeJS app and the database server onto two different machines is a good idea. Technically, you could run everything on the same machine. You'll always have the same logical separation though. Now actually, there also is a third way, which I really don't want to talk too much about though. You could have your NodeJS server and not build a REST or GraphQL API there, but instead render HTML pages on the fly on that server with templating engines like EJS or Pug. If you took my Node.js The Complete Guide course, you'll learn about this approach as well. Now, you therefore really render different HTML pages for different requests on the server, and that rendered HTML code is returned. Now, to get React into the equation, you could have some parts of these pre-rendered HTML pages which are controlled by React in a widget-like way. So React only controls parts of the page instead of the entire page. This is possible, but it takes away from the great, highly reactive user experience we can build with single-page applications. Since we create and return HTML pages from the server for everything the user does, we constantly reload pages, we add a slight delay, and we don't have that highly reactive mobile app-like feeling we can achieve with single-page applications. Therefore, this is not the approach we will use here. Technically, of course, though, you could build an application with the same technologies, MongoDB, Express, React, and Node, so MERN, with this approach. But you would not get the same great user experience, and therefore, typically, when we talk about MERN, we talk about the logically separated ends, no matter if they're served by the same physical machine or not. We don't really talk about this approach. Well, and with that all out of the way, let's have a look at a very simple first MERN application so that you can see the big picture also in code, before we then dive into the different course modules where we will get a refresher on React, NodeJS, and MongoDB, and then more importantly, build the different building blocks of our course project, which is such a MERN app, and then also connect these building blocks. So let's see that big picture, or at least parts of it, because MongoDB requires this extra database server setup, which we'll tackle in a separate module. But let's see this part at least, the React and NodeJS API communication part, in action in a simple application. And no worries, this is just a short demo application. We'll build one, a way bigger one, the course project, from the ground up throughout the rest of this course. Attached, you find a zip folder, which you can unzip, and in there you'll find a frontend and a backend folder. Now, combined, this makes up your MERN application, and this is a very simple dummy application which I prepared for you. The frontend holds a React application. The frontend folder here was created, or this project here was created with Create React App, which is a tool by the React team to create React projects. And it holds a React application with some components, because React is all about components, as you will also learn again in the React refresher in a separate module. For now, you can just take it for granted. So we'll have the different components, the building blocks of our front-end user interface, so to say. And with the backend folder with exactly one core file, server.js. Now, to run these ends here, you need to install Node.js. You can install it from nodejs.org, and there simply download the latest version, 13 in my case, but that of course will change over time. Does not really affect the way Node works or looks like, however. And simply download that latest version and walk through the installer you get there. The default settings are fine, and this will install Node.js, so this special JavaScript runtime, onto your machine. It will also install one other tool onto your machine, and that's npm, the Node Package Manager. This is a tool which is required anyways to install the various dependencies, so third-party libraries we use, in both our backend code as well as our frontend code. Because even though the frontend code is not run by Node.js, it still will use third-party libraries, which are then simply used by the browser, or, also an important part, by our build setup, our development setup, where we have a dummy server that serves our front end, which reloads the page whenever we change something, which optimizes our code, and so on. These are all steps which are not run once we deploy our finished front end, but which help us during development, and for that we also need third-party libraries, and actually also the Node runtime, which runs this entire front-end build process. So we definitely need Node.js to do anything here. Now, you also see I opened this project here in an IDE, in an integrated development environment. This is Visual Studio Code, a great free-to-use IDE you can find if you Google for VS Code, in which you can then install from the page you get to, code.visualstudio.com. It's free and available for all operating systems, so simply download it and walk through the installer if you want to use that same IDE here as I do. Now, in that IDE here, I also installed some so-called extensions. You can get to the extensions menu with View Extensions. And there specifically the extensions I recommend that you install are the Material Icon theme to make sure your file icons look like mine if you like that look. Path IntelliSense, which can help you with auto-completion of file names. Prettier, which helps you with auto-formatting your code so that it is easy to read and you don't have to format it manually. And with all that installed, also if you go back to the Explorer or use the shortcut you see here, I also recommend that you look into the themes you got configured. Under Code, Preferences, Color Theme, there you can switch it to a different theme. I'm using the Dark Plus default dark theme here, which gives me the look you see here. You also here see the file icons I got from the Material Icon theme. Last but not least, I already talked about Prettier and that auto formatting. You can always check out your keyboard shortcuts, and there specifically the Format Document shortcut is one you should bind, because that will help you use that Prettier extension to automatically reformat your code. But with that, that's basically the setup I have here. Then I opened that extracted folder, which holds the backend and frontend folder, and I'm now ready to go. Well, or almost. First of all, as I mentioned, every end has some packages, some dependencies it uses. You find those in the package.json file, which is your project management file, you could say. And you see that I treat backend and frontend as separated projects, because they are logically separated. Now you see here for the backend in the package.json file, I got free dependencies, free third-party libraries this project uses. For the front end, for the React application, I got these free dependencies. React, the library we use, React DOM, which is also part of React, and React scripts, which in the end helps us with our build setup and with this dummy server that serves the React application and so on. Now, to install these dependencies, you need to open up your terminal or command prompt, and you can use the one integrated into your IDE. You can go to terminal, new terminal here to open it, and then navigate into your front-end folder, and in there run npm install. And this uses the npm tool which was installed together with Node.js to install all the dependencies which are mentioned in the package.json file. It will then create such a node modules folder where these dependencies and their dependencies are actually stored in. Now, doing this just for the front end alone is not enough, so I will open a second terminal and also navigate into the backend folder, because there I also want to install all the dependencies so that for both the front end and the backend we got that installed. So let's wait for this installation process to finish, and thereafter let's start our two servers and see how they communicate with each other. So the installation of all the dependencies in both the front end and backend folder finished, and now let's simply see what we got there before we have a look at the code. Now keep in mind, we have two logically separated ends here, and here during development at least, we will also have two separated servers. Now of course both runs on our machine here, on our computer, but actually we will run these two different ends under two different domains. Now let's see what we got here. In the front-end folder, you can run npm start to start a development server that's part of the setup, basically added by this React scripts dependency, which will host your React application, this React single page application. So it's a development server which in the end hosts this single index.html file, which you find in the public folder there, which then in turn will import all the scripts it needs and launch your React app. You find that application, it should open up automatically actually, under localhost :3000. Localhost might look strange, but this is your domain. It's available on your local machine. It's a special domain there. And :3000 is the port on which we're visiting this. And combined, this actually is a domain as it would be the case for yourpage.com. So this combined is the actual domain. And if you would visit another page on, let's say, localhost 5000, that might look very similar, but it would actually be a totally different domain, as if it were served by a totally different machine. So here React automatically runs on localhost 3000, and that's our React single page application. Now let's go to the backend folder, and there you can also run npm start. Now here nothing opens up automatically, but you will see that you're now in a process which doesn't stop. So you can't enter a new command. By the way, it's the same for the front end. That is the default, and it is what should be the case, because that means you have a running server. You can always stop these processes by hitting Ctrl+C on your keyboard, but then of course the server will be down. So as long as you're developing, you should have it up and running. So we got these two running servers, and the Node backend server here actually will run under localhost 5000. However, if you enter that, you will not see anything because this specific endpoint /nothing is not supported. Remember when I said that you as a developer decide which endpoints you want to support and you want to execute code on? Well, that's not one of them. Things change if you enter /products there, however. You see now you get back in the end a JavaScript object. This is actually this JSON notation I was talking about, which holds a products key and then an empty array. So here we seem to get back some data, even though it's empty, and that already looks quite promising. And now really keep in mind, localhost 5000 is a totally different server than localhost 3000. Now, obviously here we have some communication problems. With your Node server up and running, however, reload the React app on localhost 3000, and you will see that the loading part goes away, and instead we see could not find any products. Now let's add a book here for, let's say, $12.99, and click Add Product. And what you see is it now appears down there. Now that's nice. But what you will also see, if you reload now and you keep both servers up and running in between, you still get that. You see loading for a fraction of a second, and then you see a book here. So it looks like the book we created here really was stored somewhere, was stored on our backend server. And when we reload the React app, we're fetching data from that server. And since the server runs on its own domain, but technically, of course, on the same machine as our frontend, that request is super, super fast, which is why we see that loading text only for the fraction of a second, if we see it at all. But the really important thing here is that we are storing data on our backend, so on the NodeExpress app or with help of the NodeExpress app, and we're fetching it from there. Now that's how it works. Let's now have a look at the code to get a rough understanding of what's working together there. Now I want to start with the backend for that. Let's have a look at the server.js file. This is, in the end, our NodeExpress server. And one important thing about Node and Express is that, unlike with, for example, PHP, when you're building a Node application, you launch the server itself with Node.js. With PHP, you need some extra software like Apache to launch a server, which then runs and interprets your PHP scripts. With Node, you use Node itself to launch that server. So the server.js file has all the logic it needs to run the server, but also then to handle incoming requests. Now, we'll dive a bit deeper into how Node and Express works in a standalone refresher module, so I don't want to lose too much time on that right now. In the end, what you'll just see at the end here is that we have some listen method, which we call, which in the end will start your server and listen on port 5000. So this is also where you could change the port, but not all ports will work. Some are not allowed by your system. And for example, 3000 is not allowed because that's where our React app runs already. So you should leave that at 5000. And in addition, besides some other setup, you will see an app get and an app post method. This registers so-called middleware for certain paths. So here you see that path thing for certain HTTP methods, namely here a get method and a post method. So here you see that method path combination thing I was talking about. And then some functions that should be executed when a request reaches such a method path combination. And then here in the end I send back a response with some products. Here I create a new product. I validate the user input before we do anything else. And then I create the product, create a unique ID with some third-party library, add it here to this dummy products thing I will have a look at in a second, and then send back a response upon successfully creating that product. This is our core backend logic. Now, what we're not doing here is talk to a database, because for that we need to set up a separate MongoDB server, which is a bit more work, not horrible, but a bit more work, and therefore we will do that in a separate module. But what we do have here with dummy products is a dummy JavaScript array. This, however, is only stored in memory of this running Node application, which means whenever we restart the server, which we can do by quitting our Node server with Control-C and then rerunning npm start, all that data will be lost. So after restarting that server, if we reload the React app, you see it doesn't find any products anymore, because as I mentioned, this is only stored in memory of the Node app, which of course is not a great storage. It's just a dummy storage here. Later, we'll of course store data in a database. You will also see this strange thing. I will come back to that later. That is important to allow communication between our frontend, which runs on a different server than our backend. But again, I will explain in detail why we need this and what this does later in the course. Well, and that's already it for our backend. You might not understand everything here, but again, we'll have a refresher on NodeExpress later. But it should be relatively clear that these are our endpoints and that this is where our main logic happens on the backend. Now let's have a look at the frontend. There we have a React application, and React applications are all about components. Components can be functions or JavaScript classes, and in this course I will use only functional components. In my React the Complete Guide course, you learn about both though. So there you can learn more about React components and different ways of building them. Now here in the Frontend folder, you see that index.js file. This is in the end the entry point for our frontend application. This is where we render our React app, which is imported from the app.js file. So let's maybe have a look at that. Here, this is the JSX code. By the way, if you've never seen this before, this looks like HTML. It's HTML in JavaScript, an invention by React in the end. It's called JSX, and it is transpiled to valid JavaScript by the build setup, which we use behind the scenes here with our npm start process in the front end. This is simply a special syntax which allows us to write code which is translated to instructions that should insert or remove elements in the DOM in a highly readable way to us developers. So here what I get is I'm rendering a couple of React components, header, new product, product list. These are all React components. And also some default HTML elements like main and paragraph based on certain conditions, for example, if we're currently loading or not, and I'm passing some data to my components. Now these components are all imported here at the top, and you can find them in their separate files. For example, a button component, which wraps the native HTML button and adds some extra styling. The input component, which combines a label and input element and adds extra styling and behavior. The header component, which looks like this, and some product-specific components. For example, our new product form here, our product list, and a single product item. This together is responsible for getting onto the screen what you saw there. And in case that's totally new, besides that React the Complete Guide course I would recommend to you, you will also get that brief refresher I also already mentioned multiple times. Now in app.js, we also got more than just our components which are rendered. We also got some front-end logic, so logic that decides what should be shown on the screen and which also is responsible for sending these background HTTP requests to our, backend, which is our Node.js Express server. Now you see that logic here in the app function, in this app component, and there I use a feature called React hooks. These are special functions provided by the React library, which help us with managing state, which is data that when it changes leads to a re-render cycle of the component, so which basically tells React to update the real DOM if the data changes. And we also use the useEffect hook. This is in the end a hook which allows us to run some code when certain pieces of data change. And here specifically, I configured it to run when our application launches, and only then. Now here in this when the application launches code, I in the end reach out to the backend. The fetch API is a native JavaScript API built into browsers. I send a request to this backend URL here. It automatically is a GET request, and this is a combination which is supported there, get to /products. As you can see in the backend code, triggers this function. And then I expect to get back an object which has a products array, which I indeed do send back here on the backend. And I extract that response, then access this products key and set my loaded products, so this loaded products state data, to the data I got from the backend. And as I mentioned, this state data is special. When it changes, React will re-render the UI, which is the reason why when this loading finished, it swaps this loading keyword here for either our products or this fallback text. I also got the add product handler function, a function in a function, which is totally fine in JavaScript. It is supported in JavaScript without any special tricks. And in this add product handler here, I in the end build a product object and then also send this to the backend, but to a different URL /product and also with a different HTTP method. The default one is get, but here I override the default to set it to post. And post to /product, that is also supported on the backend, and it triggers this function here. Now there I attach my data, and send some extra headers to let the backend know that I'm sending JSON data. This is a helper method available in JavaScript to create JSON data. I check if the response is okay. Otherwise, in the end, I will show an alert. For example, if invalid data was entered in the inputs. And if everything is fine and we stored our data in the backend, I update the products I work with on the front end to re-render the UI and reflect that newly added product. This is what happens here. Now again, more detailed refreshers on the ends will be provided later, but I hope that with that this big picture is clear in general. Now, as I mentioned multiple times, we'll build a complete app throughout this course from scratch. You just get this finished app here. Later, we will build it from scratch, no worries. And therefore, then you will learn how these pieces are built and how they work together. But the general structure should already be clear right now with that big picture here. So we got a basic idea of how the MERN stack works and how the different pieces work together. As I mentioned throughout this course, you will not only get refreshers about the individual building blocks, but most importantly, we'll build an entire application where you can see all these pieces built out individually and then come together when we connect all the different blocks with each other. Now, this project which we're going to build is a project we of course have to plan before we dive into it. So in this module, I want to plan a React, or specifically the entire MERN project with you, because this hopefully also helps you approach your next project and get an idea of what you might want to keep in mind, what you have to think about before you get started, and how you can create a plan for the thing you're trying to build. Now, for that, there are a couple of general planning steps through which we'll walk in this module, so that by the end of the module, we have a clear plan of what we want to build and how we want to build it. The first step for that, of course, is that you need an idea. You want to solve some problem. That often or typically will not be a step you have to think about and specifically dive into, because more often than not, you will have an idea and then you want to start planning an app that solves the problem or that works on that idea. So this is only a rough first step, which typically can already be checked off the list by the time you're getting started. So the next step, the real first step after you have an idea, you want to solve a problem, is that you create a design. You sketch out the application you want to build. At least this is what I like to do if I'm building a front end. And that, by the way, is really important. The steps I'm giving you here are not the objectively correct steps you have to go through whatever you're trying to build. These are the steps that work for me. For you, the order might be different. Maybe you have some other step. Maybe you don't need a specific step. I'm really just sharing my personal approach here with you. So I got an idea and now I want to create a design. I want to sketch out the application. Now, when I talk about creating the design here, you could really work with design tools like Framer X or SketchUp or Photoshop and build your design there. Now, I'm not a designer and this is not a design course, so we're not going to do that here. Often, this is also a task you will probably outsource because chances are you want to focus on writing the code and you also are not a designer. Hence, here in this module, we'll just draw the general skeleton. We'll sketch out the application. We'll not really set up a specific design for this application here. Of course, we want to make sure it looks nice, but that's something we'll do when we implement it. I already prepared some nice styles and colors for you there. So once we got the general skeleton, we sketched out the general front end of this application, we of course also have to think about the data we work with, both in the front end, but also more importantly on the back end of our application. So we want to plan our data models, the data we or our app will work with. Which entities do we need and which data do we need to send across the wire from frontend to backend and then also from Node expressed to the database. This of course is a crucial part because that is a part that will affect all building blocks of your MERN application. Now, once the data model is clear and we got our front end sketched out, we of course have to plan our backend endpoints and the pages. You could put that into quotes because we don't really have more than one page, but the different components you could say you want to have on the front end in your single page application. These are the steps I want to go through together with you. We'll do it here in this module, and this is my rough planning process I go through whenever I approach a new project. Now, obviously, you can do way more work on all these steps. You can also come up with a complete design on your own. But as I mentioned, since this course is not primarily about designing and so on, I want to keep this module short and just give you a general idea of how this works. So let's dive into the first step, which is the idea which we need. Now, as I mentioned, often this is a step you can skip or which is skipped automatically because you already have a pretty clear idea of what you want to build and which problem you want to solve. In this course, I want to build an app with you where users can share places, their favorite places or any places they feel like are worth sharing, where each place has an image and a location and a title and so on with other users. So they can share it with other users. Or put in other words, if you're a user, a visitor in this application, you can view a list of users, you can click on a user, and then you see the places this user shared. The great thing about this app is that it's not too complex, and yet it has all the important pieces you want to have in such a demo app, which you will probably also need in the apps you're trying to build after this course. Specifically, we have all the core CRUD operations in there. So create, read, updating, and deleting will cover all of that. We'll be able to create users, create places, get users and get places, which is basically reading the data, update places, and delete places. So that's all in there, which is super important. In addition, we have more than one data model. We have users and places, and that helps us work with relationships as well. We also work with images, and hence we'll cover image upload, which is also a very important topic. And of course, we'll also validate user input to make sure that only valid data ends up in our database and on our backend in general. And last but not least, we'll have authentication and authorization in this course. The difference is that authentication means that users need to sign up or log in to work with some parts of our app. In this example, new places should only be creatable by logged in users. And authorization means that even if you are a logged in user, you're still not able to do everything. For example, in this app, updating or deleting places should not be possible for all authenticated users, but only for the users who created that place. So we got a lot of core important things in this app, which is why this makes for a great demo application for this course, and which is why this is my idea for the course project. So let's now have a look at the design sketching part. And as I mentioned, we'll not worry too much about the design when it comes to picking colors and so on. There I will just provide you some colors I came up with in advance. Instead, here I now want to focus on sketching out the front end of this application. So how this app should roughly feel, how the pages are connected, what should be visible on the user interface. For that, you can now have a look at my amazing drawing skills. Not, but I hope it will still be helpful. So what do we have in the front end of this application? Well, it all starts with the page we're visiting. And by the way, I'm drawing the desktop view here. We'll also build this application such that it looks and works great on mobile. But here I'm just sketching out the desktop view. So we'll start on some page where we probably want to have a header with some title of our application. So the name of the app, our brand, something like this. And then also some menu items on the other end of our header here. Now I'll come back to these menu items. Let's think about what we see on the starting screen. There, I want to have a list of users. So a couple of list items in the end, which simply are rendered beneath each other, where for every user we have like an image of that user, the name, like max or menu, and then the number of places of that user. So the number of places that user shared. So maybe here I shared 2 places and menu shared 1 place, let's say. And of course we have more users here. So that's the starting screen. Now, when we tap a user, something should happen. Before we think about that though, let's talk about the menu items I want to have in the header. There, it depends on whether we are authenticated or not. If we are not authenticated, then here in the header, I want to have an authenticate option. Here I'll just name it auth. You could name it login. So basically an option which we can tap to be taken to the authentication screen. If we are authenticated, then here I want to have an option to create a new place. So to be taken to a screen where we can simply, well, create a new place. I also want to have an option which should always be available, and that's basically the users list. So this starting screen here, that should always be available no matter if we are logged in or not. We could also say that this option, when we tap this, is basically also happening if we tap the title, because that is our starting screen of the app. So these 2 options here are basically equivalent, we could say. I think that would be a setup which should generally work. But now let's see what happens when we tap a user here. So when we click our user here, like menu, then I want to be taken to a new page. Now on that new page here, which is loaded, of course we have the same header as before with the title and with our different menu options here. I'm not going to write them out again. These are the same options as you see up there. So instead, let's focus on the main area of this page. What do we see there? Well, menu has 1 place, right? He has 1 place. So here I expect to see that 1 place. If you had more places, then I would expect to see a list of these places here. Now, that place should have an image, and we'll see how exactly we create this. We could have the image at the top here, for example, then the title, and then also options that allow us to interact with that place. For example, we can have a view on map button here. The idea is that when we click this or when we tap on this option, we open up this place or the location of this place in a modal, so in an overlay to the screen, where we can see that place marked with the help of Google Maps. In addition, I want to have 2 other buttons on the right here, an edit and a delete button, which we only see if we are the creator of that place. So that's only visible if creator, so if menu in this case, so if the logged in user who is viewing this screen is also the creator of that place. Otherwise, only the view on map button is visible. Now when we tap that view on map button, as I said, I want to open an overlay which has a map, so which uses Google Maps to display the place on the map with a marker. That's the idea. What should happen when we tap this view on map button. So this is roughly how that could look like. We might also add a description so that we have the title and description here, but that's my general idea. The idea is not that we can tap this place to be taken to a new screen where we then view all the details, but that we can see all details or reach them, like in the case of the map, from this screen. But of course, that is something you could build differently. It's just the approach I want to go with here. Okay, so that is our list of places where we can also view place details. We get there from our list of users because every place is mapped to a user. So we have to tap a user first before we can see the places. Now, what about the other buttons we have there? The off button and the new button up there. Well, let's start with the off button. When we press this off button, I of course, again, want to have my header up there with the same menu options we saw before. But then here, I want to have a form where the user has to enter some data, namely the email, the password, and also any other data we might need. For example, also a button which allows us to pick an image and so on. This all should be here. And then we need a button which allows us to log in or also switch the login mode so that we can basically toggle between login mode and sign up mode. And this will also affect what we see up there. So when we're in login mode, we of course only have to enter email and password. If we are in sign up mode, we will also need to provide the image and the name of the user and so on. So that's the authentication form, which we only are able to reach if we are not authenticated yet. Now, what about the use case that we are authenticated? Well, then we can, of course, press this new button here in the menu and go to a new page where we also see the good old header, but where we then can create a new place. And that is very similar to the authentication page with totally different fields, but the idea is the same. Here we have input fields to create a new place, also our image picker for the place, and so on. And then, of course, a button to add that place. That is the general idea here. We simply have a page which allows us to create a new place. Of course, when we tap this add button or when we tap the login button down there, we send a HTTP request to the backend where we will then basically send or attach all the data we picked here in the form. And then on the backend, we can extract that data and create the user, create the place, and so on. Now, creating a new place is one thing. We also have this edit button here, right? So when we tap this, we also want to go to a new screen. And that should be a screen with the good old header we already know. And on that screen, I also want to see a form, a shorter form though, where we can edit some data, specifically the title and let's say the description of a place. Not image and address, but these two fields should be editable here. So we basically have like a shorter form of that create new place form here. We have a, well, shortened form to update title and description. This is what we could have here. Now, when we click the delete button, I want to open up a modal where we have to confirm the choice and basically have a chance to cancel the deletion process in case we click this button accidentally. Well, and that is my beautiful drawing, which basically lays out the front end of this application. Now, I can guarantee you it will look prettier than what I drew here, but this drawing here, this skeleton, which I sketched out here, basically gives us an idea of the flow of our app and how users can navigate through it. It gives us a rough first idea of the pages and components we will need there, and it basically helps us build the right application, the right React application for the app we want to build in the end. So that's my sketch for the front end. Now let's analyze which data we got in our application and which endpoints we need on the back end. Now we have an idea of how our application should roughly look like. Which data are we going to work with? Well, there are two main entities we heard over and over again in the last lectures. We have users in this application, and of course we have places. Now it's up to you which exact data you want to have on your user model and which exact data you want to have stored in your places. For me, in this demo application I came up with, I want to have users who have 4 key fields or attributes. Every user should have a name, an email address, a password, and also an image. Now, name and image are optional. We'll definitely need email and password in order to implement authentication, which of course requires an email-password combination. Now, for the places, it's also up to you, but there I want to have a title and a description for every place, a human readable address, so basically street name, city name, a location, which is a pair of coordinates, latitude and longitude, and also an image. Now, besides these two standalone entities, it's important to understand that of course they are related. Every user can create multiple places and therefore owns multiple places. And on the other hand, every place belongs to exactly one user. So implementing this relation and updating it correctly will also be a part of the application we're going to build. So we know about our data and how the front end should look like. Before we plan the different routes we want to have on the front end and which pages we need there, let's have a look at the back end. Which API endpoints will we probably need there? Well, since we have two main data models here, user and place, I got two main endpoint areas. Let's say we want to accept requests which reach our backend domain.com/API/users, and then there are a couple of specific routes which all start with API users, specifically /nothing. If a GET request reaches our backend domain/API/users/nothing else, then I want to return a list of all users. We'll need that for the page where we display all users and the number of places they created. If we send a post request to /API/users/signup, then I expect to have data attached which allows us to create a new user, and then after this creation succeeded, also automatically log the user in. And you will learn what logging users in means in the context of a MERN app in the authentication module. When we send a post request to /login, we'll just log the user in. So I expect to have a password and email attached to that request. And then we'll skip the creation part because we assume this user already was created. We just try to log the user in. So these are our user related routes. But of course, we also have places. So let's say for requests which reach our domain /API/places/user/UID, if that's a GET request, then I want to retrieve a list of all places for that given user ID. So the idea here simply is that we are able to get all the specific places a user created. If we get a GET request to just API/places/someplace_ID, then I want to get that specific place by that ID. And important, both UID and PID, which have this colon in front of them, are dynamic segments. So what exactly is part of the URL here is up to the front end. This will be interpreted as a user ID or a place ID though. Now, if we send a post request to just API/places/nothing, then I want to create a new place, and I expect that the data which is needed to create a new place is attached to that request. If we send a patch request to /API/places/someplace_ID, then we want to update that place by its ID. This request will carry data in its request body as well. It needs to carry the data which we need for updating the place, namely the new title and the new description. And of course, updating is nice, but sometimes we also want to delete a place, and therefore I also want to have a delete route where we accept a delete request targeted at API/places/someplace_ID, which will, well, delete that place by its ID. These are the endpoints we need. We have all the CRUD operations in there, we have authentication in there, and we will build them out step by step throughout this course. Now let's have a look at the front end. We already sketched it out, but now let's plan the specific page components we need there. So on the front end, we got a couple of pages, and namely when we open the app, when we just visit this website for the first time, we are on mycoolpage.com/nothing. What should be visible on this starting page? Well, I want to show a list of users there. So this list of users where we can click a user to then be taken to the places of that user. Speaking of that, we need a route, and now these are all front-end routes which are interpreted by React, or to be precise, a library that supports routing in React and which will not be interpreted by our backend. So we also want to have a route there on the front end for some dynamic user ID, which we don't know in advance, /places, which should load all the places for that specific selected user. I also want to have a /authenticate or /auth route, which shows us a page that holds the sign up and login forms between which we can toggle, and also a /places/new route, which shows us a new place form. In addition, we need a /places/someplace_ID route, which leads us to the page where we see the update place forms, so where we can enter the new data for a selected place. Now, on the front end, not all pages are visible all the time. The list of users is always reachable, and so is the list of places for a selected user. These are always reachable no matter if we, the visitor of this page, are logged in or not. The only difference is that when we're viewing the list of places, when we're not logged in, or if we are logged in but we didn't create the places we're looking at, we'll not see the edit and delete buttons. We'll only see those if we are logged in and we're the creator of a given place. Now, if we are trying to authenticate, this page should only be reachable if we're currently not authenticated. Because if we are authenticated, it makes no sense to try to log in again. We already are logged in after all. Now, for a new place and update place, it's the opposite. These pages, these front-end routes, should only be reachable by users who are authenticated, so who did log in or who did just sign up. And these will be our front-end pages. Now, you don't need to memorize all of what we walked through in this module. Instead, I hope that this module just helps you plan your next project. We will now go ahead and implement all these different things step by step in the different modules of this course. This is just our general agenda, and with that, we're well prepared to start working on the real code. To ensure that we're all on the same page and we all have the basics of React down, let's now have a brief refresher on React.js, understand what it is all about, how React generally works, and how you build modern front-end web applications with React. Now, one important note though, this does not replace a complete React course. It's only a brief refresher, having a look at some of the core fundamentals that make up React. I definitely recommend that you also have a look at a dedicated React course, like my React the Complete Guide course, if you want to learn all about React and if you want to ensure that you get the most out of this course as well. We're just having a brief refresher here. Now, in detail in this module, we'll have a look at the React.js basics and understand how React works there and how we can build web applications with React. We'll also have a look at how React manages state and stays reactive and what makes up React in the end. And with that, let's dive right in. So, what exactly is React.js? It's a JavaScript library for building user interfaces. And as such, it's all about running JavaScript in the browser. It's a JavaScript library for browser-side JavaScript code. It's not a Node.js library. It's a browser-side JavaScript library. Now, to be precise, React.js itself is referred to as a library because it's very focused on that user interface thing. But it actually started a huge ecosystem with other third-party packages that, for example, help us with app-wide state management or with routing, front-end routing, and therefore effectively you could also call it a framework, I would argue. But these are semantics, not too important right now. Let's instead understand how React works and how we use it. React helps us build user interfaces that are shown in the browser, that run in the browser, and therefore we use it to build the front end of web applications, what the user sees. React does not run on a server. React does not communicate with databases. We use it to build highly reactive modern user interfaces. And we do so by following a declarative approach, which means that in React we rather define the result and maybe different states of the result and under which state we want to render what and want to show what on the screen instead of the steps that lead to the result. That would be an imperative approach, which is basically what we have if we use vanilla JavaScript, where we have to define every step, add this element, add this CSS class to an element, remove this element. This is what we do in vanilla JavaScript. And this can be very cumbersome in very complex user interfaces. We typically don't want to do that if we're building bigger applications, because managing and orchestrating all these steps and ensuring that when something changes, we execute the right steps is very error prone and takes a lot of effort and work away from our actual business logic and from building nice user interfaces, and instead forces us to spend a lot of work on JavaScript primitives, on reinventing the wheel, and so on, and we don't want to do that. So in React.js, we instead focus on the result, and we do so by using components. Components is a concept introduced by React. Basically, these are UI building blocks, which we define, and you will learn how you do that in this module, of course, which we define, and then we compose our user interface from these components, and every component can also define what it should render under which circumstance, and React will then magically wire up everything behind the scenes and implement all these steps in the gray box here for us, so that we don't have to write the steps, we just define the results. This is React.js in a nutshell. Now let's have a look at how it actually works when we write some code. For this, attached you find a starting project. This starting project was created with Create React App, a tool created by the React team in the end, which makes it easy to spin up new React projects and give us a project structure like this. I adjusted it a little bit, but generally it's exactly the same you would get from this tool. Now, why do we need such a tool? Why don't we just import a script in a HTML file and get started? Because React is a bit more complex than vanilla JavaScript. In the end, we ship vanilla JavaScript code, but the way we write the code is a bit more convenient to us as a developer. We can use certain features which wouldn't run in the browser, and therefore this project setup here has a couple of tools included which take the code we write as a developer and actually convert it to code that runs in the browser, so that we have normal code that is executed in the browser, but we have an easier time writing that code as a developer. In addition, we get a development server, which is a simple server that serves our front-end application, so which has no backend, only serves that front-end application, and which automatically reloads or injects changes whenever we change and save something in one of our source code files. In addition, here with React, we're building a single-page application. That's not a must-do, but it's a common choice. In a single-page application, you only have one HTML file, which in the end is returned by the server serving that application, in this case, this HTML file, which itself is relatively empty. But this file will then later include script imports. They will be added automatically by these tools I mentioned earlier, which in the end host and run our React application, which we in turn write here in the source folder with our files we got there. So that in the end, we have a web application, a front end, which consists of one HTML file, where then JavaScript is used to render something on the screen and re-render that something on the screen when it's needed. And that allows us to build highly reactive modern user interfaces where everything happens instantly. Because JavaScript runs in the browser, things happen instantly. We don't need to wait for a new HTML file to be downloaded from a server. Instead, everything is already there. So when a user clicks a button and we want to show a box on the screen in response to that click, boom, it happens instantly because of JavaScript. That's the feeling we want to provide, and we can do that with React. Now, enough talking about the theory, let's write some code. As I mentioned, we do that here in the source folder, where we find an index.js file and an app.js file, both very simple files. Now, let's have a look at the index.js file. There you see we have a couple of imports at the top. This is, by the way, how you import code on the front end. Import something from, and then either a relative path to your own file, or if it's a third-party package, just the package name. And then here we have imports from our own files with a relative path, as I mentioned. And then here we are executing one command in the end, React DOM render. Now this is coming from the React DOM object here in the end, which we're importing from the React DOM library. And that renders this strange thing, which is not regular JavaScript, into this place on our HTML page. This is regular JavaScript, and here we are selecting the element with an ID of root. If we have a look at our single HTML file, that is this div here. So that is in the end where our React single page application will be hosted to, and thereafter React will take over and render everything in that place. So that is what we're doing here, but what is this strange thing? Now for that, we need to understand what components are and how React works. So we learned that we have this index.js file, and I can tell you that this file in the end includes the code which executes first when we start our app, and that this renders this strange thing into the place of this div here. Now what is that strange app thing here? We're importing app from this app file, in the end from the app.js file, because extensions are added automatically on the imports. And there, what we have is in the end a JavaScript function. This is a regular function, an arrow function stored in this constant. And then we export this constant and therefore this function. Pretty straightforward. But the thing inside of the function is not straightforward. What we return here looks like HTML, just like this looks like HTML. But it's in a JavaScript file. It can't be HTML, right? You can't add HTML in a JavaScript file. That's a special syntax invented by the React team. It's called JSX, and it allows us HTML-looking code in JavaScript files. And under the hood, this will be translated to instructions React understands. In detail, this here is similar to React create element, a method provided on this React object here, and then here h1, and then here null or an empty object, and then as a third argument your text here. For example, hi, this is React. Different text than before, but it will render something similar on the screen. This will yield the same result, and I can prove that to you if we simply start our development server and try to see this app in action. To start it in the package.json file, we find a script, the start script, which already exists there. And this will in the end use that tooling I mentioned earlier to then transform our code and to start up a development server, which automatically reloads or injects changes when we change something. So here we can open up a new terminal integrated into this IDE, and there run npm start to bring up that development server. And you should keep that server up and running as long as you are working on your code, because when you close it, you can't preview your page anymore, your app anymore. Now, when you start this server, when you run npm start, it should automatically open up a new tab in the browser on localhost 3000. If it doesn't, simply do so on your own and visit it. And there you should see, hi, this is React, which clearly is the text I entered here. So in the end, this here is React syntax, and we could write our entire app with this syntax. But this gets very cumbersome, especially if we start nesting elements into each other. That is why React gives us this alternative JSX syntax, which in the end is just translated to React create element and then what I just showed you. That's also why we need to import React here, even though it looks like we're not using this React object anywhere in this file, right? We have this React text here, but that's something different. So we're not using it anywhere in this file. Well, it gets used implicitly because this is just syntactic sugar in the end. It is translated to that other syntax I showed you. And that is what React is all about. We tell React which elements it should render. And under the hood, it then will translate this into commands that the DOM understands, that the browser understands to render real DOM elements. Now, for example, if I add the title here, which gives us this tooltip that's built into the browser basically, this works. And I save this, it automatically reloads. You don't need to do so on your own. And if you now hover over this, you see this tooltip. This works. Very small here, but you can see it if you test this on your own system. Now, this works because that in the end is translated to React create element h1, then this object which we previously left empty. Here we set the attributes or the properties we want to set on that DOM node which is created here. In this case, title to this works. And then thereafter we have the text. This is how this works, and React will do everything it needs to do. It will create this element, it will set all these properties or attributes here, and it will render the last argument here inside of that created element. And that's also the part where this JSX code helps us, because if in here we have, let's say, another HTML element, we would have to nest multiple React create element calls into each other, which quickly becomes very hard to manage. That's why this JSX syntax here is a great idea, a great invention. So we will use this syntax, and we also use it here in index.js. The difference is, though, that here we don't use it with a normal HTML DOM element, but instead here we use a custom function, because we are using what gets exported in the app.js file. And what we export there is a normal JavaScript function. Well, that is one of the most important concepts of React: components. React is all about components. Now, what does this mean? This function here is of course a regular JavaScript function, but it's also a React component. What makes up a React component? A React component can be one of two things. It can be a function which returns JSX or returns React create element calls, or it can be a JavaScript class that has a render method. So this here, if I change this, would also be a React component. Class app extends React.component. That's important. You have to extend React component. And then you have to add a render method. And in that render method, you return JSX. This is a regular React component as well. And if I save this, you therefore see the same output as before. It works in basically the same way. There are some technical differences, which I discuss in detail in my React to Complete Guide course. Here, it doesn't really matter. In modern React, you can use functional components only, so function-based components, and that's therefore what we'll do in this course. We'll write every component as a function. It's not a must-do, and as I mentioned in my React to Complete Guide, you learn about both types and how they differ, but using function components only definitely is a modern way of using React, and it is therefore the way we will use. But always keep in mind that this is just a regular JavaScript function. What makes it a React component is that it returns this JSX or this React create element logic in the end here. If we return, let's say, an object instead, this would not be a React component, and hence you get an error if you save this. It really has to be JSX code, something which can be interpreted as JSX, like this here. This is how React works. And therefore here I am exporting my own component because this is treated as a component, and your own components can be used in JSX as well. The only important thing there is that they should start with a capital character in the file where you use them in JSX, because this tells React that it's not a built-in HTML tag. App wouldn't be a built-in tag, but that it's a custom component. And this information is important to React, and therefore start with an uppercase character, but then you can use any custom component in JSX. And the cool thing now is that we can build up our application from small reusable components and compose our user interface with the help of such components. And with that, why don't we do that? Why don't we build a simple first React application and see how things work together there? Now, in this refresher course module here, we'll not write a complex React app because that's simply not the idea of this module. We will write a realistic app in the main module later in this course, after this module here, where we will work on the course project. So that's just a refresher here, and I focus on the core React elements therefore, and not on building an amazing application. So React is all about components, and therefore typically we split our app in components. Now let's start without splitting it though, and instead of outputting a h1 tag, here in app, I will use a div, let's say, and in that div, let's add more HTML code. I'm saying HTML here. Of course, it's JSX, but it is translated to HTML, to DOM nodes in the end, right? But it is JSX. So here we could have a h2 tag where we say course goals. And below that, we want to have a list on, or the list of our course goals. And there, a goal could be that we want to finish the course, that we want to learn all about the course main topic, and that we want to, let's say, help our students in the course Q&A section. And that could be some goals. Now, a very trivial application. Now, I don't have any special spectacular styling here, which is why we save that and we get this output. Now, I will add some styling, and for that, I will add a app CSS file here and import that file into the JavaScript file. This, of course, is not possible in vanilla JavaScript, but because of that under the hood tooling, which in the end analyzes our files and then transforms the code, this is possible, and this is simply transformed to inject this CSS code into the HTML file as well. Now here, I'll give this a CSS class, and there is one special thing. The class attribute like this doesn't exist in JSX because class is a keyword in JavaScript, so it is class name, and this is how you add CSS classes to elements in JSX. This also, of course, is kind of a proof or reminds you of the fact that this is not HTML, but HTML-ish looking syntax. I'll name this class goal list here, and now in here we can define some styles for the goal list here, and I will simply set list style to none here, remove a margin or give it a margin of 2 rem top and bottom, and a padding of 0. And on every goal list item, I will add a margin of 1 rem top and bottom, 0 to left and right, and then simply a border of 1 pixel solid, and then this grayish color here, and a padding of 1 rem. And this is very, very simple styling because I don't want to spend a lot of time on writing CSS styles here. Now, maybe one adjustment. Let's actually give the list a margin of 2 rem in all directions. Now we have this list of our goals. To adjust the course goals here at the top, I will also give this div a class name of course goals. And then in the CSS file, maybe at the very top, we can style course goals, and there the h2 tag to be aligned in the center, just like that. Now, again, very huge goals, but that is okay for this course here. We're just practicing React. So we got these course goals here. Awesome. This, of course, is a very simple markup. Now, what you often would do in React is you would split this into more components. You would, for example, outsource this list into a separate component to keep every component on its own, relatively lean and focused on one task. For that, we can add a components subfolder here in the source folder. And in there, I will add a goal list.js file. This will hold my goal list component. Now, to create such a new component, we first of all have to import React from React. Otherwise, we can't use this JSX syntax. And then I mentioned that a component is a function. And by the way, you can also create it with the function keyword or with the function expression or with the arrow function syntax I used before, which is the syntax I will use here, but that is not a must do. And then here I export my goal list like this. And now in here, I return this unordered list. So I'll cut it here and then add it here as a return value. And if I reformat that, you see automatically these parentheses are added around it so that this can be nicely formatted across multiple lines. Otherwise, this would not be valid JavaScript. So it is. With the parentheses it is, because then JavaScript knows that this block belongs together. So now we have the goal list in here. And in app.js, we can now import our goal list component. You can name this here however you want. Doesn't have to be the same name as under which you export it here. Only important thing is that it has to start with an uppercase character here in app.js. And I import from the components folder and there from goal list. And as I mentioned earlier, you can omit the file extension here. It's not required. And then here you use goal list like a regular JSX element, like a regular HTML element, you could say. But since we have no content between the opening and closing tag, we can and we have to write a self-closing tag here. This would not be allowed. You always have to close tags in JSX. So this would now be my goal list component. And therefore, if we save this, we see the same output as before. We also get the same styling because styles here are always applied globally, even if you import them into a specific component file. And still, it is a good practice to set up the styles in the CSS file next to the component they belong to. Hence, I will add a goal list CSS file add my goal list styles there, and import that goal list CSS file into the goal list JavaScript file. This is not a must do, but it makes it easy to find the styles that belong to this component. Keep in mind that styles are not automatically scoped to a component though. The normal CSS rules are applied because all the CSS files, no matter where you import them, are applied globally to your entire page. With that though, we're back to the same result as before. So why did we do that then? Why do we split this up if we have the same result as before? I created the separate component, A, of course, to practice creating your own components, but B also because it really is the core philosophy of React to split your app into smaller pieces. Of course, it's up to you how small you want to split it. Every list item, for example, could also be its own component, and there would be nothing wrong with that. The idea simply is to have small, manageable code files, and later, once we add more logic to the app so that we can also interact with it and we change the number of goals, for example, upon a button click and so on, we of course want to be able to manage a lot of the logic in the goal list component and not in other components. So really splitting it into components has the idea of separating concerns, of keeping your files small, focused, and manageable, which if you're working in bigger projects is a huge win because it makes it much easier to manage and work in such bigger projects. Now, thus far, everything in our app is hard-coded though. Now, more realistic would be that, let's say, our goal list is managed here in app.js as data, and we want to render the goal list HTML items or JSX items based on that data. Now, I'll manage it here in app.js simply because later I will add another component here that helps us create new goals. But for now, let's just add a normal constant here to this functional component because it is a normal JavaScript function. Of course, you can do more than just return JSX. And this constant here will have my course goals. You can name it however you want. And this will be an array. And in this array, each goal can be a JavaScript object created here with the object literal notation. Of course, you could also create your own class or constructor function and instantiate that to create such an object. Now, let's say every goal has an ID, CG1 for course goal 1, and then has some text, let's say. And the text here is simply the text I have hard-coded here. Finish the course. So I'll copy that and add this here. And I'll split this across multiple lines to make it easier to read. Because I'll not just have one goal, but 3. So the IDs are CG2 and CG3, let's say. And now I will just copy all that text here into my objects here in app.js. Also that last text like this. And there I can now also get rid of that ampersand thing here. We don't need that here. We can output the text like this, and React will render it properly. So now we have the course goals array, and my idea now is that in the goal list component, these goals, that data here, should in the end be output. So it should be output dynamically in this component, in the goal list component, instead of being hard-coded. So we can remove this code here. Now that leaves us with 2 problems. Number 1, how can we output a list of data dynamically in JSX? But more important than that at the moment, how can we get that list of data, which is defined in the app component, into the goal list component? Well, let's focus on that first, because without that, we can't focus on the other problem. We can pass data from component to component with a concept called props, short for properties. We can define our own, you could say, attributes, which are these props, on our own components. So for example, here on goal list, we could say we have an items attribute or a goals attribute, totally up to you. I'll go with goals here. And that goals attribute, or prop is the common term, so this goals prop, then passes data to that component. Now for that, I don't use a string here, which I want to pass down, but instead I want to pass down my JavaScript data structure, the array here. And for that, here actually we use another special syntax in JSX. We use single opening and closing curly braces. Looks like we're creating a JavaScript object here, but we are not. If you do this inside of JSX, which I am doing here, that's JSX, then this means you wanna merge your JSX code with some JavaScript expression in the end. And here we can point at course goals. That is a valid JavaScript expression. We're just pointing at a constant. And what this in the end means is that React will pass course goals here, the value stored in this constant, in this case this array, into this place of JSX. In this case, into this prop, therefore. So goals will be a prop that holds a reference to this array now. Now, inside of goal list, we can now receive that goals prop. So let's go to goal list and see how that works. In goal list, we have a function, right? A functional component. Now, this function right now doesn't get any parameters. We can change this. We can receive a props parameter here. Every function that is used as a React component, which means it returns JSX, also receives props. This is an object passed to your React functional component automatically by React. And it's an object that bundles all the props you passed to the component. So in our case, goals is the single prop we have. So here we will have an object which has a property with the name of goals that holds the value passed to that prop. So in other words, here I could console log props.goals. .goals because I named my prop goals here. If you chose a different name here, which is perfectly fine, you have to use the different name here. Now if we save that, we won't see our goals anymore at the moment. But if we open the developer tools, we see the array being logged here, and that log is coming from goal list line 6, as you see, which of course is this log here. And there we see our goals data, which means, yes, it arrives successfully inside of the goal list component. The concept of props is a super important concept in React because this is what allows you to pass data from component A, the app component, to component B, the goal list component in this case. Now let's have a look at how we can output a list of data dynamically in JSX, because here we got a list of goals, an array of goals, and we want to output this as list items here in our unordered list. How can we output an array of data as JSX elements? Well, actually, it's relatively trivial. We will map this array of JavaScript objects to an array of JSX elements because React is capable of outputting an array of JavaScript elements. For that, let me show you how this works. Let's use these single curly braces because I want to add a JavaScript expression here. And my expression here is a simple array, but an array of list items. Hi, and then another one. This works. I output this in my JSX code with the single curly braces because this here, of course, is not JSX, it's an array, but it's an array full of JSX. And if I save this, it outputs hi and this works. We get an error or a warning, which we can ignore for now, but this works in general. Now, since this works with hard-coded data, we can also output our array of goals. So we can output props goals here. But the problem is that props goals is in the end an array of JavaScript objects, not an array of JSX code. So if we try to output this here, it will fail. It tells you that objects are not valid as React child or as React children. So in the end, we can't output plain vanilla JavaScript objects in JSX. Instead, we need to map every object into a JSX equivalent, so into a renderable element. So here we want to map every object into a list item in the end. So on props goals, which is an array, we can call the map method. That's a default vanilla JavaScript method that exists on any array. The map method takes a function, here I'll pass in an arrow function, which is executed on every element of the array you call map on, and then this function here will return a transformed version of that element in the original array, and overall map will then return a new array full of these transformed data pieces. So this function will therefore receive the existing element here, so every goal in our goals array, and then returns a new element. So in this new array returned by map, I want to have a bunch of JSX elements. So here I will just return a list item which is JSX, of course. And in the list item, I want to output my goal text. Now, goal here is that JavaScript object we have in the original array, because this function runs on every element in the original array and gives you the object in the original array or the data piece in the original array as an argument. So goal here is that object which looks like this here. So I'm only interested in the text here. And again, we can output the text by outputting a JavaScript expression here. Hence, we need the curly braces in our JSX code here. And we have goal.text here. My expression is that I access the text property on the goal object. So now what happens here is I map my array of plain JavaScript objects to an array of JSX elements. And such an array of JSX elements is renderable, as you learned. So now if I save this, you see this outputs my course goals again. Now we also get a warning regarding a unique key that is related to how React re-renders the DOM and that it wants to do this efficiently. You learn more about that in my React the Complete Guide course. And therefore, whenever you output lists of data with this technique, you have to add a special prop to every item you are rendering in that list, in this case to every list item, and that's the key prop. That is a prop React itself understands, and here I want to output goal ID, again wrapped in curly braces because this is a regular JavaScript expression. So now with that we don't get the warning and we get our course goals. So this is how we output a list of data. With that, this is looking pretty good. We're outputting our list of data. Why don't we now work on adding some functionality that allows us to add our own goals? That would be a nice next step. To output our own goals, I'll add a new component in the components folder. And to keep it manageable, I'll actually create a new subfolder for every component. This is not a must do, but I personally like doing this because then I can quickly find all my components. Of course, you now need to adjust your import here in app.js. My IDE did it automatically. In case that did not happen, make sure you adjust your goal list import to reflect that new folder I added. And then I will add a new goal component here in the components folder as well. In there, add a new goal.js file and a new goal.css file if you want to apply some styling. Now in a new goal.js file, we first of all need to import React from React. You always need to do that, otherwise you can't use JSX in that file because, keep in mind, JSX is translated to React create element. And then here I have my new goal component here. We could accept props, but as long as we don't need them, we don't have to. And then I export new goal. Now in app.js, I want to render new goal. So I will import new goal. Again, the name here is up to you, but it should start with a capital starting character. And I import this from components, new goal, new goal. And then here we can render this above our goal list, let's say, like that. Now this wouldn't work because new goal is not yet a valid React component because it's a function right now, but it's not a function that works as a React component because it's not doing one crucial thing. It's not returning JSX. So let's return some JSX here. And there, to keep things simple, I'll add a form. And in that form, I'll add an input field. Type text, self-closing element. In regular HTML, this doesn't have to be self-closing. In JSX, it does have to be self-closing. And then a button, which is of type submit, where I say add goal. A very simple form. And if we now save that, you should see it here. Now let's add some styling to make this look a bit prettier. For that, I'll add a class to the form, new-goal, and I'll import the new goal CSS file into the new goal JavaScript file. And then here on the new goal class, which is added on the form, I'll add a margin of 2 rem in all directions and text align center so that this looks a bit nicer. And now we could also style the input and the button, but I don't want to spend too much time on that, so I will leave it the way it is. Now right now when you click the button, by the way, this page will reload because right now the default browser functionality will kick in, which is that when a button of type submit is clicked in a form, a request is sent to the server that served this page. Now that's not the behavior we want here though, because here I don't want to send a request to any server because we're not doing anything on the server side. Instead, I want to handle that click with JavaScript. And that is the first thing I'll do here. Let's see how we can handle events, because thus far we haven't done that. I want to handle the submit event of this form here. And React makes that simple. We can add event listeners to any element, not just to the form, but to any element by adding on, lowercase on, and then the name of the event. Now, not every event is supported on every element, but here you got the default HTML elements available. So for example, on a form element, you have the submit event, on submit. On a button, you also have on click, but since it's a button in a form, it's better to handle this on the form itself. Now, what do you pass as a value to onSubmit though? As a value, you have to pass a function that should be triggered when this event happens. So a pointer to a function. You could do this here with curly braces and then an anonymous inline function, but I don't like that too much. Instead, I will create a new function here. And in JavaScript, you can create functions in functions. So instead of the new goal function, which it still is in the end, I can create a new function. I will create my add goal handler. Now the naming is up to you, but I like this naming of having handler at the end of my function name if it is a function that is triggered upon some event. So this is a function. In this case, I'll again use an arrow function, which is not a must do, but I will use only arrow functions here. And onSubmit now can point at add goal handler. Don't execute it here, so don't add parentheses. Instead, you just want to point at the function so that the browser and React, in a common effort, can execute this function for you when this submit event occurs. Now, this function will get an event object, an event parameter, passed in automatically by React. And there, for example, we can call prevent default, which prevents the browser default of sending a request to some backend, which it shouldn't do here because we're not handling this on the server side here. Our server only serves that single index HTML file. It does not have any logic to handle any submissions. Instead, I want to handle it here in JavaScript on the front end in my React application. And for the moment, I'll ignore what the user entered here, and I will simply instead create a dummy goal. And I want to pass that dummy goal to app.js and add it to my course goals here so that it then is rendered here. Now, step by step. We can create a new dummy goal, of course, in that add goal handler by adding a new goal constant here, which is a JavaScript object. The ID here could be a random number with math random. This, of course, is not really a unique ID, but it's good enough, and I'll convert it to a string. It's good enough for our demo application here, I mean. And then the text here later will be the text the user entered here. For now, just some dummy text. My new goal. So now we have the new goal here, and of course, we can console log that to see that everything up to this point works. So if we save that, we see our form here. And if I click on add goal, the page will not reload, but instead we see this dummy goal here. And I can create, of course, multiple goals, but at the moment they're not added to this list. To add them to the list, we now need to get that goal out of the new goal component to the app component. Now before, we learned we can pass data around with props, but that was from app to goal list, so to a lower level component, a component which is included in app. Now it's the other direction. We want to pass data from new goal to the parent component, so to the component which includes the new goal component. How does this work? You can also pass data back, and you still do this with props. The idea just is that instead of having props that pass in data like a string or an array or an object to the lower level, to the child component, as it's also called, you pass a callback function from the parent component to the child component. So no array or anything like that, but a callback function. So here in the app component, we could define a new function add new goal handler. The name is totally up to you. And I name it handler because it also will kind of be triggered upon an event. And here I expect to get the new goal. And then here I can reach out to course goals and, for example, push the new goal into this array. And thereafter console log course goals. Now we have this function, and now we can pass it to new goal via props. So there we could add a prop on add goal. This is now not an event listener React defines. For all the built-in HTML elements, we have built-in event listeners. Like, for example, in the new goal component, on the form, we had onSubmit. On a button, we have onClick. On input, we also have onClick, for example, because you can also handle click events on inputs. You can handle those on any HTML element. Now, in the end here, I called this an event handler. But what it actually is just a prop. Technically, there is no difference between class name, where I pass in a string, and onSubmit, where I pass in a pointer to a function. So in the end, this is just a prop of the form element which React offers to you. So here in app.js, we can also pass a prop here on new goal, which holds a pointer to a function. I just name this prop like this, not because I have to. I could name it add goal or this here, but it's a convention to name props which in the end pass functions to lower level components like event handlers, because the functions you pass down to components in the end will be called by these components upon certain events. That is how it typically works, and you will see that the more React applications you build. So therefore, I follow this convention and name this on add goal and pass my add new goal handler to the new goal component. So I pass a pointer, not the execution, but just a pointer to this function to new goal on this on add goal prop. Now that means that inside of new goal, I can now accept props here. I can accept this props parameter. I always get it, even if I don't get any props. But if I don't get any props, there isn't much sense in explicitly writing it out here. But now I need a prop, which I'm getting on new goal. And that is that on add goal prop I defined here. I want to call that function I receive on that prop here inside of my add goal handler in new goal. So instead of logging the new goal, I can now call props on add goal here. On add goal, because that's the name I chose here. And on add goal passes a pointer at a function to the component. So inside of the new goal component, I know I can execute on add goal because it holds a pointer to a function. So I now execute that function it pointed to. And I can pass my new goal as an argument to onAddGoal, because indeed, in the function I passed to onAddGoal, I expect to get a new goal as an argument, as a parameter. So now if we save everything, we should see that if I click add goal, we're outputting something from app.js line 16, which is this log here, and we're outputting our new course goals array, which are our old goals and the new goal. So passing the goal from the lower level, from the child component, the new goal component, to the parent component, the app component in this case, works. And it works with props. We just use props to pass a function that is then called by the child components instead of passing data directly from parent to child. This gives us a way to communicate back from the child to the parent with help of such a function. So now we're able to communicate back, and we are actually updating our course goals array in the app component. But what you see is, despite the array being updated, and clearly the new goal is part of the array, our output here on the screen didn't change. And that leads us to a core concept of React: state. React does not re-render this JSX code and therefore the real UI all the time whenever some event is triggered anywhere in the app. So just because I click this button here does not mean that React will re-render the entire screen just to make sure it doesn't miss any data change. This is not how React works. Instead, in the end, you have to tell React when it should re-render. And you do so by using a concept called state. This course goals array here is a regular JavaScript array. Put in other words, React totally ignores it. We have to tell React that it should not ignore it, and that instead, whenever we change this array, it should update the UI, the JSX code, of the component in which we changed it. So in this case, of the app component. Now to do that, we import one other thing from the React package, and that's useState, a function built into the React library, a so-called React hook, and you'll learn more about hooks in my React the Complete Guide course, of course, a function which we can execute inside of functional components and only inside of functional components. In class-based components, you also have a state management mechanism, not focus of this course here, but you could also do it there. But in functional components, you use these hook functions, as they are called, all these functions starting with use at the beginning, to manage state. So to manage data, which when changed, should lead to the UI of that component in which you manage the state to re-render. So here in the app component, I now want to call useState, and to useState, I pass this array here. This is my so-called initial state then. I can get rid of that constant for now. This tells React that this component has some state and that this is my initial state. By the way, you can also have multiple different state pieces and they're all watched independently. But here I only have one main state, and that is my array of goals. And I tell React that I have this state and that this is my initial state. Now, of course, I want to get access to that initial state, store it in some constant, so that I can use it in the rest of the component, because course goals is now missing everywhere. So useState also returns something. It returns an array of exactly 2 elements. The first element always is our latest state snapshot, so either our initial state or, once we changed it, the updated state. And the second element of that array returned by useState is a function that allows us to update that state, replace it with a new value, and tell React that it should re-render. So here I will use array destructuring by using square brackets on the left side of my equal sign here to extract these 2 elements I have in the array returned by useState. And there are always exactly 2 elements. So it does not depend on which kind of state data you pass here. useState gives you an array with exactly 2 elements. First element, your current state. So in my case, my array here. Second element, a function to update the state. Therefore, typically we name this set, and then any name of your choice. Set course goals in my case. So now I have 2 constants created with the help of useState. First constant holds my state snapshot. Second constant actually holds a function which we can call to update that state snapshot. And we will call that function here an addNewGoal handler. We can call set course goals here. And now I want to update my course goals by adding a new goal. Now, a simple form of doing that is to simply then use my old course goals and call concat here. Not push, because push modifies the existing item. Instead, set course goals wants a brand new array, which will replace the old array. And concat will also add an item to an array, but it will return a new array to which this item was added. So it gives us a brand new array, doesn't touch the old one, and we then pass the brand new array to set course goals, and React will then use that brand new array to, under the hood, replace the old array in its internally managed state, and it will re-render this component once it did so, and therefore update this course goals constant with the new array in the next render cycle, which in the end means that React will execute this function here. And therefore, when it does so, it will reflect that new data in our JSX code. So here I want to concat my new goal. And if we now save this and I click add goal, you see new goals are added to the list. Because React now re-renders this screen or the parts that need to be re-rendered whenever we update our state. Now, how exactly React re-renders and so on is not the focus of this course. You can learn that in dedicated resources like the official docs or my complete guide. For now, it just suffices to note that React magically and efficiently does re-render the page or the parts of the page that need re-rendering based on the state changes we applied. State is a crucial concept in React, and therefore it's important to me that you understand how it works. Use state is how you manage state in functional components, and your state can be anything. It doesn't have to be an array. It could be some text, a number, an object, an array, a boolean, anything like that. Use state always returns an array with 2 elements, no matter what your state is. If your state is a number, use state still returns an array with exactly 2 elements. Because the first element then always is your latest state snapshot, and the second element is a function that allows you to update that state snapshot. Whenever you update the state snapshot, React will do 2 things. It will update the internally stored state data. So for example here, when we add our first new goal, it will replace the initial state with our brand new state, in this case with the brand new array we created with concat. And once it did update the data internally, it will call this component function again and execute the entire function, and hence also re-render this JSX code. Now under the hood, it will not re-render the entire DOM, it will just check which parts of the DOM need to be updated, but it will re-evaluate the entire component. This also means, of course, that it re-executes use state, but use state internally works such that it only initializes that state when the component is rendered for the first time, and for subsequent re-render cycles, it just pulls out the latest state snapshot and basically ignores the initial value we set up here. This is how state works. Now, it is also important to understand that this way of updating our state in this scenario is not the best possible way. So I'll duplicate it and comment it out so that we still have it for reference, but we also see the better approach. This approach clearly works, and in most cases it will work. But you have to be aware that this whole state updating, re-rendering part of React is in the end managed by React. And when you set a new state, it doesn't pause everything and immediately re-render your app. Instead, it schedules the state update. And if you have an application with a lot of ongoing state updates and a lot of work being performed, which is not the case in this application, but can be the case in other applications, then your state update might be deferred by a few milliseconds. That means that actually maybe if a user clicks add goal multiple times, the course goals which are currently rendered on the screen might not be our latest state, because not all state updates might have been processed yet. Therefore, there is a better form of updating this. Instead of passing our new state data to set course goals, you can pass a function to set course goals. A function which receives the latest state, pref course goals, and has to return a new state snapshot. And React will then schedule all these function calls and guarantee you that they are executed in the right order, so that even if a state update was deferred, by the time the update thereafter executes, it guarantees you the first one executed as well. And then here you would simply therefore return pref course goals, which still is an array, concat new goal. It will yield the same result as before in this app, and in this simple app, this approach would have been fine. There is basically no chance of React deferring updates so long that we would end up with an incorrect state. But this is the bulletproof approach, which will always work. You only need it if your state update depends on the previous state's data, as this one does. If your state update is a new data piece which doesn't depend on the previous state, you can always safely use this non-functional form. And here, side note, we can of course also shorten this, take advantage of arrow function syntax, and get rid of the return statement and the curly braces, since we have only one expression which we immediately return. So now with that, it works as before, but this is a bit of a safer approach and the recommended approach if your state update depends on the previous state. State is a crucial concept in React, and with our knowledge about state, we can now also make sure that we don't just create a dummy goal, but we actually reflect the real user input. So for that, let's go back to new goal. What we want to do is we want to store the user input in some variable on every keystroke, so that we have the latest value entered by the user, and then pass that entered value to props on add goal, or to our new goal here, instead of that hard-coded dummy text we have at the moment. So here in new goal, I want to capture the user input here and send this instead of my hard-coded text here as part of the new goal. So we could create a variable here, user input or entered text maybe, which is an empty string initially. And here on input, there actually is an onChange event we can listen to, which is fired on every keystroke. So now we can add a function, text change handler. There we will get an event object, and that event object will hold the user input on event target, which refers to the input element dot value. And therefore we could set enter text equal to that. Now enter text will change with every keystroke once we bind onChange to text change handler, like this. Now here in new goal, we can use enter text, so what the user entered here, and then thereafter let's also console log the new goal here so that we can see that this works. If we now save this and I enter test here and I click add goal, we see this works and this is output here. This approach is generally fine, but it can have one tiny flaw. What if we want to reset this after adding a new goal? Of course, we can go to our add goal handler, and once we created the new goal, we can of course set enter text back to an empty string. But of course this won't do anything. If I enter this goal, you see this is not reflected here. Why is it not reflected? Because the new goal component didn't re-render. This is not state we're managing, this is a regular variable. So of course we can change it, of course we can use the changed value, but if we then set a new value to it, this is not reflected on our input because this input only has a connection to the text change handler. It does not know that it should reflect the current value stored in entered text. Now we could tell the input component that it should do so by binding its value prop. We can bind this to entered text, and with that we tell the input component, hey, the value displayed in the input should be the value stored in entered text. If we do that, we'll notice something new. Now we can't type there anymore. If I type here, the input is not reflected. Now if you think about it, that makes sense. What you're telling React is that input should be rendered such that the value is the entered text. With every keystroke, we change entered text, but entered text is not state, it's a regular variable. So that means that we change the variable with every keystroke, but React doesn't re-render the input component. It doesn't reflect the updated value. To React, the value always is an empty string, because that was the last time it rendered this component, and therefore this JSX code, and therefore this input. So we need to tell React that this is some state, and that when it changes, it should re-render our JSX code. So again, we can import use state here and convert entered text. Use array destructuring here, and use state is an empty string initially, or has an empty string initially here, because I'm managing my entered text, and the second element is a function to update the state, which I'll therefore call set entered text. And now here on every keystroke, I set my entered text to the value in event target value. And here we don't need that function form of updating the state because we have a brand new value that doesn't depend on the previous state. So we can just update the state like this. And now this will re-render this component whenever we type, whenever we call set enter text, so on every keystroke, which sounds horrible, but which is great. React will do this in a very efficient way. And therefore, this latest value will be reflected on the input element. And here in add goal handler, if we want to update enter text and reset it, we can therefore call set enter text and set it back to an empty string. And with that, we now have the best of both worlds. We can enter something here, that all works, but we also can manipulate it and reset after adding a new goal, like this. So this is now another use case for state management. And of course, there are many use cases in a React application. And here we are using state management to create something which is also sometimes called two-way binding. We're binding the value of the input, and on every keystroke, we're updating the value which we then bind back to the input, so that we always reflect the latest value inside of the input, but we also are able to manage this in a state-driven way so that we also have a chance of manipulating the value from inside our code up here and reflect this back into the input in this case. With that, we have another scenario of state management, and we are now able to add our own goals. This is React in a nutshell. Now there is way more to React, and we'll see way more throughout our course project, where we will build an entire app with React, where we will also add routing and do more complex user input management and so on. But for this refresher, we learned everything we need. Now, as I mentioned multiple times, really also take some dedicated React resources, no matter if that's my complete guide course or the official docs or any other tutorial, if you are serious about React. This course has not the goal of teaching you React from the ground up. I do explain a lot to ensure that we're all on the same page, and I will explain every feature we add throughout this course, but in dedicated resources, you simply get a way deeper and better insight into React, into all its features, including features which we don't need in this course, and how it works under the hood. So that's my strong recommendation. From this refresher, the most important takeaway is that you understand that React is all about components, that components are functions that return JSX or JavaScript classes with a render method, which we don't use here though, that components can receive props to receive data from parent components, that props can also receive functions, pointers at functions, so that the child component, the component used in another component, can communicate back to its parent component, so to the component using it, and that you have this very important concept of state, which allows you to manage data that, when changed with one of the state updating functions, actually causes React to re-render the component and re-render the JSX code and re-evaluate what needs to be output on the screen. This is what allows you to render dynamic content with the help of React. These are all the important takeaways. And again, there is more we will learn and more you can learn about React in general, but these are the concepts which definitely should be clear by now. Now that we had a brief React refresher and we're all on the same page, at least regarding the React basics, let's apply that knowledge and also dig a bit deeper in our main course project and there in the React frontend we're building. So in this module, we'll start building our frontend with React as a single page application, which means everything the user sees, everything in the browser is managed by React, every change there is applied and rendered by React. And then later in the course, we'll build our Node backend and we'll connect React to that backend. But here we'll just focus on the standalone frontend, which therefore, of course, right now won't be fully functional. We won't be storing any data on a server yet, but that will come later. In this module, we will instead build that single page application and dig deeper into React, and you'll have a really nice example of a more realistic React app. We'll add routing and the core pages, which you could also put into quotes because we'll still only have one single page, but we'll add different components and tell React when to load which component based on the URL the user entered, which is really nice. And we'll also split our app into multiple core components, of course, because you learned that React is all about components. We want to keep our components small and manageable, and therefore we'll split them. We'll also add some pure user interface components, which technically still are regular React components, but you'll see that some components are mostly focused on just providing some styling, be reusable, whilst other components will have a lot of logic and state management attached to them, and you will see how that naturally grows as you're working on a realistic React project. We'll also handle user input later. We'll also even write our own React hooks. We only saw the use state hook thus far, which was built in. In this module, we'll also see some other hooks and create custom ones. Yes, this is possible. And therefore, this is a module packed with content, not a short module for sure, but a great practice on React, on building a realistic app with React, and an important preparation for this course, where we later will connect it to our Node.js MongoDB backend. Now, earlier in the course, we of course already planned our React frontend, our single page application pages we want to have there. And pages here really means different React components, which then will be loaded with help of a third-party library that reads the browser URL and instructs React to render different components. And here is our plan. Now, we'll not implement everything we see here in this module. We will add all these pages or components, but the authentication part you see on the right, that will be added later in the course once we also added authentication on the server side. So it's something we can't ignore for now. We can't really implement right now, but we can build the general skeleton and idea of the entire application. So let's do that now. Let's start with that. And to get started, I have a brand new project. You find that project setup attached to this lecture here. You can simply extract it and then run npm install in the extracted folder. And thereafter you can run npm start. Here I am again using that built-in terminal in my IDE. npm start to bring up that development server serving our React single page application. Here it is. Now, don't be worried regarding the gray background. That will make sense later once we start adding more and more components and styles. This will be the general background color of this application. Here, of course, it looks a bit strange. Later, it won't. And of course, also not a must-do, but I will use it, is the developer tools here. I like to have them open so that I can quickly see any errors we're getting and so on. Of course, you don't have to do that, but I will work on this project with the developer tools opened. And with that, let's go back and let's start working on this application and add components, pages, and more. But of course, the question is, how does that all work? Well, there are different ways of getting started, but since we know that we will have different pages, I like to add these pages, which are regular React components, just components which will control everything on the page, step by step. So for that, I'll first of all add a new subfolder in source, a new subfolder which in the end will hold my pages. Now there are two approaches you could follow. You could, for example, work with a pages folder, which will hold your components that are in the end rendered as full screen pages. And you can add a components folder to hold your components which are not used as full screen components, but instead which are only used on parts of every screen. For example, a button component could be in the components folder. The new place page component could be in the pages folder. You can do that, and for an application of this size, it would certainly work. However, it's not the approach I will use, because for bigger applications, it can be hard to then quickly find your different components and pages if they're all managed in two main folders and then a couple of subfolders. Instead, I will split my logic by feature, which means I will create a new folder in the source folder, which I'll name places. And in there, I will have a pages folder and a components folder. So my idea is that I will have my place-related components in the places components folder and my place-related pages in the, well, places pages folder. Now, why do I do that? Because I'll also add a user folder next to the places folder, so directly in the source folder, where I effectively will set up the same structure, components, and then user pages. Now, this allows me to organize my components in a bit better way because I have user-related components and pages in the user subfolders and places-related components in these subfolders. Side note, if you took my complete guide, pages was effectively named containers because in React you also sometimes refer to components that have a lot of state management logic in them as containers, and pages tend to be components with a lot of state management logic in there. I will opt for pages instead here to make it really clear that these are the components loaded with the help of this routing package, which we still have to install. Now I will also add a third folder in source, and that is a shared folder, because we will have some general purpose components and also some other features which don't really belong to either places or users. So in shared, I'll also add a components folder, no pages folder, because pages by default can't be shared. They can't be shared amongst multiple pages because a page is a standalone thing. And later we'll also add other things here to the shared folder. For now, just a components folder. So this is the general structure I like to work with. It's one possible structure, not the only correct one, but it is one which I think is particularly helpful when working on bigger projects. So with that general structure set up, we prepared the folder structure. Now let's actually quit the development server with Control-C and install a new package. And that new package which I want to install is that routing package. That routing package is a third-party library we can integrate that will help us read the URL the user entered. For example, localhost /nothing versus /users or something like that. And will then load different React components on the screen based on the URL entered. Technically, we still are on the same single HTML page, but that routing package will tell React that now everything on the page should be replaced with the content of component B or of component A, and so on. The name of that package is React Router DOM. So let's npm install with --save react-router-dom. And important here, make sure you add @5 thereafter and then --save exact to pull that specific version of React Router DOM into the project. And thereafter, simply hit enter and this package will be installed. This is a third-party library not managed by the React team, but a very popular library that helps us implement this routing logic so that we don't have to manually parse the URL and then do different things based on it. So this now installs this. Let's wait for this to finish. So installation finished for me. And now we can use that package to load different components as full screen pages in the end. Now, if you want to learn all about routing and the React router, of course the official docs of the React Router DOM package are a great starting place, or as also mentioned before, in my complete guide, you also learn more about routing. Here, we will only use the features of the package which we need for this specific application. So how does routing work then? It starts in the app.js file, because in the end, this is our root component, right? It's the component we render into that place here in index.js. So app component really is the starting point of our entire application. It's the first thing which is getting rendered. So it's inside of this component here created with the function keyword, which also is fine. You could also change this to use the arrow function syntax. So here in this component it is where I want to set up routing. Now how do we set up routing? Well, we first of all import something from that React Router DOM package. And that something is the browser router. Here I'm using this import syntax instead of that syntax because React Router DOM actually is a package that has named exports, which means it exports multiple things by their name. And then here this is using this curly brace syntax to target specific exported things by their name. And here I need the browser router, which is exported. And I will also rename this with as to just router. This is a feature you can use with ES6 modules, which this in the end is, to assign an alias to something you're importing. And now we can use that router here in the app component as our root JSX element. We wrap this around everything that is part of the app that should be able to use the router. So we wrap this around every route that should be able to use our router. The question is, what should be able to use our router? Well, our pages should be loaded with help of the router. For example, if we go to the user pages folder, there we can add a users.js file. And in there, I want to create a very basic React component where we import React from React. And then I'll name this users. And this is a regular React component where I then export it as a default. And in here, I return users works, just some dummy text so that we see that this is rendered. If this is our users component and we want to load that with the help of routing, whenever the user is on just our domain /nothing, well, then we can go to app.js and there we now can use another feature from React Router DOM, the route component. Here we can use route as a component, so as JSX code in the end. We're importing this from React Router DOM. And on that route component, which is provided by that package, which can only be used inside of our router, which has to be set up as a surrounding element, there on the route component, we can add a path property and define the path in the URL. So the thing after the domain that should be entered to reach this specific route. So here, /. And what should be rendered when that route is reached? Well, the thing you pass between the opening and closing tags of route. Alternatively, you can also add a component prop to route and then create route as a self-closing component. That also works. But moving forward, this package actually also supports an alternative syntax where you only set up the path on the route component itself, and then you wrap the component that should be loaded for this path inside of the route component tags. So in my case, I'll import users from ./user/pages/users and then render this here. Now the trick is that this will not always be rendered on the screen, but thanks to this wrapper, thanks to this package, it will only be rendered if our URL path is /. So if I save this now and I restart my development server, we should actually see our user's content on the screen because I am on /nothing by default here, and hence we should see that. So let's wait for the development server to start up. And indeed, I now see users works. Now, if I enter something else, by the way, I also see that though, not just for /nothing. The reason for that is that by default, this path is treated as a filter, which means any path that starts with this will render users. Now that's not what I want. I want to only render users if the path is exactly this. So exactly /nothing after the domain. You can enforce this by adding another property to route, and that's the exact prop. You can set this to true, but you can also omit this. If you just add it like this, the value that is passed in will be true automatically. This means now this route is only rendered if the path is exactly /. So if I now save this, we see users works. But if I enter something else, we see nothing. Because now we're not on exactly /nothing, and therefore this does not work. For that scenario, to make sure that we are not able to end up on unsupported pages, we could import another component from React Router DOM, and that's the redirect component. We can add this here in the router as well. And there on redirect, we use this as a self-closing component. We can add a to property and redirect to /. Now, this code is parsed from top to bottom. And what React Router will do is when the URL changes, it will basically go through all the routes we have set up here. And it will see, okay, if the path is nothing, we render that. If the path is anything else, this will not trigger. And instead redirect will kick in and will redirect us back to /nothing. So if we save that, and I now enter anything else, you see we are automatically redirected to /nothing. So this works exactly as it should, and now we make sure we always end up here if we enter anything but this path. So now we can see our users. Now our users are not everything, of course. We also want to be able to create a new place, for example, and we will fill these components with more life later, no worries. So in our pages, in the places folder, we could add a new place.js file, and in there also create a straightforward component by importing React from React, then creating this function, new place, where we return some JSX code, in my case here just some h2 tag, new place works so that we see that this also is loaded successfully. And then I export this as a default, new place. Now we can register this as a route as well in app.js. We can duplicate this here. And for example, say if the path is places/new, then I don't want to load users, but I want to load new place. So I'll import new place from /places/pages/new place. And then here we render new place as a self-closing component here if that is our path. So if we now save that and I enter anything, I'm redirected to /. If I enter /places/new though, I'm also redirected. Now why is that? Well, that happens because of the way the router works. I said that it would parse this from top to bottom, and indeed, when it encounters this route here, and this here is our path in the URL, it will render a new place. But, and that's really important to understand, it doesn't stop thereafter. It still evaluates the lines thereafter as well. And that's good, because we could be rendering something totally different here. Let's say a normal footer. We definitely would want to render that below our routes, right? So that on every page we have that footer, for example. So it does still execute the next line, and therefore it does still redirect. To make sure that we don't redirect, but that instead we either render this route, or we redirect, we can import one other component from React Router DOM, and that's the switch component. The switch component can be wrapped around your route definitions, so before the starting route and after redirect. And this now instructs React Router that inside of the switch block, whenever it encounters a fitting route, it will not evaluate the lines thereafter. So it will not redirect if it was able to identify this path here and hence rendered this new place component. So with this switch component wrapped around our routes, if we now enter /places/new again, you see now we're not redirected, and instead we render this. If we enter anything else which does not exist, we are redirected, and therefore now this works as it should. And this is routing in a nutshell with the help of the React Router DOM package. This is how we can still stay in React world, but make sure we render different main components, so to say, which still are regular React components in the end, based on the path the user entered in the URL. And that's how our single page application in the end becomes a multi-page application. It's still all on the same single HTML page with which we started. You can always validate this if you view the page source. That is the single HTML code with the root div. But React re-renders what we see on the screen. Without reloading the page, it just re-renders it based on the URL we enter, thanks to the third-party library here, which simply instructs React which component to render based on which path we entered. So now with routing set up, let's start working on the actual components, and there I want to start with the users component. The users component is not where we sign up, but where even if we're not logged in, we can see a list of users and how many places they shared. It's this list of users page here at the very top of our plan we created. So therefore here in the users component, the goal is to output a list of users, you could say. So I will create a new component here already, because splitting is always good. And in that new component, in the user folder, in the components folder, I want to output my list of users. So I will name the component users list. JS is the file name. We will also need some styling, so I'll add userslist.css here as well. And I also want to have a separate component for every item in that list. So I'll have a user item.js file as well as a user item CSS file. Now, as always, how you exactly split and structure your code is always up to you. There isn't a single best way, there isn't a single right way. But having a granular structure where every component is relatively small and focused is rarely a bad idea, and is therefore what I will do here. So in users list.js, I'll set up a default component by importing React from React so that we can use JSX. Then we have users list here, and we will get some props here because we will get the list of users from outside later, so from the parent component. And then I will export this. And I will copy this into user item and just rename users list here to user item, both here and then the export. And other than that, it's the same. I will also import the CSS files. So here I import user item.css, and in the user list, in the users list JS file, I will import users list.css so that we have the style files imported as well. Now in the users list component here, my idea is to output either a message of no users found if we have no users in the app yet, if we just launched, or most of the time when we do have at least one user, a list of our users. So there are two possible branches of JSX code I want to return. And that in the end will depend on some data which I expect to get from outside via props. So which I expect to get from the parent component. So here we can add an if check and say if props items, I expect to get an items property. The name is up to you. You just then later have to use it on your users list component when you use it in JSX as well. So here I'll go with items as a name for this prop. If the length of that, because I expect items to be an array and hence it should have a length property. If length is equal to 0, which means we have no users yet, I want to return a div with a class name of center, which is a class name I defined here in index CSS. It just centers the content. And in there, I want to output a h2 tag where I say no users found. So that's my first possibility. Alternatively, if we don't make it in here, and that's not the JSX code we return in this component therefore, so if we do have at least one user, we will return something else. We'll return an unordered list, and in that unordered list, I want to map my items, which is an array of objects, not an array of JSX, but an array of vanilla JavaScript objects, into an array of JSX elements. So here we can use the curly braces to output a JavaScript expression, or to be precise, the result of that expression in JSX code. And here I want to go through my items, which I get on my props, and map every item into a JSX element so that this can be rendered as JSX here. So every item here will be a user, of course. You can name this however you want, but it will be a user, so that name makes sense, I guess. And I will return a single user item for every user. So I will import that other component, import user item from /user item, so from that other file here, and return user item as a self-closing JSX element. By the way, here we can also shorten this, get rid of the curly brace and of the return statement, and take advantage of the shorter arrow function syntax, which looks like this. Now, every user item needs to get that special key property, which we don't need to handle inside of the user item, but which React needs to manage lists efficiently. And there I expect every user to have an ID. I can't expect all of that because we are the one writing this application code, so it's our duty to provide the right data later. I also want to forward the ID of a user on a separate prop to the user item though. And I also will pass in an image, which we can output. User.image, let's say, has that image data. And the name of the user, which I expect to get on user.name. I also want to output the count, the number of places this user has created. And hence I will pass a place count property to user item and forward user.places. I expect places to be a property on the user object that holds the number of places, not the other place data, just the number of places this user created. So that's a lot of I want to. Right now, nothing of that will happen because all we have at the moment is a simple user item that receives a bunch of data and doesn't do anything with that. And even worse, all our logic is based on the assumption that we get an items prop in the user's list, and that's also not the case. So before we work on the user item and the styling, let's make sure we do pass in the items prop to the user's list, and that what we pass in as a value is an array of users where every user has the data we're trying to extract down there. Now the question is, where should this be passed in? Well, in our users page. That is where I want to use that users list in the end. So here I will import users list from, and now let's go up one level to be back in the user folder, and then into components, and then here it's users list, which I want to import. And then here I will return users list in the end. So my page is very simple because I outsourced the rendering of the list into a separate component. And that's a default approach in React to keep your components lean. only do very few things in every component on its own, instead then delegate tasks to other components. In this case, delegate the rendering of the list of users to the user list component. So now users list requires an items prop, because that is what we try to extract in there, right here, props items and props items, and that should be an array. What we pass in as a value should be an array. So here in my component, I will create a users constant, and that is written in all caps because it's kind of a dummy constant. Later in the course, we will fetch our users from our backend, from our Node.js application, but at the moment we have no such backend, so I will work with dummy data for the moment. So here, users is an array of objects. And now every object will represent a user, and since we try to extract some data from every user, we should make sure that this data is all provided. Specifically, every user needs to have an ID, an image, a name, and places. Later, of course, a user will also have an email and password, but on this component, we're not interested in that. So here, we will never extract that data from a user. So here, it's okay if a user has an ID, let's say U1, has a name, up to you, let's say Max Schwarz, has an image property, and here I just picked a random image URL from the web, because right now we have no image upload in our application, so we'll have to pick some URL of some person somewhere in the web. And last but not least, every person also needs a places property, and here I'll set this to 3, any arbitrary number of your choice. Now it's that users array which I'll pass to items, and then I will reformat this with a shortcut, and this is what we got. So I got one user here with 3 places, and I forward that array of that one user to users list. Now in users list, we then output our user items, and in user item, nothing happens. So time to let something happen there in the next lecture. Let's work on the user item as well, and let's ensure that we output something for every user. We're getting a bunch of user data passed into user item, ID, image, name, and so on. So let's make sure we use that. So in the user item component, of course, it's again all about returning JSX code. And I'm using parentheses here so that I can conveniently write multi-line JSX code. Every user should be a list item in the end here. Because it's inside of an unordered list, it's good semantics to use a list item here. Now we'll add a class name of user item to every list item here. And by the way, on the users list, I will also add a class name to the unordered list of users list. This will make sure that later the styling works properly. Now with that, back to user item. So here we have a list item for every user. In there, I'll add a div, and on the div, I'll add another class name, user-item __ content. Make sure you get these class names right, because I will provide the finished CSS code to you, and the CSS code, of course, will be fine-tuned for these class names later. I don't want to bore you with writing our own code, which is why I will give you the finished one. Inside of that div here, I want to have another div with a class name of user-item __ image, and in that div, we can then render an image, a self-closing tag where the source simply is props.image, because that is the key under which we receive that image URL. I will also provide an alt tag here, and that will just be props.name, which is the property under which we receive the name of the user. Now let's add another div next to that first div, which holds the image. And on that div, I'll add a class name of user-item __ info. And in that div here, I then want to have a h2 tag where I output the username in curly braces, props name, and a h3 tag where I'll output props.placeCount, which is that name of the prop where I get the number of places this user created. And then also after that, in a new expression, in new curly braces, I'll check if props place count is equal to 1, and if it is, with a ternary expression here, I'll say place, otherwise I'll say places, simply to have the right plural form depending on whether we have 1 place or 0, 2, 3, 4, 5 places, and so on. And that can be a simple basic user item. Now, if we save everything and we have a look at this by going back to /nothing, we see something. This is not really styled in a good way because I haven't added any styling yet, but we see something. We see our content here. Now, let's also quickly validate that we see the no users found text, if we have no users, by temporarily commenting out the single user we have in our users array. If we now save that, we see no users found. And again, don't be irritated by this grayish background. We'll soon change this. So this now generally works, but of course, styling is totally off. Now, therefore, in the next lecture, let's make sure we work on the styling and the general presentation of our data and our components. We have this ugly looking application, and now it's time to change that. Attached, you find two CSS files, users list CSS and user item CSS, and you can replace yours with those files or simply copy the content you find in those files into your respective files. That's what I'll do here. Just paste that all in. If you now save this, it reloads and doesn't look that much better. We still have this super huge image here, and just our text is a little bit differently formatted now. Now, to change that, I prepared a separate component, which we will add to shared components, and there I'll create a new subfolder, UI elements, to have some core UI elements we need. And there you can paste in a component you also find attached. In the avatar zip file, you find an avatar.js and an avatar CSS file. Paste both into UI elements so that you have avatar.js in there and avatar CSS. We're not writing this from scratch because I don't want to bore you with writing more and more components. This is a component which has a div which wraps an image and which has some styling to properly style that image. And we can use this avatar component in our user item component now. So let's go back to user item, and in there import avatar from, going up 2 levels, shared components, UI elements, avatar. And then here replace this image tag, not the surrounding div, but the image tag, with avatar. And to avatar, you need to pass an image prop, because if you inspect that component, I do expect the image and the alt prop, also a width prop, by the way. So I do pass in an image here and set this to props image, and the alt prop, which is set to props name. Now, I'll not pass in a value for the width and also not for class name and style. This component just is built such that it supports these special props, and later we might need that, but you don't have to use that. There are some default stylings, and if those are right for you, there is no need to change this. So we only pass the alt and the image prop, and if we now save this, this definitely looks better. Now, still not perfect though. We can still improve that. It will look better once we wrap our user component also into a link, because I have some styles set up for anchor tags. And I want to have a link because when we click the user, it already has a hover state, right? When I click the user, I want to be taken to all the places this user created. Now, we won't render a link with a regular, boring anchor tag though, because instead we again want to leverage React Router DOM and make sure that we don't have a real link, which would try to load a brand new page and therefore would reload our existing page, but that instead the React routing package, React Router DOM, can step in before a navigation happens, before a page reload happens, and block that default action from happening, and instead have a look at our configured routes here and load the appropriate React component. We want to give React Router DOM a chance of doing that. So here in user item, I will import something from React Router DOM, and that something is the link component. Under the hood, this wraps and renders an anchor tag, but it also adds this extra block the navigation logic. We use that inside of the list item, inside of the div here, but outside of that div which holds the image, we can add a link opening tag and then a closing tag after this inner div. And now on the link, you need to specify a to prop which defines where to you want to go. And this now actually will be a dynamic path. It's not always the same URL, because it is a URL that should reflect the ID of the user, because we want to load all the places for a given user later. So the idea is that later we have something like user ID places, for example, where user ID, of course, is dynamic and not always the same, because we will have multiple users. So to here is built with help of a dynamic expression, and hence we need curly braces. And then here I will use backticks to create a template literal, which means a string where we can easily inject values. And I want to go to slash, and then inject the value, and that value will be props ID, so it will be the user ID, slash places, so that we always have a different link for every user. If we now save this, this looks way better. And now we can hover over this and click it, and nothing happens. But if you watch the bottom of your browser, you see that it will go to slash user ID slash places. We just haven't added such a page yet, which is why at the moment nothing happens. But generally, this works, and that is of course amazing. Now, I'm still not entirely happy with the way this looks. I also want to add another utility component, which you also find attached to this video, to this lecture. And that's the card. The card zip file, if you extract it, holds a card.js and card.css file. Copy both into your shared components UI elements folder as well. This renders a simple div with some nice styling attached with a little drop shadow and so on. It gives us this card look you might know from other web pages. And now we can use this in user item as well. There we can now also import the card, import card, from shared components UI elements card, and wrap our link with it. So inside of that inner div, but outside of the link, add card, and then close card after the link. And with that, it looks a bit worse actually, because now there's one thing we need to do. We now need to get rid of this div here, copy the class name first though, get rid of the opening and closing tag thereafter, and add the class name to card. Because card is a component that is able to accept a class name prop and merge it with its own classes. And with that, if we save this, we now have a nice look, rounded corners, this nice cardy look with a slight drop shadow, and I think this now looks really nice. Now, of course, still it's a relatively empty page and we will add more, but we are getting there. And at least now we have our list of users with only one user at the moment, but we could render more, and we can click that user. So that is pretty nice. That is a nice first step. Now let's continue our work and let's add more and more components, and then also at some point more and more logic. So let's continue our work on this application. But before we do so, I want to dive into some important concepts or some theory about React, which you also have to understand. We have two main types of components in React. We have presentational components and we have stateful components, you could say. Or put in other words, we have some components which are relatively dumb, which just output some content, apply some styling, some structure. And then we have components which also are smarter and manage some state and orchestrate that their child components receive new data and so on. The card component, which I provided to you, for example, is a good example for a presentational, for a dumb component. It just renders a div, it applies some styles, and it just outputs content it receives from outside through props. The same for the avatar. Also, very simple. User item, it's the same. It's really, really dumb. It has more HTML elements in there, but it only outputs content. It gets data from outside and renders that. It has this link, which has some built-in logic to block interaction and to block navigation, but that's handled by a third-party library, by another component actually, by the link component. The user item component, therefore, is pretty straightforward, only a presentational component. Same for the user's list. It has the logic to decide what it renders, so it's maybe a bit smarter, but in the end it still only outputs something on the screen. The users component also is pretty dumb at this point, though theoretically the list of users here would be fetched from a backend. So whilst this component is dumb because we have to work with some dummy data, this would actually not be a pure presentational component. Instead, later in this course, this will be a component that does more than just present. It will be a component that will actively also fetch the data it wants to show. Here, again, we just don't have any backend from which we could fetch at this point. But this will later be not a dumb presentational component. Instead, later this will be a stateful component, which indeed does fetch data. Now, what does this difference mean for you? How does this impact the way you build your components? Well, it's not really impacting the way you build your components. It's just important to be aware that there are these two types of components in React: smart and dumb ones, stateful and presentational ones. And it shouldn't impact how you build your components, but you should be aware of the fact that it's totally normal to have way more presentational components, dumb components, than stateful components. Typically, you have a few components where you manage your data, where you fetch data, and so on. And then you have way more components that simply control how things are presented and how things are laid out. That's just some theory about React and about components that you can keep in your mind, can be helpful in job interviews, and even if you're not looking for those, it's helpful knowledge to have if you are a React developer. Now, with that short theory lecture out of the way, let's go back to working on our components here. On the users list component, there is a little adjustment I want to make, which I forgot before. On that output here, if we find no users, there I also want to use the card component. So I'll import card from shared components, UI elements, card. And I will use the card in here to wrap the h2 tag with it. Just like this. This will then look a bit nicer if we have to render it. By the way, if you wonder how I organize my imports, I have third-party library imports always at the top, then an empty line, and then my own file imports where I tend to have the CSS import at the very bottom. Technically, that does not make a difference. It's just how I like to organize my imports. And with that, we have this adjusted. Now let's build a brand new component from scratch. Because at the moment, this looks okay, but one important thing that is missing is a header, for example, a main navigation bar at the top that ensures that we can actually also reach other parts of our application. For example, at the moment, we can view our list of users, we can click the users, and at the moment nothing happens, but we can change this. But what we definitely can't do from inside the application is go to the new places route. I have to manually enter places new. And of course, that's not a pleasant user experience. We don't want to force our users to guess which URLs they can enter. So instead, it would be nice to have a navigation at the top where you have a button that takes you to the new places page. And that's exactly what we'll work on now. For this, I'll go to the shared folder because the navigation isn't really exclusive to one of our pages. It's shared instead. And there, next to UI elements, I'll add a navigation folder, which should hold all the components that are involved in the navigation menu process. Specifically in there, I want to have a main header component stored in a main header.js file. And I will have a main header CSS file for the styling. I want to have a main navigation.js file, which will be part of the header. You can say the header will be the shell, which provides the styling. The main navigation component later will be the component that has all the links. And I will also need some CSS for that. I also want to have a nav links.js file. That will actually be the collection of links, which we render in main navigation. And therefore, I will have a nav links CSS file. And also a site drawer.js file, because this app also should work nicely on mobile screens, and there we will need that site drawer. So a lot of components we have to work on. Let's start with the main header. The main header is pretty straightforward. We import React from React, and then we import main header CSS for the styling. We have no styling in there yet, but that will follow. And then here we have main header as a component, where we receive some props and then return some JSX later, and we'll export that main header component from this file so that we can use it in other files. Now regarding the JSX, I want to have the normal header element being rendered here, and I'll add a class name to that header element, which is main-header, and that will later be picked up by the styling in the main header CSS files. Now, what should be rendered between the opening and closing tags? There, I want to be flexible, and I want to allow anything to be rendered in there. Any HTML components, any custom components, anything should be renderable in there. So, we can use a dynamic expression and now a special prop, props.children. This is one of the very few special props React knows. Props children will always refer to the things you pass between your opening and closing tags of your component. Now, what do I mean by that? Well, let's go to the place where I intend on using main header, and that's the main navigation. In there, we can import React from React, and then create main navigation, where we also might receive props, and then export main navigation. Also, don't forget to import main navigation.css so that we have the styles which we'll later add available. And now in here, in main navigation, I want to return my main header. So I'll import main header, which we just created, from the main header file. Then we can render it like this. And now between the opening and closing tags, we can insert what then in the end will end up here in place of props children. So in main navigation, we can now decide what should be rendered inside of our main header. And there I want to have a button, which will later open my side drawer. And in there I will have free spans, free empty spans simply as bars, because I will add some styling which renders this as a hamburger icon, and every span will be one, well, part of the hamburger. We will add a class name here, which is main-navigation __ menu-button. Besides the button in the main header, I want to have a h1 tag with a class name of main-navigation __ title. And the text here could be your places or whatever the name of your app should be. And then I want to have a nav element. And in there, I want to have my nav links later. So for now, just 3 dots. These will be links later. The header here also should be clickable. So I'll import link from React Router DOM and wrap my text here with it. So here I'll have the link and then there to/nothing to always get us back to the main page when we click the title of the app. This is in the end my main navigation for the moment. And now really keep in mind that what I enter here between the opening and closing tags of main header will in the end be forwarded under the special children prop to main header and will therefore be output in that place here, in props children's place. So props children is a placeholder for the content you enter between the opening and closing tag of your own component, you could say. Well, and now, even though some things are missing, let's add styling and let's then render the main header. Now for the styling, again, you find attached a main navigation CSS file where you can just paste in the content into your main navigation file here or replace it. And the same for main header. Make sure you add all those styles I prepared for you. With that out of the way, we can go to the app.js file because the header should always be visible no matter which route you loaded. So I will not include it in every page, but instead render it above all my pages, above that switch statement here. So here I will import my main navigation from shared components, navigation, main navigation, and that will include the main header as you saw. And that should be rendered above my routes so that this is always visible no matter what we load as a page on the rest of the page below, well, our main navigation. So here inside of router, because I do use the link component from the router package, for example, but outside of my routes config, I will render main navigation as a self-closing tag because I don't need to pass anything between the opening and closing tags to it. I also don't need to pass any props to it. With that, if we save this, we have our header here. Now, this looks a bit strange because our place is below the header. Let's change that. Let's change it by wrapping our switch statement here with the main component. And now on the main component, I want to ensure that we keep some distance to our main header, to our main navigation. And that should already be happening because if you look into the main header file, into the main header CSS file I provided to you, I do add some margin to the main element. So now this looks better. And now we still have no navigation links here, but at least we have a header. And if we decrease the size here, you see the hamburger button goes away because it's already styled to adjust the layout based on the size we have available. On smaller screens, we do have the hamburger button. Right now, however, if we click it, nothing happens. So that's something we'll have to adjust. So here, let's go to the bigger screen where we have the desktop view. We now have to work on the different links here and then make sure we also add a side drawer that works on mobile screens. Let's work on the navigation links now. For that, let's go to nav links and import React from React, because here I want to have a list of navigation links, of links in my main header or also in the side drawer, depending on where we render that. So there I'll have my nav links component, which could receive some props. We'll see if we need that. And then export nav links as a default. I also, of course, want to import /navlinks.css for some styling. Now, inside of navlinks, I will definitely also return some JSX code that includes some links. So we'll import something from React Router DOM, but that something is not link, but it's navlink, a special link in the end, which also can analyze the URL and allows us to, for example, color the link differently if we are on the page the link leads to show the user that this is the currently active link, for example. And then here I return an unordered list where I'll add a class name of nav-links to it. And you should do the same to make sure that the styling I will provide to you works. And then we have a list item in there without a CSS class. And there a nav link, which leads to /nothing and says all users, for example. And I will now copy that to provide another link here to, let's say, my places, to later view all the places we created, so our places. Let's add another link where we say new place, so that we can also add a new place later, or also add place, therefore. And another link, authenticate, which will not be that important right now because we won't add full-fledged authentication at this point, but it's still good to already have the link. Now be aware that later, not all links will be rendered all the time. For example, my places will only be rendered if we are logged in. Otherwise, there is no way we can view our own places. Add place will only be rendered if we are logged in. Authenticate, on the other hand, will only be rendered if we are not logged in. So at the moment they are all rendered, this will not be the case later. That's really important to understand. Also, one other thing, to the first nav link, which leads to /nothing, add exact as a prop. This tells the nav link that it should only mark this link as active and apply the styling I will give you in navlink CSS later when we are exactly on /nothing and not on any route that starts with /, because that would be every route and then this would always be marked as the active link. Also, we need to adjust the other two props here, of course. For my places, I want to go to /u1/places. This is a dummy placeholder. Later, we will populate that with the real user ID of the authenticated user. But since we have no authenticated users at the moment, there's nothing we can do regarding that. Here on add place, I want to go to /places/new. That's the link we were missing before, which we had to manually enter. And here, let's say for authenticate, I want to go to /auth. Now that's up to you. We haven't added that route yet, but we will add it later. So now we have all these nav links. We can now use that in the main navigation component. So in there, we can simply import nav links from /nav links, and then render this here instead of the 3 dots. Nav links like this. Also important, attached you now find a nav links CSS file, and you should replace yours or the content inside of it with my nav link CSS content. If you do that and you save all files, you should see nav links here, and you see the active page highlighted like this. Of course, you can always, by the way, adjust styles in the CSS files if you want to have a different styling. This is just the styling I will go with. So all users is currently active. If I click on add place, you see this is now active. So this works. We can switch here. And of course, some routes are not yet supported. For example, my places and authenticate. We always are redirected there because I haven't registered routes for them yet. But add place in all users works. And now we can switch with help of these buttons. Now that's great. If we highlight this in mobile view here in the Chrome DevTools by clicking on this icon though, we have the hamburger icon, but clicking on it doesn't really do much. We open now side drawer. Instead, I have the nav links all clammed in here, which doesn't look super great. So we should fix that, and we should make sure that on mobile view, this also looks good. To make sure this looks good on mobile view, there are 2 main things. The first one is simple. In main navigation here on the nav element, which wraps nav links, add a class, which should be main-navigation __ header-nav. If you do that, thanks to the provided CSS styling, you see now the links here on the right are gone. But now we need to enable that button here and make sure we animate and show a side drawer, which gives us our links. To do that, we have to go to side drawer, of course, and work on that a little bit. So here I will import React from React and import /side drawer.css, and then create the side drawer here as a component and export it, of course, as we always do. And now in here, in the side drawer, I want to do a couple of things which we haven't done before. For one, I want to add animation so that it slides in and slides out. And I also want to render it in a different part of the page than where I will include the drawer. Now, what do I mean by that? Well, for this, let's first of all return an aside here, a default HTML element, which should render props children. And that will be my drawer. For that, I will add a class name here, which is side-drawer. Just like that. Now attached, you find a side drawer CSS file, and you can copy its content here into side drawer CSS. Now with that, let's use the side drawer in main navigation. In main navigation, I want to render it next to the main header. So we'll import side drawer from /side drawer, and now render it, for example, here. Side drawer, opening and closing tags, because inside I want to have a nav element with a class name of main-navigation __ drawer nav, which is basically the opposite to my header nav if we are in a smaller screen. And there, I again want to pass in my nav links. I set up styling which is flexible enough to render nav links horizontally or vertically, depending on whether we're on a smaller screen and hence in a drawer, or on a bigger screen and hence in a header. But here we have a syntax error. In React, and that is just a rule you have to memorize, you must only have one root JSX element per component. You can have as many nested as you want, but here having a side drawer next to a main header as the values we return won't work. And that's actually not a React limitation, it's a JavaScript limitation. In a normal function, you can't return 2 numbers like this, for example, either. That just doesn't work. So to return multiple root level elements, React gives you a special wrapper, react.fragment. This doesn't render any real HTML element to the screen, it just fulfills this requirement of having one root element, and then in there you can have as many side-by-side or nested elements as you want. So now we need React fragment, and now we can render the drawer. If we save this, here is our drawer. And it works, that's great. But of course, we can't close it, we can't open it, and it's also not animated, because it's also always there, I guess. In addition to that, however, if we inspect this in the real DOM, we see our drawer, this aside, is rendered here in the root, which isn't too bad. But semantically, since this really is an overlay to the entire page, I would rather have it being rendered right under body, so somewhere here, which leads to the same result regarding the look of it, but semantically is a bit different. It's a tiny thing, but still something which I'd like to have. We can implement this with a concept called React portals. Let's have a look at that. So what are React portals? Portals in React is in the end a concept that allows us to project or render a React component in a different place than it normally would be rendered. Normally, the side drawer would be rendered as part of our main navigation and therefore wherever this main navigation is rendered. Now with a portal, we can mark a new place in our HTML file, so in public index.html, where we want to render our portaled content. In this case, I will add a new div in front of my root div here, and I will name this drawer hook. The name is totally up to you. So this has an ID of drawer hook, and it's outside of the root div. It's next to it, in front of it. This is where I want to render my side drawer. So now back to the side drawer, we have to tell React that it should render this content here. For that, I'll first of all store my JSX content in a new constant. You can do that. You can do with JSX whatever you can do with a regular JavaScript expression. So you can also store it in variables or constants, not just return it. And what I will return is something different than before. We need to import React DOM from React-DOM. This is the other part of the React library, which thus far we only used to render the React application itself here in index.js. Well, turns out React DOM has more than just a render method. We can also use React DOM.createPortal. And now we tell React which content to render where. And there I point at content, so what's stored in this content constant. And then we need to select a place in the DOM where this content should be rendered when this component is mounted, when this component is used. And here I want to get an element by ID in my HTML page, and there I use the ID I just assigned there, which is the drawer hook. Now if we save that, we see the same result as before, but semantically this is now rendered differently, which I like a bit more. It's inside of the drawer hook now. Now, isn't the end of the world if you don't do it like this. It is not even bad, but I find it interesting to also dive into portals here and show you this alternative. It's especially intriguing if side drawer would be included in some deeply nested component and you would otherwise render it somewhere deeply inside your element tree in the DOM. Well, then a portal might be especially nice because it allows you to render the content of a component in a different place than the component itself. The component is part of the component tree, so to say, and the content is rendered somewhere else. That's a portal. That doesn't solve our problem that the drawer is always visible and not animated though. So let's work on that. To control the visibility, let's go back to main navigation because ultimately that is where we have the drawer and where we also have that menu button, that hamburger icon in the end. Here, I want to manage some state. I want to manage the state whether the drawer is opened or not. So we have to import use state from React. And then here, we can have our drawer is open state and set drawer is open as a function to update that state. And initially, let's say that is false with use state and the initial state. Now we can use drawer is open to only sometimes render this drawer. And one way of doing that is to wrap the drawer here into curly braces and then check if drawer is open is true. And if it is the case, with a ternary expression, render the side drawer, otherwise render null, which means render nothing. This is how we can conditionally render content in React. If we do that, you see it's not open now. By the way, we can also shorten this and take advantage of JavaScript and use the logical AND operator here, which means if this is true, this here will be rendered. This is how JavaScript works. It's vanilla JavaScript, so it has the same effect. Now we need to make sure that when we click our button, we do open the drawer. So on the button, we can add an onClick prop and then add a function to our main navigation functional component, which I'll name open drawer. And there I want to, well, open my drawer. So here I want to call set drawer is open and set it to true. Change the state to true. And here on click, I will point at open drawer. If we do that, I can now click this button and the drawer is there. It's not animated, but it's there. Unfortunately, now we can't close it anymore. So that's something we should fix. For that, I'll also add another function, close drawer. And here I want to set drawer is open to false, of course. The question just is, where do we trigger this? For that, we need a new component. A component we can render as a background to the drawer, so that when we then click this background, we close the drawer. And you find such a component attached. Backdrop zip holds a new component which you should add to your UI elements folder next to avatar and card. You have a backdrop CSS file and a backdrop JS file. The backdrop component also utilizes the portal concept, and therefore you should add such a backdrop hook place in your index.html file. Above the drawer hook, I'll add the backdrop hook. And the backdrop is simply, well, a backdrop, a background which is rendered behind the drawer, for example. Now in main navigation, I also therefore want to render the backdrop conditionally. So there we can check if drawer is open is true, and if it is, render the backdrop. Now important, you need to import backdrop in order to use it. So import backdrop from, and now let's go to UI elements and then backdrop. With that, we render the backdrop, and the backdrop component listens to a click on the backdrop, so on this background, and then emits a function it expects to get on an onClick prop its own. So on the backdrop, we can add onClick, because we do handle such a prop there, and bind that to close drawer. And now if we save this, we can open it. Now we have that background. It's a bit darker than before. If we click that, it closes. So that's great, but a little animation would be nice, right? So let's add an animation in the next lecture. To add an animation to the side drawer, I'll install a new third-party library with npm install --save. And the name of that library is react-transition-group. I explain it in more details in my React the Complete Guide course. It is simply a library that makes it easy for us to play a little animation if we add an item to the DOM, so to say, if we render an item for the first time, or if we then remove it. That is where this library helps us. So let's wait for it to finish installing. And now that it is installed, we can restart our development server with npm start and use that library here inside drawer. For that, import something from React transition group, and that something is the CSS transition component. So that's a component provided by this third-party library. It's a component you should wrap around this aside element here. So CSS transition can be used as a component in JSX and is wrapped around the side. Now here we need to configure that. We need to tell this library when exactly this side drawer becomes visible. We do this with an in prop on CSS transition, and I want to bind this to props show. So I expect to get a show prop on the side drawer, which we don't get at the moment, but which we have to add, which in the end is true if the side drawer should be visible, and false if it should be invisible, if it should be removed. I'll add a timeout, which is the duration of the animation, and here I'll set this to 200 milliseconds. And a class names property. Important, class names, not class name, class names. It's a special prop accepted by this component. And this should be slide-in/left, which in the end is a CSS animation defined in index CSS. You can see it there. It's a couple of CSS classes with -enter, -interactive, and so on at the end. And these are special class names which this third-party library knows how to use and which it applies in sequence when it animates the element in or animates it out. Now last but not least, I'll add mount on enter and unmount on exit to tell that component and the third-party library that the aside component, which is inside of the CSS transition component, should really be added to the DOM or be removed from the DOM when it should become visible or invisible. Otherwise, it's just animated out or in and not really removed. Here, I want to have it removed or added depending on its state. So now we just have to make sure we use this show prop properly. So to site drawer, we should pass a show prop. So back in main navigation, I'll change the logic on how the site drawer is rendered. It's now always part of JSX, but it's not always visible because now we set that show prop and set this to drawer is open, which is true or false. And then inside of site drawer, we have the logic to control whether the drawer is visible or not. So if we now save this and let it recompile, now we can click this button and now you see you have a nice little in and out animation when you open the drawer. On desktop mode, of course, this has no effect. There, everything worked before, but now we also have a nice working mobile view. And with that out of the way, I'd say this doesn't look too bad. Now we can go back to more logic related to our core application. For example, show the places for a chosen user. Now, one thing I noticed, of course, that's missing on our site drawer is at the moment when we click on one of the links, it stays open. It navigates to the new page, but we manually have to close it by clicking on the background, which is not ideal. Fixing it is easy though. In the site drawer component, on the aside, we can add an onClick listener, so to say, so this onClick prop, which is basically supported on any default HTML element, and then forward this event, so to say, or the function we want to call to props onClick. Or put in other words, we expect that on the site drawer component, we get a function passed to the onClick prop of the site drawer component, and we then pass that function we get there onto the onClick prop on the aside element. So in the place where we use the site drawer, which is the main navigation, we now also have to add this onClick prop we're expecting there, and there we can point at close drawer, just like this. And I will also rename my functions here to onDrawer handler and close drawer handler whilst I'm at it, just to be consistent with the naming I use in the other places of the app, where I always name the functions that are called upon events with handler at the end. So with that, if we now save this and we go back, you will see if we click on a drawer, it closes, but therefore also when we click on one of the links, we get navigated there, but we also close the drawer, which of course is the goal. So as a next step in our little application, which is slowly taking shape here, let's work on the places. We are able to view our users, and when we click a user, I want to view all the places that belong to that user. And right now, that is just not happening. I can click the user, and I, in the end, just reload this page over and over again. The reason for that simply is that we haven't set up any route here in app.js that would handle the case that we want to view the places of a user. Now, for that, we first of all should create a new page, a places page, which is responsible for showing all the places of a user. So in the pages folder, in the places folder, I'll add a user places.js file, and in there I want to have a component which, well, fetches and renders all the places that belong to a user. Now, the fetching part will only happen later once we also have a backend to connect the app to, but for now here we'll also work with some dummy data. So let's import React from React here and create our user places component as we did multiple times before in this course. And of course, export this component here like that. And now I want to return my list of places. Now that list of places will actually be outsourced in a separate component. You don't have to do that, but again, I want to keep my page component lean. I want to keep every component lean and therefore split my app into smaller pieces. For that, we can add a place list.js file in the components folder, in the places folder, for example, and add a place list CSS file there so that some styling can also be added. And also maybe add a place item.js and a place item CSS file so that we can split this up even more, and just as we did it with the user, manage list and item separated from each other. So in place list.js, there I want to import React from React again and create my place list component where we will receive some props to configure what we output. And in the end, of course, I export place list. And we can also add the CSS import to /place list CSS. We can copy all that content into place item because in the end, this file here will look very similar, just that we're talking about the place item component, and hence we should adjust the CSS import and also the names down there. Now back to place list. In there, the idea is, surprisingly, to output a list of places. Well, at least if we have places. So similar to what we did in our users list component, and therefore we might be able to merge some logic, but I'm not sure. I will leave it separated here also to make it clearer and easier to follow. So similar to that other component though, I will first of all check if my items prop, which I expect to get, which should be an array of places, if the length of that is equal to 0, which means I have no places. In that case, I want to return a card in the end where I say no places found. So I'll return a div here, first of all, with a class name of place-list and then center as an extra class. So 2 classes added to that div. And then I want to add my card. So I'll import the card component from the shared folder components UI elements card. And then in that div, render that card like that. And in there, add a h2 tag where I say no places found, maybe create one. And then also below that, a button which says share place, or actually that should be a link later, which leads to the new place page. So I could import the link here from React Router DOM, but actually we'll soon create a custom button which can be either a button or a link, and therefore for now I'll just leave that button placeholder, which for the moment won't do anything. So that's our fallback if we have no places. Then we return this content. Now, of course, hopefully we do have some places, so let's also handle that scenario. In that scenario, I want to render an unordered list with a class of place list added to it. And in there, similar to what we had in the users list, I want to loop, or I want to go through all my items and map this array of vanilla JavaScript objects, which we'll have there, to an array of JSX elements. So we can output something dynamic here with curly braces, and then props items map is the way to go. This allows us to go through every place we have and then render a place item for every place. Now for that, let's import the place item component. Import place item from the sibling place item file, which is in the same folder. And now we can pass data to place item. For one, we need to set that special key property React requires. It always requires that when you're rendering sibling items that have the same type, so put in other words, if you're outputting a list of JSX elements. Then here I want to have a key of place ID and also an ID, which I want to forward, also place ID. Then I want to forward an image because every place should have an image. So I will forward place dot, let's say, image URL. Of course, it's up to you which data you expect here. You just have to make sure that when you later create and fetch the data, it has the structure you are expecting here. So I'm expecting that a place has an image URL property and an ID. I also want to have a title on my place, so I will forward place.title. I also want to have a short description, so I will forward place.description. And also an address, a human readable address, which should be place.address. In addition, a place is created by a user, and that user has an ID, so I will forward place.creator to the creator ID prop. And the coordinates are also required. We have the address to show the human readable address, but I also need the coordinates to show this on a map because we're going to render a map as well. And there I want to have place.location as a property on the place that holds these coordinates. Coordinates will be an object with a lat for latitude and a lng for longitude property, but you'll see this in action later. With that, we added a bunch of data we feed into place item. For now, I think that does the trick. Now let's work on place item and let's make sure we do something with all the data there. Now, place item will become a bit more complex in the future, but for the moment, it can be very straightforward. I want to return a list item here. A list item that also gets a class, place item, and that now somehow needs to output all the information we get. For example, here I want to output an image. For that, I'll add a div, and that div will also receive a class name of place-item__image. And in there, we can add an image element and set the source to props.image, because we will pass this image prop to place item, so we can reference it there. Alt can be set to props.title. Now below that div, I'll add another div with a class name of place-item__info. And here I want to have a h2 tag where I output the title, and a h3 tag where I output the address, and then let's say a paragraph where I output the description. Now, by the way, I will of course again provide some styling to you, so make sure you got all the class names and so on right, and you got the same HTML structure so that the styles work for you. Of course, you can deviate from my structure and setup, but then you'll have to adjust the styles on your own. Now, last but not least, I'll add one last div here to every list item, and that is a div that receives a CSS class as well, the place-item__actions class. And in here, I want to have buttons that allow the user to interact with that place. The interactions here should be that you can view the place on a map. So that should open up an overlay which shows the place on a map, and we will of course add that functionality throughout this module. I want to have another button which allows us to edit this place. Later we will make sure that we only see this button if we are the creator of the place. For now it will always be shown. And the same for the delete button. Later it will only be shown if you did create the place. For the moment it's always shown. So we got these three buttons there. Now I want to wrap my place here in the end with the card component. So we'll import that card component, which we imported earlier from shared components, UI elements, card. And then inside of the list item, add the card surrounding all the divs, and to the card itself, I'll also add a class place-item__content. With that, we have some code that should output places. Now it's time for some CSS. And therefore, as before, attached you find a place item CSS file, which holds all the CSS code you should put into the place item CSS file in your project. And you find a place list CSS file, which holds CSS code you should add to your place list CSS file. And with that, we hopefully have a setup here that works. Now back in user places, of course, we have to use our place list. So there I will import place list from, going up one level, components, place list, and then here return the place list component as a self-closing component. But of course here we have to pass in items on that items prop, and that should be an array of the places we want to display. For that, I will create a dummy array here, actually outside of this function, which I'll name dummy places to make it really clear that this is only a temporary placeholder. And in there we can now add some places. Each place needs an ID, let's say P1, a title, let's say Empire State Building, a description, one of the most famous skyscrapers in the world, an image, and there we have to be careful. In place list, I extract image URL, so a place should have a property named image URL. So let's name it image URL here, where I will just pick an image from the web that shows the Empire State Building. Here we go. Then the human readable address, which I will simply fetch on Google Maps. There I searched for the Empire State Building, and this is then the address I want to use. And for the coordinates, which I also need, coordinates, I am extracting location, actually, should be the name. I'm extracting location here, so let's name this location. And that should be a nested object with a let and a LNG key. And both should be numbers, latitude and longitude, which is the default measurement system for coordinates. You get that from Google Maps as well. The thing here after the @ symbol, that's the latitude before the comma. So let's add it here. And then after this comma here, in my case the -73 and so on, that is the longitude. And the minus is part of the longitude. So let's add that here. And with that, I have my dummy place here. Now I will actually just duplicate it, the exact same place, but with a different ID. And I also forgot that we need a creator field, because we are also extracting the creator ID, which should be stored in a creator field. And there I will use U1 here, and for the other place I will use U2. And these will be the IDs of the users who created the places. For now, as all the other things on this front end here, of course, that's just dummy data. So we have all of that added. Now we can feed our dummy places into the place list here. So let's do that, just like this, and save it. And now to see whether that works, we need a way of reaching user places. And to reach it, we need to adjust our routes, of course, because that is ultimately where we control which pages are loaded for which URL. So here in app.js, I will import the user places component from /places, pages, user places, and now add a new route. Add a new route where the path we're looking for actually has a dynamic segment. You signal that to the React router by adding a colon and then any identifier of your choice, UID or user ID, whatever you want. You will later be able to extract the actual value entered in the URL for this segment in the component which is loaded. This simply means you don't know the exact value yet, it is dynamic. Here it will be the user ID, and of course we will have many users, so this could be U1, U2, U3. Well, we just want to handle any user ID here. Now followed by places, so that we can reach this route if we enter our domain / some user ID / places. If that's the path we have, I want to reach user places here, this component. Now let's also add exact here as we did it on the other routes to make sure that only exactly this path loads this route. And now we should be able to reach user places. If we save that and we go back to our application and I click on the user, we are going to a page which has exactly this path. So if I click here, that looks good. Here are our user places. Now the buttons don't look awesome yet. We can definitely work on those, and we will. But other than that, this looks really, really neat. Now you see my places is highlighted here. This makes sense because at the moment in nav links, I set the link my places leads to /u1 places, which is exactly the link we're on right now, because we clicked on this user who has an ID of U1, and therefore, well, this is the URL we have. Now what we're not doing is we're not making sure that we only show the places that belong to that user. This is something we're not doing. And that will be the next step. In user places, we want to make sure that we filter out the places that don't have the ID of the user we have encoded in the URL, because we only want to see the places of the user with the ID U1, not all places. So this place with the ID of U2 for the creator, we don't want to show that. Let's fix that. Now to filter out places by ID, we need to find out which ID is encoded in the URL. And for that, we can use a tool React Router DOM offers to us. We import it, from React Router DOM. And there we have a hook, the useParams hook, which we can use in functional components. Like all hooks, they're only usable in functional components, but since I only work with functional components in this app, we can use them in every component. Now useParams is simply executed as a function, and it gives us access to the parameters, as it's called, so to the dynamic segments React Router is aware of. Dynamic segments are these things you encode with a colon in your route configuration. So in this case, we can get the user ID. And useParams will return an object which has your dynamic segments you set up in the route config as properties. So for the user places component, there will be an object with a user ID property, which then in turn holds the concrete value that's entered in the URL as a value. So here I can access user ID and store that in, let's say, the user ID constant. This gives us access to the user ID that's encoded in the URL. And with that, we can get our places. We could call it loaded places here by using our dummy places. And then we can use the built-in filter method to run a filter on every element in dummy places and have a look at every element and only keep it in the newly returned array. Filter will return a new array if the creator of that place we're looking at is equal to user ID. And then we want to forward loaded places here to place list. As a consequence, if I reload, we now only see one place here. If I visit U3, I see no places because we have no place for a user U3. And for U2, I also see one place. So this works, and we are now filtering this successfully. Now, why don't we work on the map next? However, before we do so, let's make sure the buttons look a bit more pretty. To get prettier buttons, I got something prepared for you. In the Shared Components folder, add a new subfolder, which you can name Form Elements. Here, I want to store some components which are helpful with creating forms or with user interaction. And there, attached, you find a button zip file, which you can extract and which you can unzip. And in there, you find a button.js and a button CSS file, which you should move into this Form Elements file. Now, let's have a brief look at what you get in there. You get a component, and in the button component, I render different things based on the props we receive. If we have a ref prop, I render a normal anchor ref, a normal link. If we have a to prop, I render a link as it's coming from React Router DOM. And I also give users the option of adding some special styles, for example, controlling the size of the button, inverse, danger. We'll use that throughout the course, no worries. There also are some default classes attached for some nice styling. And of course, I also render a normal button. If we have neither a to nor a ref prop, then we render a normal button where we can also control the type, forward on click listener, and even disable it. This is a button, and here we got some styles for that button so that it hopefully looks nice. Now with that, we can use this button in the place item component instead of the buttons I currently render there. So let's import this button component here, import button from shared components, form elements, button, and replace the buttons down there with the better button, with the custom button. Now the buttons can be configured, and for view and map, I want to add the inverse prop, which makes this look better in my opinion in this place here. For editing, I don't want to add any inverse prop, but I want to add the to prop because this should actually be a link which redirects the user to a page that allows us to do the editing. So here I will add a template literal and then forward to, let's say, places slash, and then here props.id, which is the ID of that place, so that this leads us to slash places slash place ID, which is a route we haven't registered yet, but which we will add later. And for deleting, I will add the danger prop, which colors this button red and more dangerous. And we will also soon add on click listeners to the first and the last button. With that, I think that looks a bit nicer. And we can now focus on making sure that when we click on View on Map, we actually, open an overlay, let's say, where we highlight the position of this place on a map. To show the position of a place on a map, I will add two new components. One is a modal. A modal is an overlay, which you see on many websites. It's basically like a pop-up, but built into the page, not in a new browser window. It has a background where we can use this backdrop, which we already use for the side drawer on mobile. And then we have that modal as an overlay. In that modal, we can display anything. And indeed, I will build a reusable modal here, which we can use to host any kind of content, confirmation dialogues, whatever we need. In this case, a map. And that's then the second thing we need. We'll build a special version of that modal, which uses that modal, but then hosts a map inside of it. So let's start with the generic modal itself. For this, in UI elements here, next to card and so on, we can create a new file, the modal.js file, and also a modal CSS file, because we will certainly need some styling. In modal.js, as always, we import React from React, and then we have our modal component here, which receives props, and which exports this modal then in the end. We also need to import our CSS file here, so import /modal CSS. Now actually in here, I want to have a second component. No one is forcing you to only have one component per file. Typically that is what you have, but if you have two components that work closely together, then you can also absolutely have more than one component in a file. Please note that I will only export the modal here though. The second component, which I will build here, is only for internal use. So the modal component will use that second component I will also build. And that will be the actual modal overlay. So the thing we will actually see on the screen. This is another component I add here, which is not exported but will be used by modal. Now let's start with structuring the content of the modal overlay. I will use the React DOM create portal method there. So let's import React DOM from React DOM. And then here I will return React DOM create portal and output some content here in a special place. There I will use document get element by ID modal-hook, which is a place we should add in the public index.html file. Maybe here between backdrop hook and drawer hook. That's our modal hook. That's the place where the modal will then be mounted to in the real DOM. So in the modal component, we now need to specify the content, which should actually be rendered there. Now the content here is a div with a class name of modal. Now actually, it's more than that. I want to be flexible here, so I will render a template literal here so that I can add my modal class, but I can also inject some other class name, and that's props.className. So that in the end, when we use the modal, we could also add our own classes to the modal, and we're not restricted to the classes set up here. Just a little extra flexibility. I will also add a style prop and set this to props.style, so that we could also directly add inline styles to this modal if we wanted to. Then I want to have a header in there. So basically a header, a title shown at the top of the modal. This header will also receive a class name. And here again, I want to be really flexible. So we'll add modal__header, but then also add props.header class so that we can add our own header classes if we want to. In the header, the idea is to have a h2 tag where we output some text that is received on a props header property. Now that's the header. Below the header, but still inside the div, I will add a form. We'll not always need that, but if we had some modal content that should be part of a form, wrapping everything with a form here can be an advantage. Now you could also certainly build this in other ways, but here I want to have a really flexible modal, so I want to give the developer who will then use the modal, which of course is us, the possibility to add content that is automatically wrapped in a form. Not a must do, but something I want to do here. Here I will add an onSubmit handler and check if props onSubmit is set. And if it is set, I will call props onSubmit. So we'll bind onSubmit to the onSubmit I get through props. And otherwise I will pass an inline function here where we get the event and where I call event prevent default. Why? Because I want to make sure that if we render any buttons inside of that form, we don't accidentally reload the page by triggering our form submission here. If we do provide our own submit function, then it's the duty of that submit function to prevent the default. Now inside of that form, I'll add another div. Class name here, again, is a dynamic binding to be really flexible. And there I will bind this to modal __ content, and then props.content class. So similar to the header, the idea simply is that if we use the modal in some place of our app, we can dynamically provide our custom header class to adjust the default look, our custom extra class for the content, and I'll do the same then later for the footer of the modal, which we'll also add. Inside of this content, I'll output props children, so whatever we add between the opening and closing tag of the modal. And then last but not least, I'll add a footer, still inside of the form, and here in that footer, or on that footer, just as before, dynamic classes are added. And here I will have modal __ footer as a class, but then for extra flexibility, add props.footer class to allow external customization. Now that's, by the way, also the reason now why I have that form here. In that footer, the user should be able to inject footer content, for example, buttons that allow the user to confirm a choice or something like that. And that would be hard to do if we only injected everything in the content here. Now, by the way, that split into a content div and the footer is the reason for this default form here. If the user wants to render a modal that holds a form, of course you could inject the form here as a content with props children. But if you want to have a nice styling where the submit buttons are visually separated from the content, which is the styling that will be applied by default with the default classes I add here, then this would not be possible to be all in one form, because the form would live here and the buttons would live here and they would not be inside of the form. That's why I have this wrapping general form here, which wraps both the content div as well as the footer, where the user can then inject, for example, the inputs of a form and then the submit buttons. And if you're not using a form and you're not providing on submit, it's ignored anyways. So that's the general structure of the modal overlay. Now, why do I have a separate component down there? Because a modal is more than just the overlay. A modal also needs a backdrop, and I also want to play a little animation when we open and close the modal. So therefore, we need to import two more things. We need to import the backdrop from /backdrop here, and import CSS transition from React transition group, that animation library we already used earlier. With that, in our modal component, not in modal overlay, but in modal, I want to return a React fragment because I'll have some sibling top-level elements. And I want to check if we have a show prop, which is trueish, in which case I will render the backdrop. And on the backdrop, we can click. And I want to trigger a onCancel method or function, which I receive on the onCancel prop here, if that is the case. So that outside of the modal, in the place, in the component where we use it, we can handle the cancellation and close it or do whatever we want to do. Now, besides rendering the backdrop, I also want to render the CSS transition here. And the in prop here is bound to props.show, which is our trigger for the backdrop as well. I set mount on enter and unmount on exit, add a timeout of 200 milliseconds, and then class names, not class name, but class names, and set this to modal. Now, the appropriate class names which this CSS transition component then will use will be added in modal CSS. And speaking of that, attached you find a modal CSS file, and you can simply put the content you find in there into your modal CSS file. Now make sure you're importing modal CSS and you're almost done. I'm saying almost because the key part is missing. The modal overlay, we're not using that in our modal down there. Of course, that is what I want to render between my CSS transition components though. So here we can add modal overlay and close it. And now do one thing. We forward all the props we get from outside to modal overlay. This syntax might look strange, but what it does is it takes the props we pass to modal, which is the component we export, and forwards them to modal overlay, which is the internal component which we don't export. This allows us to set, for example, footer class, content class, header, and so on the exported modal component where we of course don't need it, we don't use it here, but we then forward it to modal overlay. So it allows us to set props on this internal component from outside, so to say. And this syntax might look strange, but this is the spread operator, which takes all the key value pairs of the props object and spreads them as attributes, so to say, onto modal overlay. And with that, we created a general modal. Now that general modal is nice, but of course we want a modal with a map. Now we'll work on the map soon, but for now let's show the normal modal. For that we can go to the place item where we have this view on map button. And now we need to manage some state, which we change when that button is pressed to show the modal, and then also when the backdrop of the modal is pressed to hide the modal. So I will import, use state from React here, and add a new state in place item, show map and set show map, which initially is false, because initially I don't want to show the modal. And then I will add functions here, the open map handler. There I simply call set show map and set this to true. And the close map handler, and you can guess what I'll do there, I'll set this to false. Now we also need to import the modal we just built. So import modal from our shared components, UI elements, the modal file there. And now use that. Now how do we use it? I want to render it next to my list item, and keep in mind it won't really be rendered there. Instead, because I use a portal, both on the backdrop as well as the modal overlay, it will be injected in a different place of our index.html file. And that's the nice thing about portals, which I already touched on earlier. They allow us to use a component in a certain place, in this case in the place item, and yet render the content of that component in a different place, which semantically might be better than attaching the modal markup next to the list item. We might be able to achieve the same look, but for screen readers and so on, and for semantics in general, that would not be ideal. So that's where a portal can help us. Now to have multiple sibling root items, we need React Fragment. So we can wrap the list item with that. And then with React Fragment as a new top level element in this component, we can render our modal here next to the list item. Now on this modal, I want to set the show prop and set this equal to show map, so to this state we just added. I also have an onCancel handler here, which, just to make this clear again, is in the end a function that will be triggered when we click the backdrop. That's when I, in the end, forward that click event to onCancel and trigger the function that's passed through onCancel. So onCancel will therefore point at the close map handler function, so that this function is executed when we click the backdrop. I will provide text for the header, and there I simply want to use the address, the human readable address of the place. And add an extra content class, which should be place-item __ modal-content. Let me reformat that to make it easier to read. And also add a footer class to that modal, which I'll set to place-item __ modal-actions. Now last but not least, I'll set the footer prop itself to a dynamic value, which will be some JSX, because there I want to have a button which allows me to close the modal. And therefore I'll add the onClick listener to the button and set this equal to the close map handler, just as onCancel. This button component here, through the footer prop, will be rendered in our modal overlay in this place at the end. That's where I use the footer prop. And since I forward all props I pass to modal overlay, if I pass anything in a footer prop, this is where it will end up. So with that, I prepared the modal, but the main content is missing. Between the opening and closing tag of the modal, we have to specify what should be rendered in the place of props children. Because remember, props children is that special prop React knows, which renders whatever is between the opening and closing tag of your React, of your JSX element. So here in the modal, there I want to render my map. For now, I will render a div here with a class name of map container. And I will actually add this class in place item CSS, maybe here above the media query. Map container can be a simple class where you set a height of, let's say, 20 rem and a width of 100%. So make sure to add this class to place item CSS and to this div here. And inside of this div, we'll soon add the map. For now, I'll just have a h2 tag where I say the map, which is of course not our final result. And with that, we're almost there. The missing piece now is that we connect the buttons down there. Now we can add an on-click listener, as I already did it here in the footer, because the custom button component in the end forwards the default on-click event to, well, the function that is received on an on-click prop. So we have to provide such an on-click prop to react to a click. And hence here on the view on map button, I'll add on-click and bind this to open map handler. So to that function which sets show map to true. Now if we save all files, it should recompile. And if I now click on view on map, you see that modal slide in and of course also slide out if I close it. However, it reloads the page if I close. So let's quickly go to the modal. Reason for that is that we have this form which gets submitted. And yeah, there on prevent default, of course I should execute this as a function, not just point at it. So I add the parentheses after prevent default. And now with that, if we go back, I can click close and it doesn't reload. Instead, it just removes the modal. And this also should look good on mobile. Yeah. Bit big there maybe. So maybe we should shrink our map container a little bit. Let's say 15 rem should do the trick. And with that, it looks good. But of course now the map itself is missing. We could of course also, by the way, fine-tune the position where the modal is shown, that it's shown further on top. That could be done in the modal CSS file. There, change top 30 VH maybe to 22 VH. VH is a CSS unit that is basically the viewport height. And this means 22% from the top of your viewport height. So now if we do that, yeah, I think that looks pretty decent. Yeah. So now let's focus on outputting a nice little map rendered through Google Maps here in this modal. To output Google Maps with React, or to render a Google Maps driven map in React, you'll find plenty of packages if you search for React Google Maps. And you could absolutely use one of these packages. I will not do that though, but instead build my own basic custom map to show you how that would work behind the scenes, because I think that's really interesting to see and to learn. Now for this, in the shared UI elements folder here, let's add a new map.js file and a map.css file next to it. Now in the map.js file, we build a regular React component, of course by importing React from React, and then here our map component which receives props, and then by exporting that map component, and then of course also import ./map.css. You can probably soon do that asleep. Now here, let's return a div. That div will be the host, so to say, for our map. And that div will receive a class name, which should be set dynamically. So I will, again, assign a default class of map, but then also offer the possibility of customizing this. You don't have to then use this possibility, but at least you could. I will also set style to props style so that you could also directly manipulate the inline styles, just adding some extra flexibility here, no matter if we use it or not. Now I want to render a map here with Google Maps, and for that we need the Google Maps SDK. So you can search for Google Maps JavaScript SDK and you'll find the official documentation. Now, first of all, we need to set up a project here and get an API key. We'll also later, by the way, in the Node.js module do the same, because there we'll need some other service from Google, and you can then later reuse the project you're about to set up here. To set up such a project, you need a Google account and click on Get Started. Now also, one important word here, for Google Maps and to use their tooling and their APIs and their SDKs, you need an account with a credit card. It's generally free to use, and you can search for Google Maps pricing to find their pricing information. You get $200 of free usage every month, which is a lot and which definitely suffices for what we're doing here in this course. But if you're using it in a real project, of course, you should definitely check which prices or which costs you can expect. And you also now need a credit card to continue and render a map. If you don't have one, of course, you could look into alternatives like Mapbox or simply render some dummy div with a background color here so that you can still continue with the course even if you're not seeing the map. Unfortunately, you need a credit card, not my rules, but Google's. Now here in this overlay, which you see on Google's page, check maps and also maybe places because we'll need that later when we, in the Node.js module, also need a Google project and unlocked maps functionalities. Click continue thereafter, and now you have to select or create a project. There I will create a new project, which I'll name MERN. But you can pick any name you want here and click next. Now this will take a while and you'll have to confirm that this is the account you want to use for billing. As I mentioned, what we do in the course here will be possible for free, but definitely check the pricing if you're using it in a real project. Confirm this here. And after a while, the creation will be done. And you should see an overlay with your API key, which you will also need. If you're not seeing it, go to APIs and then click on Maps JavaScript API, Credentials. And this is the API key here, which you will soon need. Now, why do we need it? For that, search for Google Maps JS SDK again and go to their docs again, where we've been before. Here you'll learn how to render a map with Google Maps. And here you'll learn way more than what we will use in this course. So if you want to become a Google Maps expert and you want to use it in a lot of different ways in your next projects, these docs are the place to go. Now, one thing we need to do is we need to grab this script here and add this to our index.html file. There, let's say here at the bottom of body, but since it has async and defer on it, this doesn't really matter. So maybe also here in the head, we enter this script. And now here we need to inject our API key. So this API key I just mentioned, copy it, and then here replace your API key without the ampersand with your API key. But get rid of that callback init map thing here so that you just have the script import ending with your API key. This will import the JavaScript package that helps you render Google Maps. With that, let's go back to our map.js file, because here we can now use this package which is added to our application. In there, in this component, we create a map with new window.google.maps.map. This is a constructor function which will now be available on the global window object in the end, thanks to this import we just added here. This SDK will be loaded and will add global variables on the window object, the Google variable to be precise, which then gives us access to the maps feature and there ultimately to the map constructor function. This now needs a pointer at an element, so in this case at this div, where the map should be rendered. Now to get this pointer in React world, we'll not use document getElementById and assign an ID to the div, even though that would also work, but we'll do it in a more elegant way. We can import useRef from React. This is another hook which we haven't used before. useRef can be used to create so-called references, which can be one of two things. We often use them to get a reference, a pointer at a real DOM node. That's one use case, a very prominent one. The other one is actually that with refs, we could also create variables which survive re-render cycles of our components and don't lose their value. But that's not what we need here. So all we do here is we create a mapref constant by calling useRef, const. And then on the div here, we add a special prop, the ref prop, which React understands, where we point at the mapref. And React does the rest and sets up a magic connection between this div and this constant, so that in this constant, we in the end store a pointer to this div. And now here, to this map constructor, we pass mapref, though not like this. Instead, there we have a current prop, which holds this actual pointer which we need. So now we tell Google Maps where it should render the map. Now the map constructor here takes a second argument, which is an object where we can configure that map. Specifically, we can set a center and a zoom level. Now I want to make sure that both can be set from outside. So here I want to be able to use props center and props zoom so that this is really controlled from outside this component. And now it would also be nice to render a marker at the center. And by the way, you can learn all that syntax here in the official Google Maps docs in case you're wondering how I know all of that. So here to render a marker, I simply call new window .google.maps.marker, and to marker you pass in an object which has a position key which should be props.center. And as a second argument you pass in a map key which should point at your map object which you created before. So here this map constant. This will create a new marker in the center of our map. Now with that we have everything in place which we need to render a map. So let's now go back to the place item and import map from shared components UI elements map like this and render it here instead of h2 the map. Instead we render our map here as a self-closing component. And now on this map we have to provide this center prop which should be props coordinates and the zoom prop which I'll set to a level of 16 which should work quite well. Now important, this coordinates prop here, right? This has to have a specific format. You find that in the official docs of the JavaScript SDK, of course. It has to be an object with a let and a lng key where both values are numbers. Now that's exactly what we have in our coordinates prop here, because in place list where I set the coordinates of a place item, I refer to place.location. And if we have a look at a place, there we do have a location property, which is exactly an object of that structure we need. If you created this in a different way, you definitely have to add some step to map it into the value Google Maps expects here. So into an object with a let and a lng key. And with that, let's save this and let's have a look. If I click view on map, this crashes. Now why is that? Well, this has something to do with some React internals. Let's have a look at the map component again. I rendered a map by using map.ref current here, right? And that uses our reference, which I said is magically set up with the help of React here to this div. Now what's the problem here? When this component renders for the first time, which will in the end happen when we render our place item, then this is executed from top to bottom. We initialize our ref, but the connection has not yet been established because this part hasn't executed yet. And this is where the connection is established. So we just initialize the ref, but there is no connection yet. And in the very next step, I tried to render a map in that place, but the connection wasn't established yet. So this can't work because Google Maps can't find out where to render this. Now, thankfully, React has got us covered. We can import another important hook, the useEffect hook. I haven't covered it thus far, but it's a super important hook and we'll see it a lot throughout this course. useEffect allows us to register logic, a function, that should be executed when certain inputs change. So for example here, we set up useEffect, and we set up the function that should run, and then as a second argument to useEffect, an array of dependencies of that function. And whenever one of the dependencies changes, then the function here will be re-executed. If we specify no dependencies, this will only execute once when the component is initially mounted and loaded, and never thereafter. So, now we can move our map creation and marker logic into this function we have in useEffect here. Now, with it moved in there, we should also be clear that center and zoom in the end are dependencies here. So I will use object destructuring again to get these two properties out of props, center and zoom. I do this so that I can add them as dependencies independently here, and I don't have to add the entire props object as a dependency, which could change more often than just center and zoom. So here in there, we just refer to center and zoom therefore in all these places. And now we have a useEffect function which will rerun whenever the center or the zoom value, which is passed in from outside, changes. And again, that's just object destructuring, a default JavaScript feature which pulls elements out of props, or which pulls keys and their values out of props, so out of this props object, and stores them in new constants. Now, how does this help us? Well, useEffect will run when this component first is rendered, because then center and zoom changed. They had no value before, now they have a value. But, and that's the important thing about useEffect and why it helps us here, it will run after JSX has been processed and rendered. So it will run in the first render cycle, but after the JSX code has been rendered. And that means this connection here will have been established by the time this code runs. And we take advantage of this. If we now save this, this reloads, and if I now click on View on Map, this works. I'm not seeing the map, so something is still wrong, but generally it works. We get no error. So let's now make sure we also see the map though, because that of course should be the case. And the reason why we don't see the map is simply missing styles. In our map component, I have that map class here, right, on the div. Well, in map CSS, we should add some styles here for this map class selector, and we should set width to 100% and height to 100%, so that the map is rendered in the entire container we provide to it. And if we now save this here, this already should work, otherwise reload, and now you should see that, and you got a Google map here, which you can scroll and move around and zoom in and out and really use like your normal Google Maps functionality. You can even switch to satellite mode if you wish to. So now we're rendering this, if we click on View on Map, in our standalone modal. And with that, we already achieved a lot here. And we're still far from done. We're not able to add places, Authenticate is not working, and so on. So there's still a lot of missing work or a lot of missing functionality, but we will get there. This is a great step forward. So, our application doesn't look too bad. We can certainly do some things here. Now, one thing we can't really do at the moment is add a new place. Now, one important note at this point, whilst we can of course add everything we need to add a new place, so the form inputs and so on, what we'll not build at this point of the course is a real functionality to add a new place to the list of places here, for the simple reason that we have no backend yet where we could store that new place. Now, we could absolutely use something like Redux to manage application-wide state in our frontend app here, and therefore manage our places locally in the browser. But this is not what we need later in the course. There, we don't want to manage all our data just locally in the browser. Instead, we want to manage it on a server to also share it with other users and not just have it on our machine, on our running instance of the React app. So therefore, I will add the add place functionality now, but will not wire it up to our list of places, because here in our code, of course, we only have a dummy list of places anyways, right? We have the dummy places here, and for now we'll not add any functionality to manage this application-wide, because as I mentioned, we'll do this on a server later. Nonetheless, let's work on the new place page here, and let's make sure that we actually can add a new place so that we do have all the inputs for that, and that we can at least get to the point where we would be ready to send the place off to a server. For that, we need to build a form in new place. I want to return a form here instead of a h2 tag, and on that form, I'll add a class name of place-form. You can, of course, use any class you want. And in there, I want to have a couple of inputs and also a submit button in the end. Now, for the inputs, we could, of course, use the regular HTML inputs and combine that with, let's say, label components. But I want to create my own component, which combines both, and that's important, which also has built-in user input validation. My idea is that we have some kind of input component, which we could use like this. And that on this input component, we can configure it. We can give it a type of text, for example. We can give it a label of title. And we can also add a validators property, which should take an array of predefined validation rules, which we'll also have to create. So quite a complex component, which does not just render some visuals to the screen, but which, as I just said, also has some built-in logic for validating user input and so on. So that by the end, when this component is finished, we have an onChange prop there, which triggers a function on every keystroke and gives us not just the input, not just the text the user entered, but also some information whether that input is valid, so that we have the validation built into the inputs and we don't have to do it here in this new place component. That's again this idea of splitting code and of outsourcing things. So, step by step, let's first of all build a simple input which just outputs something visually, and then later, as a next step, let's add the validation. As a last step, we'll then also add validation to the entire form, where I basically want to sum up the different validation results of the individual inputs and decide whether the overall form is valid or not. But that will be the last step. So let's go to form elements then, and in there, let's add a new input.js file and an input CSS file to add, well, this component I was just talking about. And as I said, this will be a complex component, so we'll spend some time on it. We start simple though. We import React from React here, and then we have our input component, which receives some props and which will have some logic in there, and we export this. And of course, we should also import the CSS styling here, so /input CSS. Also, a little side note at this point, there are third-party libraries like Formic, which you can use in React to get form functionality for free, so to say. So to simply install that library, and then you can set up forms and form inputs with it, and use that to handle validations on. You could absolutely do that, and you can look into solutions like that. But in my courses, I'm always a big fan of teaching the topic at hand in depth. And I find it very interesting to see how form validation could be set up on your own and how you could build quite a sophisticated form input system without any third-party library. And therefore, that is what we'll do here. Back to our input component though. Here, I now want to return some JSX. And the JSX we do return here will be a div, which groups together a label and an input. And on that div, I want to assign some dynamic class names, form control, which will always be there. But in addition, I also want to be able to later add some dynamic class, so a class which will not always be added based on the validity of the input, so that we can, for example, color the label and the input field red if it's invalid. For now, we'll just have form control there, but we'll add more later. Inside of the div, we now need a label element, and there I want to output the text which is received on the label prop of our custom component. And there I'll also add HTML4 props ID. This here is basically the for attribute you have on a normal label as well. Just as the class attribute, for is a keyword in JavaScript. So here in JSX we can't use it, and hence we have HTML4, which will be translated to that regular for attribute once this is rendered to the DOM. Well, and then I expect to get some ID via props, and I pass this to HTML4. Then here I want to render the actual input. And there I want to be flexible. This input component should be able to render a regular input, but also a text area. So to cater for both, I will take a step back here and create an element, let's say, element constant, and the content of that depends on, let's say, an element prop, where we can decide from outside which kind of element we want to render. And if the element prop holds a value of input, then element, so this element constant here, will store an input element. Otherwise, it will store a text area, like this. Now, of course, we need to configure both now. The input here will receive some props, the ID, for example, props ID, and also the type, props.type, so that we can decide from outside which type of input we create, text, number, and so on. We also might want to be able to set a placeholder text with props placeholder. And that's it for now. We'll add more later, but for the moment, that is it. On the text area, we also can set the ID of this element. And we also might want to be able to set the rows from outside. So we can set this to props rows or to a default of 3, let's say, with this fallback value in case the rows prop is not defined. Now for the moment, that's it. Below the label, we can now output the element. So here, a dynamic expression, because I'm referring to a JavaScript expression here. I'm outputting the value of element after all, and the value of element is either input or text area. So that's getting rendered down there. With that, we have a very simple input or a form control set up. Now it's also time for some styling, and for that, attached you find an input CSS file, where you can just paste the content into this input CSS file. And you will also find a new place CSS file, where you can paste your content in, and make sure that in new place.js you import that new place CSS file, of course. And this will ensure that the entire form is styled properly. Now in new place.js, we can also import the input component now. So import input from, and then let's go to the shared folder, components, form elements, input, and this should therefore work. Now let's see if it works, and for that we'll need to specify one extra thing here. Keep in mind that in our newly added input component, we require the element prop to render either an input or a text area. So if we don't specify it, we'll always render a text area, but if we don't want a text area, we have to add an element prop and set this value to input. So here in the new place component, I will add element and set this to input here. With that, if we save this, we get this simple form. Not super amazing, but a good starting point. Of course, at the moment, there is no built-in validation or anything like that. So before we add more and more inputs, let's actually focus on that built-in logic and validation part. So we have our basic input, but right now it's just a presentational component in the end. It just takes some configuration here and then renders a nice looking input field and a label. Not too bad for sure, but also not all that I want. Instead, my idea is the following. And I really want to highlight that this is just one possible approach of doing this. But my idea is that in the input component here, we manage some internal state, we manage what the user entered, and we also manage whether what the user entered is valid or not. The answer to that question, whether it's valid or not, is provided with some external configuration. So when we use the input component here, for example in new place, I want to be able to pass in an array of validators, which of course has to be an array of some clearly defined values or objects or identifiers, which we pick up in input component, through which we then go inside of input component to find out whether the input is valid or not. And then we basically pass the information whether the input is valid and what the input actually was, so the concrete value entered, back to new place. With that pattern we already know, where we have something like on change here or on input or whatever you want, and then you simply pass in a function to the input component which you call from inside there. So how can we implement this? Let's start simple, and in the input component let's add a new function in a function, the change handler, which should trigger whenever the user enters something. We can simply bind this on our element, and therefore I will actually move it up here. We can bind this to our element here on both the input and the text area. So we can add on change here and point at the change handler. Do that on the text area and do that on the input. With that, this function will be called for every keystroke. That is when on change triggers. Now when that change handler is fired, we want to do two things. We want to store the value, just like that, and we want to validate it, as I mentioned. Now, when you're managing more than one state, and the two states are kind of connected, you could use state and simply set up two states which you manage. That is absolutely fine. You're not limited to one. So we could manage the, let's say, entered value and have set entered value here, and then call use state and start with an empty value, and then replicate this and have the is valid and set is valid state here maybe, and start with false, and then you update both. You could do that. And it wouldn't be horrible, but often when you have two kind of connected states, and these states clearly are connected, the validity depends on the input value, then using a different hook is better. Use reducer. Use reducer also allows you to manage state in a component, and it also gives you a function you can call which updates the state and re-renders the component. But the difference to use state is that with use reducer, you can manage more complex state with ease. You can write some logic that basically runs whenever you want to change the state to do more complex updates than just set a new value. And therefore, use reducer is great whenever you have more complex state or you have interconnected state. So therefore, here I will use reducer. But how do we use it? Well, we call it like this, and then we have to pass in at least one argument. And that's a so-called reducer, hence the name. A reducer is really just a function which receives an action which we can dispatch, and I'll show you how we dispatch an action in a second, and it receives the current state. And then we update the current state based on the action we received, return the new state, and use reducer will take that new state and give it back to us in the component and re-render everything. So we can run a more complex state updating logic. I'll set up the reducer function outside of my component because it does not depend on any component inputs, and I'll name it input reducer. Now it is just a function which gets two arguments, the current state and this action I was talking about. So we have this function here and we pass the input reducer here to use reducer. In this function, we then always have to return a new state. And we can use a switch statement here, a vanilla JavaScript construct, to find out what action we have. Now, it's up to you how we determine which action we have, but often you will dispatch actions that have a type property, which have a unique identifier that describes the action. And here we could wait for a change action, let's say, and it's totally up to us which identifier we use here. You could use any identifier. I'll wait for a change action, and then I will return a new state here, a new state object. The state here doesn't have to be an object. It could be anything, but in my case here it will be an object because it will merge multiple different state pieces into one grouped state. And I will return this if we have this change case. I will also provide a default case here where I return the existing unchanged state. In case we dispatch some action which we don't handle explicitly here, well then we'll just make it in here. So, what's this new state which I want to return here? First of all, I will create a copy of the old state so that we don't lose any data of the old state. And we can do that with the spread operator, the three dots, and then state. This copies the old state object and copies all key value pairs of that old object into this new object. And then we can override selected keys, selected properties. For example, value. Let's say we want to have a value property in our state. I will set it to action.val. And again, it's up to you how you pass that new value along with the action. I will store it in a val property on that action object, which I will eventually dispatch. There is one other state piece which we need to manage, and that is the isValid state, whether that input is valid or not. And now here we will have to run some validation logic. Now, for the moment, I'll just set it to true, but we'll replace this with the actual validation logic, which we just don't have yet. And I don't want to introduce too many new things simultaneously. So for the moment, let's hard code this to true. So we have our simple reducer. We register it here with use reducer. Use reducer also is able to take a second argument. It's optional though. And that can be an initial state you want to set up. So a state with which you want to initialize your component here. And there I want to have an object where value is set to an empty string, let's say, and where isValid is set to, let's say, false, so that initially the input is treated as false. And now this is my useReducer initialization. Now just like useState, useReducer returns something. And just like useState, it returns an array with exactly 2 elements. So just as with useState, we can use array destructuring here to get these 2 elements out of the returned array and store them in constants. And the two elements we always get from useReducer, no matter how we configured our reducer, is the current state, I will name it input state here, and a dispatch function which we can call. This is then how we will be able to dispatch actions to the reducer function, which will run through the function and return a new state, which will then update input state and re-render the component in the end. So, with that, in change handler, I of course wanna call dispatch. I wanna dispatch to this reducer, and therefore here I pass an object, which is such a action object. And here we in our code defined action to have a type and a val property. So we should make sure we provide these two pieces of information here. So type should be set to change. And here, of course, I want to use the exact same identifier I expect up there. So if you chose a different identifier, you have to use a different identifier down there as well. And I'll set val to event target value. Event is an object we get automatically on the change event. And event target is the input element on which this event was triggered, and value then simply is the value the user entered. With this, we are updating our state. Now, to kind of reflect it, I will do two things. I will bind the value of input back to input state.value so that we have this two-way binding going on again. And I will do the same, of course, on text area, value to input state.value. By the way, in React, if you want to set the value on a text area, you don't set it here between the text area tags, as you might think. Instead, you do really set that value prop here. That is how you set the value of text area. And last but not least, to also have some extra feedback on whether this is valid or not, here below the element, I will check if input state is valid, is false, hence the exclamation mark at the beginning. And if that is the case, I want to render some error text. And that error text should be settable from outside. So I will render props error text if that input is invalid. Now I also want to render a conditional class name here. So I will check here in my class name template literal. If input state is valid, is false, hence the exclamation mark at the beginning again. If that is the case, I will add a form-control-invalid class so that we add this extra class to the entire div if our input state is invalid, which it is initially. It only becomes valid after we type at least one character, because that is when I hard-code it to true. With that, let's go back to new place and use the input appropriately. Validators is not something we use yet, so passing in an empty array is okay. On input, we can't specify this yet, because at the moment we don't really have a mechanism of feeding the value and the input validity back to the parent component. But what we can and should provide here is an error text, which I'll here set to please enter a valid title. And with that, if we save this, we have an input which initially is invalid and therefore looks like this, but as soon as we type at least one character, it becomes valid. Now, this never becomes invalid again because we have no real validation set up at the moment, but it generally works. We are able to type, we're able to change the validity initially, and that is not looking too bad. Now, of course, it would be kind of nice to have some real validation built in and to be able to really check, for example, if that's empty and so on. Now, to add real validation, let's add a new shared element. In the shared folder, I'll add a util folder, and in there, paste in the validators.js file you find attached. Now, this is simply a file with some validation logic. Now, it's just one possible way of implementing this. It is the way I opted for. So what do we have in there? First, we have some identifiers of different validator types. For example, to validate for required input so that it's not empty, a minimum length input, a min or max value if we're talking about numeric input, if it's an email address, and if it's a file, which will become important later in the course. Then I export a couple of functions here, all written in all caps, which is not a must do, but which I do here to make clear that they're kind of defined globally in one place. And yeah, every function here is a really straightforward function that might or might not take an input value, and not the value the user entered, but a value to configure that validator. And then it returns basically a validator description, an object with a type, and then one of the identifiers above. The functions that do take an input are the validators that require extra configuration. For example, the min length validator needs to know which min length a string should have, and that's then stored in this val property. So in the end, these functions return validator configuration objects, you could say, where every object at least has a type and maybe also has a val. And then I have a validate function as well, which I export at the bottom. And this function takes a value, that's the concrete value the user entered into an input, and then an array of validators. And it then goes through that array of validators and checks for the different types we are aware of and runs different validation logic based on the type of validator we got. This is what happens here, and I got some predefined, relatively simple validation logic here because I want to focus on the React part and not too much on this validation logic part here. Of course, you can fine-tune and tweak this to your likings. Now, what do we do with the validators.js file? Well, we can go to our input component again, and there we want to add some validation logic, right? So let's start by importing the validate function from the util folder here, and then the validators file. Not all the other exported things, just the validate function. And here in the input reducer, we can then call validate and now pass in action.val, so the user input in our input field, and action.validators. That's an extra key we're not passing yet, which we also should provide. So action validators. Now, where is action validators coming from? Well, on the change handler, where we dispatch the change event, here I want to add this validators key, and that should be coming from props. There should be a validators props passed to the input component. And indeed, if we have a look at new place, which is where we use the input component, I have validators here. It's just an empty array at the moment, but now with the extra utility file, we can change this. For that, let's simply import something from shared util validators. And the something I want to import here is the validator require function. Here in the validators array, we now just execute it, and this returns such a validator configuration object, as you learned. So what's the idea here now? With that, we're passing all the information to the input element that it needs to know that for this input, we want to make sure the value the user enters is not empty, because that is what I check for in the validators.js file. If the validator type is require, I check that the input is not empty. And we will have that validator type because that validator require function we're executing in new place returns an object where the type is set to validator type require. And I'm looking for that validator type down there in my validate function. So this is how these things work together. And with that, if we now save this, we start in an invalid state. As soon as I enter something, it becomes valid. But if I then empty this again, it's invalid again. So now we have real validation here for this field, which updates with every keystroke. And that's, of course, exactly what we want. But what we don't want, probably, is that when we start here, so when I reload this page, that it's marked in red right from the start. Technically, that is correct, of course. It is invalid. But we want to give the user a chance of at least entering one character before we start throwing errors at him. So to do that, we need to tweak our input component a bit more and list not just for the onChange event here, but also on the onBlur event, let's say, on the input and also, of course, on the text area. OnBlur is triggered when the user loses focus on the input element, which means the user had to click into it and then clicked out of it. And that, of course, is a good indicator to us that the user had a chance to enter something valid. And if it's then invalid after losing focus, then we want to show an error. Now for that, I'll add a new extra function here, the touch handler. And here we would also get an event, but I'm not interested in it. Instead here, I want to dispatch a new action, and it's a different action, of course. it's an action where I set the type to touch. I don't offer any other input because we need no other input. So now here we can point at the touch handler, also of course on the text area, and we can now tweak our input reducer a bit. In the input reducer, I now want to make sure that we handle this touch case. So there, I want to return a state where I copy everything that's in there so that I don't lose the entered value, for example, but I update isTouched to true. IsTouched is a new field I add here, and therefore I also want to add it on my initial state where isTouched is set to false initially. So I set it to true once this blurs. Here in change I don't set it, but with this command I copy everything from the existing state, so we will have isTouched the state as well, we just don't change it here in this action type. So now we do manage this extra information, whether this has been touched or not, and therefore now we can go down to our JSX code and only add this invalid class if the input state is not valid and input state isTouched is true. So if it's invalid and the input was touched, so the user had a chance of changing it. And the same here for the error text. Only show it if input state isTouched is true. Now with that, this reloads and we see no error message initially. If I click in there though, and I don't enter anything valid, and I click out of there, we do see it. If I then enter something, it goes away, unless we really enter something invalid again. So this is now also working as it should. With that, we got basic validation implemented. We're not passing the information about the validity and the entered value back to new place though. And we should do that because ultimately new place is where we need to gather all the input, find out if the overall form is valid, and then also submit a request to the backend later in the course to create a new place on a server. So let's make sure we feed the information about the input, the value and the validity back to the place where we use the input. So in our case, to the new place component. So in the input component here, we in the end wanna call some function which we expect to get from outside, so in this case from new place through some prop, whenever our input state changes basically, or to be precise, whenever the value or the validity of the input changes. So for that, here in the input component, I will use a new or another React hook, which we already used before, and that's useEffect. useEffect, as you learned, allows us to run some logic when some dependencies change. We can use it to run something after the first render, as we did it in the case of Google Maps. But we can also use it to run some logic, in our case here, whenever the input value or validity changes. Because that are the two conditions, and typically they change together, of course, under which we want to emit a new value back to the place, back to the component where we use the input component. So maybe here we can use useEffect like this. Then here we have the function that should be executed, and here we have our array of dependencies, so array of things that should trigger this function. Now what do we want to do in this function? I want to call props on input, for example, because that is then the prop we can set in new place to be basically informed about changes, so where we then pass a function to input. So when I call props on input here as a function, because I expect to get a function on this prop, and then maybe pass our ID of that input back to the component where we use the input component, pass input state.value and pass input state.isValid. Now we need to specify our dependencies here, and we could say our dependencies are props and input state, right? Because we use data from props and we use data from input state in there. That would make sure that this function runs whenever anything in our props changes or whenever anything in our input state changes. This can actually create infinite loops because we call a function in the parent component, and if that then leads to the parent component giving us new props, we call that function again. And even if it does not lead to infinite loops, it might execute too often. It would also execute if our touch state changes, even though that's not a state that yields any new value or validity information. So therefore, I will not feed in these dependencies, but pull out the relevant pieces with object destructuring. From the props, I want to get the ID and the onInput prop, like this, so that here I can use ID and just call onInput. And from the input state, I want to get the value and is valid from input state, like this. And that means here I just forward value and is valid. And here I have ID, value is valid, and actually also onInput as dependencies, because the onInput thing here is also something we get from outside. So whenever one of these things changes, either the function that should be called, the ID, or most importantly value or is valid, we will call onInput, so the value we get on the onInput prop. That takes us to the new place component. There, of course, we now have to provide a function that should be called. So here in newPlace.js, we can add a function and name that title change or title input handler. It's a function which will receive the ID. You might say that's kind of redundant because we know it will be the title that changed. This will become important later, so for now let's just get it. It will get the ID of the input that changed, the value, and the answer whether that input is now valid or not. Because these are the three pieces of information we pass here in our input component. ID, value, and is valid, so we get these three pieces of information here. Of course, you could pick different names here for the parameters, though it's a brand new function in a different component after all. So now here we can bind onInput to the title input handler so that this is the function that does get executed. Now we should be careful though. We will have one problem, or we could have one problem. Whenever in input we call onInput and we forward this information, we trigger this function here, right? And if in this function we now do anything that changes the state of the new place component and re-renders it, what will happen technically is that a new title input handler function gets created, because we create this function inside of the function. So whenever the component function reruns, this function is recreated. Even if it has the same logic as before, it's a new function object. That's how JavaScript works. So that means that the function will technically change. The function is fed into the input component, and there, onInput is a dependency of this function. So then this effect function would run again, would trigger this function again, and would effectively lead to an infinite loop. To avoid this, we import another hook from React, and that's the useCallback hook. We can use useCallback to wrap a function, so in this case, this function here, and define dependencies of this function under which it should re-render. And here, for the moment, I specify no dependencies, which now means if the component re-renders, if the component function re-executes, this function here will be stored away by React and will be reused, so that no new function object is created whenever the component function re-renders, but that instead this function is reused and doesn't change. And that then does not lead to useEffect to run again. That's really important here to avoid an infinite loop. And with that, of course, the question is, what do we want to do in title input handler? Well, we want to, in the end, manage the overall validity and values of the entire form. Because we will have multiple inputs there, we can already create a second one, for example. We can create a second input, and that, let's say, is actually a text area maybe, hence we don't need to type. The label then could be description. We also should provide an ID, by the way, here. ID should be title, and here ID would be description, let's say. And I also want to provide my validators. Here I want to require this, but I also want to make sure that we have a min length of 5, and therefore we don't actually need require, because if we have a minimum length of 5, well, it must not be empty anyways. Here we can enter, please enter a valid description, at least 5 characters, as an extra hint maybe. And we could also specify the rows here, but I'm happy with the default of 3, which we coded into our input component. So now we have a second input, and now we want to find out in our input handlers whether the overall form is valid, and of course we want to store all the values of the individual inputs. So actually we'll need a second handler here, a description input handler, and we'll bind this description input handler to this second input here, to the on input prop there. So now we got two input handlers, and now we need to manage the overall form validity. So we got multiple states to manage, and as you learned, that can be done with useReducer. It could also be done with useState somehow, but with useReducer it's much easier. So we'll call useReducer here in the new place component, and now we need to set up a reducer function here, and I'll name it form reducer. The name is up to you though, and just as before, it's a function that receives a state and an action and then needs to return a new state. We can pass form reducer here to useReducer. Initially here, I also want to have an initial state, and there I want to have two properties in my state. So my state is an object, and I want to have an inputs property, and I want to have a isValid property. My idea here is that isValid stores the information whether the overall form is valid. And inputs is a nested object that stores information about the validity of the individual inputs. So in my case, title. And here I want to use the IDs I assign to these inputs. That will make updating easier later. So title and description. And title then is an object again, where we have, let's say, the value, initially set to an empty string, and then is valid for that individual input, initially set to false. And now I will copy that and add the same here for description. And is valid of the overall form initially also is false. So this is the initial state. This is then the state we need to update inside of the form reducer based on the different actions we might receive. So again, we can switch on the action type to follow that same pattern as before. We can specify a default case here where we just return the unchanged state. And of course, I also want to handle a case here, and there I will handle the input change case, let's say. But that's totally up to you how you name that. In there, of course, we will return a new object, a new state object, and here we need to update a couple of things. We need to update the input state, which changed, and the overall form validity state. So let's run some logic in there. And that's the idea why we have reducers. We can run more complex logic to derive our required state update. I'll add a helper variable, form is valid, which initially is true. And then I want to go through all the inputs I have in my form here, in my form state, and find out if all these inputs are valid. So I'll go through all the inputs in state.inputs. Remember that our state here has an inputs property. So I'll go through all the inputs stored there with a for in loop because I'm going through an object. And then here I check if the input I'm currently looking at, and keep in mind this is in the end the input ID here, right? So we could name this input ID because I'm going through the inputs, so I'm going through title and description, and that is what will be stored here in input ID. I check if that is equal to, let's say, action input ID. So I'm effectively looking at the inputs and checking the input I'm currently looking at, is that the input which is getting updated here in this current action? If that is the case, I will take the information from the dispatched action on whether it is valid or not. So I'll then set form is valid equal to form is valid and action dot is valid. So if that input change for the given input is valid. Else, if I'm looking at an input in my form state, which is not currently getting updated through the currently running action, well, then I will set form is valid equal to form is valid and state inputs for the input ID we're currently looking at is valid. So basically, I take the stored value, the stored validity for this input because it is the input we're not currently updating with this action. And this approach here makes sure that I always take the previous value of form is valid and combine this with the new validity value. And if that is false, this will be set to false, and false with false or false with true will always yield false. True, which is my initial state, with false, however, will yield false, whereas true and true will keep true. So that ensures that if we have at least one false validity anywhere, the overall form validity becomes false. And with that, after the for loop, we return our new state here. And there, I want to copy my existing state first of all, and then set inputs equal to the current input state. So I'm copying that as well. But then I want to override the input state for the input we're updating with this action. And this action has an input ID field. That's my expectation. So I will use this dynamic assignment here and change the key input ID here, so of the input ID passed with the action, to be a new object where the value is action.value and isValid is action.isValid. So this dynamically updates one of our fields in this inputs, as it should be, in this inputs object. So for example, if we dispatch an action with an ID, an input ID of title, then we would in the end see title in here and update the title input with a new value and a new validity and leave the description input untouched. Well, and then I also want to set isValid here, so the overall form validity, to form isValid. That is my reducer logic. Quite complex, but it should ensure that we update the information about the inputs and the overall form validity. Now, just as before, useReducer returns values. So I will use array destructuring to get these values. And the first value is my form state. The second value is a dispatch function, just as we had it inside of the input. And now in the title input handler, I want to call dispatch and dispatch a new action where I set the type equal to input change. That's the type I'm looking for in my reducer. So we'll set this type here. And I provide a value here because I try to extract a value from action here and later also isValid and the input ID here. So we need to pass these three pieces of information. Value, of course, is the value I get here. IsValid is, well, the information I get here as an argument. And input ID is the ID here. So now we actually have a flexible, reusable input handler. So we can just name it input handler, get rid of the description input handler, and simply bind this input handler here to both the title input as well as the description input, because we get all the information we need inside of that function anyways, so no need to create multiple functions. Now here, dispatch would technically be a dependency and you can add it, but React ensures that dispatch from useReducer never changes, so you can also omit it. And with that, we are, hopefully, managing the overall form validity. So let's go back to our new place component here. And in there, let's now utilize this form validity. For example, by adding a button at the bottom. And for that, we first of all need to import it. So here, I'll import button from shared components, form elements button, and add this button inside of the rendered form after all these inputs, here maybe. Set the type to submit and set disabled equal to not form state is valid. So when the form is not valid, the button should be disabled. And then on the button, I'll have a caption of add place. And now if everything works the way it should, this button indeed should be disabled whenever our form is not valid. So let's save this and let's have a look. This reloads, we got two inputs, and initially the button is disabled. Now if I enter something here, this is valid, but the button is still disabled. If I tap in here, we get our error, button is disabled. If I enter something here which has at least 5 characters, everything gets enabled though. So it looks like this is indeed working in the way it should. If both is valid, we can tap the button, and right now we don't handle the form submission properly, but that will change. But if at least one input is invalid, the button is disabled because our overall form state seems to be invalid. So that is working as it should with the help of useReducer and all the logic we have here. Now we're not done, of course. Now let's also handle the form submission. To handle the form submission, we need a new function in the new place component. I'll name it place add or place submit handler. Name is up to you. And there we get the event object, and that is important because first of all, I want to call event prevent default. Why? Because I want to make sure that we don't have that browser default of submitting the form and sending a request, which effectively leads to a page reload and therefore crashes or ends our running single page application. Place submit handler is then bound here to the form. So on submit is here set to place submit handler. And with that set here in the place submit handler, we now can send our data to the server. Now, of course, at the moment we have no logic to send it to a server. We have no server yet. We have no backend yet. This will change later in the course. For the moment, let's simply console log our form state inputs data here to find out whether we have all the data stored in form state correctly. So the value and the validity for all our inputs. So if we now save this and we enter something here and here, and I click add place, we don't reload the page, which is great. And here indeed we have the output I want. I'm logging this here. We have the description, we have the title, and we're storing the values and the validity correctly here. So this is working, and later we will be able to send this to the backend. So that is what will happen later. And that is how easy form submission is. Our form is not finished though. Of course, we got the title and the description. Now we need more inputs though. So I'll copy this and add another input here. Because besides the description and the title, I also want to have an address for every place. Here the element will again be input, not a text area. And here I will say address. Now, address does not have a min length, but it should not be empty, so I will again execute this require validator function to configure this require validator. And the error text here is please enter a valid address. We'll not check if the address exists. We'll later do this on the backend, not here on the front end. That should already be all though. That is the great advantage of having this reusable input component and this reusable input handler function. We can add a new input as simple as that, and it should automatically be taken into account. Yeah, everything is only valid here if I enter at least one character into address. And if I then invalidate one of the other inputs, we lose that again. So this all works as it should. We can submit this. It's also part of our form state here, of course, the address. And with that, we're finished. We will later also add image upload, but we have a separate module for that. And hence, I'm happy with that form. We could send it to a server. It's not the only form we have though. What about editing places? There, we also need to be able to at least edit some of the aspects of a place. Let's continue with our application by adding a new component, the update place component. Update place.js in the places pages folder is added therefore. And then here the idea is to also show a form where users can enter some data, but for this application, I want users to only be able to update the title or the description of a place. So let's import React from React here and create update place here as a component like this here, and then export update place again. That is what we did before. Now, update place is a component which, of course, should be loaded with routing. So for now, I'll just output some dummy content here and go to app.js to add a route. Here, it's that last page which we planned, which we want to reach under /places/ the ID of the place. And then here we want to, in the end, load that update place form. So here in our route setup, we can add a new route. And the path of that route is /places/ and then the place ID. Now, one important word here, this here and this path here, of course, are very similar. If we would change the order here and move that in front of places new, we would have a problem because then every URL entered that starts with /places and then has something after it would reach this route here. Because if we had /places/new here, new would be interpreted as a place ID. So in order to ensure that we don't cause this route to never be reached, we have to render this route first so that React router first checks whether we want to go into this route, and only if we make it past this check, so to say, we look for this route. So the order matters here. And then in here, I want to render update place. So let's import that. Let's import update place from /places pages update place like this. And then update place is the component we render here like that. So simply as that, this renders update place. And now with that, of course, we can go back to update place. Later, we will then get the ID of the place out of the URL and fetch information about this place from a server and initialize our form with that place data. Now we'll do that initialization part now, but of course we can't fetch the place data from a backend because we have no backend yet. So for the moment, I'll just get the ID from my server and then simply load my dummy place data. So here I will import use params from React Router DOM to get that actual place ID, which is part of the URL. And we can get this here and store it in a constant named place ID by calling use params. And then there we'll have a place ID field because, place ID here, because I named this dynamic segment here, place ID. So we can extract the concrete value for that segment by that identifier inside of update place. Now, as I mentioned, I then want to load one of my dummy places. So here in user places, we have that dummy places array. We could export it and simply import it in the other file or just copy and paste it, which is what I will do here outside of the component, just add it here. And now I want to find a place with the ID that I have in the URL from that array of places. So here, I'll have my identified place, or however you want to call it, which I get from dummy places by calling find. And there I will go through all places and find the place where the ID is equal to place ID. That's my idea here. Now, if we don't find a place for the provided ID, for the moment, I'll just return something. So I'll check if not identified place and return could not find place if, well, I could not find it. Maybe wrap this in a div with a class name of center so that this is nicely centered. We'll have better error handling later once we have a backend and we connect this application to the backend. At the moment, we don't have that, so I'll have this dummy fallback. So let's assume we found a place though. If we did, of course, I want to render a form here, and I want to render a form which I initialize with values from that place. So here, let's return a form element again, like this, and in there, render all the inputs we need. So let's import some inputs again. Up there, I'll import input from, and now again, go to the shared folder, components, form elements, input, and we'll also need the button from there, so we can also import that already and get the button from the exact same folder in form elements, button. With those imports added, back to the form. In the form, I want to render my inputs. And the inputs I have here is a title input and then also a description input, because these should be the two pieces of information that should be changeable, that should be editable by users after a place was created. So the element here for the title is input. Type is text. I want to have a normal text input. The label will be title. And validators will be an array where I, of course, now need my validators. So for that, let's import from shared util validators. And I want to import validator require here and validator min length, because these, again, are the two validators we need here. So down there, here I execute validator require as a function. We can also provide our error text where I say, please enter a valid title. And of course, on input, where we get the entered value and validity of that value. Now, the function we add here, that's something I'll focus on later. Of course, we can use the same function as in new place, but then we also have to add use reducer and everything to update place. And that means a lot of code duplication. So maybe we can find a more elegant way there. Now, one other issue we'll have here is in this scenario, when we're editing a place, I actually also want to set an initial value on the input. And that's something we don't currently support. I want to be able to set my value here to, well, as I said, some initial form value. So initially to identified place.title, for example. So that's also something we'll need to support. And therefore, we also want to set an initial validity. And in the end, set this to true here, you could say. Because, of course, since we have a title initially, it initially also is valid already. So we'll need to tweak our input component a little bit. Before we do so, though, I'll add my description element here, which is a text area. Type is therefore not required. Label is description, and here I need the min length validator and set a min length of 5 and say please set a valid description min 5 characters. And here, of course, I want to initialize this with the identified place description, set validity to true, and we'll have to see what we do with on input. So let's still add the button though. There, the type should be submit. It should be disabled if the form is invalid. So initially it is enabled because initially this form is valid, of course, because we do have initial values for title and description, but we'll also have to revisit this logic. And then here I'll say update place. So as you can tell, we have some work to do. We need to adjust the input component to be more flexible and accept initial values and initial validities. And we want to look into reusing some form code, maybe reuse this reducer and so on, so that we don't have to duplicate so much code. So let's focus on the input component though. In the input component, we need to be able to work with initial values and validities. So in the input component here, value is not always an empty string. It also can be a value provided from outside. So here, props value could be something we set as an initial value or an empty string if the value prop is not provided. And for isValid, it's the same. We set this to props valid or false if that's not provided. So this is one important adjustment here to work with initial values and support this as well. Let's see if that works. If we save this, and we click on edit here, we're taking to this form, and this form looks horrible because the form styling is missing. I'll fix this soon. But if I now have a look at this, the button is disabled, and that makes sense because in update place, we currently always disable it. But let's see if I get an error if I now remove that initial value. By the way, the fact that we see this initial value here already shows us that our input seems to work. And yeah, if I remove it, we get an error. If I add a valid input back, we get no error. So that is looking good. That seems to work. Now, of course, the overall form is not looking that great. There, I actually want to use the same styling as a new place, and therefore I will name this place form CSS here. And in new place.js, import place form CSS and import the same here in update place so that I can reuse this styling. This, of course, means that in update place to the form, we should add this class name of place-form so that the styling applies there too. And with that, that looks a lot nicer. So that's good. So our input component seems to work and the form is looking good. But now what about the form state itself? What about this form reducer and all the logic we wrote in new place? A lot of that logic is required here as well, but not all the logic. For example, the initial state is a different one. Here we have title and description, and we should also have address. And in update place, we only need title and description, and we don't need address. So how can we kind of reuse that and still make it configurable from inside each component? For that, we can create a custom hook, something we haven't done yet, but which we will do now. Let's create our own hook. For that, just to make it really clear, a hook is a normal JavaScript function, but a function that starts with use, that's just a convention though. More importantly, a function which can share stateful logic. So a function which can, for example, use reducer or use state inside of it, and which React then recognizes and uses such that when in this custom hook you do something that updates a state, your component that uses your custom hook is re-rendered. So it's a special function React recognizes, you could say. A special function you can use in functional components, which React recognizes, and where if inside of that function you change something that impacts the state, React will re-render the component that uses your custom hook. That is what hooks are about in the end. So let's create a custom hook and it should become clearer. In our shared folder next to components, I'll add a hooks folder. Hooks because we will add more than one hook throughout this course. And here I want to add my form-hook.js file. You could also just name it form, of course, if you prefer that. Now in there, I want to hold all my useReducer logic that I set up in new place. So actually, I don't want to be forced to import useReducer and use callback in here, but instead I want to import that in the form hook. So there I want to import use callback and useReducer from React. Then in here I want to have my own function use form, and your custom hooks always have to start with lowercase use. That's a convention you should adhere to. And I will export this function. So that's my own hook now. I export it here. Now in new place, I have my form reducer, and I will cut that from new place and instead add it here into the form hook outside of the hook function, just like this. In there, we have a lot of logic that basically works standalone. There are no external inputs that are required from our component. This function only needs information about the state and the action, and all that information is passed through parameters. So this function should work just fine here. In new place component, I then also use useReducer. So let's cut this as well and move that into the custom hook, here inside the hook function. Here I call useReducer, I got my form state, I got dispatch, and here I now got some logic which is specific to a component and should not live like that in the hook in general, because not every component where we will use that hook will have title, description, and address inputs. So we'll have to kind of take this initialization logic here for the inputs, take it out of our useReducer call in use form, and instead maybe expect it here as an argument to our custom hook. So that there I get my initial inputs parameter and I assign this here to inputs. And I also get my initial form validity and I assign this here so that this is also not hard coded into this useReducer initial state, but can be set from outside when we use the custom hook. So back in new place, there I now want to use that custom hook. So I will import use form from going to the shared folder, hooks, form hook. And here the idea is that we can now call use form and then pass in our initial input validity as a first argument and the initial form validity, in my case false, as a second argument. This now initializes my useReducer in my use form hook correctly, hopefully. We're not done though. This input handler should also be taken out of new place and be added to the form hook. Here I can add input handler with use callback, that's still important, use the dispatch function which I get from the useReducer, and then, well, leave my logic in here as it is. Now our hook should also return something, because we're not interested in the form state inside of the hook, we're interested in that state in the place where we use the hook. The same for the input handler. We need to share this with the component which uses our custom hook. So here I will return an array. By the way, you can also return objects or just text or whatever you want. Hooks don't have to return arrays. But here an array makes sense because I want to return my form state and input handler. So a pointer at this input handler function. I return both from inside my use form hook. And with that in new place, I can get both. Here, use form returns an array with exactly 2 elements. So on my own hook, I can also use array destructuring to get the form state and the input change handler. Input handler was the name before, so let's keep that name. Input handler. We can assign any name we want here when using array destructuring. So now I get that information back from my hook, but the logic of that reducer and so on now lives inside of that hook. And that hopefully shows the advantage of custom hooks. Our component now got leaner, and we got that logic, that stateful logic, and it is stateful logic. When we call this patch, we will re-render a component. We got that stateful logic in the hook. And because it's a hook and React knows this concept of hooks, when we update the state inside of our custom hook, the component that uses our custom hook will update as well. So therefore now if we save this, add place should work just fine. Here, if I enter something and I have valid inputs everywhere, my overall form becomes valid. And if I invalidate an input, it becomes invalid. If I submit it, we see all the data is there. So our custom hook works. And now we can use that custom hook also in update place, and hence we're sharing all that form management, input change handling logic. So let's go to update place, and there import use form from shared hooks form hook. And now, just as before, in here we can call use form, initialize our inputs and the form itself. The form itself should be valid initially. For the inputs here, we will have a title input. And for the title input, whoops, we need a colon here. For the title input, the value initially is, let's initialize it below identified place. Initially is identified place dot title. Is valid of that input is true, therefore, because that will be a non-empty value. And for description, the value is identified place dot description, and this will also be valid initially. So then we get back our form state, and we will also get back our input handler. So with that, we can use both. We can use input handler here on the on input props of our input components. And we can set the value here to form state dot inputs dot title dot value here in this case. And here on the description, it's form state inputs description dot value. And the same for the validity. This is form state inputs description is valid. Title is valid. So is valid at the end is important here. And here it's description is valid. Now please note that value and valid only are used in the input component to initialize the value. We could therefore also name it initial value if you wanted to. Maybe that is a bit clearer, to be honest, so that there is no confusion that you think we're always setting a new value here. No, we're just initializing this. So inside of our custom component now, in the input component, we now should use initial value here, and initial is valid here. So basically the props I'm passing here, I named it just initial valid, so just initial valid here as well. That's really important, just to avoid that this is confusing. So with that, back to update place. We're initializing these values. We bind to input handler. Now we can also bind our button here and check if form state is not valid. So if the form is not valid, and only disable the button if that's the case. Now with that, if we go to my places and click on edit, initially the button is enabled, of course, because initially, well, the values are valid. If I do empty this though, the button becomes disabled. It's the same here. If the description is too short, it's disabled. So this seems to work. Now let's also make sure that submitting this works. So in update place, we also can add our submit handler. And I don't want to share this with use form because the submission logic is very specific to the component in which we do have the form. So here I'll have my place update submit handler, or however you want to call it. We get the event, and I will call event prevent default to prevent that form submission and the request to be sent. And then console log form state dot inputs to see what's stored in there. And then we can bind place update submit handler to on submit here on our form. And if we do all of that, and I click update place, this looks quite good. And if I change something here, this should also be reflected. Let's see. Yeah, I got the exclamation marks at the end here too. So this is working. Let's also see this. Yeah, also looks good. So this is working, and with that we created our own hook to reuse our stateful form-related logic. We created our own hook, but I'm not 100% happy with it yet. It works just fine here, but later in the course, when we update a place, we will actually load that data here from a backend. We will fetch the information about a place from the backend, which means it will not be there instantly when we render this component. It will take a short while. This here, of course, is available instantly, but let's also handle the case that this would take longer. You might think that later, when we reach out to a server, we use fetch or something like this, which returns a promise. And in the then block, we can then call useForm to initialize our form with the then fetched data. This is not allowed though. In React, there is a rule when it comes to hooks that they must only be used directly in your component function. So you must not use them inside of if blocks, inside of loops, or inside of other functions, including then blocks. So you would not be able to call useForm in a then block. And that makes sense because it would mean that you only set up your hook after the response is there and not when this component first renders. But of course here, during the first render cycle, we already need information from our hook from form state. So we need to call useForm early. Still, I want to update my form values at a later point of time once my response is there. And here to simulate this, let's just say that we get our identified place only after useForm is called. Of course, we could switch position here, but let's imagine that this is not possible because this takes longer to load. What can we do in that case? In that case, we probably want to initialize this with our invalid values here, so with empty values. And later, once we connect this to a backend, we will show a loading spinner whilst we're waiting for a place to load. So we will not show an empty invalid form, no worries. But here, let's just say we have some dummy initialization values. And then here, once we got an identified place, I want to update my form state. Now for that, we need to revisit our form hook and add some functionality that allows us to replace the values and the validities stored in the form. For that, I'll add a new function here, which I'll name setFormData. I will also wrap it with useCallback so that it is stored by React and not recreated unnecessarily. And then the actual function should take input data and form validity as inputs. And then here, I want to dispatch an action, which I'll give a type of, let's say, setData. That's totally up to you, of course. You can use any identifier you want. And with that action, I want to pass my inputs data. So input data stored in the inputs key. And my form is valid data, which is that form validity we're getting. So this is an action we dispatch against our reducer now. setFormData is then also returned in this array, so that if we want it, we can get it. And then here in our reducer, we just have to handle that new case, that setData case we just added down there. Inside of setData, I want to return a new form state, which is basically overriding the existing state. Hence, I will also not copy the old state. I will just replace it entirely. And there, I will set inputs to action.inputs, because on my action here, I do have that inputs key. And we also have that form is valid key, and that will be used to set the overall validity of the form. Is valid is set to action, and then I had form is valid. So action form is valid. So now we can basically call this setFormData function, which we're exposing here, whenever we want to set a form data, so whenever we want to dispatch this action. Use callback also needs to specify its dependencies, and here we essentially got none. So this will never be recreated, this function. So we got that in place. With that, let's go back to update place and get access to set form data here as well, which we can pull out of the returned data as a third element. Side note, in new place, I will not get it because there I never need to set any form data. I only need that in update place. So there, now, once we got our identified place, we want to call set form data and basically initialize our form now. Set the overall validity to true, and here set different values for title and description. Title will have a value of identified place title, and the validity is true therefore. And here I have identified place description, and is valid is true here as well. Now calling it like this would be bad though. If we called it like this here, directly in our component function, it means whenever this component re-renders, we set new form data. Whenever we set new form data, we in the end dispatch this action, and therefore we trigger our form reducer, and whenever that reducer runs, it produces a new state, and whenever it produces a new state, even if the state data hasn't changed, it still is technically a new state. So whenever it produces a new state, the component that uses our hook will re-render. So we would have an infinite loop here. To avoid that, we can use a good old friend, the useEffect hook. We can use useEffect from React and wrap our call to set form data in it. So here I have useEffect, and in this function here, in the useEffect function, I want to call set form data. Therefore, I have two dependencies here, set form data and identified place. Now, identified place, thankfully, will not change with every re-render cycle. That logic will run with every re-render cycle, but we will always find the exact same object, the same object in memory. So it will not change, and therefore useEffect should not trigger again. And set form data will also not change because in our hook, we wrapped it with use callback. With that, if we save this and we go to edit, you see this is empty now. You see this is empty and it also never changes. So something is not working as it should. Let's see what that is. So what's the problem here? The problem is that our hook and our set form data logic here will work fine, but we do have this initial value and initial valid prop on the input, right? Now what happens inside of our input component? These values are taken to initialize our input state there. So that means when the values assigned to these props change, nothing happens in our input component, because only when this is rendered for the first time, this initial state is taken into account, and thereafter it does not run again. So it doesn't reflect any changes to the initial values. So how can we work around this issue? In update place, we have to defer when we create our form, so that we only render the form and its inputs when we really got our data for that, when we really got our identified place data, and once we used that to update our form data, so that we don't create this form too early with the dummy fallback data we set up here. Later, once we connected React to our backend, this will be easier because then we will be sending a HTTP request anyways, and we will know once this request finished. Here, since we're still kind of working around a problem which we don't really have, I'll use a temporary workaround, which we will absolutely replace later. I will only return this form here if we do have a value for title, let's say, which is an indicator that the values have been loaded for title and description. So here I will check if form state inputs title value is a thing, and only if it is a thing, I will render this form here and then close the curly brace after the form. And I actually don't need curly braces for that because it's the start of the return statement anyways. So now the form is only rendered if we do have a title value. Or to make this a bit nicer from a code perspective, we could also say if we don't have this value, so if this is an empty string, which is the case in our initial fallback value, we instead return some dummy JSX, where we maybe say loading. And again, we'll find a better loading solution later. But for the moment, this should do the trick. Here, I got one extra parentheses. Let's remove that. And with that, now, when I reload, we don't even see the loading state because, of course, everything loads instantly here because we're not really making a HTTP request. But we see we now got our correctly initialized form data. The problem we now have is, once I clear the input though, it's gone and we see loading because in our logic, whenever we don't have a title value, we want to show loading. So it's maybe not the best fallback. We can use it at the moment though, because as I mentioned, we will replace it later once we have a real loading state we manage with the help of HTTP. As a temporary workaround to have a little bit of a better solution, we can introduce a new state here with use state and name this is loading, set is loading, use state. Initially we are not loading, let's say, or to be precise, initially we are loading here. And then in use effect, once we also set our form data, of course we're not loading anymore. So here I will set is loading to false. So initially we are loading, then I set it to false once we got our data. And down here we can check if we are loading. In this case, I want to show the loading fallback and show the form otherwise. Now this works as before, but now we can also clear it without removing everything. So this is our solution for now. It's just important to understand that because of the way the input works and the initial value and validity is really only used once, we have to ensure that we only render this once we got the final values for initial value and initial valid. And with that, we are rendering this update form just fine. We are able to submit it and have our data there, and we're therefore well prepared here to connect this to a backend later as well. We made a lot of progress. Now let's fine-tune some smaller things, or one smaller thing which I noticed or which we still have outstanding, and that is in the end when we load our list of places here. So when the place list component gets rendered, you might remember that there we also have this share place button which we show if we find no places. We can simulate this if I temporarily comment out the 2 places we added here to dummy places. If I save that and I go to my places here, that button. I want to fine tune this. I want to use my own custom button here. So let's import button from, and then let's move to shared components, form elements button to use our custom button. We used a lot throughout this app already. Whoops, that was the wrong component though. Let's do that in the place list component, of course. That is where we need the button. And in there, let's replace this button here with our custom button. Now there, I also want to add a to-prop now, because the button is configured to work with such a to-prop and then renders a link in the end. And of course here I want to point at places/new, so that we have a proper button there. This looks way better and we're taken to add places when we click it. Now with that, I also want to test something else. Let's go back to user places and comment these places back in. And there, let's make sure that when we added a place, right, the URL is place P1, for example. If I use P2, we load that other place. And to see that we really loaded a different place, here I'll name this emp.statebuilding so that we have a tiny difference. And now when this reloads here, of course, I need to rename it in update place as well, because I just copied my array and did not export it. So let's replace this in update place JS as well, so that we have different places in the end. And indeed, it loads that different place now. If I load P1, we should see Empire State Building. And if we load P3, we get an error. So good that we tested this. We should fix this as well. And the error we're getting is here in update place that I call set form data, and identified place title is what I want to access. The problem is if we find no identified place, this is undefined and you can't access properties like title and description on undefined. So we should actually check here in use effect if we do have an identified place. So if this is not undefined, and only if we do have it, I will call set form data. I will always call set is loading thereafter and set this back to false. but I want to only set form data if identified place is not undefined. So with that, now we see could not find place if we have an invalid place, but we don't get an error. And we can also make this could not find place thing a little bit more pretty by simply importing card from shared components UI elements card, so the good old card we used before, and then wrap this in a card. So down there where I render could not find place, how about wrapping this here into a card? Let's see how that looks like. If we do that, yeah, I think that looks a bit nicer. With that, we made some changes which I found quite important to make. Now we have a nice flow here where we can edit a place, where we can view it on a map, of course, where we can also add a new place. Of course, all not really doing something because the backend is missing, but the general functionality is there. And once we do add a backend, we can then connect, react to it, send requests, handle loading states, and of course then also send our data and get our data from the backend. Now, the one missing thing I want to add now is the delete button. It still won't work because, again, we're not talking to a backend yet, but at least I want to make it do something. And on Authenticate, I actually want to go to a separate page where we can enter some credentials, where we also have a form there for, so that this is also already prepared for later when we then will add real authentication. Now let's start with deleting though. Where do we delete a place? Well, that happens in place item. In place item, we got this delete button. So here is where we have to work on to make sure something happens when we press that button. Now the question is, what should happen when we press it? And my idea is that we open a modal that asks the user whether he or she is sure if you want to proceed, so that you have a chance of canceling the deletion process. And only if you then click yes in that modal, we will later then, once we have a backend, send a request to the backend to delete this. So let's add such a modal. We already do have one modal here. That's the modal for the map. I will simply add a second modal because we will only render one of the two at a time. I will add a second modal next to it where I want to render this question whether you really want to delete this or not. So the content of this modal is a paragraph, let's say, where we say, do you want to proceed and delete this place? Please note that it can't be undone thereafter. So some warning like this. Now we need to configure that modal as well. I will add a header here where I say, are you sure? And a footer class of place-item __ modal-actions to nicely position my buttons in the footer. And speaking of that, I will add footer, and there I want to have some JSX which is rendered in the footer of the modal. And that should be two buttons, one to proceed and one to cancel. So therefore, here I will have two JSX elements next to each other. That is not possible. You need one root element in any place where you basically create a brand new JSX branch. And therefore here I will use React fragment, and in there then have my buttons. So the first button gets this inverse style here, and I will say cancel there. The second button gets the danger style, and there I will say delete. So this is then really when we will delete the item. So now we need to wire things up. We need a couple of functions to handle our different states, and of course, therefore, we also need some state itself. So let's add new state here, and that is basically the state that manages whether we show that confirm modal or not. So we could name this show confirm modal, and set show confirm modal is then our update function. And here with use state, we initialize this to false, because initially, of course, we don't show this modal. And then we need some functions. We need a show delete warning handler, which has the single responsibility of calling set show confirm modal and setting this to true. Then I want to have my cancel delete handler, This has the responsibility of setting show confirm modal to false. And of course, we'll have the confirm delete handler. That is where we then really will go ahead and delete the place. And again, that is something we can't do right now, but for now I'll just log deleting here so that we can still see that this was triggered. Now we need to wire up these different functions and also use our state. Let's start with the state. On the modal here, I will set the show prop, which controls whether the modal is shown or not, to show confirm modal, that state we just added. And on cancel will be set to the cancel delete handler, of course. The same for this cancel button. On click here, we'll simply trigger the cancel delete handler. On the other hand, on click on this button here, on the delete button in the modal, will trigger the confirm delete handler. And now we need to wire up that delete button at the very bottom. There, of course, upon a click, I want to show my confirm modal. No, that's the wrong thing. Show delete warning handler is the function name. That should be triggered here. With that, if we save this, if I click delete, we see that modal. If I click cancel, it gets closed. If I click here, it gets closed. If I click delete here, of course, nothing happens, but I see deleting. I want to close my modal in that case as well, though. So in here, in the confirm delete handler, we should also set show confirm modal to false to close the modal. So with that, if we now click delete and click delete here, we would really send a request to delete it, and we will do so later. And for the moment, we just close the modal and print this. So that's all the working. The real magic will happen later, but it's a good start. And with that, let's work on authenticate and make sure that there we also show a form. We can even switch between two modes, login and sign up mode, and we at least gather the user input for now. Let's work on authentication. And here's a little challenge for you. Try starting this or working on this on your own. For that, make sure that when we click authenticate here, we're not taken to this page, but to a brand new page, which you have to create in the user pages folder. You could name this page auth.js or authenticate.js or something like this. On this new page, add a form. You can use the use form hook for that and add a form that renders an email and a password field. You also want to add some validation to these fields, and in util, for example, you find this function you can execute to set up email validation. The password should be validated with validator min to check that it's at least, let's say, 5, 6, 7, whatever you want characters long. So add such a form utilizing our form hook and this validation and the input component, and add it on a brand new form. Definitely try this out on your own. As a next step, after a short pause, which I give you to pause this lecture and try it on your own, we'll do it together. So, were you successful? Let's try it together, and for that I will add a brand new page here, the auth.js page, in the user pages folder. I will also add auth CSS to have some styling for it, and attached you find that styling. You can just paste it in there. And I'll leave it up to you whether you now use my styling and my markup or stick to yours. The general logic, of course, should be the same so that we have no problems in the rest of the course. So in the auth.js file, of course, we import React from React. We import that auth CSS file we just added to get the styling. And then here we have the auth component, which will render some JSX later, and we export this auth component. Now, inside of the auth component, for the moment, I'll just render auth as a text here to see whether I can get there, because in app.js, I now want to register it as a route. And there, I simply want to add a brand new route, maybe here at the end, where the path is /auth, let's say. And then we render our auth page, which we therefore need to import. So here we got auth from /user /pages /auth, and auth is getting rendered here, like this. Okay, so now with that, if I now click on authenticate, I'm taken to the auth page. So that's working. Of course, make sure that the link here in the nav links is the same link you're watching for in your route config. So now in the auth page, let's replace the h2 tag with the actual content we want there. And the actual content we want there, of course, is totally up to you. I, of course, want to have a form in there, but a form which I will wrap into a card. So I'll import card from shared components, UI elements, card. So I'll actually wrap everything here in such a card, like that, and split this across multiple lines to make it easier to read. And besides my card here, or besides my form, in that card I want to have some text, some title where I say login required, and then maybe this horizontal separator just to have some visual separation between the title and the actual form. On the card I'll also add a class name of Authentication, which is simply a class set up here in auth CSS. Now inside of the form we can now add our controls. So let's import input from shared components, form elements, input, and let's repeat that for the button. So let's import button from shared components, form elements, button, so that we have these two things available, these two components. And now in the form, we can add our button here, our input here, excuse me, and that will be the input for the email. So I'll set an ID of email here. I will also set the element here to input, because it should be a regular input. The type can be set to email here, so that we take advantage of this native built-in email type. And the label can also be email, to give the user a clear idea of what we want there. Validators, of course, is an array, and there I mentioned that we can use some of the validators I created. So I will import them from shared util validators. There I want to have the validator email and the validator min length. That is what I need. So here then I will execute validator's email as a function to add that email validation here, and also provide an error text, which could be please enter a valid email address, like that. Now onChange also needs to be connected to something, and here I will use my custom hook again. So import use form from shared hooks form hook, so that we can call use form up there and initialize it. Initially the form is invalid, and for the inputs we have an email input where the value is empty and which is also invalid initially, and we'll also then have a password input where the value will also be empty initially and it's also invalid. So that's my initial state, and then just as before, use form returns something. It returns an array with 3 elements. I need 2 of them here for now, and that's the form state and the input handler. And now the input handler here can be bound to onChange on this input. And then we can duplicate this input here, and create a second input with an ID of password, and a type of password, and a label of password, and a validator of, let's say, min length 5, but it's up to you which min length you want to require here. And of course here I will say in the error text, please enter a valid password, at least 5 characters. Now let's also add a button here of type submit, and on the button I'll say log in for the moment. Later we'll also add a sign up functionality, but for now it's just about logging in. Now that button should be disabled if the form is invalid. So we'll set disabled equal to not form state is valid. If the form is not valid, the button is disabled. With that, this should actually work. Let's save this. And I get an error, yes, because it's not on change, but on input on our own input components. So let's replace on change with on input there. And that looks a lot better. Now you will see if I enter an email here, this is not valid. If I tap out of there, as soon as I make it a valid email address, it is accepted though. Password has to be at least 5 characters long, and then it's accepted as well. And yeah, this all seems to work here. Let's also submit it. And of course, that does not work yet because I haven't added a submit handler. So let's add a new function here. The auth submit handler maybe, where we get the event and then call event prevent default to prevent this automatic submission of this request and the reloading of the page therefore. And then in here, I will console log form state. Later, as always, we'll do more. I'll actually console log form state inputs. Later, we'll do more because later we will also have a backend. For now, let's just bind on submit here to the auth submit handler where we log our input state. Now with that, if we retry that, enter some data here, log in, this looks good to me. So this basic form is working, and that's nice. It also shows us how reusable our own hook and the input component is. But of course, logging in alone is not enough. Users have to sign up before they can log in. And during sign up, they should also provide a name. And of course, we want to be able to switch between both modes. So you can also try implementing this on your own. It will be a bit more tricky. In the next lecture, we'll do it together. So let's implement the switch button now. And for that, at the bottom of the form, below the submit button, and actually outside of the form, I'll add a new button with the inverse style, which I find to look quite nice, where I will say switch to sign up. And upon a click here, I want to execute a switch mode handler function, let's say. The name is up to you. We have to add that function to our functional component now. So here I'll add this new switch mode handler function. And the idea there is, of course, that we do just what the name implies. We switch our mode of that form. To switch a mode, we need to manage a mode. And that has to be a state, because when we change it, our component has to be re-rendered. Or at least parts of it will need to be updated. And React will figure out which parts that are. So let's import useState from React to manage some state. And then here I'll set it up. Use state, and I'll name this state is login and set is login, because we either are in login mode or not. And initially, let's say we are in login mode. So initially, this is true. We can also name it is login mode and set is login mode to be even clearer about what we're managing here. So now in switch mode handler, I wanna, well, switch that mode. So we'll set is login mode to what it was not. So I will invert it. For that, I'll use the function form here and get my priv mode and set the new mode to not priv mode. This is this function form of updating the state, which we should use if our new state update is based on the previous state, and it basically inverts it by adding this exclamation mark. So if it was true, it's now false, and the other way around. Now we can use this login mode, this is login mode constant now, which will change. For example, here on the button, it shouldn't always say login. Instead, I want to check if we are in login mode, in which case I say login. Otherwise, I say sign up. Also here, I want to switch to, well, that depends. If I'm in login mode, I want to switch to sign up. If I'm in sign up mode, which is the opposite of login mode, I want to switch to login. So we want to output some text dynamically here. In addition, I also want to render a brand new input if we are in sign up mode, because then I also need to fetch the username. So here, if we're not in login mode, which is the sign up mode therefore, I will render a brand new input here in this place. The element is an input, the ID is name, the type is text, and the label is name or your name, whatever you prefer. And validators here, well, here I will just require this. So we'll actually import a new validator, validator require, and use that down there in my validators array for the name. So here I'll just execute validator require. The error text here can simply be, please enter a name. And on change, of course, points at my good old input handler. Now, if we save this, we see this button, and if I click it, I get an error. And we get an error because on input is not a function, yeah, because it's on input here and not on change. So Now this works and we can switch between these two modes. But what you'll notice is that our form will not work correctly. If I enter an email and a password, it's not valid here, and also not in login mode. So basically, my button never unlocks here. And that makes sense, because what we just did is we added a new input, which sometimes exists and sometimes it does not. And when we switch to sign up mode, in the end, this becomes part of the form. So if I reload, for example, in login mode, I can enable the button. But now it's also enabled if I switch to sign up. So basically, we're not correctly considering this new field here. The validation inside the input works, but the form validation is not wired up correctly when we switch the mode. So we have to make sure we do that. To make sure we do that, we have to go back to the switch mode handler. And there, in the end, we want to set our form data. Now, not to reflect some initial state in our inputs down there. Those will initially always be empty. But to correctly update our behind-the-scenes form data when we switch the mode. And keep in mind that in our hook, when set data is dispatched, which happens when we call set form data, we do set the input and the form validity data. So we do update the form data whenever we call set form data, which makes sense if you have a look at the name of that function. So we want to call that whenever we switch the mode to bring it up to date with the available inputs. So here I'll check if we're not in isLogin mode, let's say, so if we are signing up, in which case I want to call set form data. Now set form data is not available right now. We need to extract it from use form as a third element here. Then we can call set form data here. Now here in set form data, I want to set my form data for the case that we're not in login mode. Now keep in mind, this here runs before we switch the mode. So if we're not in login mode, we are in sign up mode, but since switch mode handler executes and we're in that handler, it means we're now switching to login mode. So to update our form state correctly, we need to drop the name field because we're coming from sign up mode and we're going back to login mode. So the form validity depends on the validity of the email and the password field. So here I'll check form state inputs email is valid and form state inputs password is valid. If both are valid, the future form will be valid because we're switching to login mode and there we only have these two fields. Now here for the inputs, I simply want to retain the values I have for email and password and drop the value that was stored for name. So we can simply set name to undefined here, for example, to drop it. Now else, in the else branch, where we are in login mode, but we are executing switch mode handler, so we are moving to sign up mode. In this scenario here, we want to call set form data, and the form will definitely be false. The validity of the form will definitely be false because we just added the name input field and therefore it can't be valid. Now I want to retain my current form state inputs data here, so my current values for email and password, but I want to add a new name field now. And for the name field, the value initially will be empty and is valid therefore will be false, which is the reason why the overall form validity will be false. And with that, we call set form data, and then also set is login mode to switch the mode visually, and hence our UI and the behind the scenes form should be updated correctly. Now, one important note, in the end, of course, we are performing multiple state changes here. Set form data will in the end change some state and re-render the component, and set is login mode will do the same. React is smart. If you have multiple state changes in the same synchronous code block, so in the same function which executes synchronously, so all the steps execute immediately after each other, it will batch them together and perform one single state update and one single re-render cycle to avoid unnecessary re-render cycles. With that, if we now save this, let's see this. Let's enter something here, some valid email address and a valid password, and switch to sign up. You see now this button is disabled, which makes sense because we added the name, which is empty. If I go back to login, it's enabled again, unless I have something invalid here, which is when it crashes. So that is something we'll need to tweak. Let's see what's going wrong here. Cannot read property is valid of undefined in our form hook. And yeah, that makes sense because here, when we switched from sign up mode back to login, I set name to undefined to drop it. Now that's nice, but of course I also have to copy my existing fields, otherwise I also lose them. So we need to copy all the fields and then just overwrite name to be undefined. Now, even with that change applied though, if we go back and I switch to sign up, enter nothing here, and go back to login, you'll see this still crashes with a similar error. And the reason for that is related. Now, I do keep all my old inputs now, that's great, but I still set name to undefined. So the property is technically still part of the form object, the value of it just is undefined. But since it still is part in the form hook, in the input change case, when I go through all my inputs, I still of course find this name input as an input, the value just is undefined, but the property is still there, and therefore I still try to access is valid on the property. There are various solutions for that. One solution is that we add one extra if clause here in the for loop, and we check if state inputs for the given input ID, if that is truthy, or to be precise, by adding an exclamation mark here, if it is falsy. Which means, is it undefined? If it is undefined, then I continue here. Now what does continue do? Continue basically tells JavaScript that we don't continue with this iteration of the for loop, and instead we go to the next iteration, so to the next property in this case. So we skip this property if it is undefined, because then I don't need to validate it, and I don't want to adjust my form validity. And if we now save this and we go back, I can switch to sign up and switch back here. And if I now enter something here, you see this works just fine. And if I now go here, enter max, that's looking good. Remove the password here, it's invalid, switch back, enter it back. So that is looking good. This looks now like it works. And that fixes the issue of us switching modes and changing the form therefore. Now if we click submit here, we see email name and password being submitted with the data we entered. If I go back to login and I click login, we see name is undefined, which is fine, but email and password is there. So this seems to work, and this is how we could implement this with different modes between which we switch and different form data which we manage for those modes behind the scenes. Now to come to an end in this very long module where we build an entire React app from scratch, I want to make sure that when we click login or sign up, we don't just log to the console, but we instead do log the user in. At least we fake to do so. We can't really log the user in because we have no backend where we would send and validate the data, but at least we can change something on the user interface. For example, if we are logged in, I don't want to see the authenticate button here. Instead, a logout button would be nice. I also don't want to see my places if I'm not logged in, because we can only reach our places if we are logged in. So I want to manage the login status of the user in the React application here, even though we have no full login flow yet. We're missing the backend. Now to manage that status, we need a brand new React concept, which is called context. Context allows us to pass data between any components in our application without using props. And that is very useful if you have some general application-wide data like, is the user logged in? So such a central vital question, which affects a lot of parts in your application, which you simply don't want to pass around with props because that would be madness. You would have to pass props from everywhere to everywhere. It would be super annoying. So context is some behind-the-scenes data transfer mechanism, you could say, and it's built right into React. Now to use context, I will add a new folder in the shared folder next to components and hooks, and I will name it, well, context. The name is up to you, but I will manage some context in there, so I guess the name makes sense. In there, I'll add an auth-context.js file, and here I will import create context from React, a function React offers. We can call it to create such a context object, which we later can share between our components to share some data behind the scenes. We can initialize it with some initial data, and there it will have a very simple piece of data. I'll have the isLoggedIn key, which initially is false. And I will have a login function, which here is just an empty function for the moment. And I want to have a logout function as well. So a method to be precise, because it's a function in an object, and that is called a method. So we got isLoggedIn as a property in this object with which we initialize our context, and we got login and logout as methods there. Now I'll store this in a constant of context, and I will export this constant. So this is my auth context. This is some object we can now share between components, and when we update it, any component that kind of listens to it will also update. However, we're not ready to use it just like this. There is a reason why it's not a regular JavaScript object, but why we have to create it with create context in the end. Because with our context created, we can now go to app.js, so to a place in our application that is on top of our component hierarchy, you could say. An app component is clearly at the very top. It's our root component, if you want to call it like this. In there, I'll import auth context from shared context auth context. And now how do we use auth context there? We wrap the parts of our application that should be able to use that context with it. So here we have this entire router. In the end, I go there and wrap everything, the entire router, with auth context dot provider. So this context, which is created with the help of create context, in the end is an object which has a property which turns out to be a React component, the provider property. So we use this component here and wrap our entire router with it, with auth context provider. Now every component in there, like main navigation and every loaded page and every component used in a page, has access to this auth context. That's one nice thing. Now the provider also takes a value prop. And here we bind the value we manage with our context, which we initialize to this object here. We bind this to a new value. We bind this initial value to a new value. And whenever this value here changes, all the components that listen to our context, so that actively tap into the context, will re-render. Not all the components that are wrapped by auth context provider, but only the components where we then will add some code to listen to our context. And now that's the cool thing. We can now manage some state here in the app component and bind this to the value of our context. And hence, when the state here changes and the value changes and this component re-renders because our state changed, we will be able to re-render or update the components that are interested in our context. So for that, let's import use state here in our app component, and also already use callback because we'll need that as well. And then in the app component, let's add a new state, and that is logged in and set is logged in. And with use state, we can initialize this, and at the beginning, let's say this is false. Then I add a login function here, which I wrap with use callback so that it is not recreated unnecessarily to avoid infinite loops. So my dependencies of use callback is an empty array for now. This means this function here will never have to be recreated. Now in there, I simply want to set isLoggedIn to true. And then I will copy that and create a logout function which looks very similar, but where set is logged in sets the logged in state to false, of course. And now value here is bound to a new object where isLoggedIn is set to our isLoggedIn state here, and where the login method is set to our login function here, and logout is set to our logout function. And now whenever this changes, which is the case when isLoggedIn changes, this new value will be passed down to all the components that are interested. And that's the nice thing here. Now with that, the question is, of course, which components are interested? Well, for example, our navigation, or specifically the links there. If we go to nav links, we have a couple of links which we only want to show if we're not authenticated, and links we only want to show if we are authenticated. So here in nav links, let's import auth context from the context folder and then auth context, and import a new hook, which we haven't used before, use context. And this does what the name implies. It allows us to tap into a context to listen to it, so to say. So here we can then call use context and pass in the auth context just like this. And what we get back is an object which will hold the latest context. And this component will re-render whenever this context we're listening to changes. That's the magic React manages for us behind the scenes. So here then, auth is an object that holds the isLoggedIn property, the login method, and the logout method. And we can now utilize this. For example, my places should only be visible if we are logged in. So I'll check if isLoggedIn is a thing and only render this list item if it is. Add place also only makes sense if we are logged in. So let's render it appropriately. Authenticate, on the other hand, only makes sense if we're not logged in, because there is no reason to authenticate if we are logged in. With that, what you see when you reload is that at the beginning, you only see all users and authenticate. You still see the edit and delete buttons, but that's something we'll still take care about. Now let's make sure that when we click login here, we actually trigger this login method on our context to change that state. Now also try this on your own. We'll do it together in the next lecture. So let's make sure that when we click login in the auth page, we do actually log in, or at least we fake it. So in the auth.js file in user pages, I will import use context. And of course, I will also import my auth context here from the shared folder, the context folder, and the auth context file. And then here in the auth page, we can also get access to this auth object by calling use context on the auth context. We can use this auth object and the login method we have there inside of our submit handler. There, besides logging what the user entered, I will call auth login like this. And this should already update the context and the data managed there, and therefore also the user interface. So if I enter some valid data here so that the login button gets enabled, you see that changed here in the navigation. Now, of course, it would also be nice to then redirect the user, though. It would be nice to then leave this page. And a very elegant way of doing that is that we go to the app.js file where we set up all the routes, and we simply set up different routes for the logged in and the not logged in state. And we set up different redirections as well, which makes sure that when the state switches, we get redirected. So for that here in app.js, I will add a new variable, routes. And now we can check if is logged in, which is a state we're managing in app.js, if that is true. If it is true, I'll set routes to a specific set of routes. If it is not true, so in the else case, routes will be a different set of routes. So let's maybe start with the routes that are relevant if we're not logged in, so in the else block. There, I want to bring my root route. So let's copy that here. And I also want to bring my user ID places route, because we can view places of a user even if we are not logged in. And we're already getting an error here. Multiple root level JSX elements next to each other, never a great idea. So let's use React fragment to wrap them. And let's continue adding routes now. So we have the root route, we have user ID places. I don't want to have the new place route. I don't want to have the update place route. I absolutely want the auth route. So I will add that as well, because we should be able to reach the auth page if we are not authenticated. And I will also add a redirection here, where we should always be redirected to /auth actually as a default maybe. So that if we are on any route which is not handled before, we are redirected to /auth. Now let's copy that setup here and use it in the logged in case here. Here the routes will be different. I do have that users and the user places route. I don't have the auth route though. We shouldn't be able to go to the auth page. Instead, we need the routes for a new place and for updating a place. So let's copy that. And for redirecting, we also need a different logic. If we are authenticated, I want to redirect to the starting page, let's say, for invalid routes we are on. Now with that, we can go down, and here in switch, we can replace the routes we have there with the value in our routes variable. Now let's see if that works. If we save that, this reloads. I'm on the auth page. I can go to all users and to the places of users. If I click here on edit, I don't go to the update route though, because we haven't defined this in the unauthenticated state, which is good. We'll of course make sure that this button doesn't even exist in a second. So on authenticate, if I now do log in, I am redirected thereafter, and I can go to add place. Could not find place. That's interesting. We should take care about that. And I can go to my places and to the update place page, and that's all working. Now, what's causing this could not find place thing here? Let's have a look. And the problem probably is that I have this route here, where I look for a place ID, and as I said, new is interpreted as such. And actually the switch statement is not working correctly here. I do enter it all into a switch statement, but the React fragment in between seems to destroy things. It's not a problem though. We can just replace React fragment with switch here in both route setups. And then down there where I enter my routes, I just get rid of the switch statement because it's now part of the routes variable already. With that, this reloads, and we should be able to now go to new place to add place without that warning. Yeah, so that is all working. This also still works here. And now let's make sure we also render a logout button, which allows us to log out, and we don't render these two buttons if we are not logged in. Here I am logged in, but if we're not logged in, I don't want to render them. Side note, later we'll also make sure that we only see them if we are the user who created this. For the moment, we can ignore that. So as before, definitely feel free to add that logout button on your own, and to make sure that you also get rid of these buttons here if we're not logged in. In the next lecture, we'll again do it together. I want to start with these two buttons, and I want to get rid of them if we're not authenticated. So in place item, which is where we have these buttons, we're interested in the context. So here, use context, and then let's import the auth context from shared context auth context. And as before, create our auth object here by using use context and listening to auth context. So now we have access to the auth context here in place item. We can now use that here to control our buttons. Not these buttons though, these buttons here, edit and delete. And I want to make sure that only if auth is logged in is true, I'm able to see these buttons. So the edit button is only visible in that case, and the same here. Only if auth is logged in is true, we should be able to see the delete button. Hence, if I save that and this reloads, you see I don't see the buttons. If I now log in though, like this, and I go to a place, I see them. So that's nice. Now, it would also be nice to have a logout button. So for that, we can go to nav links and add one. Here, maybe at the very end of the unordered list, I will check if auth is logged in is a thing, because a logout button only makes sense if we are logged in. And in that case, I'll add a new list item here with a button in it. Actually, a regular button now. Of course, you maybe created your own solution here. I'll go for a regular button. And on this button, I'll have a caption of logout, and upon a click, I want to trigger auth logout. I'll not execute it here. Instead, I just point at it so that when the button is clicked, this is executed. With that, if we save this, we can log in here. And now we have this logout button here with some default styling because of the CSS, which already is set up there. When we click that, we are logged out. Now let's see if we also are redirected. If I'm on add place and I click logout, yeah, I'm back to authenticate. So this all seems to work just fine. And of course, it's not the full, real, final login flow yet. There is more we will have to manage there. But for the moment, this will do. And this is a good introduction to React, to building a full app with React, and now also to how you can manage app-wide state in React with help of the context feature. When we talk about the MERN stack, we of course have to understand the E and the N part, Express.js and Node.js. Of course, we'll build the entire backend of this application with these two technologies working together, and therefore there you will learn a lot about them. But in case you're really new to Node.js and Express, I recommend that you check out dedicated resources like my Node.js The Complete Guide, but B, here in this module, you'll also get a brief refresher. We'll quickly dive into Node.js and Express, understand what it is all about, how it basically works, and therefore hopefully by the end of this module, we're all roughly on the same page. Now again, this module is not there to replace a complete Node or Express course. There is a reason why that course has more than 30 hours on its own. But it's there to make sure that if it's been some time since you worked with Node or Express, or you haven't worked with it but you're learning it simultaneously to this course, we all can get started with it quickly, and it's not all brand new what you're going to learn in the next course modules thereafter. So in this module specifically, we'll have a look at what exactly Node.js is again and how it roughly works. And of course, we'll also explore the E, Express.js. What is Express about and how does it work, and why do we use it? Why do we need it when we build a backend with Node? So let's dive in. What is Node.js? Wouldn't hurt to understand that if we want to write some Node code, right? So Node.js is in the end a host environment for JavaScript, a runtime for JavaScript, you could say. Now, for that, of course, it's important to understand that JavaScript is the programming language. And most of us started with JavaScript in the browser. It is the only programming language we can use in the browser to write some logic there, to execute some logic there, to change the document after it has been loaded and so on. For all of that, we need JavaScript. The browser, therefore, is one host environment of that JavaScript language, but it's not the only one. Basically, one of the most popular and important browser JavaScript engines, V8, which is the engine built into Chrome, has been taken out of Chrome. It's still in there too, but it has all been cloned and is now maintained as a standalone project. And that is basically Node.js. It's a JavaScript engine originally built for the browser, now working without a browser, and enriched with some extra APIs. So it allows us to run JavaScript outside of the browser. And of course, that means that some APIs were dropped. For example, we no longer can interact with the DOM if we're writing Node.js code, because we don't execute the JavaScript code in a browser environment, and therefore there is no DOM. But new APIs are available. In the browser, for example, you can't really work with the file system. For security reasons, you can't store files on the system of your users or read files from there. Well, in Node.js, you can do that because Node.js does not execute on computers of the visitors of your web page, but instead you execute it on a computer of your choice. For example, on a computer, on a machine you expose as a server to the internet. That is Node.js. It's JavaScript outside of the browser with new tricks learned and some tricks unlearned, I guess. And with Node.js, we can write any kind of application, any kind of script with JavaScript. Doesn't have to be code that handles incoming requests, but often it is, because one popular use case of Node.js is to use it to build web servers which handle incoming requests, maybe talk to databases, and also send back responses, so that we can use Node.js basically as a replacement for PHP, for example, or Java, or ASP.NET. That is one very prominent use case, and it is the use case we will look into in this module because it is exactly what we will use it for throughout the rest of this course. Now, to play around with Node.js a little bit, I prepared a brand new project here. It's basically an empty folder which I opened with my IDE, Visual Studio Code. And in there, we're going to write some Node.js code, execute it, and understand how it works. Now, important for that, of course, in case you haven't done so yet, you need to install Node.js. Simply download and install the latest version from nodejs.org. It should automatically pick the right operating system for you. If not, click on Other Downloads to choose one manually. Simply download the latest version there, walk through the installer this gives you, and you can leave all the defaults there, and hence, by the end of the installer, once you went through the entire process, you will have Node.js and another tool, NPM, which stands for Node Package Manager, installed on your system. Now let's ignore that NPM tool for now, and let's write some Node.js code. For that here, I'll add a new file, app.js. You can name it however you want. And in there, we can write normal JavaScript code. We can, for example, create a constant, username, and then console log that if we want to. Now, important, this here uses next-gen JavaScript syntax. I'm using const and let instead of var. And in general, throughout this course, I will use modern JavaScript syntax, arrow functions, destructuring, spread operator, and much more. So in case you're not really familiar with this modern JavaScript syntax, you should definitely look into some dedicated resources which teach you this modern syntax. For example, my accelerated ES6 JavaScript course, or of course my JavaScript to Complete Guide course, which teaches you everything about JavaScript, including a little introduction to Node.js actually. So we have this basic script here. And if we now save this file, we can execute this with Node.js. For that, let's open the terminal here in this IDE. It's the normal terminal, just integrated into the IDE. And it's already navigated into this folder, which is the convenient thing about it. And there you can run node app.js. The node command is available because you installed Node.js on your system. And then we just type the file name, including the extension, of the file, of the JavaScript file we want to execute through Node.js. If you hit enter, I see Max here, and you should see whichever name you entered here as a username, because that is what we do in this script. Now it is noteworthy that if we try to enter alert here, and we execute this, we would actually get an error here. We get an error that alert is not defined. This is the thing I mentioned regarding some APIs not being available. The alert function, which does exist in a browser environment, does not exist in Node.js. And this kind of makes sense because the alert function opens an alert in the browser. Here we have no browser. Node.js has no built-in functionality to open some window on your system. That's not how it works. So that's one of the APIs which we can't use anymore. But no worries. There will be new APIs. For example, we can write to a file. For this, we need to import this file system functionality. If you only worked with browser-side JavaScript and you haven't worked with modern project setups there, which use bundling to combine multiple files, you might not really know the concept of imports and exports in JavaScript. You might simply work with multiple script imports in your HTML files to import multiple scripts. Well, in Node.js, and also, by the way, later in React.js, where we will have a build workflow which supports bundling and splitting our code across multiple files, we are able to import functionalities from file B into file A, and we're able to export functionalities so that we can use them in other files. And it is important to understand that with the exception of some very few global functions, everything which you want to use in a file has to be imported before you can use it. So for example here, I want to write something to a file. For that, conveniently, Node.js has a couple of built-in core APIs, just as the browser has a couple of built-in core APIs like the DOM API. For working with the file system, Node.js has the file system API. We import it with the require function. And that's important. The require function is a function globally available in Node.js, one of the very few globally available functions. Now, require takes a string, and that either is a relative path to one of your files where you're exporting something, or, in case of the file system or other core baked-in modules, the name of that module, in this case FS for file system. This is a module which is available with the default installation of Node.js. You don't need to install it separately or anything like that. Now, require is a function which tells Node.js that you want to import something from that file, or in this case, this module you're pointing at. Now, that something, that object of functionalities, then is returned by the require function. So we should store it, in this case in a constant, which I'll also name fs, though this name here is up to you. You could name this however you want. Now we can use this file system object to use a couple of methods which are built into this file system module Node.js offers to us. Specifically, there is a writeFile method. The writeFile method takes a path to the file we want to write, and then the data we want to write to that file. Now, the path in its simplest form can just be the file name, and it will always be written into a location relative to the script you're executing. So here, for example, we could have userdata.txt to create a text file, and it would create that userdata.txt file next to the app.js file. Second argument is our data, and there I will enter name plus username. So I'll just write a string as data to that file. Now, with that, there is a third argument we have to provide to writeFile, and that's a callback, a function which will be called for you once this operation is done. Because writeFile, like many functionalities built into Node.js, is an asynchronous task, which means it can take a bit longer, especially if you're writing or reading a lot of data. And therefore, Node.js does not block the execution of the other JavaScript code. Instead, it will outsource this longer taking task to the Node.js environment, which is able to use multi-threading and so on, which JavaScript, the language itself, is not. And it will call a function once it's done. This function will get an error object, which is null if no error occurred, or which is not null if an error did occur. So if error is truthy, we know we have an error. So in this case, I just want to log the error. And otherwise, I'll just log wrote file. I'll return in here so that we don't log this in case we do have an error. Now with that, we have some valid JavaScript code which will run in the Node environment. And if we now call node app.js again, you see wrote file here, and you see the userdata.txt file appear here. And if we look into that file, we see name colon, and then, well, the value we stored in username. So this is also Node.js code using one of the APIs, which is only available in the Node.js environment and not in the browser environment. Other than that, other these special APIs, it's regular JavaScript code, and therefore everything you know about JavaScript also applies to Node.js code, because it is JavaScript. The only exception really is which APIs you're able to use. All the browser-specific APIs like the DOM and so on are not available here. Instead, you have new APIs. So Node.js is JavaScript, or allows us to run JavaScript anywhere. Now, of course, we can use it to write our own utility scripts, like, for example, a script which stores a name in a text file. Well, arguably, that's not too useful, but you could imagine writing a script that does way more useful things. Of course, you also have methods to read files, to search directories, and you could write a script which automatically cleans up your computer, which creates an audit file with all the files you added since the last time you ran the script, or whatever you want to do. Your imagination is the limit. But it's not what we're going to do here. We want to instead use Node.js to write a web application, specifically a web server, which we can use to send requests to and get back a response. To create such a server, we'll import another core module which is part of Node.js, and that's the HTTP module. The HTTP module allows us to create a server. It has a create server method which we can call, which is of course very convenient if you want to create a web server. The important thing here, by the way, is if you're coming from something like PHP, if you're used to working with that with Node.js, you don't just write the server-side logic, so what you would have written in PHP as well, but that with Node.js you also create a server. In PHP, that's different. There, you use something like Apache to run your PHP code. You don't do that in Node.js. Instead, there, you use the language or the runtime itself to create the server. So create server is the method here, and it takes one argument, the request listener. So basically a function which is triggered whenever we have an incoming request. This gets two arguments, a request and a response object. The values for these arguments are passed in by Node.js when such a request reaches the server. Create server then returns a server object, and on that server object you can call listen, a method which will set up an event listener for such incoming requests. To listen, you can pass a port number. In this case, I will go with 3000, or actually let's go with 5000 because that's the number we'll use later as well. Now, this opens up a local server on your machine, not exposed to the internet, of course, unless your machine you're developing on is open to the internet, which it should not be, by the way. And then you can send requests to the server under localhost :5000, which is the port number here. Now, for every request you send, you will reach this function, and in there, we don't do anything. Now, before we populate this with some life, it's important to understand that the listen method here will spin up a server, which of course is an ongoing process, which means it won't shut down. You won't be able to enter new commands unless you manually shut down that running process, because it's an ongoing listener which continuously waits for incoming requests. It's also able to handle multiple requests simultaneously, which of course is a must-have for a real server. So with that, let's maybe print console log incoming request here in this function, which should be triggered for every request. And let's console log request.method. The request object is a huge object with a lot of properties and methods. And request.method is a property which gives us the HTTP method which was used for the incoming request. We can also, for example, print the URL which was used. Now, and what we should also do for every incoming request is send back a response. Otherwise, the browser which is sending the request will eventually throw an error when the request times out, and it will time out if you're not sending back a response. Now, for sending back a response, you can use that res object. And there you have an end method, which basically means I'm done configuring the response, please send it back. This method also takes some data you can send back. So here, for example, we could set back some simple text, success. If we do so, and we save this, we can now execute this file again, and now you see what I meant. It doesn't quit. I'm not able to enter a new command. You can always quit manually by pressing Ctrl and C, but then the server is not running anymore. So of course, as long as you're developing, you don't want to do that unless you changed some code and you want to restart it with the new code. So here I will start it and keep it running. And now let's go to the browser, and there simply enter localhost 5000 and visit this page. And what you should see there is this success text. And that's of course coming back from our response function here, or from our request handler and the response we're sending back. Now, sending back just some plain text is boring. Why don't we send back some HTML code? Of course, this is not a totally valid HTML document because I'm missing HTML and so on, but the browser will still be able to render it. So here I'm sending back a h1 tag. Now, if I reload, we see no change. And that, by the way, is a common source of error. If you change your code here, you need to restart your server, because when you run your file, if you run node app.js, it executes that file. And if you thereafter change the code in there, it doesn't automatically re-execute it. So we manually have to stop the server and rerun it with node app.js if we changed the code. Of course, that's a bit cumbersome, and later we'll see a more elegant method of handling this. For now, let's just restart it. If I now reload here, we see this looks like a h1 tag, and indeed if we inspect it in the browser DevTools, we see this is a h1 tag here. So this was sent back and interpreted as HTML by the browser. Now, if we don't want the browser to interpret this as HTML, we can call the setHeader method on the response before we end and therefore send it, and set the content type of our response body so of this data we're sending, to, let's say, text plain. This tells the browser that what we're sending back should not be interpreted as something special, but as plain text. So if we save that and we restart and reload, we see the HTML tags here because this is output as some text. My browser wraps this into some pre-tags here. That's just something the browser does by default. The magic really is the thing in between. It's just interpreted as text. You can also see this, by the way, if you go to the network tab in the browser and you inspect the request which was sent there. Here you see the URL and the method. And if you scroll down, you see on the response header the content type was set to text plain, which causes this way of rendering it. Of course, we can also set this to text HTML to basically get the same behavior as before, where if we now reload this, it is indeed rendered as HTML, because that is also what we're telling the browser from our server. Now, this is how we can send back responses, and if you're already wondering if this is the best possible way, because writing HTML code like this certainly is not too nice if we're writing longer code, then I can definitely comfort you. This is not the final way of how we will write our code. After all, this is just Node.js. We haven't seen Express yet. Before we see it though, let me give you one other reason why we might want to use it. And for that, let's actually write some code which sends a post request to the server where we then want to extract data and then send back that data to the client, let's say. For that, to be able to send a post request, I'll create a form element here. And in there, have an input type text with a name of username, just like that. And a button, create user. Make sure you got your opening and closing tags right. And that button will be of type submit. Now, this is definitely not so readable. I am aware of that. It is all the HTML code we need to write here though, so I'm doing it all in one line. As I mentioned, this is not the final way of how we will do this later. Now, if I save this and I restart my server and I visit this page again, I see this input field and this button. Styling is awful, but it's also not what we're talking about here, so this is fine. Now, if I enter something here and I click create user, the browser by default sends a request to the backend. It sends a GET request and appends the entered data as query parameters. Now, I don't want that default, so I'll set the method to post, which means the browser will now send a post request. It will send it to just our domain. Now here in our request handler, we can now check if request method is equal to post, which means the form was submitted. And then we want to extract that username here and do something with it. Maybe send back a response where we render that username in a h1 tag. Now, how do we get that data out of our request though? Well, first of all, let's create an else case. If we're not getting a post request, then I want to return this content here. So now in the if branch, I want to get the data which was part of the request, because for a post request, the browser will automatically add that username here and the value the user entered to the request body. So I want to extract this here. Unfortunately, there is no request body property or anything like that, which would give us convenient access to it. Instead, we have to register an event listener for the data event, which means we're getting new data, because data is actually streamed into the server in chunks. So we're actually getting it in chunks instead of one big chunk. Now, for such a small piece of data as we're having it here, it probably is in one chunk, but that's not guaranteed. So here, I then get my chunked data in this callback function, which we have to provide to this event listener. And I will construct my body here, a simple string, to which I'll now add this chunk. So I'm building up a string. This chunk here will actually be something which we can use as a string. Now at some point we'll also be done parsing data. So we'll add another event listener actually in front of the data event listener so that this is set up first. It's not triggered immediately, it's just registered immediately. And there we'll have a callback function which is executed once the entire request body has been parsed, once the entire request has arrived. So once we have in the end built up our body. Now here I then have my body. So for now, let's just console log body and look into it. And also send back a response where I for now have just a h1 tag, which is empty, or which is not empty, but which doesn't have our body. But I say, got the post request. And now with that, let's restart the server, reload this page, localhost 5000, and send another request. Now I go to this page here, which is great. And on the server side, we see this output, username equals menu. So that's what's in my body after everything has been parsed. So here we can get the username by taking our body, splitting it on the equal sign. Split is a default JavaScript method available on strings. This will give us an array with two elements. First element is the part in front of the equal sign. So username in this case. Second element is the part after the equal sign, menu. That's the part I'm interested in. So I access the second element with index 1 on the created array, stored it in the username, and now here we can output the username. For that, we could use template literals or just concatenate a string like this and output the username between the h1 tags here. With that, if we restart the server again, so quit it and restart, and we enter localhost 5000 again, don't reload, just visit localhost 5000 again. We try this one more time, now we see menu here. Now, this is a lot of work for sending responses, and even more than that, for handling incoming data. And that's also the reason why we typically don't want to work with Node.js only. We could do that, but just with vanilla JavaScript only in the browser, that means we have to reinvent the wheel a lot. We have to find a lot of creative solutions for problems like this when we need the data, and therefore it's not what I want to do here. Instead, let's have a look at Express.js and see how that can help us. So we saw Node.js and that it can be a bit cumbersome to work with Node.js only. What is Express.js then? Express.js is a framework for Node.js. So that means we use Node.js, we write JavaScript code in the Node environment, but Express makes certain things easier, just as React, which by definition is a library and not a framework, but it's pretty close to each other, just like React makes things easier in the browser, or Angular, or Vue, or other libraries or frameworks in the browser. The idea behind a framework always is to give you a lot of utility functions and methods and things that allow you to focus on your core business logic and not so much on reinventing the wheel and building all these core primitives or doing all these primitive tasks like parsing data again. So it makes building web apps, server-side code in the case of Node.js, much easier. And one thing that is specific about Express, or specific to Express, is that it's middleware focused, which won't tell you much right now, but by the end of this module it will. So let's add Express.js to our simple application here and see how that simplifies things. Express is a library for Node.js, and thus far we have a Node project where we're only able to use Node core modules. To add third-party library, we need to convert this to a, you could say, managed project. For this, let me quit the server here. And now let's use npm, a tool which was also installed together with Node.js. npm stands for Node Package Manager, and indeed it is a tool for managing packages for Node applications. So for adding third-party libraries, you could say. Actually, you will later see in the course that we don't just use it in Node apps, we can also use it in Frontend apps, in the React app, but for the moment, let's focus on Node. Now, to use npm, to install packages here, we first of all need to convert this here to a managed project, and we do so by running npm init. Now, we're asked a couple of questions with that, and you can simply hit enter everywhere to just confirm this. And once you're done with all these questions, you get a package.json file. This holds some general configuration, which is all fine, but more importantly, this will store all dependencies we will install. And to install a dependency, in this project folder, we run npm install, then the name of the dependency, In our case, Express is the name, just Express, like this. And then also here, -- save. This will tell NPM which kind of dependency this is. -- save for a core app dependency, which we use in our application code, or -- save -dev if it's a development only dependency. So some tool which helps us during development, but which we don't need thereafter. So here it's -- save because Express will make up a core part of our application. And here I actually get an error that I can't install a package under a package which is already named Express. And indeed here the name was Express. Let's rename this to Node Express in the package.json file and repeat this npm install command. And now it will go ahead and add this Express dependency to this project. To be precise, it will do two things. It added this dependencies entry here in package.json, and it added a node modules folder. In that folder, you'll find the Express package under E, but you'll also find a lot of other packages. These are dependencies of Express and dependencies of dependencies. Now, this folder can get quite big, so whenever you share your project with someone else, it's quite common to actually delete the node modules folder so that only your code files are there. And now to recreate it, because you have these entries in package.json, you can just run npm install, and this will go ahead and install all the dependencies with the versions that are mentioned here into your folder. It will recreate the node modules folder, therefore. Here it is. So now we get Express installed. How can we utilize Express? Well, we can utilize Express to simplify this listening to incoming requests and doing different things for different types of requests. Because besides parsing the data, which is cumbersome, it's also cumbersome that we have to check the method like this. If we have more and more methods and even more different URLs which we want to check, we have to add more and more if statements to this single request listener which we have. Not ideal. So let's actually get rid of all of that so that we have an empty app.js file again, and let's use Express for that. Here, I require Express just as before. I just specified a name here. This is not a core module, but the installed module. I require it by the name of the module, in this case Express. And now this thing which we get here in the Express constant turns out to be a function. You'll learn things like that in the official docs of packages, in this case in the official docs of Express. This function will give us an app object. So we'll call Express as a function and store the result, which is a rich object full of functionalities and features, in this app constant. One feature which we have here is again a listen method. So here I will again specify the port 5000. What we don't have to do here is call create server. Express will do that under the hood and basically expose that server object enriched with a lot of other functionalities on this app which I'm storing here. So now with that, we could execute the file again and have a running server, but of course one which doesn't do much. Now to handle our get route, when I just enter localhost 5000 like this, which currently is not supported because I have no routes or no supported requests at all here, to handle that, we have to register a so-called middleware here in Express.js. Because Express has one core philosophy, which is basically that every incoming request is funneled through a bunch of middleware functions, normal functions in the end, which are able to get data out of the request or manipulate the request even, and also manipulate the response and eventually send it back. That's the idea behind Express. You have a bunch of functions which can be called on incoming requests, and every function can do something with this incoming request or with this response which is about to be sent. You can only send one response per request though. Now, middleware is registered by calling the use method on app. Use is a method provided by the Express library on this app object. In its simplest form, this takes a function. A function, here I'm using an arrow function, which takes three parameters. A request object, which is the incoming request, basically an object similar to what we got with vanilla Node.js, but it is an object enriched with some extra data. A response object, also similar to what we had in the plain vanilla Node app, but again enriched with extra functionalities. And the third parameter is a new one. This is a next function, which you call if you don't want to send a response to this middleware, but instead you want to forward the request to the next middleware in line. If you're not calling next, then any middleware after this middleware, if we had more than one, will not be reached by this request. So you should always call next unless you are in a middleware where you want to send back a response. Since you may only send one response anyways, there is no need to execute any other middlewares thereafter. So here we could create a middleware which sends back a response, and here we have a send method actually, where we can have our body where I now again want to render that form. So on that form we have a method of post, and then in there we had an input of type text with a name of username, and we had a button, opening and closing tags, where we had create user, and that button was of type submit. That's the setup we had before. Now we have it again. With that, if we now save this and we execute this file again, and I go to localhost 5000 again, we see that form, which is great. Now that form is of course nice to have, but it would also be nice if we now could do something useful with the post request. For that, let's add another middleware. A middleware which is also reached, and I will copy that middleware function, and for the moment I will just console log middleware here, and then call next, so that this middleware does not send back a response, but does something, in this case just log something, and then forwards the request to the next middleware in line. Let's restart the server by quitting it and restarting, and if we now send this request again, you will see middleware here. By the way, you could also see this twice here if the browser is by default also requesting a fav icon, which my browser is not here at this point. Then this fav icon request would also go through the middleware. You can just ignore it. Otherwise, you will just see one middleware log here. So now we have that extra middleware, but this doesn't do anything. Well, what could we do in here? We could parse our request body. For that, we could bring back what we had before. Our on listener, where we get our chunks of data. Then here we have the body, which is an empty string initially. Then we basically append our chunks of data there. And we also have the end listener here, which executes when we are done parsing the incoming request body. And in there, I can get my username by calling body split on the equal sign and extracting the second element. And now I want to add a request body field, and I'll do this just with the dot notation on the request object. I'll dynamically add a body property and set this to an object where I set the name key to my extracted username. And thereafter, I call next. Please note that I call next inside of the end handler so that we only commence to the next middleware if we're done parsing the incoming request data and not earlier. So now we go on to the next middleware in line, and in that next middleware, the request body should be available. So in that second middleware, let's check if request body is a thing, if that is set. And if it is set, I will return response send, return so that the code thereafter doesn't execute, because I either want to send this response or send that. Alternatively, we could wrap this into an else block, but we don't need to do that if we simply return here. And here, I want to have my h1 tag, then output request body .name. .name is the property where I'm storing the username. And then close the h1 tag. If we do this, let's restart the server, go to this page again, hit enter, and I get undefined. So that does not work. Why does it not work? Because I'm always setting request body. Even if we're handling a normal GET request, which has no attached data, this end event listener will fire. So request body will always be set, in this case just to an object where name holds undefined as a value. So I will tweak this and check if username is a thing, if this is truthy, and only set request body if it is a thing. Now let's restart again. Hit enter again, and we see the form. Let's enter menu, create a user, and we see that here. So now we're doing the same as before, but with Express. Some things maybe got a bit easier, but overall we didn't gain much, mostly because we still manually have to parse the data here, right? And we still need an if check to see which kind of response we want to send. So these are two things we want to improve. And actually there is a third thing. Always having to restart that server, that's annoying. Let's get rid of that too. So let's finally get to the point where we can see the real advantage of Express. Before we do that, let's make sure we don't always have to manually quit the server and restart it. For that, I'll quick it one last time, and now let's install a new library with npm install, and that is NodeMon. Install it with --save-dev, because this will be a development-only library. We'll not use it in our code, but to simplify our development flow, our development process. Because NodeMon is a tool powered by Node.js, which actually will execute JavaScript files with Node.js, but it will not just execute them, but also watch them, watch all files in the project folder, and whenever any file changes, it will restart the server automatically. So whenever we save a file with changes in it, it will restart the server. For that, we need to use NodeMon to run our app.js file, and for that in turn, we can go to package.json and use a so-called script. Scripts are simply, well, short utility scripts we can execute, and here we can add a start script, and the name should be start, and then, for example, execute node app.js. With that, if I run npm start, I execute this script. By the way, start is a special name. If the script would be named differently, for example, dev, you would have to run npm run dev. Only for start and test, you can omit the run keyword and directly run test, or in our case, start. Now, if we do that, then this code here will execute. So in this case, node app.js, which is the same as before. Now, that's not what I want here. Instead here, let's quit that server and use NodeMon. NodeMon is this package we just installed, and this is available as an executable inside of this project. It's not available globally on your machine. Executing NodeMon there most likely will fail unless you installed it globally before. But inside of these scripts, any dependency here, which is an executable script or executable tool, will be available. So now if we save this package.json file with that change made, if we execute npm start again, this will use NodeMon. We see a more colorful output there. And in the end, this executes app.js, which is great. But now you will see that if I change something, for example, here on this response, I add user : as an extra text, and I hit save, you see this restarts. And hence here, we see that change in action without us manually quitting and restarting the server, which of course is great. So that's a little convenience added. Leave that process running. You can always quit it with Ctrl+C once you're done for the day. And with that, let's actually focus on our logic here. Because now I want to make sure that I actually am able to parse the incoming request in a more comfortable way, that we don't have to manually parse it. For this, I'll install a new package, and here I will quit the server just to install that new package, which will not do all the time. And this package is named body-parser. Install it with --save, because this will now be a package which we use actively in our code. And thereafter run npm start again to start NodeMon again. Now this is a package which I import here under body-parser. You can name the constant however you want. From body-parser into app.js. Body-parser gives us ready-to-use middlewares, which we can use in Express apps, to parse incoming request bodies. It allows us to get rid of all that code in our first middleware, and instead of writing our own function, here we can write bodyparser.json or .url encoded. .json will become important later. This will allow us to automatically parse all incoming requests for JSON data. Here, I will get a regular form data, which the browser generates for me when I click the submit button. And hence here, I will use URL encoded. To that, you need to pass an object to configure it and set extended to false here in this case. Now, this will parse all incoming requests and try to extract any data which is in their body if it's of type URL encoded data, which will be the case for such a submitted form. It will also call next for us, so it will also automatically move on to middlewares after this. Now, in addition, I now want to handle a post request in a specific middleware. And for that, instead of using use, which allows us to register a middleware that runs on all incoming requests, I will use post, which allows me to register a middleware which only triggers on incoming post requests. So where the HTTP verb is post. Then here, I want to have my middleware function with request, response, and next. And in there, I want to return this response. Now I also don't need to return it anymore because there is no code thereafter which I would want to skip. We can now get rid of that if statement. Request body will exist, by the way, because the body parser automatically creates and populates such a field on the request object. However, the username will be available under the name we picked here on the input. So there I picked username, so I have to use username here as well. Now that other middleware here also shouldn't trigger on all requests, but let's say on get requests. So here I can use get instead of use. And now we're filtering for requests which use a get method. If we now save this, everything will restart automatically. And if I now hit enter on my URL again, I get an error. Now I do get this error because get and post actually need at least two arguments. The first argument is not the middleware function itself, but a string which identifies the path, so the thing in the URL after our domain, which should trigger this middleware. So we're not just filtering by HTTP method, but also by path. And here I want to filter for a slash, which means for a request targeting slash, this function will run. So if I now save this and I hit enter again, we see the form. If I enter slash users here, we don't see it. So it is really just slash. You can also add such a filter on app use, but there it's not mandatory. And also it will work as a starting filter. So slash would work for all requests that start with a slash after the domain, which means really all requests. Slash users would handle all requests that start with slash users after the domain, even if it's slash users slash new. Here for get it's different. It has to be exact match and the path is not optional. It has to be provided instead. Same for post. And we can also take this as a chance and, for example, use slash user here as a URL and tweak the form to provide the action attribute to tell the browser where to send the request to so that it sends it to slash user. So the domain slash user. If we now save this again and I hit enter here, we get the form. If I enter menu, you see the URL changed to slash user, and indeed, we see the user being output here. And that's really important. The username here, we didn't have to parse it on our own. Instead, this built-in middleware did it for us. And that's the power of Express. We have this middleware-based approach, which allows us to create our own middlewares, which is very useful to funnel a request through multiple steps and the response as well. But we can also plug in existing third-party library middlewares to get functionality like this body parsing out of the box without having to write the logic on our own, which of course really simplifies things for us and allows us to focus on our core business logic. This is basically it for this Node Express refresher. Now obviously there is more to Node and more to Express. We'll learn about a lot of our features throughout our course project. I don't want to explain everything about Node Express here in this refresher. Instead, we'll also learn more things later. But as I also already mentioned earlier, this course doesn't replace a complete Node Express course. I do have a dedicated course for that, so if you want to learn everything about Node Express, then definitely have a look at that course as well. One final thing which I want to do here is I really want to make sure that we all understand how this code executes and when what executes, because that can be confusing at times. When we start NodeMon with npm start, or we run our file with node app.js, which does the same if we ignore the live reloading functionality, then what happens? It's important to understand that when you execute this file with Node, the entire file is parsed and executed. So that means these imports are parsed and executed. So Node.js goes into these packages, runs their code, and gives us back whatever they export. We'll see the export syntax and how we can use it on our own later, by the way. Thereafter, this constant is created, and then all these use, post, and get methods are called, as well as the listen method. What's not being executed immediately when we execute this file are these middleware functions here. Not because Node has a special exception for them, but because of the way JavaScript works. These functions here are callback functions provided as arguments to post, use, and get. And therefore, JavaScript registers them, stores a reference, a pointer to that function in memory, but only executes them once they are getting called. And we are never calling these functions. Instead, with post, use, and get, we basically let Express.js set up some logic which will execute these functions for us when a request is reaching our server and that request meets our criteria here. So it's a post request with this path or a get request with this path, or in case of this middleware, any request. Only then these functions get executed. It can also be confusing that here it doesn't look like we're actually passing a function. Instead, I am executing a method here. Well, this actually returns a function though. So here, this also registers such a to be executed function. And these functions really only run for incoming requests, not when we start our server and execute app.js with Node. No, these middleware functions are executed for incoming requests on these requests. And that's it with the refresher. I hope the basics are clear. Again, check out further resources like my course or the official docs of Node and Express if you want to learn more. With that, we can move on to the Node Express app for our actual course project and start working on that. In this module, we'll get started with the backend of our application. We'll build our Node.js Express REST API and write all the code we need to write to handle incoming requests for different routes and much more. Specifically in this module, we will set up this Node and Express app. We learned how that works in general in the refresher module. Now we'll do it in a real project. We'll add the routes which we need for our project to handle different requests with different HTTP methods targeting different paths. We'll add controllers and some dummy logic for now. Later, we'll also add database and so on, but in this module, we'll just get started with some dummy logic, with some in-memory storage and so on. And we'll add controllers because we will kind of use the MVC, the model view controller pattern, without the view because it's a REST API, but we will work with models and controllers. And we'll also make sure that any data we receive from whichever client that is connected is also valid data. So we'll add some server-side input validation to make sure that the data which is attached to the incoming requests meets our requirements. For example, that the title of a new place is not an empty text string or something like this. This is what we'll do in this module. And we will therefore now implement these API endpoints which we planned earlier. Now, to be precise, we'll not add everything we need to add for the user routes. For sign up and login, we'll not implement this at the moment. We'll add authentication in a separate module later in the course. But we will set up the general routes for that and write some dummy code in there. And for places, we'll also not yet add a database. That will happen at a later point of time. But we will set up all the routes and store some places in memory for the moment. This is what we'll do now, and with that, I'd say, let's get started. I'm in a brand new project, so simply an empty folder, which I opened here in Visual Studio Code. And since I want to set up a Node and Express app here, I will first of all make sure that this project can be managed with the help of npm, with that tool that allows us to install third-party dependencies and so on. For that, let's open up a new terminal, which automatically is navigated into this project folder here. this integrated terminal. And let's run npm init there. As you learned, this asks you a couple of questions, which you can all answer with the default by hitting enter. And it will then generate this package.json file, which will manage all the dependencies and which allows you to register some scripts. With that, let's install some dependencies. Specifically, I want to install Express and Body Parser as production, so as code dependencies with --save, because I will use these dependencies in the code we write. Let's install these packages so that we can set up an Express app and can also parse the bodies of incoming requests. I will also install one other dependency with --save-dev, and that's NodeMon. This was this extra tool which makes sure that we automatically restart our server whenever we change some server-side code. This simply speeds up the development process because we don't have to manually quit and restart the server. And with that, I'll add a new file here. I'll add a app.js file. You could name it server.js as we did it in the refresher module. Here I will name it app.js. It serves the same purpose. It's our main entry file. Therefore, here in package.json, I will add a new script, the start script. And as a command there, I will use nodemon and point at the app.js file, so that when we run npm start, nodemon will use node to execute this app.js file, and it will also watch all files in this project directory, and whenever any file changes, it will automatically restart the server. At the moment though, there is no server to start because the app.js file is totally empty, of course. So let's get started with that, and let's set up a basic Node Express application there. To set up a basic Node Express application in the app.js file, I will first of all import Express with that Node.js specific import syntax where we require a package and then store the imported content, the imported object in the end, in this Express constant. And I'll do the same here for the body parser because we'll also need that to parse the body of incoming requests. And with that imported, we can create our app object by executing Express as a function. That is what you learned in the refresher module. And on that app object, we can then register middleware, either generic middleware, which triggers on all requests with the use function here, with the use method, or middleware for specific HTTP methods with get and post and patch and so on. And there we then have to specify a filter path and thereafter the middleware function. Once we're done with all the middleware, and of course right now I haven't added any, but once we have added it, we can call listen on the app object to listen on a certain port, and here I will use port 5000 to then, well, start my development server on that port, so on localhost 5000. And with that, it's now time to register middleware. Now, which middleware do we need? Obviously, we want to use middleware, body parser, that ensures that we parse the request bodies of incoming requests. In addition, however, I also want to handle requests to different paths. So I want to set up my routing, so to say. Routing simply means that I want to listen for certain HTTP method path combinations and then run different code for every combination. That is what I mean with the term routing. I want to route certain requests to certain functions that should be executed upon those requests. Now we can set up such routing with app-get to handle a GET request to /nothing, for example, but it is a good practice to not do the routing here in this main app.js file, which would get rather big if you have a lot of routes, but to outsource it into separate files. And therefore here, I will add a new routes folder next to app.js, and in there I will add two files. The first file which I'll add is places routes.js. You can name the file however you want. I just name it -routes so that it's clear that this will contain some routing logic. Of course, you could argue that since this file is in the routes folder, that's already clear and we could just name it places. But since I'll have other files named places in other places of the app as well, I'll go for places routes here and also users routes.js. Now, my idea is that in these files, I set up the middleware, or I register the middleware that is responsible for handling routes related to places and routes related to users. To do that, let's get started with a simple places route. And for that, I'll now again use Express here in this file. So I'll again import it here. And that's important, by the way. If you need Express in more than one file, you have to import it in every file where you use something from the Express package. So just because I import Express here in app.js already does not mean that it's automatically unlocked in all other files. No, if we need something from Express in this places routes file, and we will need something from it here, then we have to import it here. Now the question is, what do I need from this Express package? I need a special feature, a special tool, and that's the router, which we can access with express.router, which we execute like a function. And that's important. Here, I don't execute Express itself as a function, as I did it in the app.js file, but instead this router method with a capital R, which exists on the imported Express object. This gives us a special object on which we can also register middleware, which is filtered by HTTP method and path. But the interesting thing is that we then can export our configured router by the end of this file and import it in app.js and register this entire configured router as one single middleware in app.js. Now it becomes clearer if we simply do that. So here in router, I will start by registering a route, and let's say it's a get route for /nothing for the moment. We don't actually need this specific route, and we can fine-tune this later, but for the moment, let's just register this. We simply call get on the router. It basically has the same methods like the app object when it comes to middleware. We can use to register something on every request, or post, get, patch, and so on to register something on specific HTTP methods. Then, if we do pick a specific method, we have to add a filter string here. So simply the path by which we want to filter. And then the function, which should execute when a request reaches this route. So when we get a get request to /nothing. Then we have our standard middleware function as we know it with the three arguments, request, response, and next. And in there, we can now run the logic we want to run upon such a request. And here I will just say get request in places like this so that we can see a log in the console. And let's send back a response. And here the special thing is I'll not send back a response with send, but instead here I want to send back a response that contains JSON data. You might remember that earlier in the course, in the theory module, I explained that with a REST API, we would exchange data in the JSON format. That means that we don't send back HTML or anything like that, but instead this machine and human readable data format. Express.js makes that easy. We have a JSON method there on the response object. The JSON method takes any data which can be converted to valid JSON. So for example, an object, an array, just a number, just a boolean, or just a string. But here I'll go with an object, and there simply add a message. It works. It's totally up to you which object you pass here with any properties of your choice. Here I just have one property, the message property. It works. So that's basically the data which will be encoded to this JSON format and which will be attached to the response, which is then automatically sent back when we call JSON here. So this sends back a response with some JSON data. Now with that, we registered this route. Now that's in the routes file here, however. We need to kind of link this to the app.js file, because ultimately when we run npm start later, we will execute this app.js file. So we need to establish a connection between this file and the Express app we're setting up here and the routes we registered here. And to do that, we need to export our configured router from the places routes JavaScript file. And the export syntax in Node.js looks like this. Module.exports equals router. This simply means the thing which we export in this file is this router constant. So this configured router object in the end. This is what we export in this places routes.js file. And now since we export it here, and only because we export it here, we can go back to app.js and import from our places routes file. We can not just import from default Node.js modules or from third-party libraries, we can also import from our own files. And it is a good practice to have the third-party libraries and Node core modules at the top, and then leave an empty line here, and then add your own imports. It's not technically required, but considered a good coding practice. So here I will get my places routes, or however you want to call it, by calling require, and now not just the name of your file, but the relative path to the file. So here from app.js, we have to go into the routes folder and then target the places routes file. So it's /, which means start at the current folder, then routes, which means go into the routes folder, and then places routes. And you can omit the file extension, it will automatically add that for you. Now we have the configured router, which we export here in places routes, in this places routes constant in the app.js file. And this now, conveniently, is simply a middleware. We can use the router here as a middleware. That's a nice feature Express.js offers. So we can call app use and register places routes like this. And now this means the routes which we configured here are added as middleware in app.js. And this allows us to move the logic out of app.js and keep that file lean and set up our place-related routes here in the places routes file. With that, we have an app that should work. So if we now run npm start, our node server starts up. And if we now visit localhost 5000, we see our JSON data here. Now it gets printed as text here, but if we open the browser developer tools and we go to network and reload this page, here's our request. And what you see is that you get a status code of 200 automatically. That's the default status code Express gives you on responses it sends back. And you see in the response header that the content type is set to application JSON. Express.js does this because we use the JSON method here. It converts the data to JSON and sets the right headers. And if we go to the response tab here, you see that is the response data you got back, and this here is actually how JSON looks like. Properties are enclosed in double quotes, and string values are enclosed between double quotes as well. So this works. We're able to send back this simple data, this simple response. But of course, we're not done. This isn't even a route which we need. Instead, we need other routes if we have a look at our planning slide here. And in addition, we also need users routes. And we want to make sure that we can reach both routes in both these files. Of course, we haven't set up any users routes yet, but we'll do so soon. From our app.js file. We're also not parsing any incoming request bodies. So that's also something we'll have to do. So plenty of work left. Let's continue with that in the next lectures. We added our first simple route in an extra file here to keep our app.js file lean. Now, as I mentioned though, this isn't even a route which we need. We need get routes in the places area, but we need routes for a specific user ID or a specific place ID. We also need other routes like post, patch, and delete. So let's work on that now. Let's also make sure that we only reach our places routes if the request starts with /API/places as indicated on that slide, and not with /nothing as it's currently the case. Because we also want to be able to use /API/users to later reach our users routes. So for that, back in our application, to make sure that we only make it to these places routes if the request starts with /API/places, we have to add a filter here on this middleware in the app.js file. Now, when using the use method, you don't have to add a path filter, but you can. Then this filter will also not be treated as this has to be the exact path filter, but as the path has to start with the specified path filter. That means that here as a first argument, we can add /API/places, And Express.js will now only forward requests to our places routes middleware, so to the routes configured here, if their path starts with /API/places. It can be longer than that. So it can be /API/places/something. It will still be forwarded. But for example, just /API/nothing would not be forwarded to places routes. So with that, if we change this, we make sure that if we reload here, this does not work anymore, because now our route here, /nothing, actually has to be prepended with /API/places. And that's also important. The route filter you set up here is automatically added to the filter you have here. So if you want to have requests which start with /API/places, you must not repeat that here. Instead, here you only add the path after that initial filter you have in app.js already. So here, that simply means just API/places/nothing should trigger this function. So here, if we now enter API/places, we get our message again. This works. But of course, whilst it's nice that this works, this isn't really the logic we need here. Instead, if we have a look at our plan again, we need a get route which has /user/some user ID in it, or which just searches for a specific place ID. And to practice that, let's actually add a constant here in places routes, dummy places, which will later in the course be replaced by our database access in the end. But here, let's just store some dummy places for the moment. And every place could have an ID, P1, could have a title, for example, Empire State Building, could have a description, one of the most famous skyscrapers in the world. A location, which actually should be a nested object with a latitude and a longitude. And here I simply used Google Maps to search for that. So I'll paste in the values. You can simply use Google Maps and search for the Empire State Building to then find the latitude and longitude here in the URL. The thing after the @ is the latitude. The thing after the comma thereafter, before the next comma, is the longitude. So that's what I simply pasted in here. Then the address, which I'll also simply paste from Google Maps. And a creator field, which points at a fictional user ID, because we have no real users at the moment, U1, which I would say is the user who created that place. Later, of course, we will have real users and linked up models. We'll have users connected to places. For now, we'll just work with the dummy data. So now we have a place which we could try to get by its ID. So actually here, I want to have a GET request where the ID is part of the URL. So the idea is that we send a request to API/places/P1, for example, and this gives us the data for the place with the ID P1. So the ID should be encoded in the URL. That's a typical pattern you see in such APIs in reality. To tell Express that we have a dynamic segment which we don't know in advance, because of course I can't say I want to load something for P1, because later we'll have more places with different IDs. So to tell Express that we have a dynamic segment where we don't know the exact value in advance, but where we want to be able to later use it in this middleware function and find a place by the concrete value which was entered, we add a colon here in our filter, and then any identifier of our choice, for example, place ID or just PID for place ID. Now, Express.js accepts this route here. If I save this and I reload this URL with places/P1, we see we make it into this middleware function, and that's great. But now I also want to return that place with that ID, which I conveniently have here because I added it as a dummy place. For that, we need to extract the concrete value that was entered for this concrete request, which reaches this function. And Express.js has got us covered with that too. We can get the place ID by using the request object, and there you will have a params property. This is added by Express.js. The params property in the end holds an object where your dynamic segments here will exist as keys, And the value will be the concrete value the user who sent the request entered. So here we can access request_params.pit and get the concrete ID that is encoded in the URL. Well, and now we can search for a place with that ID in the dummy places array and add that to the response we're sending back. So here we can get our place by reaching out to dummy places and using the find method, which is a default JavaScript array method. It helps us find a specific element in an array. Find takes a function which we pass to it, which will be executed on every element in the array, and the element it's currently looking at will be fed into the function as an argument. So the place in this case, which I'll just name p here in the argument to not clash with this constant name. Then here in this find function, we have to return true if we're looking at the place which we want to find. So here I will return p.id equal place ID. So I'm comparing the ID of the place I'm currently looking at, and keep in mind this function here executes on all elements in this array. Of course, here we only have one, but if we had more than one, it would execute on all of them. And it will then return true if the ID of the place it's currently looking at is equal to the ID that was part of our URL. And then here, instead of returning some message, I can return the place here in my response. This syntax here, by the way, can also be shortened to this. That is default JavaScript. It in the end means that JavaScript automatically expands this to this. If the name of the property is equal to the name of the variable that holds the value you want to store in the property, you can shorten it. And with that, if we now save this and we reload this page, you see indeed here I get back that place data. I get back that place data because I entered a valid ID. If I, for example, would try to find the place with the ID P2, which I don't have here in my dummy places, you would see I get back an empty object because there is no place which I found, so there is no place added to this object. Of course, in such a case where we didn't find a place, we might want to handle this error differently and return a 404 error, for example. But we'll have a look at error handling a little later. For now, let's leave it as it is and instead work on another route. Let's implement that get/user/:UID route here. And that is actually a great practice for you. We'll implement it together in the next lecture. But here it's your job to instead write a new route that is able to accept this dynamic UID segment, extract it in the middleware function then, and find a place where the creator has that user ID. You learned everything you need for that in the last lectures, so definitely try it on your own first before we then do it together in the next lecture. Were you successful? Let's implement it together. I want to register a route for /user/:UID to have that dynamic UID segment. Then we have the default middleware function with request, response, and next. And in that function, I now want to get the user ID and then find the place where the creator has that user ID. So here, user ID is of course request params UID. And my place then is again found with the help of the find method, where we have this function we pass to find, and return p.creator equal to user ID. If the creator property in a place holds the user ID that's part of the URL, it's the place which I want to find. So thereafter, I can return that place here in my response. So the logic is very similar to the logic we had up there. Of course, the only difference is that now we're searching for the user ID. If we now test this and we search for a user U1, we do find a place where the creator is U1. If I search for U2, then we get no place. If we try that other route from before again with P1, that of course also still works. So we got these working routes registered here. Now one for a place ID and one for our user. Now one important note. If we enter just /user here, we of course find no place. That also is not a valid route. But why do we actually get back this empty object instead of an error, as we would, for example, get it if I search for /place instead of /places? Then we get this cannot get error, which basically means no route is defined. Why do we not get this if I search for /user? Well, that's a little gotcha we have here. The order of routes matters. This first route handles all requests which start with /API/places and then have any value, because here we handle any value and we store it as a place ID. This route handles all requests which start with /API/places /user/any value. The problem is, if we enter just /user, this is the any value which is interpreted here as a place ID. Now, when we add more, for example, user U1, Express correctly identifies that we don't want to make it in here, but that we have a more specific route down there for /user/more. But if we only have /user like this, Express does not find that this is an undefined route. Instead, it makes it in here because, well, here we do handle any arbitrary value after /API/places. And that's just something to be aware of, that of course this handles all values, even if they're not valid IDs. Now, it's not a huge problem because we simply don't find a place for user, which is interpreted as ID here. It's just important for you to memorize that order can matter here as well. If you, for example, had a /user route you want to handle, like this, which we don't need here, but if you had that, you would have to move it in front of this route so that this does not already consume this user value as an ID. Here it does not matter because here we have one extra segment which makes this route more specific and a different route than this one. But if you had /one value only, like /user, you would have to switch order here to make sure that this route is actually reached and this route doesn't consume it in advance. That's just a little gotcha to be aware of. It's not a problem here in our app because of the way we structure our routes and because of the paths we're working with, but it might be a problem in other apps, which is why I want to highlight it. With that, however, we got our two main routes implemented here, our two main get routes, and we're able to get places by their ID or by the ID of their creator, which is a nice step. Before we now work on other routes, let's actually handle errors in a bit of a better way. At the moment, if we don't find a place, we simply return a 200 response, for example for P2, with an empty object. We could do that, but I would argue it's not really a success, which a 200 status code indicates though, if we didn't find anything. I would rather return a 404 error status code, which means the request didn't find any data. For that here, we can check if not place, so if that is falsy, which would be the case if place is undefined, which is the case if we don't find a place here, then I don't want to return this response, but instead a different response, where we set a different status code. Now, to set a status code, we can call the status method on the response object. By default, this is set to 200, so we don't need to call it if we want to set it to 200. But we can set it to 404, for example, which would be a standard status code for saying we didn't find anything for the given input. And then we can still call JSON to add some data, and we should do that to then also send the request. And here we could add a message, could not find a place for the provided ID. And that message could be presented to the user later in the frontend or in the client we're attaching to this API. Now, one important note, at the moment we would actually introduce a bug here, because here I'm sending a response, and this function execution, of course, doesn't stop thereafter. So this line is also reached after this line executes, so we would send another response, which is not possible and which would therefore cause an error. To work around that, we could either wrap this response in the else block so that only one of the two code snippets executes, or to save that extra code for the else block, simply return here Not because anyone's interested in the return value of calling JSON, but simply because when we return, no other code thereafter executes. And that's exactly what I want. If we make it in here and we send this response, I don't want this code to execute, so returning here makes sense. With that, if we save this and we try to load a place with an ID that doesn't exist, you see I get this object with message could not find a place for the provided ID. And we also see it's already marked as red here because we got a 404 status code. And that's way better in my opinion. And of course, I want to do something similar here in the other route. I also want to send this response here if we're looking for a user ID which doesn't exist. So here I will say could not find a place for the provided user ID. If we now try this and search for user/u2, I get could not find a place for the provided user ID. If I enter a valid ID, it of course works. The same for my place. If I enter a valid ID here, it also works. Now that's nice, but you can already tell that we're having some code duplication here. We have a very similar check, and the way we send the response is also pretty equal. The only difference is the message. So it would be nice to kind of find a different solution here to have less code duplication. And for that, we can use a feature Express.js has built in, a default error handler. We set this up in app.js and we set it up as a middleware there. Here, we simply add a middleware after our routes middleware. And this middleware here doesn't need a path filter. Instead, we directly add our middleware function, and now it's a special middleware function though. You know the middleware functions with 3 parameters: request, response, and next. This is a middleware function Express will apply on every incoming request. Now, let's tweak this a little bit and let's add a 4th argument, a 4th parameter, which actually is our first parameter here, an error. If you provide a middleware function that takes 4 parameters, Express.js will recognize this and treat this as a special middleware function, as an error handling middleware function. That means that this function will only be executed on requests that have an error attached to it, you could say. So where an error was thrown in the end. So this function, to put it in other words, will execute if any middleware in front of it yields an error. And then in here, we can set up some default error handling code. First of all, we should check if response headers sent is true. That means we check if a response has already been sent. If that's the case, we want to return next and forward the error, which means we won't send a response on our own because somehow we already did send a response and you can only send 1 response in total. This is a little helper property which helps you check if a response and the headers attached to it has already been sent. If not, so if we make it past this if check, we know no response has been sent yet, and in this case I want to send one now. I want to set a status code on that response, and I want to give the developer of this application, so us in this case, a chance of setting that code on the error object which is thrown in one of the other middlewares. We're not doing this right now, but we're doing it soon. So we'll check if on the error object I'm getting here, if we have a code property and if that is not undefined. If we don't have it, I'll fall back to 500 as a default status code. A 500 code indicates that something went wrong on the server. So either this is set, or if it's false, this value will be used. This is default JavaScript code. And thereafter, I'll call JSON. We could also use the chaining syntax I used before to chain it right here. It's up to you. Here, I structured it across multiple lines to make it a little bit more readable. And there, I want to add an object which has a message property, because every error I send back from my API should have a message property which the attached client can then use to show an error message to their users. That's not a must do, but it's a convention you see a lot in other REST APIs out there, and it is a convention that makes a lot of sense and which I think therefore should be added to our application as well. And here again, I want to check if I have a message on the error object, which I will use and send back if we do have it, and otherwise provide a generic default message of an unknown error occurred. And we'll only use that if there is no message property or an undefined, invalid, falsy value in the message property of the error object. Now that's our error handling middleware. How do we trigger it? We trigger it by doing one of two things. Either here, instead of returning a response, we never do that, either we throw a new error here, or we call next and pass an error to it. Both works. There is one important difference. If you would be in some asynchronous code here, which I'm not here at the moment, but which we later will be when we work with the database, then you have to use the next and pass the error object approach. If you're in a synchronous middleware, as I'm currently here, because we have only synchronous actions, then you can also just throw an error. I'll implement both, one in each function, so that you see both. Later, we'll only work with next error because we will work with asynchronous code. For the moment, we're not doing that. So first of all, let me create an error here though. I will create a new error object, and that already takes a message in its constructor. And here I'll say could not find a place for the provided ID. On that error object, I'll add a code property with the dot notation, simply dynamically adding that property, because here in app.js in the error handling middleware, I'm looking for such a code property. And I'll set it to 404 so that this will be the actual status code which our error handling middleware will send back. And then I can throw that error, and this will trigger the error handling middleware. Now let's copy that here to that second route, and there I will not throw it, but call next to forward it to the next middleware in line, and since I forward an error, it will reach the next error handling middleware in line. And there I will say could not find a place for the provided user ID. If we now save that, and we try a place ID which doesn't exist, you see I get the same object as before, and the same response with a 404 status code. So that works as before, but technically on the backend, it now works in a cleaner, in a better way. Now what you can also tell, however, is for user U2, it does not work. So using next error does not do the trick here. Well, the reason is that I don't return. So that means this code also still executed. That's also why we have an error here on the backend, because more than one response was sent. As I mentioned, you shouldn't do that. So you must not forget to return here. When throwing an error, you don't have to return, because if you use throw, that already cancels the function execution. Next does not cancel it, so we have to return to then thereafter make sure this code doesn't run. And with that, if we now search for an invalid user ID, we also again get our default response. That works, but still, we have some code duplication here in these lines. So we can maybe optimize this even more if we start adding our own error model. Let's do that in the next lecture. Time to add more than just routes. Here with the error, we already have a great first place of adding our own data model. Now we could also add a place and a user model, but I'll stick to my dummy inline object literal data for now, because we'll add real models later when we work with the database. For the error, however, we'll not replace it later, so we can already implement a proper model for it now. A model basically is a blueprint, the definition of a data object we work with. And therefore I'll add a new models folder here, and in there I'll add a error, or to be precise, http-error.js file. In that file, I'll create a new JavaScript class. The class keyword is available in modern JavaScript. No extra build tools or compilers are required. And I'll name this class http-error. Now, in case you're not aware, a class is essentially a blueprint for a JavaScript object, and you can learn more about that in my JavaScript Complete Guide, for example, or of course also in other JavaScript resources. I expect that this is something you know or you're looking up whilst you're taking this course, because it is some basic JavaScript concept. Now this class will extend, with the extends keyword, the built-in error, which means it's based on the built-in error, but we can tweak it to look and work the way we want it to look and work. Specifically, I'll add this special constructor method, which we can add to any class. This allows us to write some logic that runs whenever we instantiate this class and create a new object based on it. And in this constructor, I expect to get a message as an argument and an error code. And then in here, we call super to call the constructor of the base class, so of the error class here, and forward the message to it. This will already add a message property to the instances we create based on this class here. And I will also add another property, the code property, which is set equal to error code. And you add a property with the help of the this keyword here. So this adds a code property to instances based on this class. Now we have to export this class with module exports so that we can use it outside of this file as well. And with it exported, we can go back to the places routes and there simply import it. So here I'll import my HTTP error by calling require ... which means go up one level out of the routes folder, back into the root folder, then go into the models folder, and then there HTTP error without the file extension. That's where we get this HTTP error class I'm interested in. You could name this however you want, by the way. Convention just is to name these classes, which essentially are constructor functions, therefore, with a capital starting character. So I'm doing that here as well. And now I'm doing this because now we can shorten this a bit. We can create a new HTTP error here, which gets a message and then gets our code like this, so that we can get rid of this line here, and we can also get rid of this first line and just throw this error, which we create on the fly, which is definitely a bit shorter. And here we can do something similar. We can create a new HTTP error, pass in this message here, and set the 404 status code and get rid of these two lines. And now this is really a shorter way of doing that. And if we now give it a try, you see this still works as before. We're able to find places that exist, and we get back the proper error response for places that do not exist. And with that, we added nice error handling. It was important to me to do that early so that we have it in place before we write too much other code, which also needs it. But with that, I would say we also can go back to our actual routes which we need and the logic we want to run there, and make sure that we also add more of the routes we specified here on this slide, because thus far we only have these first two get routes. Now that's of course not all. We need the post, patch, and delete route as well for our places, and then of course we also want to add some users routes, because there we haven't added anything at the moment. Before we work on more of these routes here, let's actually restructure our routes file a little bit. It's already getting a bit bigger, still okay, but getting bigger. And the more routes we add, and with all the logic that needs to execute for every route, the bigger this file will get. Therefore, it's a good idea to follow this MVC structure, which stands for Model View Controller. Now, we won't have a view here. That is what the user would see. We're building a REST API, so there is no page, no HTML file we would render on the server, which we show to the user. But we have models, like the error blueprint here, and we will have controllers. Well, we don't have them yet, but controllers will be files that hold the actual logic that should execute when a certain route is reached. So they glue together the incoming request and then our models and the logic that should run for such an incoming request. Hence here, I'll create a new folder, controllers, and in there, I will add a places-controller.js file. Again, you could just name it places because it already is a controllers folder. But to make it really clear, also if I have the file open like this, you can quickly see it here at the top, what's in the file, I will name it like this so that this is always clearly visible what's in there. So we'll have a places controller and later also a users controller file. So I'll already create both. And the idea is that in the places controller, we have all the middleware functions which actually are reached for certain routes. So for example, here, for this first route here, for a specific place ID, I would cut this function from places routes and move it to the places controller. There, I will add it as a new function. And it's up to you which kind of function you create, if you use a function declaration or a function expression. Here I'll go for a function expression with an arrow function, and I will name it getPlaceById and paste in my function. Now, as I mentioned, alternatives would be to create a function getPlaceById and then have your logic there, or getPlaceById and use the expression style, but not use an arrow function, but use the function keyword. These would be alternatives. I'll go for the arrow function here. So now we have getPlaceById. I also have another function, of course. So I'll cut this as well from my routes file and add it here in the controller. And this file, of course, will now get a bit bigger, but it's clearly focused on only middleware functions. And that's the whole idea. We want to have focused files. We want to have a file which is all about routing and mapping paths and HTTP methods to controllers. And then we want to have controllers which are all about having these middleware functions and the logic. So it's okay if that file gets a bit bigger. We can always go into this file if we want to look for the logic, and go into this file if we want to look for the mapping and the paths we're using, and we're not mixing both in one super huge file. That's the idea. So in the places controller, we can now add that other function getPlaceByUserId, paste in that function here, and now important, also move the dummy places from the routes file to the places controller file, because that is where we interact with the dummy places. That's of course therefore where we should have that array. Now this is all nice. We don't need to import Express here, by the way, because I'm not using any feature from Express here. I'm just setting up some regular functions which receive everything they need as parameters. But we need to export our functions here so that we can link them to the routes which are registered in a different file. Side note, we also need to import the HTTP error model here in the places controller though, because I'm using it in there. But now I want to export the getPlaceById and the getPlaceByUserId function. Now we learned that we can export by using module.exports. This allows us to export a single thing, but here I have multiple things. For that, Node also has an alternative export syntax. Instead of module.exports, you can use exports dot any name of your choice, but here I like to repeat my function names, so getPlaceById for example, and set this equal to the thing you want to export under that name. So in this case, I'll point at getPlaceById. Important, I don't execute it. Express will execute it when a request is incoming. I just want to export a pointer to that function so that Express is able to know what to execute for an incoming request. And I'll therefore do the same for getPlaceByUserId here. Now both will be bundled in one object which now has these properties which hold the pointers to these functions as values. So now in places routes we can import our controllers. Our places controllers can be found with require by going out of the routes folder into the controllers folder into places controllers. And then here for router getPlaceId, I can point at places controllers getPlaceById. Again, I'll not execute it here. I'll just point at it so that Express has a pointer at the function it should execute for us when a request reaches this route. And we can do the same thing here for this route. And now we have a pointer at this function for this route and a pointer at this function for this route. The result is that it should work as before. Let's try both the error and the success cases. Yep, that is looking good. But the difference is that we now have a clean routes file where we can quickly see our paths and methods and which controller function is responsible for it. And then our controller file, which is a bit longer, but which itself then is also clearly focused on just defining our middleware functions. It's now time to also work on the other routes and not just get routes. For example, let's make sure a new place can be added. Still, for the moment, only a dummy place, which is then stored in memory basically, but better than nothing. So let's add a post route. For that, let's go to the places routes file and add a new middleware here with post, because I want to filter for post requests only. And the path should be /nothing, because the idea is that any request, any post request that targets /API/places and which therefore reaches my places routes automatically reaches this route here. So just /nothing is the filter here. And then in there, I need a controller function to which I can point. So here in places controller, let's add a new function, create place, sounds like a fitting name. And this will be a default middleware function which gets a request object, a response object, and this next function which we can call. And of course, I want to export it here so that we can reference it from another file. I'll set exports create place equal to create place, so to a pointer at this function. Now in places routes, we can point at this new function, places controller create place, and we're done in this file. Now in places controller, we now need to fill this with some life, and now it gets a bit more tricky. Before, we always had the data we needed in the URL, like here, the user ID which we got from the params in the URL. Now, for a post request, I expect to have data in the body of the post request. Because whilst GET requests don't have a request body, post requests do. And you do encode the data you want to send with a post request into that post request body. Now, to get data out of the body, we can use a package we learned about earlier, the body parser. So we want to add a new middleware, and we want to add that before the request reaches the places routes, because the middlewares will be parsed from top to bottom. So you want to first parse the body and then reach the routes where you need the body. So here we will add body parser, and now I want to parse for JSON data. Before, in the refresher, we used URL encoded data to be able to work with that form data. Here I need JSON. This will parse any incoming request body and extract any JSON data which is in there, convert it to regular JavaScript data structures like objects and arrays, and then call next automatically so that we reach the next middleware in line, which are our own custom routes, and then also add this JSON data there. So in the places controller in create place, we'll now be able to get the parsed body, and we get it on a request body property. Now here I will use object destructuring, which is a default modern JavaScript feature which Node.js supports, to get different properties out of request body and store it in constants which are then available in the function. And here I'm interested in the title, the description, let's say the coordinates. It's up to us what we expect as data on the incoming request. Here I expect these fields, and the address as well as the creator. These are the fields I expect on the incoming request. And this object destructuring here really is just a shortcut for doing this for every property. So now here we're extracting data from the incoming request. For the moment, we just rely on the fact that all this data will be there. Later, we'll add validation to make sure it really is. But for the moment, let's just assume that we always get the right data. And now I want to create a new place. I'll name it created place, and I'll create an object literal here. We could create a class for a place to use it as a blueprint. But since we'll replace this later anyways with some MongoDB logic, we can leave it like this as an object literal for the moment. Now in that created place, I want to have a title, which I'll map to the value I extracted here into this title constant. And since the name is equal, we can use this shortcut. Same for description. Coordinates is not the same. Here I want to have a location key because I have a location key up there too. And that then holds an object with let and lng. And I expect that coordinates is such an object with let and lng. So we'll store coordinates in the location property. And then address will be stored in a address property, so we can use that shortcut again. And the same for creator. Now that created place can be added to our dummy places, for example with the push method or with the unshift method if you would want to add it as the first element. Here I will add it as a last element with push. And thereafter we can send back a response. Here I want to set the status code to 201, which is a standard status code you send back if something was successfully created on the server. 200 is your normal success status code. If you created something new, the convention is to return 201. And as data, I will attach this created place. So I will return the created place here. To be precise, I'll return an object where I have a place property which holds that created place. Now with that, we got our middleware function, we got that connected to this route. The question is, how can we now send a request to it? Because if I now enter just /places/nothing, which would be the path that reaches this route, you'll see I actually get an error that this route is not found. The reason is that if you enter something in the browser URL, it by default always is a GET request, which means it can't work because we have no GET route that handles /nothing. We just have a POST route. To send a POST request, we could now set up some JavaScript code that sends it, for example. By the way, if you try that, it won't work, and I'll show you why later in the course. For the moment, I'll use a different tool though. I will use Postman. You can just Google for Postman and you'll find their official page. And Postman is simply a tool that allows you test or send requests to APIs. You can simply download the app from getpostman.com and simply walk through the installer that gives you and install it on your system. It's pretty straightforward. And then once you start this installed application, you will see a screen that looks something like this. You might also have like an overlay at the beginning which asks you what you want to do. You can simply close that to be taken to this interface here. Now here in Postman, you can click this plus here or new request, but that is a different form. You can simply use the plus here, which is simpler. And in there, you can choose the HTTP method of the request you want to send, in our case, post, and then the URL, which in our case is /localhost:5000/API/places/nothing, but you can omit that last slash as well. You could then add perms, which should be added as query perms, so with such a question mark at the end, which we don't need here. Authorization, which we don't need at the moment. Other headers, which we also don't need at the moment. And a body. And here on body, click raw, and then here choose JSON to add JSON data. And now valid JSON data looks like this. You add curly braces here. And now all the properties we're trying to extract here in our request or in our middleware from the request body. And of course named exactly like this because you are trying to extract them by that name. So here I will add a title, Wall Street Exchange. I'll add a description. Double quotes are important here, by the way. Single quotes won't work. Description, where the money lives. Creator, for now I'll say U2 here. We can invent any IDs here because we have no users anyways. Also the address, and I'll again get that from Google Maps, simply searching for Wall Street there for the Wall Street exchange in the end, but you can pick any location you want, of course. So for the New York Stock Exchange to be precise, let's also name it New York Stock Exchange. Address is this here, and then here we have a coordinates property, because I'm trying to extract coordinates here, which in turn needs to have a let and a lng key in its nested object. So this is actually a nested object with more curly braces. And there we have let, and I'll again get that from Google Maps. This is a number, not between double quotes. You can also have numbers here. You don't need to have everything as a string, just as you can have a nested object. You can also have a number here. And lng is also taken directly from Google Maps and has this value. Now let's click send here, and we'll send the request to our backend. And there, indeed, this doesn't look too shabby. We get back a response, and it looks like we created that place. We can also validate that by sending a request to API/places/user u2, which is the creator ID I just used, and I find the New York Stock Exchange here. Now, important, this data at the moment only lives in memory. Whenever we restart this server here, by closing it and restarting, for example, or whenever we change something in code, when it's automatically restarted, that data will be lost. If I load that same page again, it will not find that place. Because when we store it here in a JavaScript array, it is only stored in memory. Now later, of course, we'll add a database and store it in a persistent way. For the moment, this dummy in-memory storage will do, just so that you don't wonder when it's suddenly lost. Of course, you can always recreate it by sending this request again. We can also test the GET requests here, by the way. We can also send a GET request from inside Postman to send a GET request to localhost 5000/API/places, and then, for example, the place with the ID P1. And we'll get the same response we saw in the browser before. And indeed, from now on, I will use Postman to have all the testing in one place, but for GET routes, you can also stick to the browser if you prefer that. Now, with that, we're able to create a place, and we're using Postman to test it. One thing is missing in our place, though, and that's an ID. And for that, I want to create a unique ID, which I'll do with an extra third-party package. So I'll quit this development server and run npm install -- save, and then the package name is UUID. This is a package which is capable of generating unique IDs. Thereafter, we can restart this with npm start. And now here in the controller's file, I will import UUID by requiring. And now there, we don't just require UUID, but there are different versions, and that simply are different kinds of IDs it generates. And I'll use v4, which is a unique ID that also has a timestamp component in it. So here, we then call UUID as a function. This generates such a unique ID and stores it here in that ID field. With that, if I save this again, and I create my place again here, you see I get back that place, and that's the unique ID which was generated. And now we can also send a GET request to HTTP localhost 5000/places/this ID. And as long as we didn't restart the server in between, we should get this. Of course, it should be /API/places here. Now we get this. So this is now working, and we're able to send post requests and also GET requests with the help of Postman and also with the help of our unique ID here. Now, one thing you might have noticed before is that if we send a request to a route which doesn't exist, for example, API/nothing, I get an error here, right? And I get this kind of error. Now that's okay, but we might want to handle this default route not found error. And for that, back in app.js, we can register a new middleware, not a error handling middleware like this, but a normal middleware handling all requests, no matter which verb we used, that comes after our routes. The idea is that this only runs, this middleware, which we register here, only runs if we didn't send a response in one of our routes before. Because if we do send a response, we don't call next, right? We just send a response, and therefore no other middleware after this one will be reached. So put in our words, this middleware is only reached if we have some request which didn't get a response before. And that can only be a request which we don't want to handle. So here I can then add my middleware, and in here I now want to return a 404 error. And I want to utilize my default error handler for that, and I'll simply import the HTTP error class we created earlier from the models folder, HTTP-error, and create such a new HTTP error here by calling new HTTP error. The messages could not find this route, and the code is 404, of course. And then we can throw it or call next. Here I will throw it because it's synchronous, so nothing speaks against throwing it. And that will then reach our default error handler to send us back a nice response. So if we now save that and then try this again, we now get our own response with a 404 status code, as you see here, and also with our own body. And that's just a little improvement which I wanted to add here so that we have proper error handling for unsupported routes as well. We got more routes which we want to add. A patch route that allows us to update a place by ID, and a delete route that helps us delete a place. So let's work on those now. Of course, as always, feel free to try this on your own first. There are some things, some HTTP verbs at least involved, which we haven't used before. But in general, you should have everything you need to make this work as well. So definitely try this on your own first. Here's a quick pause, which you have to pause the video and try it. Thereafter, we'll implement this together. So, were you successful? Let's implement this together now. For that, let's go to Places Routes and register two new routes. One for the patch HTTP method for /someplaceID. And by the way, this does not clash with this route because this only is interested in GET requests. This is only interested in patch requests. So the order does not matter, and the fact that they have the same path does also not matter. We would have a clash if we had another GET route with the same path here. This would never be reached. But since we have a different method, this is no problem. And then we want to point at some controller function. Before we add that, however, let me also already register a delete route also for /someID. Now in the places controller, we can add two new functions. Update place by ID could be one function where we get our response, our request, our response, and the next function, and then delete place. And I'll actually get rid of that by ID thing because we have no other way of deleting or updating anyways. So these are my two middleware functions. Now we need to export them here. So export update place and point at the update place function, and export delete place and point at the delete place function. And now in places routes, we can use that. Places controller, update place, and places controller delete place. So we're done in the routing file. Now we have to work in the controller file. Now, for updating, there are a couple of things we gotta do. For one, it's important to know that for a patch request, you also have a request body. And that's important because since we want to update certain fields, the data for those fields, of course, needs to be attached to the request. So I will copy that extraction here from create place and add it to update place. However, here I only want to allow updating the title and description. So I'll only extract that. Other data can be sent, but will not be considered. We also need the ID of the place which should be updated, and that is encoded in the URL. So here we have a mixture of some data being part of the URL and some data being part of the request body. And you typically encode the identifying criteria, so the ID in this case, into the URL, and the data with which you then work into the request body. So now to get that place ID, we get it from request perms PID, or whatever you chose as a segment here. Of course, if you choose PID here, you have to use PID here. If you chose a different name in the route setup, you have to extract your data by that name here. So now with that, we can search for the place in our dummy places array with the find method, and find the place where the ID is equal to place ID. And here I'm using the shorter form of that arrow function, where if we only have one expression and we want to return the value of that expression, we can omit the curly braces and the return statement, and this will then automatically be returned. So this is the shortest possible form of writing this. So here I'm identifying a place, and now we can update it. Now, I actually want to update it in an immutable way, which means I don't want to start working on the properties of the place like this, because that would immediately change it here in this array, because objects are reference values in JavaScript. In case that doesn't tell you anything, attached you find an extra resource on reference versus primitive values in JavaScript. Now, it wouldn't be horrible if we directly added this, but it's also not a great practice, because if saving our data or saving parts of our data would fail thereafter, which it can't really here, but if we would also store a file or something like that, then some data might have changed already, whilst other data failed. So I actually want to create a copy of that place, change that copy, and only once that copy is finished, I want to change the entire place in my array of places with that updated copy. So therefore, to create a copy, I'll use the spread operator here and wrap this in curly braces. This creates a new object and copies all key value pairs of the old object as key value pairs into the new object. Then I'm interested in the place index in the array. We can get this with dummy places find index. Same logic as before, but this returns us the index of the place instead of the place itself. And then I want to update my updated place object here, set the title to the title I got here in the request body, and also set the description to the description I got in the request body. Now you might be wondering why I'm able to change a constant here. Well, again, check that attached resource on primitive and reference values and it will become clear. Basically, the constant stores the address of the object and not the object itself. So now we got the updated place, we got the index of the place. Now I can set dummy places for the identified index equal to the updated place. So I replace the old object at that index with the new updated place. And then we can send a response. Status code 200, not 201 because we didn't create anything new. And there we could add a message if we wanted to, but here I just want to add the place. I want to return the updated place to be precise. And this should be a valid updating middleware. Let's test it. Let's save this and go to Postman. And there, of course, we have our places P1 place, right? If we send that request, that gives us the Empire State Building, which is never lost when we restart the server because it's hard-coded in our code up there. Now let's change something about that place by creating a new request, a patch request, where we target localhost 5000/API/places/P1. That's the ID of the place we want to add it. And then on body, choose raw, choose JSON, and in there, set a title property because we are expecting a title and a description property, and then a value of your choice, Empire State of Mind, and a description, a pretty great song. Now if you hit send, let's see if that works. Looks pretty good. I got my updated place back. I got a 200 status code. And if I now try to find that place here with my GET request, I also see the changes reflected there. So I successfully changed this. Now, just as with creating data, whenever we restart the server, this will be lost. But for the moment, this is great. Now let's also make sure we can delete a place. To delete a place, I want to set dummy places equal to dummyplaces.filter. The filter method is a default method available on JavaScript arrays. It returns a brand new array filtered per our function we pass to filter. This is a function which also runs on every element in dummy places. And if we return true in that function, we keep that place in the newly returned array. If we return false, we drop it from the newly returned array. The original array is never touched, but since I then overwrite the original array with that newly returned array, we update it with our filtered array. And here I want to return true for every element, but the element which has the ID that is encoded here in our URL. So we need to extract that ID first. Place ID, we get it from request params.pid. And here I return p.id unequal place ID, which means return true and therefore keep the place if IDs do not match. If IDs do match, then it is the place I want to remove. So I will return false, which drops the place from the newly returned array. And that newly returned array then overwrites the old array. And that's already it. This is as simple as deleting a place is with our dummy data at least. Later, of course, we'll adjust all these middleware functions to work with a real database. Of course, we also should send back a response, a 200 response. And, well, it's up to you which data you want to attach. Maybe send a message, deleted place, or attach the place you deleted. You would have to identify it first then. I'll not do that here. I'll just send back this message. You could also omit this. You could also not send back any data like that. It's up to you. I will send this message object. And now I want to see whether it works. So here in Postman, let's delete that p1 place. For that, I'll create a new request with the delete method, http localhost 5000/API/places/p1. No data needs to be added to the body. We can just send it like this, like a GET request almost. And I get an error. Assignment to constant variable. Yep. I'm overriding dummy places here. But since this is the first time I'm replacing the entire array with something new, I accidentally still left this to be a constant. It should be a variable with let, so that I am allowed to assign a new value to dummy places and replace the entire array with a brand new one. So here I'll go with let, and now if we save this and we simply send this request again, it now works, deleted place. And if I now try to find that place, indeed I can't find a place for the provided ID. Now again, just as with updating and creating, if we ever restart the server, of course, we're back to our initial state, which is that we have that place, because at the moment, all changes are only done in memory. Still, that's good enough. We can see that all these routes work, and we got our initial REST API set up therefore. We have our routes, our place routes at least. We have our place controllers with the logic to get places by ID or by user ID, to create a new place, to update a place by ID, and to delete a place by ID, which is already amazing. Now, with that, we should also implement some user routes. We won't really add authentication right now, but we can still at least add the routes and add some dummy logic to them, so that later in the course, in the authentication module, we can simply add the authentication logic to the already existing routes. So let's do that as a next step. Now actually, before we move on to the user routes, there's one tiny bug I want to fix, or little oversight from my side. In places controller, I have get place by user ID. Now obviously here we can only get one place, because in dummy places I added only one place. If we had more than one place, and that place had a different creator ID, or it had the same creator ID, it wouldn't matter. I would always just get the first place where the creator ID matches. Of course, that's wrong. This here should be called get places by user ID, and instead of a single place, we should be retrieving multiple places here, because every user can have multiple places. There can be more places here that share the same creator ID. It's not a unique one-to-one mapping. We can have multiple places with the same creator ID. So therefore here we want to have get places by user ID, and here we don't want to find, which gives us the first place that matches the criteria. We want to use filter instead, because filter will return a new array full of elements that fulfill this criterion. So full of elements where the creator ID is equal to the extracted user ID. Therefore, let's name this here places and check if we don't have places, or more realistic, if places length is equal to 0 maybe. If that's the case, we didn't find places for that creator ID, and then I want to return cannot find places for the provided user ID. And here, of course, I return places and not a single place. Now we need to adjust it down there on the exports as well. This should be get places by user ID on both sides. And in the routes, in the places routes, of course here, I also want to point at get places by user ID. With that, if we save that, and we go back to Postman and send a request to localhost 5000/API/places/user/u1, which is that one dummy user ID I have here, right? We should get back an array. So if I send this here, it's an array of places now. Of course, with only one place, because we have only one matching place, but that's better than nothing. If I send this for u2, for example, we get back could not find places for the provided user ID, because indeed we have no places for the provided user ID then. So that is now better than before. This is the actual functionality I want to have in get places by user ID. So let's make sure to fix that. We're done with the places with the right orange routes here. We haven't even touched the user routes. So time to change that, and as always, it's also great practice for you. Register all these user routes, make sure that you can get there from inside your root app.js file, and simply add some dummy logic, send back some dummy response in all these routes and their mapped respective middleware. Now, of course, after a short pause, which you have to pause the video to try it on your own, we'll then do it together. So, were you successful? Let's go to users routes.js and let's make sure we set up routing there. For that, we can actually copy the code from places routes and move it in there so that we import and set up the router. But of course, here we will need the users controller, which we require from the users-controllers file in the controllers folder. And we'll have different routes. We will have a get route to /nothing. And that's all what we planned on the slide earlier. And there we will probably have some middleware function, which we haven't created yet. So we'll leave this empty for the moment. We'll not have a second get route, but we'll have two more post routes. One post route, which should be /signup, which will later be triggered when a user sends his sign up data. And one is post login, when a user does not sign up, which means create a new user, but instead tries to log in on an existing user. These are our routes. Now we need the middlewares for that, the middleware functions for that. So here in the users controller, I'll add a new middleware function here, which I'll name get users. And that's a normal function, request response next, and looks like this. Then I have the sign up function, request response next, and I have the login function, request response next, like this. Now all three functions need to be exported, so I'll use that multiple things export I showed you earlier with exports.getUsers, exports.signup, pointing at the signup function, and exports.login, pointing at the login function. Now all these things are exported from the controller, and back in the users routes, we can now reference these exported functions. So here, users controller get users, here users controller dot sign up, and here users controller dot login, pointing at these functions. Now back in the users controller, we can now add some dummy logic. And for the moment, that means I'll also add some dummy users here. Simply again, an array. Here it can be a constant because we'll never replace it with a new array. And there we could add a user. Let's say a user has an ID. A user has a name, Max Schwartz in my case here. Not my full name, but good enough. A user has an email, test@test.com, and a user has a password, which will later, by the way, hash to make it non-plain text. But for the moment, I'll go with a plain text password in our dummy data here. That's it for the moment. Now in get users, I want to return that array of users. So here we can send back a response status code 200, which we therefore actually don't need to set. We can do it, won't be a problem, but we don't have to. We can just send back our response where we have our users, and there I simply send back all my dummy users. Simple as that. So it's a very simple middleware function, of course, but it does what it needs to do. For a sign up, I want to create a new user, so I will extract data from the incoming request body, and the data I get there is the username, the email, and the password. Let's maybe just go with name here, but you can expect any field you want, of course. And then here I'll create my new user, created user. It's a new object. ID can be generated with that UUID package we installed earlier. Let's just make sure we import it here if we want to use it in that file. So const u requires uu/v4. And then we can execute UUID as a function to generate a unique ID. And then name, email, and password are all stored in equally named properties, which is why we can always use this shortcut, which then behind the scenes is expanded to this, which you could also write alternatively, of course. Then I want to add that user to my dummy users. Here with push, we can do that. And then send back a response where the status code is actually 201 because we created new data, and where I then store the created user in a user property of the object, which is added to the response. Now for login, I want to extract data from the body as well. It's a post request, so it will have a body. I expect to get the email and password there. And here, I simply want to search if we have a user with that email in our array. And if we do, if that password is equal to the password we get here. This is not our final authentication logic. We'll refine and harden that in the authentication module, but for the moment it's good enough dummy code. So here I will have my identified user. You can of course name the constant however you want. By going to my dummy users and finding a user where the email property holds a value equal to the email I'm getting in my request body. And if I do find that user, so if identified user is truthy, I can continue, or put in other words, if it's falsy, I want to return an error. So I will import my own HTTP error class by requiring it from the models folder like this. And then we can create an error here and throw it. So throw new HTTP error, could not identify user, credentials seem to be wrong, and the status code here is 401, which means that authentication failed. If we make it past this if check, we know we found a user, but we haven't validated the password yet. So let's check if identified user password is equal to password, which we extract from the body. Or actually, let's grab this and combine it with this check. If we don't find an identified user, or if we do find one, but the password is not equal to the password we got in the body, then we want to return this error. Otherwise, if we make it past this check, we know we do have a valid user, and then I want to return a response where for the moment I will just have a message where I say logged in. Of course, later we'll send back more data than just this text, but for the moment this will do. And I'd say that's good enough dummy code for all user routes. Let's give them a try. To try them, we have to make sure we can actually reach the routes we set up in the user's routes file though. And at the moment this would not be the case, because you must never forget that initially you start your server by executing the app.js file, and only what's set up there will work in the running server. And there I do, for example, register my places routes as middleware. I don't do it for the user's routes, at least not yet. So that's what we have to change. We should add a new import here and import the user's routes by requiring them from the routes folder, user's routes, and then register them as a middleware. So here, right below or right above the places routes, doesn't matter, I'll filter for API/users and forward any requests where the path starts with that to my users' routes. And now we can actually reach these routes. At least that was the hope. We have an error. Cannot find controller users controllers. Yeah, I need to add a S here at the end of my file. That was missing. Now it restarts and it works. And now with that, let's go back to Postman. Let's first of all send a GET request to get all users. So here I'll send a request to localhost 5000/API/users. If I do that, I get my users array here with the one user I got. So that's looking good. Let's now try to sign up. For that, I'll add a post request and I'll send a request to localhost 5000/API/users. Now here we need to attach a body. So let's go to body, raw, JSON, and attach some JSON data. Now to sign up a new user, we need to add a name, an email, and a password, because that is what we're extracting from the incoming request. So here I'll add a name, menu, an email, test2@test.com, and also a password, testing. If we hit send here, let's see if it works. Could not find this route. Yeah, because it should be /signup, of course, not just /users. Yeah, this looks better. Menu was created. Let's now try logging in by sending a request to localhost 5000/API/users/login. Here we also need to add a body, JSON body, of course. And there we just need to provide an email and a password. So first of all, I'll provide a valid combination. Testers. This is the combination for this user. Email is test@test.com. Password is testers. That is what I am providing here. Should be a post request though, not a GET request. And then click send, and I get logged in. Now let's try an invalid combination. For example, an email address which doesn't exist, or the email address test2, which I just created, but where the password is wrong, because here I created testing as a password, not testers. And this also fails. If I enter testing though here, it should succeed, and it does. So now that works. There's just one tweak which we could add. We want to make sure we're not able to create a user, which we already have. So an email address shouldn't be registered more than once. So here in the signup middleware function, I'll actually check if we can find a user with that email address. So has user can be found by using dummy users. And then there I'll find a user where the user email is equal to the email that was attached to the request. And if that is truthy, which it only is if we found a user, then I know we already have such a user. In that case, I want to throw a new HTTP error where I say could not create user, email already exists. And I'll add a status code of 422, which we typically use for invalid user input. So if we now try this, and I try to create a user by sending a request to the signup route, which already exists. So for example, test@test.com is hard-coded. It exists even after a server restart. I get this error. If I try test2@test.com, and remember that the server restarted because of that change, so our previous changes are lost, it therefore works. If I now try it again though, after it worked one time, it of course fails because now this user exists. So this is looking great. We got the dummy user routing and logic in place. And with that, we implemented every route, every API endpoint that's listed here on that slide where we planned our API. Now, therefore, we're almost done. But there's one thing which I really don't like at the moment. And that is that we don't validate incoming data. For example, when we create a new place, we don't check whether we do have a title, whether that's not empty, and so on. And that's something which should change. So user input validation is an important topic. For example, at the moment, I can create a new place and simply leave out the title, share an empty field. And if I send this, it creates a new place with an empty title. I certainly don't want that. I want to validate the data I get on the incoming request and actually send back an error if it doesn't match my expectations. To implement validation, I'll use a third-party library, Express Validator. I'll use that because manually validating it here with if checks, where I check if title, once we trim it, to remove excess white space, if the length is empty, in which case I send back an error. Doing all that is possible, but very cumbersome. I don't want to write dozens of if checks to check different conditions. Instead, this library will make it easier. It's built for Express. It gives us middlewares that we can register to run various validations on the incoming data. You can learn all about this package on this page here, on their official documentation. But of course, here I will also show you some of the most important features. Now, most importantly, we need to install it. So let's stop that running server and run npm install --save, because it is a dependency we need in our code, express-validator, and hit enter, and this will now install this third-party package into your project. And thereafter, you can restart npm start. Now we can add validation, and the first step for that is actually in your routes file, here in places routes. There, I have two routes where I want to validate the input, and that are my post and my patch routes. I don't need to validate these parameters here, because if an invalid ID is passed here, I'm simply not able to identify data, and we're already sending back an error response in that case already. So I only need to care about post and patch here. There, I want to make sure that the data which is in the request body, and that is what it's really all about, I want to validate my request body data, if that is valid. So how does this package work? Well, first of all, we need to import it. We import it, but we import it a bit differently with object destructuring. I require Express Validator here, and I could simply import it all into one object. Validator, for example, that would work. But here, I actually only need one specific method. So I will use object destructuring and import the check method. By the way, we could have done something similar here for Express Router. I could have implemented just router like this and called it like that down there. That would also work, and that's basically what I'm doing here. I'm mixing these syntaxes also to show them both. This is regular JavaScript syntax in the end. So we need the check method here. Now, the check method actually is a method or a function we can execute, and it will return a new middleware configured for our validation requirements. Now, we need it here, for example, on this post request. Now, one thing I haven't taught you thus far is that when you register a middleware like this, you actually always have this filter, this path here as the first argument, but thereafter you're not limited to one middleware. You can register multiple middlewares on the same HTTP method path combination, and they will simply be executed from left to right here in your arguments. So here, I want to add a new middleware, a new parameter, a new argument I pass to this method call, which will be this check function. Now here, we execute it. We don't just point at it. Instead, we execute it, and check then takes the name of the field in your request body which you want to validate. So in my case, for example, the title field. Now it will return a new middleware function which is then registered here and which is then executed by Express. But this middleware function now needs to be configured, you could say. Right now I'm saying I want to check the title, but I'm not saying how I want to check it. Well, I want to ensure that it's not empty. That is my requirement here. For that, we can chain various methods on the result of this check method. For example, the isEmpty method. This overall returns a middleware, which is given to Express, so to say, which checks for title to be empty. Now, I want the opposite. I want that it's not empty. And conveniently, there is a not method you can chain in between. And this reads like plain English in the end, right? We check that the title is not empty. And that overall gives us a new middleware, which is added for post requests that target /API/places/nothing. And it will run before our controller runs. Now, it's not the only check I want to perform, so I will add more middleware. And instead of adding multiple arguments, we can also group that together into an array. We could add multiple arguments, but I want to make it clear that all these middlewares belong together, so to say. They're all related to validation. And I want to check the description here as well. I want to check that description is of a specific length. Now this takes an argument where I configure this with an object I pass to isLength. And there we can set a max length and, interesting for me here, a min length of 5 characters. This automatically means that it must not be empty, but not being empty is not enough. It also needs to have at least 5 characters. I also want to check the address. And for the address, I want to check that it's not empty, because I'm not sure, maybe we do have a valid address that's only 1 character long, so it should just not be empty. Now, I will not validate the coordinates, because later we will not get them from the client anyways. Instead, later I will add a function here on the server where I reach out to a Google API and translate the address which I get to coordinates, and if that fails, I throw an error here on the server. We'll do this a little bit later, so for the moment, let's just focus on this validation here. Now that's the validation for creating a new place. If we now save that, we can give it a try. Let's try create a new place where the title is empty. It still works. So what did we do wrong? Well, actually, Express Validator consists of 2 parts. You register this middleware, but this alone does not return an error. Instead, now you have to go to your controller, so to the middleware function which is executed upon your incoming request, and then there you need to add something as well. You need to import something from that Express Validator package, and again, I will use object destructuring to import just what I need. Here we need the validation result function. Then in the middleware functions, which are triggered upon your routes that have validation added to them, right at the beginning, you can call validation result as a function and pass the request object to it. And now what this function will do is it will look into this request object and see if there are any validation errors which were detected based on your setup here. So this will return you an errors object, so to say. Now this object has a method isEmpty, which you can call. And if this is not true, we know it's not empty, which means we do have errors. And in this case, we can throw a new HTTP error where we say invalid inputs passed, please check your data, and add a status code of 422. Now, actually, this errors object has a bit more data, which is why I'll log it here. And you could also attach this to a response. You could send a response here with a status code of 422. And, for example, not just add your message, but also more details about the errors if you wanted to. Here, I'll go with the default error handling and just send this generic response message here. So with that, if we now save this and we try creating this again, now it fails. We get this error and the 422 error code. And indeed here now in the console, we see some output. We see we have this errors object, and in there we have detailed information about the errors. We see that for the title field, we had an invalid value. Now you can configure this in more detail if you wanted to, and the official docs of Express Validator are the place to go to learn how to add your own error messages and so on. So that's something you can do. I'm happy with this basic validation we have here, but of course I also want to add it to this patch request. And that is a great challenge for you, not just for the patch request, but also for the user routes. And there, think about which routes really need validation, and then come up with some validation rules that make sense to you. Also have a look at the official documentation here to find out how you can validate. And in the next lecture, we'll implement all these validation steps together. So let's start by adding validation to our patch route in the places routes file. There, I'll add the second middleware, which is actually an array of middlewares. And again, we can check the incoming data here. Now, when we update a place, there are two pieces of information which we're extracting, title and description. So I want to validate these two pieces. I want to check the title field here, and check that it's not empty. So the same criteria I had up there. Well, and for the description, I also want to have the same. So I will check that we have a min length of 5 characters. And now with that, let's go to the places controller. And actually, we can now copy that logic which we got in create place. We can simply copy that over to update place, so that we first check if we do have validation errors. And if we do, I send back my error response. If we don't, I continue with my normal updating logic here. So with that, let's give it a try. Let's try running this patch request with an empty string for title, and this fails. Now let's enter something valid here, but have a description which is too short, and it fails. And you also see that it does not just fail, it really also doesn't apply any of the updates, of course. Now if I do enter a valid description, however, this succeeds, and therefore if I get that single place, we see that updated data here as well. Now that's the validation for the other places route. Now for the user routes, I also want to validate. So first of all, let's import the check method here in the places routes file. And now the question is, where do we need validation? The obvious answer is these two routes, right? These two post routes. But actually, I would argue that we only need to validate on the signup route. Why? Because when the user logs in, we're searching for a user with that email, and thereafter we're comparing passwords. So if invalid data was entered there, the login will fail anyways. So there isn't really a need to validate it before we run our logic. Hence, I will only add validation here on the signup route. And there I want to check the name of the user and make sure that it's not empty. I'll not require a minimum length because, well, we have very short names in the world as well, right? Just as we have very long ones. So I certainly don't want to check for any minimum or maximum length. Just not being empty would be a great thing. I also want to check the email, and there I will validate something else. I don't care whether it's empty or not. I want to make sure it's a valid email address. And for that, we have the normalize email method, which, for example, makes sure that test@test.com is converted to test@test.com. And thereafter, after normalize email, I also want to call isEmail. And this now validates that this really is a valid email address after being normalized. And last but not least, the password the user chose also has to be checked. Here I want to check that it has a min length of 6 characters for security reasons. Now, just as before, this is one half of the validation logic. We also need to copy this here, where we check for validation errors, into our signup middleware. And that means we need to import the validation result function. So here I will use object destructuring to get validation result out of the object I import from Express Validator. And then down there we send back our error response if we couldn't validate the input data. Now with that, back to Postman, and let's try to sign up with an empty name. Invalid inputs passed. Let's try to sign up with a valid name, but an invalid email address. I deleted the @ symbol. Does not work. Let's try to sign up with a password, which is too short. Does not work. And let's enter validator everywhere, and this works. And now for a login, if I, for example, leave the email field empty, we simply couldn't identify a user, and that's totally fine. We need no extra validation there. So this all is looking good. We added validation. I noticed there is one place where we can add some extra logical step, and that is for a delete place. I want to check if we have a place before we try to delete it. So I'll check if dummy places find finds a place where the ID is equal to the place ID we're trying to get rid of. And if that is not the case, if this is falsy, then I actually want to throw a new HTTP error where I want to say could not find a place for that ID, and hence not return this deleted place message. That's just a little bonus which I want to add to ensure that when we do delete a place, it works if we do have the ID, but we get back could not find a place if we don't have the ID or don't have a place with that ID, instead of always returning deleted place. With that, validation was added, and now the only missing piece, which I still want to implement here, is that when we create a place, I don't want to assume that we get the coordinates from the client, but instead my assumption here is that we get the address, and we then translate that to coordinates by actually working together with another REST API, which we won't write on our own, but which instead already exists. A REST API created by Google, which helps us, well, convert addresses to coordinates. To convert an address to coordinates, Google has a nice API. You can search for Google Geocoding API, and below the ads, you should find this API here. That's the documentation of the API, and you can, of course, check that out to learn all about that API. In the end, what we want to do is we want to do a geocoding request here on the right. We want to search for an address and get back coordinates. Now, to be able to send a request there, we need an API key. That's not something we need on our API we build, but a lot of API which are exposed to the public, which is not the idea of our API, a lot of APIs which are exposed to the public require API keys so that they can kind of keep track of the users working with their API. Now, to create such an API key, we first of all need a Google account. So let's sign in. By the way, in case you can't create a Google account or you can't set up billing with a credit card, which you will also need, unfortunately, to work with the Google APIs, you can just write some dummy code that simply translates every address into the same pair of coordinates so that you can follow along in the course just fine. I will show this in the next minutes as well. So now I did log in with my account, and I can now click on Get Started here at the top, and you'll be forwarded to a page where you can pick the products you want to work with. Now there, we only need places, but it also doesn't hurt to choose maps if you decide to also use Google Maps on your front end with one of their SDKs, like the JavaScript SDK they are exposing. But places is the thing we absolutely need right now. So you can click continue, then select a project or simply create a new project, which is what I'll do here. Course, project, you can of course pick a more meaningful name. Click next and now wait for this to finish. Now you might be prompted to set up a billing account and add a credit card. What we do here is free though. You can search for Google Maps pricing to find detailed information about their pricing, and you will see that you have a $200 free usage every month for their APIs, and that will get you very far. You'll find examples down there, you see what this costs and so on. So what we do with the frequency and volume we use in the course will be free, but of course check this in case you're working with Google Maps or any Google API in a real application. So here I will confirm that I want to use this account for billing. And again, if you can't set up billing, you can't continue here, but I will show you some dummy fallback code in just a second. Here I will just confirm that I will enable all APIs, and then this will load a bit more. And I get my API key. By the way, no need in copying mine. By the time you're watching this, I will already have invalidated my key, of course. Now this key is something you should copy or just leave this window open for now, because we will need it. Now I will add a new folder to the Node application, which I'll name util for utility. You can of course name the folder how you want. And then there I'll add a location.js file. In there I'll add an API key constant, all caps to make it clear that this is like a global constant I will use in this file. And this is the API key I got here by Google. Now, with that, we can write a function here in that file, which takes an address, reaches out to Google's API and converts this address to coordinates. Now, if you can't set up billing and you therefore don't have an API key, here's a dummy function you can use. Get coords for address. And by the way, of course, it does not matter if you create a function like this in the declaration form, or if you do get coords for address and use an arrow function, for example, you can use either notation. Here, to mix things up, I'll use this declaration form, and I expect to get my address here as an argument. Now, if you have no API key, if you can't set up billing, you have no credit card, you can simply return coordinates here. Coordinates, where we have a latitude, and there I will use the dummy latitude I have in the places controller. So essentially I will use this object here to be precise. I will return this object here. There now. That's my dummy. However, actually, in the real function, which we'll write in a second, we'll make a HTTP request, which will be an asynchronous task in which therefore will work with promises. So we'll turn this function into an async function by using the async keyword in front of it. Async await is a functionality built into modern JavaScript. It in the end makes sure that this function, or the return value of that function, gets wrapped into a promise. And it makes sure that when you're working with promises in there, you can use await in front of the promise to wait for its response instead of promise then. And if this all doesn't tell you anything, attached you find more resources on promises and async await. Since it's JavaScript, I assume that this knowledge is there here, or that you're picking it up side by side with this course. And therefore now what we have here, and that's the main takeaway, is a function which will return the coordinates, but wrapped in a promise. So not immediately, not synchronously, but asynchronously through that promise. But returning this here is the fallback anyways, so only required if you have no credit card. Otherwise, now we'll write the code which will send a request to Google's API and get us the coordinates for a given address. Now, to send a request from inside a Node app, we have some built-in core modules that help us with that, but it's a bit cumbersome to use them, to be honest. So I will use a third-party package here, which I install with npm install -- save, and that's the Axios package. Now, if you have some JavaScript and especially some front-end JavaScript experience, you might already know this package. It's a very popular package for sending HTTP requests from front-end applications to backends. Now, not known by everyone is that this package can also be used on a Node server to send a request from there. And that's exactly what I'll do here. So I'll install Axios, and it will allow me to send a request from my Node server to yet another server, so to yet another backend. So let's run this here with npm start. And then here I will import Axios by requiring Axios like this. Now here, I can send a GET request to a URL. And now the question is, which URL? Well, we get that from the Google Docs. Again, search for Google Geocoding API to get back to their docs. And there it was this geocoding request. Here you can simply copy this URL here and go back to your code. Now I will use backticks here to create a template literal, another default JavaScript feature, which allows me to create a string where I can easily inject dynamic segments. Because here, this address, this dummy address, should be replaced. So mark all that address, so everything after that equal sign in front of that ampersand symbol, and then add a $sign and opening and closing curly brace. That's the syntax for injecting a dynamic value into a string or into a template literal. Now, that is the address we're getting as an argument, but we need to convert that to get rid of special character or white space with the help of a global function available in JavaScript in Node.js, and that's the encode URI component function. Simply pass your string to it, so the address string, and it will give you back a string which encodes everything into a URL-friendly format. Now, we also need to inject our API key here, and that's, of course, the global API key constant we created. Now this sends a GET request to this URL, and it should return us the coordinates for that given address. So here I get my response by awaiting. That is available because I added async here for the response. It's the same as if I would have called then here and then added my response handling function here. It's just a bit easier to read, which is why I use it. And then there we can get the data out of the response. Access gives us a data field on the response object that holds our data. And now I first of all want to check if data is not set, or, and that's special for the Google API, you can read all about that here in their docs, if there is a status field, data.status, which is equal or which holds a value of 0 results, written like this. Google will give us this field with this text if no coordinates were found for the specified address. And this will handle the scenario that the user entered a valid address when it comes to our validation, so that it was a non-empty field, but an address which simply can't be found. Well, in that case, we'll get back this response by Google. If we do get back that response, I'll create a new error, a new HTTP error, and therefore I will import my own HTTP error class here from the models folder. A new HTTP error where the message is could not find location for the specified address. 422 could be a status code we set here because it probably happened because of an invalid user input, but you could also go for 404, it's up to you. And I then want to throw that error here. Now, if we throw an error here in the async function, the promise that is automatically created and wraps everything in the function will basically also throw that error. If we make it past this if check, we know we have no error. So then I want to extract my coordinates, and I get that from data.results. And you can read more about the structure of the response you get from Google here in their docs. So the coordinates can be found in data results. There, the first element, because this turns out to be an array, but the first element is the one that best matches the given address. There, geometry, and then location. And this will be an object which looks like this here. So this is the location object. So it has this let and lng key with number values in it, which we need. And here I will then return the coordinates. So that will then also return a coordinates object, just as we did it before with the dummy code in case you don't have an API key. And with that, we just have to make sure we export this function so that we can use it. So we can use module exports and set this equal to get coords for address. Of course, not executing it, just pointing at it so that we can execute it from inside our files. Specifically, the place controller. There, I want to use this now. So here I'll have get coords from address, which I will require from the util folder, and there the location file. And now we need to call this when we create a place to translate our address to coordinates. For that, I will convert my createPlace function here to an async function as well by adding the async keyword in front of the argument list, simply so that we can use the await keyword in here and work with promises in a more elegant way. Now, since I did this, however, we should also not throw errors anymore, but call next here instead, because when working with async code, throw will not work correctly in Express. So you always need to next your errors now. With that, I still do my validation first. And once I extracted the address, it's time to convert the address to coordinates. So here we can call get coords for address and pass in the address. This returns a promise, so we can await it and get our coordinates here. Now, this might fail. It might throw an error, right? I'm throwing an error in there. And if we want to handle an error when using async await, we have to wrap this into a try catch block. That's also vanilla JavaScript. So I will actually create a coordinates variable here and assign a value to it inside of try catch, so that coordinates is not just scoped to the try block. And then here we might catch an error if that fails. If we do catch an error, I simply want to next it. I want to forward it. I also want to return so that no other code thereafter runs. Since we catch the error, we don't quit the function execution automatically, so we have to quit it by calling return. Otherwise, if we don't make it into catch, so if we do get coordinates, coordinates will be populated with our coordinates. That also means that I no longer expect them here on my incoming request. Instead, I get them here when we convert the address to coordinates. Therefore, we will still have coordinates down there if we make it thus far, and everything in general down there can stay the way it is. Let's now give this a try. Save everything, and let's see whether it works. So here I'll try to create a new place. I no longer need to provide my coordinates here. I will create my title here, New York Stock Exchange, so that this is all valid, and hit send. And I got an unexpected token error here because of that extra trailing comma, which I forgot to delete. Make sure you do, and then send it again. And this is looking good. We got the location here, and since I'm not passing coordinates here, these have to be the coordinates inferred by Google. Let's also try a different place here by entering a different address. For example, the Marienplatz in Munich. You could enter anything here. Google will translate and look it up. That's really good. So here we have the Marienplatz, a place you probably have to visit when you are in Munich. And let's look that up. Keep the old coordinates in mind. We should get different ones now. And we do. So that's really looking great. We got that up and running. We also got no errors here on the server side. And therefore now we're even sending a request from our backend to another API, which already gives us an idea of how we could communicate with our own API later. And we're doing this to convert an address to coordinates. And with that, I'd say we have a pretty nice dummy REST API already, a NodeExpress application which gives us exactly the API we planned. And the biggest thing that is missing right now, of course, is the database access, which we'll add in an extra module. Now, one thing I just noticed, here, of course, we should return now, because I'm no longer throwing an error, so function execution would not stop otherwise, hence we have to return now to make sure we don't execute any other code thereafter. We didn't need to do that before when we threw an error, because when we throw, function execution automatically stops. If we just next it, it does not stop automatically, so we have to return it. And that's it for this module. We built our first little REST API with Node and Express. We added our middleware functions here as controllers in this separate file, and we're mapping this to incoming requests here in the routes file, where we listen for different HTTP methods and different paths, and then execute different middleware functions. You learned how to add validation, how to set up your rules, and how to then work with validation errors and possibly send back errors. We created our own error model for that, and we're using the default Express.js error handling middleware to send back a standard uniform error message if something goes wrong. In general, you learned how to work with Express and Node, and how to work with that middleware concept of Express, how to parse request data, and also, of course, how to map your different routes to different filters here. That really is a lot of new things, or a lot of useful things, and that is what makes up any REST API you build. Now, of course, there are missing pieces. We're not talking to a database yet. That will happen later. And we don't have a real user authentication flow. We're just doing some dummy authentication here. Now, of course, that will all be added, but we're done with the first step towards a real REST API, and therefore we can now move on to the next steps.
Welcome to this optional module. In this module, we will refresh our knowledge on MongoDB and Mongoose. So if you have some prior experience on these technologies, you might want to skip this module, but in case you're totally new to MongoDB and Mongoose, or if you want to refresh your knowledge, this module contains all the required information. Now, MongoDB is a database, and we can connect MongoDB to our backend, in our case the NodeExpress backend, and store information in this database. Mongoose will help us to easily manage the connection between the backend and the database. We'll dive into that, of course, throughout this module. Now, what's in this module now? Well, in this module, we'll learn what MongoDB is. We'll set up a so-called MongoDB cluster, the MongoDB server in the end, and we'll set up a simple Node and Express app and see how we can then interact between our backend and this MongoDB database. We'll then have a look at Mongoose, and we will understand what Mongoose models are. Mongoose models help us to define a structure for information stored in the MongoDB database. This is what we will dive into here. And finally, we will see how we can create and access documents stored in our database with Mongoose. That's what's inside this module, so let's get started. And let's get started with, well, a very important question. What is MongoDB actually? Well, MongoDB is a NoSQL database which stores documents in so-called collections. Now, if you're coming from a SQL world, and as a developer, chances are that this is the case, you might refer to documents as records and collections as tables. Now, with MongoDB being a database, we use it to store application data. In our course project, this would be users and places. And storing this data doesn't enforce a specific data schema or any relations. We can define a data schema, but it's not really strict. And we can also have relations. We'll also do this throughout this module. But in contrast to a SQL database where relations play a core role, this is not the case for NoSQL databases like MongoDB. And MongoDB can also be easily connected to Node and Express. But very important, we can connect MongoDB to our backend. Therefore, we do not connect it directly to our front end. More about that in a few minutes. So to summarize that, MongoDB is a powerful database and it can be easily integrated into a Node Express environment, so the environment we are using here in this course. One important note though, you can of course also use other databases, SQL databases for example. And this brings us to the next question. What is the difference between a NoSQL and a SQL database, and why are we using a NoSQL database here? So NoSQL versus SQL, what are the differences and when should you use which one? So we got NoSQL, we got SQL, and examples for NoSQL databases would be of course MongoDB, which is what we are using in this course, or CouchDB. And for SQL we could name MySQL or Microsoft SQL, just to give you some examples here. Now, NoSQL databases do not enforce a strict data schema. We talked about collections and documents already, so tables and records in a SQL database. And collections can contain documents with different schemas. So you could have a basic schema for your documents you have, but then for newer documents, you could change the schema and add an additional property to it, for example. This is possible with NoSQL databases, and this also makes it very flexible. For SQL databases, we enforce a strict data schema. So if you define the tables and the corresponding records, well, you normally don't deviate from that structure, or deviating from that structure later would be a bit more difficult. Therefore, you should create your data schema, and this is what you stick to in a SQL database. For NoSQL databases, we also have less focus on relations. A relation would be something that if you have a document with the users and a document with the places, then the users document could contain the place ID to refer to this place, so to establish a connection. Now we can also do this in NoSQL, and we will do it throughout this course, but generally the core focus of NoSQL is again less strict and less focused onto such relations, again to make this whole storing and querying data structure a bit more flexible, you could say. For SQL, well, relations are a core feature. You typically have one table with the users and one table with the corresponding products, and then you need a relation to kind of know which user bought which products. And to summarize these points so far, we can actually say that NoSQL works with independent documents, so the documents are not necessarily related to each other. For SQL databases, well, the records are related. That's again one of the core concepts behind the SQL database actually. These are some differences, but when should you use which database now? Well, NoSQL databases are great for logs, orders, or some chats or messages. So generally, whenever you have a high frequency of incoming information that should be stored or requested. Because NoSQL databases are really fast and you can create your own queries quite easily. Therefore, these are typical application areas for NoSQL databases. SQL databases are rather used for shopping carts, contracts, or generally bigger social networks. So these kind of applications. Now talking about these differences and these recommendations, this is not a hard restriction here. These are some general guidelines you can follow, but you can always deviate from that depending on the application that you want to build. It can also happen that you have both types of databases inside your application. So one specific area of your application interacts with a NoSQL database, the other one with a SQL database. That's not too unusual, actually. In this course, we use MongoDB as the MERN Stack is a, well, quite cool combination of different technologies. And it's a lot of fun working with MongoDB and Mongoose later. It allows us to quickly query data and to really interact in a nice and efficient way with the database. But as I said, this is no hard differentiation here, but this is a MERN Stack course, therefore we will use MongoDB here. So that's the differentiation between NoSQL and SQL. And before we then set up MongoDB now, there is one last thing we have to cover. Because actually, if you have a front end, we could actually directly connect this front end to our database. Well, that would be a really bad idea. Let me tell you why. So connecting React or frontend in general to the database, is that a good idea? Let me tell you why this is not the case. Because actually you could say, well, I got my front end with React in our case, and I got my database on our database server, and now I want to do something with the database. I want to store data or fetch data. And technically, this would be possible, but the question is that something you should do? And the answer is no, you shouldn't, because this is a highly insecure approach, because secure authentication is not really possible if you directly connect your frontend to the database. Because to interact with the database, we need to provide credentials, right? Otherwise, we cannot use the database. And we could provide these credentials as part of our front-end code. The problem is that our front-end code is running in the browser, and therefore anybody can access it in the end. So with that, we would expose our credentials, and therefore definitely not what we want. And this would also expose our full database, so people could do more with a database than they're actually supposed to do. Therefore, connecting React to the database is nothing you should do here. Therefore, we will connect React to our backend, to our NodeExpress backend. React will then send the requests to this backend, and then the backend will process the information and establish the connection to the MongoDB server. And this is a secure approach because here our credentials will not be exposed, and therefore we can provide a secure authentication. So that's why we connect NodeExpress to MongoDB here, because that's a typical approach how you will use it in a real-world MERN application. So with that, we know what MongoDB is, why we use it, and why we connect it not to the React app, but to our backend, to our NodeExpress backend. Therefore, let's now have a look at MongoDB and set it up. Enough of the theory, let's get started with MongoDB now. And a good place to get started is here, mongodb.com. Here you have two options to work with MongoDB. One option would be to go to Software and then select the Community Server. This would allow you to download MongoDB locally to your machine if you click onto this option here. Then you should select the community server, select your operating system, macOS in my case, and then you can simply download it by clicking onto this button. This is one option, so to install it on your machine. We'll use a different solution though, and you can find this solution actually right here if you go to Get Started for free, or you can go to Cloud and Atlas. MongoDB Atlas is a fully managed cloud service hosting your MongoDB database. And the great thing is that the basic version of it can be used for free. And this version is totally sufficient for the purpose of this course. For larger scale applications, you might have to select the paid version though, but well, that's of course depending on the application type you want to use. But for the course, this is perfect. So what you can do then is you can click right here on Start Free. And now you should enter your email, first name, last name, and the password, and then you can click right here to, well, sign into MongoDB Atlas, or as I do have an account already, I'll simply select login right here or sign in right there. So you have plenty of options actually. And then you should see this starting screen right here. You can create new projects in this menu. I'm here in this refresher project, but if you start MongoDB Atlas the first time, this is what you can see here. And the first thing you have to do is you have to create a so-called cluster. The cluster is basically your server in the cloud running your MongoDB database. It's called a cluster because it could contain multiple servers to allow horizontal scaling, but this is not part of the free version and also not required for the course. Therefore, we can click Build a Cluster. Now select the Starter Cluster. You can see here it's for free. That's the important thing. You don't have some more advanced options, but I guess it's totally fine. So click on to create a cluster here. And now you can select the cloud provider. We'll go with AWS here. And then you only have to select, well, all services with the free tier available hint here. So we will use the server in North America, North Virginia. You can select the cluster tier, but also important here, free forever. That doesn't sound too bad, I would say. We don't need a backup, so this is also fine, and you can define a cluster name. We'll stick to cluster 0 here, and then we can click Create Cluster. And with that, we are done with the first step. As you can see, this might take a few minutes, but then this cluster is created, and with that, we can run our MongoDB database. There are two more things we have to do though, because at the moment we only have this server, but we need to access it. And to get access to the server, we need to work on the security settings. You can find these settings right here in the left part of the screen. And let's first go to network access here. Here you have to whitelist an IP address. This means you have to specify which machine, which computer, or which server in the end is allowed to interact with the database. Here I'm working with a local development environment, therefore I have to add my IP address right here. You have to add your IP address, of course. So click on to add IP address, and now you can simply select add current IP address. You can also allow access from anywhere, but that's not what I want here. I'll stick to my current IP address, and very important, the IP address might change from time to time, therefore in case you don't have data access after a while, make sure to check your IP address again and to update this IP whitelist here. So now you can confirm this. And also very important, as I said at the moment, this IP address is the IP from my local machine. Once you deploy an application to a real server in the internet, you should provide the IP of this server, of course. Important is always that the interaction between your backend and the database is set up correctly. This can take a while, but now my network access is active, so my machine can interact with the database, but there is another thing we have to configure, and this is the database access, meaning that we need to create a user with corresponding user credentials, which is then allowed to access the database. So we go to database access, and now create a new user here. For the authentication, we'll use password, and you should select a user with either the admin privileges or, in our case, read and write to any database is also sufficient. So we'll go with this one. Let's give the user name and menu. So this is my name. And you can now either manually create a password or auto-generate a secure password. I can show you this one right here. Of course, these credentials are no longer valid at the time when you're watching this course, so it doesn't make sense to copy-paste these. And now we can hit add user. And with that, we are actually done. It just takes a few more seconds. As you can see, some changes are still deployed. But if we go back to our cluster, yeah, as you can see, it still takes a few seconds. So let's wait until this process is finished. And now it's done. So with that, we have a working MongoDB cluster with the right access and a configured user. What's missing now, of course, is, well, a backend which allows us to interact with that database. This will also help us to understand this cluster, database, collections, and document structure I was referring to earlier in this module. Therefore, in the next lecture, it's time to set up a really basic backend, which will then allow us to connect with this database. So MongoDB is set up. Now it's time to make sure we can interact with this database. For that, attached to this lecture, you can find this code. Make sure to download it and run npm install. And as you can see, it's a really basic Node Express application, you could say. If we run npm start, we again got a development server. I'll quit this process now as we don't need it for the moment. And as we can see, we want to send a post request here to /products or a get request also to /products. So in the end, we want to make sure that if we send a post request that a new product is stored in our database, or if we send a get request that we get all the products stored in our database. In the MongoDB terminology, this would mean we want to store a document, so each product would be a document in our collection with post, and get would mean simply give me all the documents stored in a specific collection. We'll dive deeper into that throughout this module. Now the idea is that the MongoDB logic, so the logic related to the connection to MongoDB, is outsourced to a separate file. We'll create this file soon, and that we then simply refer to this file here as part of our methods as a separate argument. Therefore, let's get started with creating this file, and we can simply name this MongoJS maybe. And what I want to do in this file, or the logic I need in this file, is actually quite straightforward. First, I want to create a constant here, which could be called create product. This would be the constant related to our post request that we send to our server. And this will be an asynchronous task. I can tell you this already, because if you're working with databases here, these tasks, for example, storing new data or fetching data, can take a moment. Therefore, these are always asynchronous operations here. So we'll add async, and we have a request, a response and next. And we will have a second constant. This will be our, well, maybe get products. Again, an asynchronous task here. Then we're going to need this logic in here in our app.js file, as I said, for the post and get request as an argument. Therefore, we can already export our functions with exports.createProduct being equal to createProduct, and with exports.getProducts equal to getProducts. So now we'll be able to reference these functions from inside other files. I'll come back to app.js soon though, so let's focus onto the MongoJS file now. And if we now focus onto our logic, maybe for create product here, then we need the code to create the product, so the core logic. But before we do so, we need to establish a connection to MongoDB. And to do that, we first need to install it. Therefore, let's run npm install --save MongoDB. So we now installed MongoDB, and in case you're wondering how I knew this command, if you go to the official docs now, a link is attached to this lecture, you can select the specific driver you're using MongoDB with. So you could also use it with Python, for example, or Java. We are using Node.js here, so you can select Node.js. And if you now go to installation, you can see the command to install MongoDB is this one right here. Just to be precise at this stage, just to avoid confusion, you don't install the database, of course, you only install the driver. So an SDK which allows you to interact with the database. The next thing we need is we need to use the so-called Mongo client. The Mongo client will simply help us to create a new Mongo client instance in the end. So basically to make sure we can connect to a specific server. This means we have to import it. So we create another constant named Mongo client, which is equal to require MongoDB. And very important, we refer to the Mongo client class right here. What we need next though is we need to specify which MongoDB server we want to connect to. And for that we have to go back to MongoDB Atlas. And here we are now in our cluster that we created. We can select connect. And here we have different methods to connect to our MongoDB server. In our case, we want to connect through our application. So we click here. Our driver version is Node.js 3.0 and later. This is fine. And here we can now see our connection string. And we have to copy this string. And now we can create a new constant named URL. And here we now simply copy paste this connection string. In this string, you see you have three interesting fields though. The first one is this menu. That's the name of the user I just created. Then we have to provide the password. And then we have this test part right here. Well, the password is quite straightforward, I would say. This is just the password that we created when we created the new user. This was this menu user here. Here I just paste the password I created previously. And the last step in our connection string is this part right here, this test. This is the default name for the so-called database. So we have the database which contains the collection, which then contain the single documents, in our case the single places. And we can give this a new name, maybe places test. Not the most creative name, but I guess it's fine for our purposes. With that, we now added the Mongo client and have our URL. So theoretically, we would be able to interact with our database now. What's missing though, of course, is the logic to create the product. Let's continue with this now. So to create a new product here, we have to, well, define it. We have a new JavaScript object right here. So in this object, I'll create a new constant named new product maybe. This constant will hold an object which represents the product we want to create and store in the database. And in this constant, we now have to provide the structure of a new product. Now, a product could typically have two properties, a name and a price, for example. So the name would be our request body, right? And here, the name property. Second part, our price, would be the same, would be our request body. And here we want to get the price of our products. By the way, we should also name our database accordingly. So this should be products, not places test. Places is what we use in our course project, therefore the confusion here. So now we created a new JavaScript object that represents a new product. Now we need to get this into our MongoDB database. This is the next thing we have to add here, and for that I'll use a new constant named client maybe. Here we use a new instance of our Mongo client that we previously created, and the Mongo client now needs information regarding the server we want to establish the connection to. And for us, this is our URL, so we can add this constant right here. Very important note though, this part right here does not establish the connection. We'll do that in a few seconds. This code just tells MongoDB and the Mongo client which server we want to connect to, but initiating the connection is not taking place at this stage of the code. Because this is what we will add right now, and for that we'll add a try-catch block. Why try-catch? Well, because connecting to the server can fail or creating the product can also fail. Therefore, we want to make sure in case any of these things go wrong, then we catch this error and we stop the code execution. For that, let's quickly add the catch code block here in the error case. And if we have an error we want to return, that's important, you have to add return here, otherwise the code execution won't stop at this point and we want it to stop. So we want to return a response in JSON format, and the response should contain a message stating that we could not store data. So that's the error case, but actually we want to make sure that our connection is established, and we can use our client that we defined right here because the client knows that we want to target a specific server, a specific URL. And for that, we have an asynchronous task because connecting to the server is a task that can take a few moments. Therefore, we have an asynchronous operation right here. And now we want to refer to our client and here to the connect method. This now will finally establish the connection to our MongoDB server. With the connection being established, we have to continue with what? Well, now we want to access a specific database on that server. For that, we can create another constant, maybe name it DB for database. And we again refer to our client, but here to the DB method now. And here we can either provide an argument or not. If we don't provide an argument, as we do it right here, DB will take the connection string, so the URL that is provided up here in our URL constant. We could also provide an argument, then DB would take this database. Now we got access to the database, and what we want to do right now is we actually want to, access a collection in that database, and inside this collection, we then want to create a new product. Here we could now use a new constant, result in this case, and our result should now be added to our database, and here to a new collection, right? The collection is what contains all our different documents, and in the collection, you now have to provide the name of the collection as an argument. In case a collection with the name you provide is not existing, the collection will be created automatically by MongoDB. In case the collection is existing, well, then the document will be added to this existing collection. In our case, I will name the collection products here. And now, inside this collection, we want to insert one. As you can see, we have different insert methods, also many, but in our case, we want to insert one single new document, one single new product, and this new product we want to insert is our new product right here. With that, we almost have a working code right here. So we opened the connection, got database access, got access to the collection, and created a new document, and we catch any errors. What's missing now here is the closing of our connection, because if you open a connection, it will remain open until you manually close it. And that's not necessarily what you want, because having opened hundreds of connections is not very efficient and also not the way you should interact with your database. Therefore, after each creation of a new product, we should make sure that our current connection is closed. Therefore, we again refer to our client and now to the close method. With that, the connection is closed. And we also should send a response here. So we refer to our response and refer to the JSON method. And here I want to send back our newly created product. So this would be our basic syntax here. What is missing now, of course, is the connection to our app.js file. Because at the moment, the MongoJS file is not related. So we should make sure that once we enter our post path with /products, well, then our MongoJS code should be executed, and therefore we should be able to create a new product. To do so, we need to import the file here. For that, let's create a new constant, and let's maybe call it Mongo practice right here. And here we require our file. This is located in /mongo. No need to add the file extension right here. And now we can add Mongo practice as an argument for the post method. And here we have to refer to create product because that's what we want to do right here. We want to create a new product. So this was a lot of work. Let's now start our development server with npm start. And now go to Postman and create a new post request targeting localhost 3000/products. And we want to create a new product. Therefore, we have to provide the body, raw, and the JSON format here. And our body must contain a name. The name is maybe Apple here. And the price may be 99 cents right here. So let's see if we now send this request. Yeah, we see we get back the name, the price, and the ID. This was automatically added by MongoDB. That's a default feature in the end. We will have a look at the ID, what it is, and how it works towards the end of this module. So for the moment, you can't just ignore it. And if we now go to our database, here to our cluster, right, and then to collections, we can see the products test database now. This database was created due to the fact that we named it products test, and we get the products collection. That's the collection name that we defined. And inside this collection, we now got our first document, the Apple for 0.99. So this is working fine now. With that, we are now able to create new products in our MongoDB database. The next step now is to work on getting the products. So creating products works fine. So we have this part of our application, but now we want to make sure that if we send a GET request, we can display all the products stored in a collection and therefore displaying all documents. To do so, we go back to our MongoJS file. Here we now work on GET products, and the core syntax will be pretty similar to the one we see up here for our create product logic. Nevertheless, I'll create it from scratch once again, just for practicing reasons. We don't have to specify a structure for the product, obviously, because we want to get the product. Therefore, we again have to create our new client constant, which again will instantiate a new Mongo client class. And don't forget to provide the URL, otherwise the client doesn't know which server we want to connect to. So that's as we did it before up here actually. So we are now at this part. Now I will again add a try catch block here, because as for creating documents, also when getting documents from the server, well, things go wrong. Therefore, we want to make sure we have a proper error handling here. So the catch block is actually almost the same as we had it before. In the error case, I want to return, again to interrupt the code execution, a response with the JSON method, and this should be a message, maybe could not retrieve products. And in the try block, we can follow the same logic. This means we first want to establish the connection to our MongoDB server, an asynchronous task again. So we refer to our client and the connect method. Then we want to get access to a specific database. So we create a new constant DB again. And we again use our client and now the DB method without providing the database name, as we added the database name in our URL up here. So that's again this part. And now we don't want to store a new product. Now we want to get access to the existing products. For that, I'll create a new constant here, which could be named products. And again, we have an asynchronous task. Therefore, let's add a wait. And now we want to refer to the database in there to a collection. Now the collection name has to be the same that we used up here, because now I want to refer to documents stored in this collection. Therefore, we refer to our products collection. And now, what do I want to do? Well, I don't want to insert one, but I want to find a document, so we can simply use the find method. And by default, the find method in MongoDB returns a so-called cursor. A cursor is basically a pointer to the results of the query, and you can then iterate through the cursor to see all the results. We don't want such a cursor right here. We actually want to display all the documents immediately. And to achieve that, we can simply add the toArray method This will allow us to get the documents in an array. You can also configure find to have a filter or to only return some fields of the identified products. But here we don't need either of that. Later in the course you will see examples for filtering though. And that's it almost. As before, we have to make sure that once we open a connection, we also close it. Therefore, we again use client close here. And finally, I need a response, and the response should be again of type JSON. And I want to refer to our products. Here we have the constant here. So due to block scoping, we should add a variable, products variable, and now remove the constant. With that, we can use it down here, and we want to get the products as a response. By saving this, we are done in the MongoJS file, but we have to make sure that we also add our getProducts function in our app.js file, this time as a second argument here in the get method. For that, we add mongopractice.getProducts here. Again, don't forget to save this. And let's now go to Postman and create a second request, this time a get request. Also to localhost 3000/products. And now if we hit send, yeah, we get back our product. So this seems to work. Let's now also create a second product maybe to see if we also retrieve multiple products. Let's say we have a banana, maybe for 1.19. And let's create this product. This worked fine. And if we now send another get request, we should see that we get both the apple and the banana. Yeah, perfect. This is great. Let's now have a look at our database and reload it once again. And we also have both our documents in our products collection, first document and the second document with the banana. So this is how we can create documents in MongoDB and how we can get all our documents. Now, although this is a very simple application in the end, we wrote quite a lot of code just to do this. And we also have to define each single step to make sure MongoDB works correctly. If you see, we have to define the client here, then we have to establish the connection, we have to refer to the database, to the corresponding collection. We have to tell MongoDB that we want to insert one specific document, and so on. In the end, this is not a big problem, but actually I would prefer to rather focus on to the core logic of our application, because in the end, well, I just want to create a new document. Why do I need all this code right here? And why do I have to set up the connection manually? And why do I have to close it manually? And so on. The great thing is there is a little helper which can make our lives a lot easier when working with MongoDB, and this helper is called Mongoose. Up to now, we used the official MongoDB driver to interact with our database. And while this worked fine in general, we saw that it was a bit cumbersome at some points. Turns out there is a better solution for this database interaction. And this solution is Mongoose. Mongoose is a third-party library and it builds up on the official MongoDB driver, but it makes this interaction with the MongoDB database a lot more convenient. Mongoose uses so-called schemas, and schemas allow you to define the structure of the documents you want to store in your database. Now, in case you have the requirement of such structured data, as we do it for example, then these schemas make storing and fetching data from the database a lot more convenient. In case you don't have the requirement of such structured data, so if you have unstructured data in your project, this might not be the perfect solution, though Mongoose can also be used with unstructured data as a side note, but for our purposes here, Mongoose is a very nice helper. Therefore, let's install it right now by using npm install --save Mongoose. This will install Mongoose now, and Mongoose will allow us to connect to our database server and will also allow us to create and get data. Now, for our little project here, storing and getting data means storing and getting, well, products. Therefore, we now have to create the schema for a product. So let's now create our product schema here. Now, besides the schema, we'll also create a so-called model. The schema is basically the blueprint for our product, and the model builds up on that blueprint and then allows us to really use that schema in our project, but we'll see this step by step now. Therefore, I'll refer to both schema and models, well, kind of interchangeably here. What does a product look like in the end? Well, if we go to the MongoJS file, we can see it up here already. We have a pretty simple product. We only need a name and a price in the end. Therefore, let's now create this schema for our product. And typically you create a new folder named models, for example. And in this folder, we now create our file for our product schema, and therefore naming it product.js file is probably not the worst decision here. Now, to create the schema, we need to import Mongoose first. So we create a new constant named Mongoose and the require syntax. And we require Mongoose here. So with the package imported, now we want to create the schema. For that, we create another constant, maybe named product schema here. And this constant now refers to the imported Mongoose package and here to the schema method, important with a capital S here. Now, it turns out that this schema method here is a constructor function. Therefore, if we add new right here, we can pass in a JavaScript object, and this object then defines the structure of a newly created product and therefore of the document that we want to store. Now, we saw that the product contains two properties, the name and the price. So let's start with the name here. And in its simplest form now, we can now simply add a string here, for example, to define that our name should be, well, a string. But Mongoose actually gives us more power than this. We can pass in a JavaScript object here and now say that it should be of type string. And we can also pass in additional properties, for example, the required property, and set this to true. This will simply mean that we have to provide the name here, and you actually got more properties you can add to a schema. You can find these here in the official Mongoose docs. If you click onto read the docs here, you get a nice general introduction to that whole schema topic here. And if you click onto schema types, and scroll down a bit, then you see all schema types here. Here we use required, you can also use default and so on. So you can dive deeper at this point if you want to. But for our purposes, this should be fine here. So let's now define also the price property. Again, we pass in a JavaScript object, this time not of type string though, but this should be a number and it should also be required. So this is our schema already, but as I said before, to be able to use this schema, which in the end is the blueprint for a document, a product we want to create, we need to add a model based on the schema. With the model, we can then use the schema in our app in the end. To do that, we again refer to our Mongoose package here, but this time we use the model function here. The model function requires two arguments. The first argument is the name of the schema. Well, in our case, product would be a fitting name. By the way, when we use this model, this will also become the name of the collection without the capital starting character though and the plural form. So our collection will be called products then, which is kind of a fitting name. And the second argument should refer to the name of the schema that we created. And as we also want to use this model in other files, we will create a Mongoose.js file in the next lecture. We also have to export it with the export syntax. So module.exports is equal to our Mongoose model. So this is our model, and let's now see how we can use this to create a new product. So we have the model and the schema, so the blueprint for our product. How can we now use this logic to create new JavaScript objects and in the end to create new documents stored in our database? Let's get started by creating a new file here first, a Mongoose.js file, because I want to keep both the Mongo.js and the Mongoose code here for you, just as a reference. And in this Mongoose file, we'll now add the logic to create and get new products. We'll first start with creating products and we'll use Mongoose for this purpose. Therefore, we have to, again, import Mongoose with the require syntax here. So that's Mongoose, but we also want to use our model in here. Therefore, we should also import this. For that, we'll create another constant, and you can name this however you want, but as we refer to our model, and as we can use this model to create a new JavaScript object based on the blueprint in the end, convention is to start with a capital letter here, so the constant product would be equal to, again, the require syntax, but now referring to our models folder, and here the product file. You can omit the file extension here. Now, to create the product based on this model, we create another constant, again, create product as we had it before in the MongoDB part. This will again be an asynchronous task here. Request, response, and next. And now in this function, we want to use our model. To do that, we need another constant here, and this will now be the created product. So not create product, but the created product. So in the end, this should now use our model to create this new JavaScript object. And as it turns out, our product, so our model that we use in the end, can be instantiated as here. Our model function is a constructor function. Therefore, we can again use new here and refer to our model. And here we can now pass in a JavaScript object, and into this JavaScript object we can pass in the information required for our model, for our product schema in the end. And what is required? Well, it's again our name, and we get the name from the request body that we send, and inside the body this should be the name property. And same thing for the price, this is also provided in the request body, but here the price. So this is our create product logic. We will also use this in our app.js file, of course. Therefore, we can also use our export syntax here once again to make sure this works. By the way, I'm not using module exports at this stage because technically we only have one export now, but we will add the get products logic soon, and I want to be able to easily switch between the Mongo and Mongoose file in app.js. Therefore, I'm using this export syntax at this stage. What's missing now though is the logic to connect to our database now via Mongoose, and of course also to finally store the document, the created document, in the database. These are the next steps now. How can we now connect our backend to the MongoDB database? By using Mongoose. We saw with MongoDB this was a bit cumbersome, I would say, because each time we created a new product, we had to use the Mongo client, we had to use the connect method to set up the connection, and in the end we had to close the connection once again. Now Mongoose works a bit different here. Mongoose only requires one specific method, and I will add this method up here. And we simply use our Mongoose library once again, so the imported package, and here we refer to the connect method now. The connect method holds one thing, and this one thing are again our credentials that we stored here in this URL, so we can copy and paste this information here and pass it into the connect method. And this now manages the entire connection between our backend and the MongoDB database. So we don't have to open a new connection and close it each time we create a new product. This is all managed by Mongoose, and without diving too much into the details, Mongoose uses a concept named connection pooling. So Mongoose actually opens some connections here and manage these actively to make sure we can always have a, very efficient connection between our database and the backend. But in contrast to MongoDB, so without Mongoose, I would say that this is a lot more convenient. Besides managing the connection between our backend and the database, Connect also returns a promise. So we can also add then here to, for example, console log that we are connected to the database here. And we can also add catch to, catch any potential errors. Now that's of course not the only error handling logic you might implement here, but things can go wrong when we try to connect to the database. Therefore, we can use catch here to console log that our connection failed in case things go wrong. So that's also a nice thing to know about the connect method here. Talking about error handling, by the way, here in our MongoJS file, we use try catch to make sure that we catch any potential errors. We could also implement this then when we work with Mongoose, of course. I'll skip this as part of this refresher, as I want to focus onto the plain logic of Mongoose here. We'll of course implement it later in the next module when we use Mongoose as part of our course project. So the connection is established, but how can we now finally create the product and store the document in the database? Well, for that we have to save the new product, right? And before with the MongoDB driver, this was not the most convenient approach, as we had to refer to the database, we had to refer to the collection, then tell MongoDB that we want to insert one document, and so on. So we had again some things to keep in mind. Now with Mongoose, this works a bit different because, as I said already, Mongoose is a helper here. The only thing we have to do right here is we could create a new constant, maybe named result. And this constant refers to our created product, so the newly created product that we want to store in our database. And now we can use the save method. The save method is a method provided by Mongoose, and it's a method which can be used in connection with the corresponding models and schemas that you created in Mongoose. So here with our product model, for example. That's also one of the reasons why we're using the model right here. Otherwise, we could just use a normal JavaScript object, but with the model, we have access to this save method. And the awesome thing about the save method is that this method does all the heavy lifting that is required to save a document behind the scenes. So we don't have to worry about all the things I just talked about. So for example, about insert one. Saving does all the things we need. It refers to the right database up here specified in our credentials. It refers to the right collection. The collection is the name here, as I said, the first argument in our model method. So the collection name will be products, plural form with a small p. And, well, saving will just save that new document, that new product. As connect up here, save also returns a promise. Therefore, this is an asynchronous task, so we have to add a wait here. Again, this makes sense. Said that before. Interactions with the database can take a few moments. Therefore, we have an asynchronous task at this stage. And the promise in the end yields the saved product. So this means the document inserted into the database, which then is stored in the result constant. And also, as mentioned before, handling errors here would possible with try catch, for example. At this part of the course, I'll not focus onto this here. Therefore, as we now stored the document, what's missing is the response. So the response could be of type JSON, and here we simply want to give back our result. Now we only have to make sure that we can use our model, so our whole Mongoose logic, in the app.js file, because at the moment we still refer to our Mongo file right here, so Mongo.js. Therefore, we should change this to our Mongoose file. Again, we can omit the file extension. What's missing at the moment is our get logic here. So let's comment this out for a moment. We'll implement this in the next lecture. So saving this and now running npm start to bring back our development server. This looks good. Let's now go back to MongoDB Atlas first. Here to our collections, because I want to delete our database that we have at the moment to make sure we see that Mongoose really handles all this for us now. So let's delete products test right here. Oops, products test, not product. So we now drop the database, so our collection should be empty again. Okay, now let's go to Postman and create a new post request to localhost 3000/products. And here body, raw, and JSON. And now we need to provide the name of the product again. So as we did it before when we used the MongoDB driver, let's say an apple, and the price should be again 0.99. So let's send this post request. And this looks really fine. We have the apple and the price. Again, we have the automatically created ID. As I said, this is something we'll have a look at in a separate video towards the end of this module. And if we now check out our database and reload it, we see we again got the database. So this was automatically created by Mongoose. We got the corresponding collection, and inside the collection, we also got our document. And with that, we achieved a lot already. We now switched our entire test project here to Mongoose. We used a schema and a model, and we are now using this model already to interact with our database, and here, for example, to create new documents. Let's now use Mongoose to also get documents from our database. As we saw, creating products with the help of Mongoose works fine now. Let's now also make sure to be able to get the products stored in our database. This means we follow again the same core logic we had when we worked with the MongoDB driver. So we now create another constant, call it again get products. Again, an asynchronous task with request, response, and next. Into this arrow function, we pass in another JavaScript object, and in this JavaScript object, we again need a constant because we will use this constant as part of our response, as I want to get back the documents stored in the database. So this constant could be called products here. Now getting products is different than adding them. Before, it made sense to instantiate the product model and call the save method on the created object. But now we have no created object, right? We want to get products stored in our products collection instead. Keep in mind that all those products were therefore created based on instances of the product model. So what we did in the create product function. Since that's the case, Mongoose gives us an easy way of finding documents created based on this model. We can use some static methods on the model constructor function itself. In our case, the find method is what we need. And regarding this find method, there are some things to keep in mind. The first thing is, as you can see it here, find is a so-called static method used directly on our constructor function. Therefore, we also used find already in our MongoDB logic here with get products. Here, we used find, and as I told you, find returns a so-called cursor, which then allows us to iterate through the different documents stored in the database. And we could turn it into an array with the toArray method here. Now the Mongoose find method, this is a specific find method related to Mongoose, returns an array by default. So there is no need to convert this into an array, well, as we have an array already. We could also get a cursor here if you want to by adding the cursor method. With this, you would be able to turn this array back into a cursor as we had it in the MongoDB logic. The last important thing about find is that here with save, you remember, we had a promise, or save returned a promise here. This is not the case for find. This Mongoose specific find does not return a real promise, but kind of a promise. What this means is that you can still use async await here, but in the end, it's not a real promise. If you want to turn this into a real promise, you can add the exec method here. This will turn it into a real promise. And talking about promises or asynchronous tasks, we should also add await right here. So this is it already. Again, very lean code, I would say. The only thing that's missing now is our response. I said it already. For this, we will simply return our products stored in our database. We are almost done now. The export is missing, so name it get products and save this in our mongoose.js file. And now comment back in our get products code in the app.js file. So if we go back to Postman now and create a new get request here and send it, we get back our product. And important with find, we get back all our products. So if we would add our banana once again, 1.99, create this banana quickly, and now again send our get request, you see we get both of these documents that we stored in our database. And that's actually almost the end of this refresher. With that, you saw the core idea behind MongoDB and also why Mongoose makes our lives a lot easier and allows us to really focus onto the core business logic of our app. There is one thing we didn't talk about so far though, and this is this ID property right here. What's this actually? So what is this ID here? We can also see it in our database. And if you remember back the MongoDB part of this refresher, we also had this ID. Well, the ID gets added to the document each time we store a new document in the database. This is a unique ID for each document. So with the ID, we can identify a specific document and it gets added automatically, no matter if we use the MongoDB driver or Mongoose. The thing about this ID is that, well, you can see it here actually, it has a special type. It's not a string, it is a so-called object ID, so a MongoDB specific data type, you could say. And typically you might want to work with these IDs, for example, as part of if checks or things like that. And with JavaScript, you cannot work with this object ID data types. For that, you need to convert these IDs into a string. And Mongoose, again, has a convenient way to do so. I can show you this back in the project, here in the mongoose.js file, here to create product. And now here we can console log the type of our created product. But interestingly, we can now access the ID already. I'll come back to that in a few seconds, but we can access the ID in two different ways. And our goal is to convert the object, this object ID, into a string. And again, Mongoose got a nice little helper for that. For that, we use a so-called virtual getter, which is added by Mongoose, and we can refer to it with ID here. If we do so, save it, and now again, create the banana, go back, you see, now we turn it into a string. So with this virtual getter, this is working. By the way, if you would refer to the ID property, so with the underscore, so as you can see here, we have the underscore in front of ID. If you would do this and create the product, you see, we get back an object. So here, this conversion doesn't work. So again, Mongoose got us covered. And with that, we can convert the object here into a string. So this virtual getter helps us to convert the object into a string. But why can we actually access our ID property here? Because neither in our model nor up here in our JavaScript object, we have the ID property. Let me comment out this console log quickly. And let's now log our created product up here. So before we actually save it to the database, saving this and creating a new product, we can see that now, although we didn't store the document to the database, this happens afterwards here with our save method, the ID is added already to our object. And that's really interesting, right? Although we didn't define it in our model nor here in our object, we get this ID property here in our object and in our document in the end. That's also the reason why once we store the document, this ID is added. And this is in the end a default feature provided by MongoDB. Now let me delete that console log here though, and let me comment this back in. And as we talked about this ID now, I think it makes sense to have a bit of a closer look here before we conclude that module. So throughout this module, we learned how we can connect our backend, our Node.js backend in our case, to a MongoDB database. We learned what MongoDB actually is, we had a look at NoSQL versus SQL databases, and we learned how we can set up MongoDB with MongoDB Atlas. We then used the default MongoDB driver first to connect to the server and to create and get products. This was the code we wrote here in our Mongo.js file. We soon saw that using the MongoDB driver is fine, but a bit cumbersome. Therefore, we then added Mongoose to our project. Mongoose is the third-party library, which kind of manages the interaction between our backend and MongoDB in a very efficient way and allows us to focus on the real business logic. Also because Mongoose comes with this concept of schemas and models, which allows us to create blueprints for documents stored in our database. With Mongoose, we can make interacting with the database a lot easier. We saw that here in our Mongoose.js file when we simply use the model in the end. And we also saw that besides managing the connection, we saw it up here with the connect method, or saving documents easily or finding documents easily, Mongoose also helps to convert the IDs, so the object ID that gets created automatically in MongoDB, to a string. So again, another nice little helper function. And with that, we hopefully refreshed our knowledge on MongoDB and Mongoose. In the next module, we can now implement this knowledge into our course project. Really looking forward to this, so let's continue. Welcome to this module. In this module, it's finally time to connect our backend to a real database. For this purpose, we will use MongoDB and Mongoose to manage this connection between our backend and MongoDB. And before we continue, make sure to dive into the refresher module, also part of this course, in case MongoDB and Mongoose are totally new to you. If you know the basics of these tools already, then you can continue, and in this module, we'll then have a look at how we can define our Mongoose models. Because Mongoose is all about models, this means we will have to create a place model and a user model. Both models will define the general structure of the so-called documents stored in our MongoDB database. Besides that, we'll also have a look at CRUD operations for our places and our users. CRUD stands for create, read, update, and delete, and these are typical operations you have to do if you want to interact with a database. Finally, we'll also have a look at the relation between places and users. We will establish a connection between these two, because if we, for example, create a new place, then this place should be allocated to a specific user. This logic is missing so far, therefore it's time to implement it. And with that, let's dive into this module. As mentioned before, we will use a MongoDB database and specifically Mongoose, which will help us to manage the connection between the backend and the database. Therefore, we first have to install Mongoose in our project, and then we'll see where we have to implement it in our code. To install Mongoose, we simply use npm install -- save Mongoose. This will take a few seconds, and after that, we can use Mongoose. To be able to use it though, we of course have to import it to our project. The question is, where do we have to import it? Well, the core idea is that our general application doesn't make a lot of sense without the database in the end, because all our data, no matter if it's related to the user or to the places, will be stored in the database, and therefore we somehow will interact with this data. This means the right place to implement our connection to the database is here, our app.js file. So let's first import Mongoose now with our well-known import syntax up here. We require Mongoose. Now we can use Mongoose. The question is, where do we use it here in our code? Well, down here, where we start up our backend server. Because as I said, the logic should be as follows. We first want to establish the connection to the database. If this connection is successful, then we want to start our backend server. In case the connection to the database was not successful, well, we don't need the server because we will throw an error instead. The good thing is that the connection to the database, thanks to Mongoose, comes with an integrated feature to do so. Because we simply now use our Mongoose constant here and refer to our connect method. Connect returns a promise as the connection to the server is an asynchronous task. And with that, this means that we can also make use of our then and our catch method right here, which will allow us to create exactly the logic I was just talking about. Before we dive into connect right here, connect requires specific credentials as an argument to, well, connect our backend to the MongoDB database. We'll have a look at that in a few seconds. So let's first focus on to then and catch, because if the connection was successful here, well, then we simply start our server. So we simply use a normal arrow function syntax right here and take our code and paste it right here. So that's the first case. If our connection was successful, we start our backend server. In case it was not successful, we'll simply throw an error right here. And here we could console log the error. So that's the startup logic. What is missing now, of course, is here our connect method and the required argument. To get this missing information, we have to Google for MongoDB Atlas. And down here, you can find MongoDB Atlas. If you click onto it and go to sign in up here, you can simply log in with your username and your password. And in here, I'm now in a brand new project. Now, we had a look at MongoDB Atlas in more detail in the refresher module. Therefore, I'll focus on to the core settings required to establish the connection to our database. The first thing we have to do is we have to make sure that we can access the database from our current machine. Therefore, we go to Security and Network Access and add our current IP to the so-called IP whitelist. If you click Add IP address right here and now add current IP address, you see your current IP address right here as the whitelist entry and press Confirm. This will take a few seconds. And after that you did the first step, you can access MongoDB from your current machine then. Status changed to active, therefore step 1 is done. Now we also need to create a user which uses this specific network access we just created. For that, we go to database access, and you see we have some existing users here, but we will create a new one by clicking add new user. Now you have to enter a username. In my case, I'll select menu, and a password, which I'll show you here, which will be maybe acadamind123, not the most secure password, but totally sufficient for our purpose here. Make sure to select read and write to any database as the user privileges. And with that, we can add this user now. Again, this will take a few seconds. The user was successfully created. Now we can go back to our cluster, and if we now select connect, we can now choose a connection method between our backend and the MongoDB database. We can connect it with the Mongo shell or MongoDB Compass. In our case, connect to application is the right choice. Here we select Node.js and 3.0 or later in our case. And here we can now finally find the so-called connection string. The string is what we need to be able to access our database. Important though, we have to use our username and password, so the data we just added for our user, to make sure the data access is configured correctly. So we can copy this and now add it right here, in quotation marks of course, to our connect method. Now, very important, we have to change the username to menu in my case. Important, use your own username and your own password here. By the time you're watching this, by the way, this data will not be longer valid, so it doesn't make sense to copy these. The password was academind123. And one other thing we can optionally change is right here, test. Test is the default name for the database that we will create. We will change this here in our project to places maybe. With that, we set up the connection to our database. Let's save this and let's now run npm start to see if we have any errors. No, this works fine. With that, step 1 was done, the connection is established, but of course we cannot add any data to this database. This means in the next lecture, it's time to set up our places model. So let's create the place model now. Well, before we do that, what is the place model actually? Well, MongoDB thinks in database, collections, and documents logic. This means we have a database which can contain one or multiple collections, and a collection can contain one or multiple documents. And in our case, each single document is a new place that we stored. That's the MongoDB side. From a Mongoose side, we think in schema and model logic. A schema is the blueprint of a document that we want to store. So in our case, the blueprint of a place. For example, we can make sure that a place must contain a title. So this is the blueprint, the schema. Based on the schema, we create the so-called model. And each instance of this model in our code will then result in a new document. So that's what we want to achieve right here. We want to create the schema and the model. And in the next lecture, we want to instantiate the model to make sure that we can store a new document or a new place in our project. Let's get started with the place schema therefore. For this, I'll go to the models folder, create a new file named place.js. Now the schema and the Mongoose model are concepts related to Mongoose. Therefore, we have to import Mongoose first. So we require Mongoose here. And the schema is also a special concept part of Mongoose. Therefore, we have to create a schema constant here, which accesses the schema method. Now we can create another constant. This will now be our actual schema, and we could call it place schema, as this is the specific schema for a single place. Here we now instantiate our schema and create a new JavaScript object. And this object now contains the logic for our blueprint of a later document. We have such a blueprint already actually as dummy code though, here in our places controllers file. Dummy places also has the general idea behind a document. We, for example, don't need this ID property anymore because the ID will be created automatically by MongoDB when we store a document. We'll see that later. But title, description, location, and so on, these are properties that we want to have in our document and therefore also in our schema. Let's start with the title and add the semicolon here. And we could say that the title should just be a string. That would be possible. But here I would rather add an object because I want to add more information to that title. Because as I said, the title should be of type string, but the title should also be required. This means the title must not be empty. And I guess this makes sense because a place without a title, well, not too helpful. Therefore, we should set required here to true. We can actually copy this because we might need that more often here. The second property is our description. The description, well, should also be a string and is required. Now I want to add a new property we didn't have so far in our places controller, and this is the image. Now, one important note here. The image is not the actual file. When we work with databases, the image always is a URL, so a URL pointing towards a file, which is not stored in our database. Because storing files or images in a database is not a good idea, because it kind of contradicts the idea of a database which should be fast and which should be able to execute the queries as quick as possible. If you imagine storing big files there, well, this would slow down your database, and this is definitely not what you want. Therefore, here we will use a URL. The URL will also be a string and will be required, so we can again use the same logic. We also need an address. And the address, well, should also be a string and required. Let's get rid of these double empty spaces here. And then we also need the location. The location is a bit different because in contrast to our previous properties, we now have a nested object, because here in our places controller, you can see that the location contains the lat and long properties. Now, Mongoose is able to interpret that, so we can easily also add a nested object here and now add the latitude, which here should not be of type string, but of type number, and required should again be true. Can actually copy paste this and also do the same thing for the longitude. So here we can also use this nested object logic. The last thing we need is our creator here. The creator will again be of type string and will be required. Don't need the comma here. And the creator later will be replaced by a real unique ID. I mentioned that with the places already, that the ID will be created automatically by MongoDB. Same thing will happen later when we create a new user. For the moment, we'll just use dummy information, so we enter the user ID manually. And with that, we actually created our schema already. This was only step one though. As I said, we have the schema, then we need the model, and then each instance of the model will create the document. So to create this model, we now simply add module exports, and this should be equal to our mongoose and now the model method. That's a special method available here in Mongoose, and model will return a constructor function later. We have to add 2 arguments to this function. The first argument is the name of the model. The convention here is to use an uppercase starting character and a singular form, no plural form. Well, as our model is here to create a new place, place is actually a fitting name, I guess. By the way, this will also be the name of our later collection. The collection will not have the uppercase starting character, and it will be plural though. So our collection will be named places then. The second argument is our schema that we want to refer to in our model, and that's our place schema right here. With that, we created our Mongoose schema and the corresponding model. Now it's time to use this model and to create our first document. So where do we create this document? Well, if you think about the operations that we want to achieve here, create, read, update, and delete, then the first logical step to use the model is C, create, because if we can create a document, then we can also have a look at reading it, updating it, or deleting it. So we want to create a new place, and this can of course be done here in our places controller. Here we have the dummy places. We won't use these at the end of this module, of course. And if we go down a bit, we have our create place constant. This is what we should focus on now. As we want to use our newly created place model though, we first have to import it. For that, up here, we import place, again with a capital P, as this will be a constructor function. And this requires our models places file. With that, we can use the place model, and if we go down a bit here it is, our created place constant. The previous code is fine, so here we have some validation, and here we have the coordinates that we get with our geocoding logic, so we don't have to change this. But here our created place logic, this has to be updated. So let's get rid of this code here, and let's first instantiate our place constructor here with new place. And now we have a new JavaScript object, and here we can now add data to our model. What our model needs though is already predefined by our schema, so we have title, description, image, and so on. Because of that, We can get started with the title once again. I'll again use this shorter syntax here. So title is what I wrote right here. We need the description, the address, we need the location with the corresponding coordinates, and we need an image. And as I said before, the image should be a URL, so no real file. Later in this course, in the file upload module, we'll learn how we can store images on our server, not on the MongoDB server, so not in the database, but on our backend server. Then this URL will point towards a file stored on our server. Here, I'll just take a dummy URL from a file in the internet. Make sure to store this as a string. Don't forget the comma. And with that, we only need our creator here. As I said, we will use a dummy ID here. Don't forget to add the semicolon. And with that, we created our model already. As I said, very important, make sure that the properties here in our model are the same that we have here in our schema. Otherwise, well, this will throw an error. Now, talking about errors, this brings us to this push logic here. This is not valid anymore because we have a different method we can use here for our created place constant now with the model logic, with our place model. The logic here is created place.save. .save is a method available in Mongoose, and save will handle all the MongoDB code you need to store a new document in your database, in your collection. And additionally, save will also create that unique places ID I talked about previously. Save is also a promise. This means we have an asynchronous task. Again, as we saw it with the connect method before, saving files to our database can take a few moments, therefore asynchronous task right here. And as we already have async up here in our create place constant, we can now add a wait here. And to make sure we catch any errors, let's also add try catch to make sure we are covered in case anything goes wrong, which hopefully won't be the case. So we will catch our error here and create a new error constant with our new HTTP error we used already. And the error message could be something like creating place failed, please try again. And an error code of 500 here. With that, we are almost done. There is one thing missing though, and this is return next error. We have to add this here, or we should add this here, to stop our code execution in case we have an error. If we don't add return next here, the code execution would continue even if we throw an error. Definitely not what we want right here, therefore important to add this too. With that, we are actually done. So if we now start our server once again and go to Postman, create a new request. This should be a post request targeting HTTP localhost 5000/API/places as we want to create a new place. Then we go to body, raw, and JSON. And now we have to add all the properties that we defined in our model. So this was first the title, which is the Empire State Building, maybe a description, a very famous building in New York. We need the address, which we can again get via Google Maps here. We don't need the location, it's automatically retrieved via our geocoding logic. Same thing is true for the image, we hard-coded that when we instantiate the place. This means we only need to add our creator, and this could be you too maybe. So let's see if we now hit send here. Yeah, this looks good. So we created that place apparently. Here you can see the unique ID that was created automatically. We have an underscore in front of the ID. We'll tackle that later, but generally this looks fine. Let's also see what happens if we go to our database now. Here, if we click onto collections, That looks good. By the way, here we have two places. The first place is the database name. The second is the name of the collection. So places here is what we specified in app.js, right here in the connect method places. And the collection name is here in place.js, right here, our place in the model method without the capital P and in plural. So that's basically the name of this collection here. And more importantly, inside this collection, we can now find one document. And if you look at the ending of the ID, it's EB6. And that's exactly the document we created right here. With that, we achieved a lot already. We were able to create the schema, to create the model, and to create our document in our database. So C, create from our CRUD operations is completed. Let's now continue with the R, read. So we'll have a look at our GET requests now. So creating places works fine. The next logical step in our CRUD operations flow is read, therefore. And to read data, we should focus on to our get places by user ID and get place by ID constants. Get place by ID would mean that we want to identify a place based on this underscore ID right here, so the place specific ID. Get place by user ID would be this creator ID that we manually entered. Let's first focus on to get place by ID though. Here we can keep our first place ID constant. We'll still need this constant to extract the data from our request. But here, our place constant, this is the one that we have to change here. Here, we don't need the arrow function, so we can just delete this entire code here. Because here, I again want to use our place model now. And as I this time want to find existing places, I won't use save as we did it before with our create place logic. Now I will use another method, which is part of Mongoose, and this is find by ID. And by the way, find by ID is a static method here. This means it's not used on the instance of place, but directly on the place constructor function. Find by ID works a bit different though when comparing it to the save method. In contrast to save, find by ID does not return a promise. And still, then catch or async await would be available. That's Mongoose specific though, but from a conceptual perspective, find by ID doesn't return a promise. In case you need a real promise here, not needed here in our case though, you can still get this if you call exec here after find by ID. With that, you could get a real promise. As I said, for our cases, we don't need that as we can still use async await here due to this Mongoose specific feature of find by ID, but it doesn't return a real promise here. However, we can use find by ID now, and we need one argument though, and that's of course our place ID that we previously defined up here. There is one thing missing though. Do you know what? Well, we again have an asynchronous task right here. As for save, also finding an ID is a task which can take a few moments. Therefore, we will again use our async await syntax right here. So we'll add async here and await right there. And as we also did it for our save method, try catch won't hurt here. So let's also add try right here and put our code into our try code block. And we'll of course also catch the error again as we did it before with our error constant and a new HTTP error. And this could say now something went wrong. Could not find a place. And the error code could be 500 right here. So that's our try catch block. Very important though, also as we did it before, we have to make sure that we really stop our code execution in case we have such an error. Therefore, we return next error. Once again, it's the same logic we actually had with our storing places method previously. We have to change one additional thing though. As you can see, place right here is no longer used, although we use it down here in our if statement. The problem here is our block scoping, so we define our constant here inside our try block. Therefore, we have to define place outside of our try block, and we'll also turn const into let here. So let place, and now inside our block, we get rid of the constant. With that, this code works fine again. One important note though, and I got a typo right here. This should not be wrong. This should be wrong, of course. Now it's fine. So one important note, the error catching right here and right there is a different one. And we have to adjust this if statement, by the way. We'll do that in a few seconds. This error is displayed if our GET request generally has some kind of a problem, if we have missing information, for example. In case the request is fine, but we just don't have our places ID in our database, then this second error down here should be thrown. That's the difference between these two errors. Talking about this if statement, to be in line with our previous logic to catch errors when we worked on our create places code, we can again use the logic we had above. So we can simply create a new constant, which is equal to the new HTTP error here. And the statement is fine. But what we need here is we need to return our next error here to make sure our code execution is stopped in case of this error. With that, the code up here works fine. We just have to tweak our response a bit, because there are actually two things that I would like to change here. The first thing is the fact that the object here we are working with, so our place, is a specific Mongoose object in the end. So we have a lot of special Mongoose methods available for this object. Now, whilst this is fine for creating data and for working with Mongoose, when we get back the response, the object might be easier to use if we just turn it into a normal JavaScript object. That's the first thing I would like to do. The second thing is, you remember this ID we have, this underscore ID. I would also like to get rid of this underscore, because although it's not a big problem in general, it's easier to really have clean properties here. So ID without the underscore, this will also make it easier to refer to this ID later. So these are the two things I want to do right here. First, let's turn our place object into a normal JavaScript object. For this, we simply add the toObject method here to the object. With that, the conversion is done already. And our second goal, to get rid of this underscore, well, this can simply be done by setting getters right here to true. And why is getters true doing this? Well, because Mongoose adds an ID getter to every document which returns the ID as a string. Normally, such getters are lost when we call toObject, but with getters true, we can avoid this and tell Mongoose to add an ID property to the created object. That's it actually. With that, our code should be working fine. Let's save our progress. And let's now go to Postman. Now create a new request, this time a GET request. Again, to localhost 5000 right here, /places, and now / the places ID we have right here. So let's enter this ID in the URL. And now let's send this request and see what happens. So this seems to work. We still have our ID up here though with the underscore, but down there we get back the ID without the underscore. With that, we make sure that our getPlaceById logic works fine. And now it's your turn, because down here we have our getPlacesByUserId constant. We also have to adjust this one, and the logic is pretty similar to the one that we had before for our getPlaceById logic. There is one thing you have to know though, you shouldn't use findById here, but the find method. It's a bit more tricky therefore, as you have to make sure that you find a specific property within a place. So basically the ID of the creator. That's the hint I want to give you. So with that, now is your chance to give it a try. And in the next lecture, we'll solve this together. So how did it go? Were you successful? Let me show you my approach now. For that, we have to go down to our getPlacesByUserId constant. Again, user ID is fine right here, but our dummy places, this is what we have to work on. And we'll also have a look at the if code. Let's see if we change this too, but this is actually what we should focus on now. So therefore, let's get rid of this code here. And now we can again refer to our place model here. And this time we will not use the findById method up here, as I said, but we'll use a different method, the find method. Find generally works similar as findById. This means we again do not return a promise here, but you can again use exec if you want to. But again, find still allows us to use async await here or then catch. Again, this is a Mongoose specific feature available right here. It's not a real promise, but you can use this asynchronous operations here. Find has some other important things to keep in mind though. Generally, using find like this would return all places. This means if we want to have a specific place, in our place a specific place by the user ID, we have to add the user ID here as an argument. So in our case, we can use the creator property and refer to user ID as we define it right here in our constant. That's one thing we have to keep in mind. Another thing is that find is available in both MongoDB and Mongoose, which we're using right here. In MongoDB, find returns a so-called cursor. A cursor simply points towards the results of our find method here of the query we did, and it then allows you to iterate through the different results you would have. The reason for that is that if you would imagine you would have hundreds of places in here, so hundreds of documents, it would avoid to bloat your data immediately and to return big amounts of data. So that's the way how MongoDB approaches this. So you get back a cursor and then can iterate through the different results. In Mongoose, find doesn't provide a cursor, but directly an array. We could also get a cursor in Mongoose, by the way. To do so, we could use the cursor property on our find method, instead of only using just find. That's what you have to keep in mind here. So we're using the Mongoose find method. We are now adding the creator property, and therefore we can filter for the specific document where the creator has the user ID we are looking for in our GET request. This means we can now again add our try catch code block here, put the constant into it. With that, our constant is not available anymore due to block scoping. Therefore, we can create let places outside of our try block and get rid of the constant, and also make sure that this again becomes an asynchronous task. Again, we have a find operation. Therefore, we'll add async up here and await front of our place model. And we also catch our error, again, with the same logic we had before. Let's again use the constant, which should be a new HTTP error here. And let's say that this should return fetching places failed. Please try again later. And again, that's the logic we have in the 500 error case, so in case anything goes wrong with the request in general. And here we also have to add return next again. With that, this should work fine. Down here, this code could also be refactored, so this way, so that we store the error in a constant. But to show you both ways again, let's this time keep it this way. As I said, you can adjust this to be in line with the rest of the code, but just for demonstration purposes as part of this course, I will just keep this the way it is. But down here, our response has to be adjusted once again. There is a little thing that you have to keep in mind. This was a bit more tricky, I must say, but maybe you did it. In case you have problems, we'll solve it together now. Because again, we have to add a method to our places here, but this time we cannot use our toObject method up here, because the problem is that, as I said, find returns an array right here, and we cannot use toObject with an array. Therefore, we have to use map here, a standard JavaScript method. And with map now being in place, we can again use place toObject right here, and then apply our getters feature to make sure that the underscore from our ID property is removed. So getters is again set to true. And with that, if we now go back to Postman and create a new GET request here, again to HTTP localhost 5000. But this time we have to go to our user's routes. So we go to API/places/user/ and now U2, so the ID of our user right here. Let's add this. Let's press send. Yeah, this looks fine. We get back our response. We again get the ID without the underscore, so getters also works fine. And again, if I would now use, let's say U3 right here, click send, you see we could not find places for the provided user ID. So this is this error right here, which is also working fine. And with that, we finished R, so read, in our CRUD feature chain right here. Let's now continue with updating places. Time to update our places now. And the great thing now is that we actually learned all the core concepts we need to do so. Therefore, this should be an easy task now. Let's do it together though. So, update places, as before, our first code here with our error check can be kept. This is fine. The same thing is true for the properties here that we want to get from our request body. This is fine. Params can also be kept. But this part here with dummy places, this has to be replaced now as we have real data in our database now. The update logic right here, well, we'll have a look at that in a few seconds. And what I can also see right here is this dummy place should, of course, also be deleted now. So how do we start? Well, in the end, updating a place simply means that we want to get the place by the place ID and then update the title and the description. Now, as I'm talking about finding the place by the place ID, we can again use our find by ID method we had up here for the get place ID constant. This also means that we will use the same try catch block again. Therefore, we can from the start use the same logic in the end we had right here. So we will implement the try catch block from the beginning now though. So let's go down and let's now say that we again have our place variable here, let this time, not a const, as we start with our try catch block. Inside try, we have our place once again, which we use right here, which we just defined. And place should be equal to place dot find by ID. That's the same logic we just saw. And what's the ID that we want to find? Well, that's of course our place ID here. This one. Updating places, once again, is an asynchronous task. Therefore, don't forget to add async up here and await down there. With that, we have to catch any error case here. If we have an error, let's again store it in a constant here. Should be equal to the new HTTP error. And this should state something went wrong. Could not update place. Error code would again be 500. And we should not forget to add return next error here. So this looks fine already. With that, we have to change updated place to place down here as we refer to place up here. Therefore, we can also use place when it comes to updating the title and the description. And what is missing now? Well, storing the updated place, of course. At the moment, we're just sending back a response, which we also have to adjust. But we also have to make sure that the updated information is stored again in our database. For that, we can again use the save method, which we also used before when we created the place. And as we know, save is an asynchronous task. Therefore, we will again use try catch. And now await our place save method to save this updated place. And in case we have an error, we'll again catch it. You see, it's kind of the same process we have here for all these tasks. And here we can say something went wrong. Could not update place. And again, a 500 error code. And also don't forget to return next error down here to make sure the code execution is interrupted. What's missing here? Well, we should again convert our mongoose object to a normal JavaScript object, and we should get rid of our underscore ID, so of the underscore of the ID property to be more precise right here. For that, we will refer to place dot to object. Here we can use this method directly as we are not having an array here as we had it before when we were getting the place by the user ID. And now we can set getters to true. Let's save this. And let's now see what happens if I want to update the place. For that, I'll create a new request right here. This time it will be a patch request to HTTP localhost, not user, but places slash the ID of our place. So let's take the ID down here. And let's paste it. Now we need to go to body, raw, and JSON once again. And now we have to add the title and the description that we want to change. For that, let's say the title should be the Empire State Building. Before we had Empire State Building. And the description here should be, well, what do we have at the moment? Here we have a very famous building. Let's say a great building, like this. So we have the two properties. So if we send the patch request now, we can see that it was successful, and we have the title, the Empire State Building, and the description was also changed to a great building. So this also works fine now. Let's now also have a look at our database. And as you can see, we also have the Empire State Building and a great building. So our database was also updated successfully. With that, we have create, read, update. What's missing now is deleting documents in our database.